live on TikTok. So we live on YouTube. Nice. All right. Let's go. All right. So the first thing I want to just correct is this question over here. They're saying using an integration method, calculate the area of the region in the first quadrant. Now, like I said, when they say first quadrant, they actually mean for the Cartesian plane. And let's go through what they mean by that quickly. So we have the Cartesian plane here. And if I was saying that and it's something complicated, the Cartesian plane is just the x and y axes, guys.
Yeah.
So which one would you think is the first quadrant? A, B, C, or D?
A.
A.
A, right? Now, in the first quadrant, the x value is more than or equal to 0. The y value is what? If you had to say. If you're in the first quadrant.
Less than?
No. Nah, guys. Nah, watch. Maybe if I put numbers here, you'll understand it better.
More than or equal to.
Yeah. So today we're just gonna be doing a bunch of hard maths. Just a bunch of hard maths. Fun. So here what, guys? If I'm a point in the first quadrant, then my x value will be positive and my y value will be what?
Positive as well.
Positive as well. So in the first quadrant, x is more than or equal to 0 and y is more than or equal to 0. That's in the first quadrant. In the second quadrant, which value is negative, the x value or the y value?
The x value.
Right, so in this situation, x would be less than or equal to 0, but y would be what?
More than or equal to 0.
Okay, good. And if you're in the third quadrant, right, let's look at something. Let's just say, for instance, we consider this point over here. Notice that the x value is negative and the y value is negative. So if you're in the third quadrant, x is less than or equal to 0 and y is less than or equal to 0. Could anybody tell me what would happen in the fourth quadrant for the Cartesian plane?
X is more than or equal to 0 and y is less than or equal to 0.
Good. I hope you all could see that. This is not paper one, this is hard maths. Right? If you're confused, right, look at this fast. 1 comma negative 1. Notice the x value is positive, so it's more than or equal to 0. And the y value, however, is negative. If the y value is negative, then it's less than or equal to 0. Co-host, I'll should be doing a job admitting people.
Yeah,
Right?
sorry what I said.
That's okay. Cool. So let me look at this in context of the question. So in the question, it said calculate the area of the region in the first quadrant under the graph y is equal to 3 sine x. So we have a function here, 3 sine x. I could quickly graph this out. Do you guys know what sine x's look like? Or no?
Nah.
Nah? It's kind of scary.
It's down, up, down, like.
Alright. So sine graph kind of looks like a S. So what the sine graph looks like. This is what the sine graph looks like. And so this would be 0 degrees. This would be a 180 degrees. And this would be a 360 degrees. This would be a what? What would this be?
90 degrees.
This would be a 90 degrees. What would this be?
270.
270.
270 degrees. Brilliant. Now the sine graph goes up to what value and goes down to what value? What do we know about the sine graph? Sine graph. Sine goes up to what value?
Does it go
One.
up to 1 and then
Right.
like -1?
Exactly. So sine graph goes up to 1 and it goes down to -1. So if we have a multiplier here, then it would tell us that the function, in this case, goes up to what?
3.
Yeah, it goes up to 3 and it goes down to
3
Negative 3.
also.
-3.
Right.
-3. So understand what I'm saying, right? Sine. The sine graph by itself, it goes up to 1 and it goes down to -1. So imagine I'm multiplying the output by 3. Then that would go to 3 and go down to -3. Now, let me ask you guys something. In the first quadrant, my input x is more than or equal to 0, and my output y is what? My output is what?
More than or equal to 0.
Good. Let's observe this graph here. Could you guys tell me between which angles? Could you guys tell me between which angles is the sine function going to give us positive values? Somebody tell me. Nikolai, looking at the sine graph over here, for which range of angles is the function going to give me positive values?
The 0,
Between 0 and what?
180.
Good. Can you guys see that from 0 to 180, all my outputs are going to be positive? You see that or no?
Yes.
Yes, sir.
Yes. Yes. Sir.
Between which angles am I going to get a negative answer?
180 to 360.
180 to 360. I hope you guys understand that. Do you all understand that or not?
Yes, sir.
Yes, sir.
One more time. They want us to figure out the area of the region in the first quadrant. If it's the first quadrant, then the input x needs to be more than or equal to 0, and my output y needs to be what?
More than or equal to 0.
Good, because recall, in the first quadrant, you're over here in the first quadrant. And so the input needs to be more than or equal to 0, and your output needs to be more than or equal to 0. So when you look at the sine graph, which angles are going to give me an output that is more than 0? Can you guys see it's between 0 and 180 or not?
Yes, sir.
Yes, sir.
Somebody tell me fast. Would 270 give me a positive output?
No, a negative
Negative.
output.
It'll give you a negative output.
Good. So to answer this question properly, we were supposed to identify that. We were supposed to identify the inputs or the angles that would give us positive outputs. And so that ranges from 0 to 180 degrees. And when we're doing integration with trig functions, we typically don't use degrees. We typically use what? What do we use to represent our angles instead of degrees?
Radians?
We typically use radians, right? For those of you guys that forgot, pi radians is equal to how much degrees?
180.
180 degrees. Yeah. And fun fact, that's why in the formula for circumference, it's 2 pi r, because a full circle is 360 degrees. And like I'm telling you here, pi radians is 180 degrees. So you need 2 pi to make a full circle. So if pi radians is 180 degrees, then it would essentially be from 0 rad to what?
Pi.
Yeah, to pi. Because we know that 180 degrees represents what? What does 180 degrees represent?
180.
Pi.
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 180 degrees is pi. Yeah, that's okay, Gabriel. 180 degrees represents pi radians. So when I'm figuring out my lower bound and my upper bound of integration, I'm going to look at 0 and pi. For those of you guys that forgot, or I should ask this, do you all know that integration allows us to find area under a graph or not?
Yes, sir.
Yes, sir. Yes, sir.
Okay, good. And it allows us to find the area under a graph between two bounds. So if I want to figure out the area of the region in the first quadrant, well, we identified I'm getting positive answers from 0 to 180, which is 0 to pi. So the area will just be integral from 0 to what? 0 to what? What is it supposed to be? 0 to 1.
Pi.
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 Right, and I'll have to integrate the function 3 sine x with respect to what?
Y.
Yeah.
With respect to x, the variable is x. 3 sine x, you have to integrate with respect to x. All right, cool. So this is really for the students I was there yesterday, because we would have looked at the whole of differentiation and integration in the last sessions. So if you wasn't there for that, you might be a bit behind. I'll try to go in depth so you can understand. Right. In the next step, you'd have to integrate 3 sine x. So here what? Forget about the constant. You have 3, forget about it. Just write it back. Just write it back. If it's a constant, nothing's going to happen to it. If I integrate sine x though, what am I going to get? If I integrate sine x,
Minus cos.
I'll get minus cosine x. What's my upper bound?
Pi.
Was pi. What's my lower bound?
0.
0.
Good. A lot of you guys might be lost because this is a continuation from yesterday's class that I had the live on. And then you have 3 by minus cosine x. So what is 3 by minus cosine x?
Minus 3 cos x.
Cool. So now we have to plug in the upper bound and the lower bound. So let's see how that's going to go. So that'll be the minus 3 cosine pi minus what? Somebody tell me minus what?
3 cos 0.
Yeah, minus 3 cosine 0. So plug that into your calculator and let me know what you guys are getting. I have a question though. Since we are using radians, your calculator has to be in what? Your calculator has to be in what?
Radians.
A calculator has to be in radians. So Casio users, do you know how to put your calculator in radians mode or not?
Yeah.
Yes. Sir.
Yeah. Okay, cool. If you're a Casio user here and you don't know how to do it, don't feel shame. Don't feel shame. Just tell me. I'll show you how to do it. All right.
So I guess
What you get?
I guess 6.
Yeah, 6 is the correct answer you're supposed to get. Right? 6. So that'll be 6 units squared. So let me plug it into my calculator so y'all could see how it works. Even though nobody said anything, I'll show you guys how to do it anyways. So we're gonna press Shift menu. Wait, what's in? Shift menu. It should work. Right. You're gonna press Shift menu. You should see 2, which has angle units. Press 2 for angle units. We want to use radians. So you're gonna press 2 for radians. And when this is all said and done, you should see a small r to the top of your calculator. So now we're going to plug in that. So it'll be minus 3 cosine pi. Cool. Minus, open brackets, minus 3 cosine 0, close bracket, and you should get 6. Are you guys getting 6?
Yes. Sir.
Yes. Sir.
Okay,
Yes, sir.
so I'll run through this question again. This was like a wolf in sheep's clothing.
So why it's squared?
Okay, so when we're finding area is the product of 2 dimensions. So if we don't know what a unit is, right, Gabriel? So the
I
unit,
didn't realize it was area. My bad.
oh, that's okay. All right. So they run through the concept again. They said using an integration method, calculate the area of the region in the first quadrant. So to begin with, anytime you integrate a function, what are you finding for? Really, what are you finding for?
The area underneath the curve.
Exactly, the area underneath the curve. And you would need a upper and a lower bound to figure out the area bounded by the curve, the x-axis, and these 2 lines. So in this question, they want us to calculate the area in the first quadrant. They are referring to the Cartesian plane. Now, if you're in the first quadrant in the Cartesian plane, that means the input is positive and the output is what?
Positive.
Right. So both are positive. So what we're going to do is we're going to do a little sketch of the sine graph, and we're going to look and see where we're getting positive outputs. So can you guys identify the range for which I'm getting positive outputs?
0 to
0
pi.
to pi.
0 to pi, that's correct. 0 to pi right here. As you can see, I'm getting positive outputs from 0 to pi. So that is how I figured out which my lower bound and my upper bound. My lower bound will be 0, my upper bound will be pi. Because I knew from 0 to pi, I'm getting positive outputs, which would be in the first quadrant, as these angles are positive, and I get in positive. So I have positive inputs and I have positive outputs. So that is what I mean when I say first quadrant. So from here, you just have to integrate. If I integrate sine x, what is that going to be? If I integrate sine x,
Minus cosine x.
minus cosine x. Good. Don't worry about the constant. It's there, it's just chilling. So you have the 3 by the minus cosine x. Then you say 3 by minus cosine x, which is minus 3 cosine x. And from here, you just plug in your upper bound. So minus 3 cosine pi. Minus, and you plug in your lower bound. Minus 3 cos 0. You should get your answer. Yeah,
Sir, I have a question.
talk to me.
I think yesterday you did a question. I don't remember if it was similar to this, but it also asks for the region in the first quadrant, but you
That was
use
a mistake. That was a mistake. That was a mistake. So hence
oh
I start off today correcting that. Correcting that. That was a mistake. They did not mean okay. So you see how we have ASTC. You see this? That's not what they meant. They meant in the Cartesian plane. They meant in the Cartesian plane. So I had to
okay.
correct that one time.
So how you
So
just know the difference, like once you use the Cartesian plane or ASTC?
it's supposed to be in the Cartesian plane all the time. Like when they're asking for the area, it's always with reference to the Cartesian plane. I just made like a misstep. That was on my part. Sorry about that. Yeah. So it's Cartesian plane. So again, guys, if you see first quadrant, that means the inputs and the outputs are both what?
Positive.
Exactly. And when you look at this graph, where's my input and output positive?
0 to pi.
Right, 0 to pi. And if you wanted, you could probably extend the graph like this. And if this is the case, anybody could tell me what this would probably be.
Minus pi.
Yeah, this would be minus pi. And what would this be?
Minus 2 pi.
Minus 2 pi.
So here what guys, if they asked you for the area in the second quadrant. Now, in the second quadrant, what do we know? What do we know in the second quadrant?
Both values are negative.
In the second quadrant, we know that the input is going to be negative, or the x value is going to be negative, but my output is
And
what?
y is positive.
Good. So if they were to ask you to find the area in the second quadrant, where would I be looking at? Would I be looking at this range over here, 0 to negative pi? In the second quadrant. So in the second quadrant, it means that my input is what? Positive or negative?
Negative.
Negative.
And my output is what?
Positive.
Positive.
So here we're saying, right? If you pick 0 and negative pi, you see now the input is negative, check. But is my output positive?
No.
No, sir.
No, no. Over here, my input is negative. Is my output positive?
Oh, yes, sir.
Yes, sir.
Yeah, so if they ask you for the answer in the second quadrant, you would use minus pi and minus 2 pi. But let me ask this question. Which one would I use as my upper bound? Which one is bigger, minus pi or minus 2 pi?
Minus
Minus 2
pi.
pi.
Minus pi.
Yeah, so I'll say minus pi here, minus 2 pi here. If they ask you for the answer in the second quadrant. Nah, yeah, I know it's a bit tricky. This question is a bit tricky. Come back, give me a second. Yeah. So they're always talking about with reference to the Cartesian plane. So let's just do a quick recap, right? If I'm talking about the first quadrant, my input is what?
Positive.
My output is what?
Also
Positive
positive.
as well.
Right? If I'm talking about the second, my input is what?
Negative.
Or my output is what?
Positive.
Right, again, if you're confused, just draw this quickly. Watch. Positive, positive, negative, negative. If you're a point in the first quadrant, both are to be positive. If you're a point in the second quadrant, only the output is positive. If you're a point in the third quadrant, both of them negative. If you're a point in the fourth quadrant, your input is positive, but your output is what?
Negative.
Yeah. So in the third quadrant, your input, which is the x, is what?
Negative.
All right. And the output is
Also negative.
also negative. If you're in the fourth quadrant, your input x is,
Positive.
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 but your output is?
Negative.
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 Okay, good, good. So when you're answering these questions, please do a sketch firsthand to see exactly what you're dealing with, right? And you know when they're talking about first, second, and third, what they're really talking about is in the Cartesian plane. That's what they really mean, right? So let's look at our options for today. So I made AI come up with a practice test. If all you want, we could do that.
So someone asks how it does know to calculate in radians.
Um, okay. You know you have to work in radians. Okay, in Add Maths, typically when you're working with trig functions, we typically use radians. And anytime you see something like 3 sine pi, you know you're not dealing with degrees. That's not degrees. Anytime you're inputting an angle in radians into a trig function, your calculator has to be in radians. So let me do a little trivia quickly. Let's do a little trivia. If I had something like sine pi over 3 compared to sine 60, quick. What mode of my calculator have to be on?
Radians.
Radian. Radians.
What mode over here?
Degrees.
Degrees.
Degrees. And let me explain something. This is an outright statement. Guys, and you know in Add Maths, there's the arc length formula and the area of a sector.
Yes,
Yes,
sir.
so
So remind me, arc length is equal to what?
Um,
R
re- r theta.
Good. And the area of the sector is equal to what?
half R squared theta.
A half r squared theta. You see these two formulas over here? These formulas will only work if your angle is in what?
radians.
Radians.
Radian.
Here, I saying it's in big, you know. These formulas will only work if your angle is in radians. It will only work if it's in radians. Only work if it's in radians. If it's in degrees, it will not work. And it has to come down to how radians work. Radians is just a ratio between the arc length and the radius. And so in these formulas, it needs to be in radians. So I hope that helped. If you're dealing with these formulas, for sure, the angle must be in radians. And remind me, pi radians is how much degrees?
180.
180.
Cool. Yeah, so here are the options for today. I made Claude AI come up with a practice test, and well, we also have all the other past papers. So what do you guys want to do? Let me know what you guys want to do.
AI one.
I just here to help.
Practice this.
I just here to help all you. Like whatever all you want me to do, I'll do.
Practice test.
Yeah,
Do
what
the
would both?
both.
Yeah,
Do
both.
both.
Well, it's 12 hours, you know. If I can make it for 12 hours, you know, that's a lot of time. So we could do a lot of work. Yeah. Right. Was this the corrected one? I had made two versions and I had do the corrections. Let me just check something real quick. Give me a second. Yeah. Give me a moment. Okay, yeah, this is the corrected version. Right, so if you could answer every single question in this confidently, chances are more than likely you will be passing the exam tomorrow. I can't see you failing the exam tomorrow. So, who wants to help me with the first question?
I don't mind.
All right, so Nikolai, give it a read.
Given that f of x is equals to x to the power 4 minus 6x to the power 3 plus 11x squared minus 6x, and that x minus 1 and x minus 2 are factors. Use polynomial division to determine the remaining factors of fx.
Right. So, Nikolai, when you read this question, you're seeing that we have a polynomial to what power?
To the power 4.
And they're giving us two what factors? What kind of factors are these? The highest power for x is 1. So what kind of factors are these? That's with L.
A linear or
Linear factors, correct. Linear factors. So in this question, they want us to use polynomial division to determine the remaining factors of f of x. So, Nikolai, do you have any suggestions?
when they say polynomial division, I'm thinking of just doing the long division for those two, but with x minus 1 and x minus 2. But then I have this feeling that is not that, and I have to put x minus 1 is equal to 0, and then solve for x,
Nah,
and then
nah.
plug it into the equation.
All right, let me take this opportunity to explain something to you guys, right? So, Nikolai, where you tell them there is remainder and factor theorem, where they equal to 0, and you would not use that in this question. In this question, they want us to figure out the other remaining factors, so we'd have to do polynomial long division.
Yeah.
Do you guys remember how polynomial long division works or no?
Yes, sir. Yes, sir.
Now, let me explain something, right, Nikolai? Our function here, the highest power for x is what? What's our highest power for x?
4.
X to the power 4. And both of my factors are what? Both of my factors are what?
Linear.
Linear factors. So let me explain something. This is an oversimplification, but just for you guys to understand. If I had x to the power 4 divided by x, I would end up with an expression where my highest power is what?
3.
Poetry.
X to the power 3. Guys, you have x to the power 3. Is x to the power 3 something that's easy to factorize? Yes or no?
No.
No, it's not.
No.
What's easy to factorize is if you have something to what power? What's easy to factorize?
The power 2.
2.
To the power 2, right? So here we're going to do, Nikolai. Here we're going to do. Didn't they give us two linear factors?
Yes, sir.
Okay, they gave us two linear factors. If I were to multiply those two linear factors together, I would end up with an expression where the highest power is what? If I were to multiply x by x, I'd end up with an expression where the highest power is what?
2, which is
2.
x squared.
And if I were to divide x to the power 4 by x squared, I would end up with what?
X to the power 2.
Would that be easy to factorize?
Yes, sir.
That would be easy to factorize. So if you get a question like this tomorrow, what I advise you to do, since x minus 1 and x minus 2 are factors, here's what you could do. You could find the product, and then you could do polynomial long division. Some of you guys might be confused. So I want to explain this in terms of regular numbers you're accustomed dealing with. So let me just say we had a number like 26. And I could write 26 as 4 by 3. That is that's 12. And then what? Wait, let me use a different number instead. I could write 36 as 4 by 3 by what? Somebody tell me. I could write 36 as 4 by 3 by what?
3.
3.
3.
Okay, so I have a question, right? Aren't 4 and 3 factors of 36?
Yeah.
Stay with me, right? 4 and 3 are factors of 36. If I multiply 4 and 3, what would I get?
12.
I would get 12. And if I divided 12 by 36, wouldn't that give me the other factor that's remaining there?
Yes, sir.
So it's the exact same concept I'm going to apply here. We have this big expression over here. We know that x minus 1 is a factor and x minus 2 is a factor. So if I were to multiply those two and divide it by x to the power 4, I'd end up with a smaller expression, which is also a factor of f of x. Let me try
Yes.
to give you another example because I feel like some people are still confused. Let's think of 45. 45 is the same thing as, I could say 15. Okay, trying to think of a number that, let's see. It's not a number I could think of over here. Probably 63. And we know that 63, okay, somebody give me some two numbers I'll multiply to give me 63.
7
Sometimes 9.
7 times 9. Isn't 7 times 9 the same thing as 7 by 3 by 3?
Yes, sir.
Yes, sir.
Here's what I'm saying, guys. Isn't 7 a factor of 63? And isn't 3 a factor of 63?
Yes,
Yes.
sir.
Yes, sir.
Sir.
Guys, I have a question. If you multiplied 7 by 3, wouldn't that give you 21?
Yes,
Yes,
sir.
sir. Sir.
And if I divided 63 by 21, which factor that would give me? Wouldn't that give me the remaining?
Three.
Wouldn't that give me the remaining one?
True. Yeah.
Yes, sir.
Yeah, so it's the exact same logic we're going to apply over here. They gave us two factors. And so if I multiply those two factors and I divide that by x to the power 4, wouldn't I end up with a smaller expression, which is also a factor of f of x?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, it's a bit, I know it's a bit hard to understand. It is. But you see, both of these are factors are what? Both of these are factors are what? Somebody tell me,
F,
both of these are factors are what?
F of x.
Good. So guys, if I were to divide f of x by x minus 1 or x minus 2, wouldn't it go into the f of x perfectly without a remainder?
Yes, sir.
Yes, sir.
So if I find a product of x minus 1 and x minus 2, wouldn't that also go into f of x perfectly?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, it would. And that would it would leave me with a what? With an expression.
Quadratic.
Yes, it would leave me with a quadratic. And then I could factorize that quadratic.
Yes,
Yes,
sir.
sir.
Exactly. So, Nikolai, if you see a question like this and they give you two linear factors, you're going to find the product of the linear factors. All right, so Nikolai, we're going to say x minus 1 by x minus 2. So, Nikolai, expand that for me.
Maybe x squared
I'm going to
plus
expand, right?
no,
Yeah, so tell me.
maybe x squared minus 2x
Mm-hmm.
minus x plus 2.
Good. That's correct. What is minus 2x minus 1x, guys?
Minus
Minus
3x.
3x.
Minus 3x. Okay, good. So I have a question. Nikolai, weren't these two factors of f of x?
Yes, sir.
Now, what does a factor mean? A factor means that these two linear terms could go into this perfectly without leaving a what?
I remain, that's it.
Exactly. So, Nikolai, how did I come up with the x squared minus 3x plus 2? Well, I multiplied two factors. So, wouldn't this, as a result, also be a factor of f of x?
Yes, sir.
So, here's what I'm going to do now. I'm not sure how much of you guys would have looked at cases like this in school. Any of you guys would have looked at cases like this in school where you have a quadratic and you divide in the quartic by the quadratic. I know typically students would do cubics
No,
and linear.
I don't think so.
Yeah, cubics.
Well, technically, this is only syllabus, eh? This could come. This could come.
So I have a question.
Yeah, talk to me.
So you can't just divide the f of x by x minus 1 and then divide what you get by that by x minus 2? If you
You
don't
could
wanna
do that. You could do that if you want. That's perfectly fine. That is perfectly fine. Yeah. This is just like killing two birds with one stone. But you could do that if you want. Alright, so Nikolai, let me run through polynomial long division. So here what, right, Nikolai? What would I multiply by x squared to get back x to the power 4?
Alright, 2.
2 or x to the power 2?
X to the power 2 and
Right? So then we're going to multiply this by everything over here. So guys, let's look at the first step, right? What do I have to multiply by x squared to get back x to the power 4? X to the power 2. And so we're going to multiply everything by this. So Nikolai, what is x squared by x squared?
X to the power 4.
Okay, what is x squared by minus 3x?
3x to the power 3.
Positive or negative?
Negative, sir.
That'll be negative 3x cubed. And then we have x squared by 2. What is x squared by 2?
2x to the power 2.
2x to the power 2. Good. Then we're going to minus. What is x to the power 4 minus x to the power 4?
That'll be 0.
That would be 0. What is minus 6x cubed minus 3x cubed? We have a minus. We have a minus by a minus.
-3.
That'll be positive. That'll be positive, sir. And that plus sin minus 6 would be 3x to the power 3.
But we have minus 6. The negative number has a bigger magnitude. So we have minus 6 plus 3. What's minus 6 plus 3?
Minus 3.
Yeah. So this would be minus 3x cubed. And then we have 11x squared minus 2x squared. What would that be?
9x to the power 2.
Right, that'll be 9x squared. Then we're going to bring down the minus 6x. And then we're going to repeat the whole process again. So, Nikolai, I'm going to ask you, what do you need to multiply by x squared to get back minus 3x cubed?
By 1. Well, by
Nah.
3x. By 3x.
So, okay,
Oh.
3x is partially correct. 3x is partially correct, right? If I multiply this by 3x, I'll get a 3 and I'll get a x cubed, but we had to get a negative.
So it'd be minus 3x.
Good, it'll be minus 3x. Guys, what is minus 3x by x squared? Somebody tell me, what is minus 3x by x squared?
Minus 3x squared minus 3x cubed.
Good. And now we're going to repeat the whole process again. We're going to multiply every single thing by the minus 3x. So Nikolai, what is minus 3x by x squared?
Minus 3x to the power 3.
What is minus 3x by minus 3x?
Positive 9x to the power 2.
What is minus 3x plus 2?
Minus 6x.
Oh, you should be grinning, Nikolai. You should be smiling. You should be smiling. Because tell me, Nikolai, what is minus 3x cubed minus 3x cubed?
That'd be 0.
That'll be 0.
Yeah.
What is 9x squared minus 9x squared?
That will also be 0.
Yeah, what is minus 6x minus 6x?
0 as well.
0 as well. So therefore, Nikolai, we would have proven that x squared minus 3x plus 2 is a factor of what?
The whole polynomial.
Yeah, the whole polynomial. And what did we get?
X squared minus 3x.
Wait, so let me just give me a second replying to that message. Yeah. Now we continue. Yeah, so we get x squared minus 3x. So Nikolai, I have a question, right? This is just a quick experiment. Guys, if I were to multiply x squared minus 3x plus 2 by x squared minus 3x, what am I supposed to get back?
The polynomial.
Yeah, I'm supposed to get back this. And so, in the question, they said use polynomial long division to determine the remaining factors of f of x. So, this was a product of the factors given to us. So, Nikolai, what is our other factor? What's our other factors?
The x squared minus 3x.
Good. So here what, guys? Here what? If I wanted, I could have represented f of x as a product of its factors. So, the factors are x minus 1. What was the other factor given to me?
The x minus 2.
Right? And we just now found that another factor is
X squared minus 3x.
However, we could factorize this further. We could. Guys, when you look at x squared minus 3x, is there anything you could potentially pull out?
The x
And if you pull out x, what would I write on the inside?
minus 3.
X minus.
Good. So to determine the other factors, what are the other factors, guys?
X in brackets, x minus 3.
X and x minus 3. Okay, this was on the tougher side. Like I say, I asked Claude to make like a tougher. But so many questions easy in my opinion. So many questions a bit harder.
When I saw this question, sir, I remember there was a question that I believe I did in the mock exams, and it was equals to 64, but it was based on the two factors and the same polynomial as well.
Oh, so this is not something that's completely alien.
Yeah, it's not something completely weird, but it's just a the fact of I thought if we were just divide the two by the polynomials and then see.
Well, this is not the only way to answer this question, you know. It's not the only way to answer the question. Like I think Jason suggested you could have divided f of x by x minus 1 and then take the quotient of that and then divide that by x minus 2. And that would leave you with x squared minus 3x. Jason, and that's what you were suggesting? I think it was Jason. Yeah. But that's it.
So I went with that situation, but the only thing I did wrong was taking the full polynomial and dividing it by the other factor as well.
Oh. Oh, no. So this is one way you could do the question. How much of you guys are familiar with things like this, where you have, I'm not sure. This is like on the harder side. I'm not sure how much of you guys would have dealt with quartics and quadratics, like with a quadratic divisor and a quartic dividend. I'm not sure how much of you guys would have dealt with that. Anybody dealt with that before? Or no?
Yes,
I
sir.
did once, so I was kind of familiar with this question.
Okay. Well, like I said, this is not the only way you could have handled the question, right, Nikolai? So, Nikolai, let me show you the alternative route you could have take. I think this is a longer route, though, but it's a feasible route. Oh, and again, just to show you all something really cool, we started off with a polynomial to what power? A polynomial to what power was the highest power of x?
4.
4. When I divided it by a quadratic with the power 2, I got a quotient of what? What's the highest power of it?
X to the power 2.
All you understand how it's working?
Yes, sir.
Yeah. All right. So let me look at the alternative route really fast. I think some of you guys would have taken this route. When we're done with this paper, maybe we could do 2025 in extreme detail or something, whatever you guys want to do.
Yes, sir. No problem, sir.
All right. So Nikolai, what would I have to multiply by x to get back x to the power 4?
X to the power 3.
Then I would multiply everything by x to the power 3. So if I multiply this by x to the power 3, what would I get?
You get x to the power 4
Mm-hmm.
plus x to the power 3.
Then I'd minus. That'll be 0 here. What is minus 6x cubed minus x cubed?
That'll just be 6.
Nah, that wouldn't be 6. So you have minus 6x cubed, and you have minus x cubed, which is plus x cubed. What is minus 6x cubed plus x cubed?
That'll be minus 6x to the power 6.
Nah. Nikolai, what you just did was multiply.
Mm-hmm.
Alright. So Nikolai, the understood coefficient here is 1. You have 1x cubed.
Yeah.
So you have minus 6x cubes and you have plus 1x cubes. So if you want in the calculator, you could just put minus 6 plus 1. What is minus 6 plus 1?
It's 5. Or
So
minus
minus, yeah. So this will be minus 5x cubed. Then what would I do?
bring down the 11x squared.
Then what?
Divide the x minus 1 into that
And what would I get over here?
You get minus 5 x to the power 2.
Good. And I'll multiply x minus 1 by that. So what is minus 5x squared by x?
You get minus 5x to the power 3.
And what is minus 5x squared by minus 1?
That'll be positive 5x to the power 2.
Then you would minus, this would be 0 here. What is 11x squared minus 5x squared?
6x to the power 2.
And what would I do next?
You bring down the 6x,
Then what?
divide the x minus 1 into that equation.
And what would I get on top?
6x.
Yeah, I'd
Oh.
get 6x. Then I'll multiply, I'd get 6x squared. 6x per minus 1 is minus 6x. And when you subtract, you see you get a remainder of 0, which is what you want. And then, what would you do next?
Divide the x minus 2 into that equation, while the product that we just got.
Oh, this is the quotient, eh? This is the quotient.
Quotient.
So this is called the divisor. This is called the quotient. And what you put over here is the dividend. I was trying to stay away from the fancy math jargon to not confuse people. But yeah. So yeah, you'll say x minus 2 into x cubed minus 5x squared plus 6x. And how would that work out, Nikolai?
That will be 6x to the power. No, x to the power 2.
Right? And I'll multiply, I get x cubed. And x squared by minus 2 is minus 2x squared. Then I would minus. And when I minus, what would happen?
You get 0 for the first one, and that will be minus 3x to the power
Good.
2.
And I bring down the 6x. What next?
You divide the x minus 2 into that equation.
Right?
So you get minus 3x.
Right? Because minus 3x by x would give me back the minus 3x squared.
Yes, sir.
So, and then I would say minus 3x for minus 2, which gives us plus
Positive.
6x. And you should be smiling because this is what you want.
Yes, sir.
Remainder at 0. So question, which route would you guys have taken? Would you have multiplied the two linear factors to find a quadratic divisor? Or would you have do it separately like that?
Now that I know I could have done this way, the first one that we did, I would more go for the first one. Because the second one, a little too long just for 4 marks.
3 marks.
Is not 4?
That's 3 marks.
No, that 3 marks is for the second question.
Yeah, but yeah, it's 4 marks, 4 marks. So which method would you go? Which would you guys have taken? Would you guys have taken this
The
approach
first one.
or the
The
second?
first one.
Okay. All right. So let's move on. So the answer to the question was x and x minus 3, because when you did the division, you ended up with a quotient of x squared minus 3x, which could have been factorized to x by x minus 3. So your factors were x and x minus 3. And then in part 2, they want us to solve f of x is equal to 0. So who wants to help me with this one? It's real simple. It's a simple one. It's a simple one. I promise. Simple one. Any volunteers?
If nobody will, I'll just go.
All right, no problem. So with these types of questions, they typically say hence solve. They typically say that. So Nikolai, when you're solving, and I'll ask everybody this, right? When you guys solving a quadratic, what's the first thing you do?
You put everything equal to 0.
Your space equal to 0 and you just factorize, right? You just factorize. And just factorize
Yes, sir.
because you're trying to figure out the values for x that would make each linear factor turn to 0. So if I have f of x is equal to 0, then what am I really doing? Well, I would have to factorize the quartic expression. Do I know how to factorize that?
Which one we factorizing again, sir?
Oh, we factorized it in previously. We factorized it previously, so they say f of x is equal to 0. And so Nikolai, when we factorized f of x, what did we get from the previous question?
We get x in brackets x minus 3.
No, those were the
I mean the
other
full thing.
a full thing.
Ah, x minus 1 and then x minus 2. And then should I put the x squared minus 3 or the x?
Put the x by the x minus 3.
Oh, okay. So then that will be the x in brackets x minus 3.
And I would set this equal to
0.
guys, listen up. Anytime they ask you to solve a function equal to 0, you are looking for the factors because you're trying to figure out the values for x that would make each linear factor turn to 0. So anytime they ask you to solve a function, they set a function equal to 0, and you have to solve, you need to factorize as much as you can. Yeah, so Nikolai, what would I do next?
You will have to solve x minus 1 is equal to 0. 2, well, x minus 2 is equal to 0. X is equal to 0. And x minus 3 is equal to 0.
Right? The answer here would be
Well, that would be just 1. The answer for that one is 2. That one remains as 0. And x is equal to 3.
so. I have a question, guys. Somebody tell me, if I were to plug any of these x values into f of x, what should I get?
0.
I am supposed to get 0 because didn't I just solve f of x is equal to 0?
Yes, sir.
Yes, sir.
Hey, I'll pick one and I'll test it fast. Pick one.
X is equal to 2.
1.
X is equal to 2, that's not a problem. Let's plug it in fast. So 2 to the power 4 minus 6 by 2 to the power 3 plus 11, 2 squared minus 6. So when I press equal, what am I supposed to get?
0.
Sir.
We're not surprised because we solved f of x is equal to 0. So tell me, in the exam tomorrow, if they ask you for the remaining factors, are you going to use remainder factor theorem or are you going to use polynomial long division?
Polynomial long division.
Good. If they ask you to prove that something is a factor, what would you use?
Yeah.
Remainder.
Yeah.
You would use factor theorem. You'd use factor theorem. Factor slash remainder. You know, hey, factor theorem and remainder theorem is the same thing, eh? It's the same thing. The only difference is the factor theorem is a case of the remainder theorem, where the remainder is what?
0.
0.
0. Good.
So could you
0.
repeat the question again? What we had to be looking for?
Right. So Nikolai, if in the exam tomorrow they give you a function, they give you a polynomial, right? And they say find the other linear factors or find the other factors. Are you going to use remainder factor theorem or are you going to use polynomial long division?
We will use the polynomial long division.
Good. If they ask you to show that something is a factor, what are you going to use?
The remainder factor theorem. Okay.
Exactly. Good. Please remember that. And if they ask you to solve the function, solve when the function is set to 0, what you had to do?
Solve for x.
You had to solve for x by factorizing. You had to factorize the function as much as you can.
Yes, sir.
Good. Are you okay with these questions or not?
Yes, sir.
Yes, sir.
Yes, sir.
Now, as saying this in bigger, Add Math is not one of those subjects where you could just not do any work the whole term and come day before and expect a miracle. No, you can't do that for Add Maths. Add Maths is something you have to be practicing a while. People are good in Add Maths, go on, that's not what I mean. Right? I'm sure there's some people here that, good in Add Maths, like Christopher. Yeah, Christopher good in Add Maths.
I kind of lost it.
You kinda lost?
Nah.
And Nikolai good in Add Maths too, but Nikolai, yeah, shadow lucky. Nikolai, you can do it, man. You can do it. So, here's a question for you guys. Simplify x squared minus 4 over x squared minus 3x plus 2 minus x minus 2 over x minus 1. Fun.
So I can try that one.
Sure, no problem, Jason.
So, sir, at the bottom, you wouldn't factorize the x squared minus 3x plus 2 to make it simpler?
Right, we'll factorize that. So since this is a simple trinomial, implying that the coefficient of x squared is 1, and you see now the coefficient is 1,
Yes, sir.
it's really simple to factorize this. So to get x squared, I could put an x in the first bracket, and I could put an x in the second bracket. Then you could look at the last term. What's my last term?
2.
What two numbers would multiply to give me 2, but add to give me the middle term, which is minus 3?
So 1 and 2.
1 and 2 wouldn't work. If I add 1 and 2, I would not get minus 3.
Oh, sorry, sorry.
Minus 1 and?
Minus 2.
Oh,
Right, minus 1 and minus 2. Because, Jason, what is minus 1 plus minus 2?
so minus 3.
And what is minus 1 by minus 2?
2. Positive
Good.
2.
So, it's real easy. I just got write x minus 1 here and x minus 2 here. That's it.
Yes,
That's
sir.
it. Guys, does it matter if I say x minus 2 first, or doesn't matter?
It doesn't matter, sir.
Doesn't
Doesn't
matter.
matter. Why does it not matter?
Because
Multiplication
multiplication is
commutative.
commutative.
Multiplication is commutative. Now, Jason, you factorize the denominator. Good. Now we
So
have to
for the top
factorize.
as well, yeah. It would be x plus 2 and x minus 2, right?
Yes, because x squared minus 4 is an example of what?
Perfect square.
Wouldn't say perfect square. That's difference are two squares. Difference are two squares. Yeah. Could somebody tell me why this is a difference are two squares?
The power is raised to 2.
Well, I have the squared term over here, but before,
What is
what can I write for us? What can I write for us?
2 to the 2.
2 squared.
Exactly. Can you guys see that it's a difference? Literally, you minus into a difference of two squared terms. So difference are two squares. And well, that would just be x plus 2 by x minus 2, yeah?
Yes, sir.
Yes, sir.
Okay, good. Nice. So anytime you see these simplified questions, it means that you need to what?
Simplify it as best as possible by
Factorize.
factorizing.
Exactly. Correct, Nicola, and correct. Somebody said something else is here. Yeah. You need to factorize it as much as possible to see what would cancel off. Is anything canceling off over here?
Yes, sir.
Yes, sir.
What's canceling off?
The x minus 2.
Oh, this real simple, boy. I think you guys seen it. I think you all could see the light at the end of the tunnel. So
Yes,
we have
sir.
x plus 2 divided by x minus 1, and then minus x minus 2 all over x minus 1. So, we had to do that, guys.
Oh, since
The
it's
same
the same
denominator,
denominators, you just
I mean minus. No.
Yeah. If you forget, right? If you're confused, I'm gonna take you guys back to SCA maths. Promise.
since
If
you
we have
have
some
0,
wait, if we had something like 5 over 7 minus 1 over 7, what would that be? How would I work that out?
It would just
4
be
over
5
7.
minus 1 because the denominators are the same.
Yeah, so guys, anytime we have the same denominator, I don't know why I say that denominator. I don't know why I say that, but anytime we have the same denominator, you just have to add or subtract the numerators. So can you guys identify we have the same denominators here?
Yes, sir.
Yes, sir.
Yeah, so all this is going to come out to be is just going to be x plus 2. And here, what is our mistake students make? They just put negative x minus 2. Is that correct?
No.
No, it becomes a positive too.
Exactly. I was supposed to put brackets and then distribute it. Because it's minus this entire term, guys. So it's minus the entirety of x minus 2. So you need to put x minus 2 in brackets. So
Then I went with that, everything would have been 0, and that would have been wrong.
exactly, that would be wrong for sure. For sure. So when I expand, what I end up with?
Minus x plus 2.
Wait, eh? Wait. I'm trying to figure out how to prop my phone up. Okay, that. Because TikTok banned my life. I don't know why. I know I was doing so. TikTok playing up. Okay, we gotta work with that. Yeah. So that'll be minus x, and what is minus by minus 2?
Oh, positive 2.
What next?
You just shift over the x to the one side and the numbers on the other side. So it
Whoa,
just
whoa,
be
whoa.
x minus x.
Wait. Wait, no, Nikolai. No, Nikolai, you're talking about for equation. Right now, we are simplifying an expression. So we're not gonna move across anything. Can't really do anything like that. Right? Nikolai, what I want you to do is I want you to look at the top, right? Are you
Yeah.
seeing any like terms on top?
Yes, sir.
What like terms you seeing?
The 2 and 2,
I see any two and any two, and what are like terms I seeing?
the x and the x.
Right. So Nikolai, what is x minus x?
So that was talking about moving
Oh,
the x. It's like x minus x and the 2 plus 2.
I thought you mean like move it across here and thing. I was like,
No, no,
whoa.
no.
Oh, okay. I guess scared me. So that'll just be 2 plus 2. Or is 2 plus 2?
Now before.
Right, 4 by x minus 1. Are you okay with that?
Yes, sir.
Yes, sir.
Yeah, so anytime you see these simplified questions, we had to do one time.
Factorize as best as possible.
Yeah, you have to factorize as best as possible. What? I have 144 people on YouTube. I was not expecting that. I thought it'd be like 30 or something. Wow.
Day before the
There's a lot of
exam.
people who just want to study right before the exam, and not before,
Yeah, that's how people has been moving. I wasn't expecting that 144, boy. That's crazy. All right. All right, let me tackle this question now. So when you see a question like this, how much of you guys are tempted to use logs?
Me, but at the same time, you gotta get the beats to be the same.
I mean, you could use logs,
You could use lots
You
before
could,
I'm
you could,
doing the 6.5.
you
Like,
could use logs. You could use logs in this. I just wouldn't recommend it. I don't.
Yes, well, so I use the 625 to get the 5, but to a power that when you multiply it gives 625.
Yeah.
not like 5 to the 4th. Yeah,
Nah, I
that
don't
times
think it'd
5.
be 5 to the fourth. Five to the fourth would be a really big number. I think it's 5 to the power 3.
Yeah, 5 times
Master
5
is 5
Yeah, it
3 4.
is 5 to
Oh, okay. I thought that'd be a
Yeah, I
big.
memorize those.
Oh, okay. Well, yeah, that's correct. So, and I'll show you guys how to attack the question using logs just now. But with these types of questions, if you could, you want to have the same base on either side, so you could equate the what?
The powers.
Powers.
Exactly, so you can equate the powers. So 625, like Christopher correctly said, is 5 to the power 4. Since we have the same base, what can be the powers?
Solve for the powers, so it'll just be 2x plus 1 is equals to 4.
And what could I do next?
Well, yeah, let's carry the 1 over.
I carry 1 over, and when I move across the 1, it's going to turn to 2x is equal to
3.
Yeah. And then I will do what?
Solve for x
Divide both, right?
divided by 2.
And x will be equal to?
3 over 2.
Now, this is not the only way you could have answered this question.
Yeah, you can just use logs.
You could have just used logs. Let me explain. What is the whole purpose of the logarithm function, boy?
It's
The
just solve for the
logarithm,
power.
exactly, the
Power.
logarithm function allows us to figure out what power you have to raise a number to get the desired result. That's what the log function does. Let me give you an example, right? Say you wanted to figure out 9 to the power x is equal to 57. Are you think that easy to do?
No, sir.
Not really, no.
Not really. However, let me cook. Guys, if you're doing odd maths to begin with, if you're doing odd maths, should you have a sharp?
Nah.
Nah.
Oh,
Nah. If you have a sharp, this failure thing there, boy.
You are very
It's a
much
big boy.
cooked.
Like,
Because
okay,
shop don't have the logs, answer.
it have the logs, but to base 10, you can't specify the log base. But let me show you guys something. Watch this, right? If I put log base 957, I'll get 1.8400. Let me show you something. What I would have just figured out for is the power I have to raise 9 to get what?
57.
57.
Yeah. And if you don't believe me, watch this, right? So 9 to the answer just fine. The answer was the 1 point whatever. Bam. You see, look, I get back to 57. So a lot of you guys don't know that this is what logs actually do. Logs is allow you to find the power. You have to raise a number 2 to get the desired result. Now,
Yeah.
let's look at the rules for logarithms quickly. I'll take a little detour to like teach logs here because I know a lot of you guys are having problems with logs. If you're having problems with logs, raise your hand. Let me know.
So, I have a basic understanding, but
Ooh, a lot of people struggling with logs. Wow.
so as soon as I see that, I see my camera just gone. Yeah, but
Hey, boy.
I see.
All right, so guys, anytime you have the same log base and you're adding, what do?
It's like a subtraction.
Multiply.
Well,
Multiply
multiplying.
BC.
Multiplying. And this is called the what rule?
Product rule.
Product.
Yeah, this is the product rule. Okay, let's look at this one. Consider I had log base AB minus log base AC. All right, what would that work out to be?
Log A,
Right.
Log
B
A,
over C.
B over C.
And what do we call this one?
Quotient.
Quotient rule.
Quotient.
Something telling me a log graph will come tomorrow, you know, which is crazy. I don't know. Something telling me a log graph will come tomorrow. Do you all
They're
know?
like logarithmic linearization.
Yeah,
The
yeah.
graph it.
Yeah,
Like,
that I have a feeling. I have a feeling that gonna come tomorrow. I don't know where it is. I don't know
So,
where it
give you a
is.
heads up on it now. Like, show you what it is.
real sir.
Hey, teach you that one time.
We could do a question on it. I'll do the 2017 question. Don't worry. I feel like I don't know. I don't know where it is. I don't know where it is.
So that was the only year it came up?
It really come that frequently, but I don't know what telling me it'll come this year. Right?
Yeah.
If all you stay to the end, we could do 2025 as well. We doing a bunch of hard maths today, you know, bunch of hard maths today. And then lastly, we have something called the power rule. So imagine I should say this. All of these rules you're learning here are reversible. And so you know about reversible reactions in chemistry?
Yes, sir.
Yes, sir.
Yeah, it is like really similar
Yeah.
here. So we could actually use these log rules reversibly. Like we could use them like you know what I mean? We could use it to condense or we could use it to unsimplify. That's how we. So imagine I had a log base A B to the power n. Using this log rule, what I could do?
It would just be
N log AB.
And
Coefficient of the log.
Now, why is this so important, chat? Why is this so important? This is important because it allows us to figure out, to find for a variable if it's raised to a power. Say you want to find for unknown, right? And the unknown is our power. Well, you could apply logs so you could bring it to the side. So let me show you guys an alternative way to answering this question. So, quick question, right? If I write LG, that's understood to be what base?
Base 10.
And
Base 10. Cool. So here what? My first step, here what, guys? When you look at this, where's my unknown? Where is my unknown?
X.
Power.
It is our power, and that is our problem. So if I were to apply logs on both sides, I'll be log 5 to the power 2x plus 1 equal to log what?
625.
5.
Cool. So here what? I just applied logs on both sides, which now allows me to use which rule?
Power rule.
Really, you bring the coefficient down.
power rule, sir.
Power rule. So I'm going to take the 2x plus 1 and bring it to the side. So I'm going to say 2x plus 1 by what?
Log
Log
5.
5.
Log 5.
And that's going to be equal to?
Log
65.
65.
6.
Right, here what, guys? We want to find for x. Right now you have the x term, which is 2x plus 1. It's there. We multiply by log 5. So to get rid of the multiplication, what could I do on both sides?
Divide.
Divide.
To divide both sides by what? What should I divide both sides by?
Log 5.
Log
Log
5.
5.
And that would leave me with 2x plus 1. Yippee! And this is good news, eh? This is real good news. This is real good news. So we have log 625 over log 5. How would I solve for x here? Well, here what, right? In the calculator, I'm sure I could plug that in. Where's log 625 over log 5?
4. 4.
Yeah, that's 4, right? Because again, what does the log function do? The log function tells us what power you have to raise the argument. It tells us the power you have to raise the base to get the argument. So like, if you see log 625 over log 5, you're really asking the calculator 5 to what power is 625? And some of you advanced students might know that this is a changer based formula here. Or you know that or no?
Yeah, sure.
Yeah. So log 625 over log 5 is going to be what? Remind me?
4.
4. So what how to do next?
Solve for x.
Oh, you understand, right? Like if you put log 625 over log 5, let me know what you guys are getting.
4.
I think getting 4.
4. 4. Good. You should get 4. You should get 4. Again, LG it means log base 10. When I move across the 1, I'm going to end up with 2x is equal to 4 minus 1. So 2x is going to be equal to 3. And then I divide both sides by 2. It's going to give me what? 3 over 2.
Yes,
Are you okay with this?
Yes,
Yes,
sir.
Here what, guys? Let's tackle the question that was in 2025. In my solutions video, I did it a long way. Let me show you guys a shortcut. Okay. So, solve the equation 3 to the power 2x plus 1 is equal to 21. Cool. So, here what, right? Who wanna work this question, mama? Any volunteers?
oh yes, sir. I see this already. I don't mind if nobody wants to.
Well, Nikolai, I know you're excited. Yeah, so Nikolai, you see how we have this is like I'm gonna show you like a quote unquote easier way to do it. So we have 3 to the power 2x plus 1 is equal to 21. Is there any okay? What base am I dealing with in this question? What base am I dealing with?
Base 3.
base 3.
Base 3. If is 3 a factor of 21?
Yes.
Yes, sir.
Yeah.
Yes,
So if
sir.
you wanted, you could have divided throughout by 3. Now here what? If you're dividing by 3 and you have if you have the same base and you divide them, what do you do with your powers?
What?
You take away?
Yeah, you take away. Well, let me explain this, right? Consider for a moment you had a to the power b divided by a to the power c. What would you do with the powers there? Since you have the same base and you divide them.
Or subtract.
I remind us.
Subtract the powers.
Exactly. So here's what I'm telling you. So I have 3 to the power 2x plus 1. And I see that, well, 3 is a common factor, 21, so I can divide throughout by 3. So if I divide this by 3, what's going to happen to the power there?
Minus.
It will be reduced.
Will be
You know
minus.
what? I wouldn't skip any working, right? I got already full working. Divided by 3 to the power 1. And what is 21 divided by 3?
7.
7.
Okay, again, you have the same base here and you're dividing. So what would happen?
It will be basically 3
Will be
2x.
minus.
Plus 1, yeah? What?
Minus 1 is equal to 7.
And what is 1 minus 1?
0, so it'll just be 2x is equal to 7.
Yo! And now this really easy to solve. This is
That's
like
it.
really easy to solve.
So could you put this in logs?
Yes, you have to put it in logs because what you're trying to find is our unknown. So now you would apply logs on both sides. So I'd say log 3 to the power 2x is equal to log 7. What next? What would I do next?
You carry across the 2x to the front. You
Yeah.
multiply basically.
So that'll be 2x log 3
Log 3.
is equal to log 7. And what would I do next?
Yes, so for 2x, which therefore will be log 7 divided by log 3.
You know what? If you wanted, you could have divide by 2 log 3 one time and hit it with one shot. Because if I divide both sides by 2 log 3, I will leave me with x one time.
Oh, well, okay.
Or let's
Okay,
see, not or no. If I divide both sides by 2 log 3 one time, what's going to cancel off on the side?
the 2 and the log 3,
To leave me with what?
x.
Yeah. And I'll get my answer just like that. Easy peasy lemon squeezy.
I believe this one was in 2025. Or was
Yep.
it? Wow.
And if you wanted, you could write 2 log 3 as what?
Log 3 to the power 2.
Power 2.
Power of 2.
Exactly. Exactly. So you're going to end up with log 7 all over log 3 squared. And 3 squared is what?
9.
9.
9.
That's your answer there. And if you was okay, do you guys know about the change base formula or no?
Change over what?
Yeah.
No.
Okay, well I wouldn't bother with that then. Most students will just leave it like this and it's fine. It's fine. Yeah. This is fine. But if you wanted to write any change base formula, this would just be log base 97. That's it.
What, that?
Yeah.
Oh,
Yeah.
okay.
So would you have to solve for x now? Like, you divide and you get
This is it.
0.88?
Oh no, this is it. If you read the question, it said they want the answer in
Exact form.
exact form. So let's run through the question again, as well as the hack that I would advise. So when you're looking at these types of questions, guys, you want to identify the base. What is the base you're dealing with in this question?
3.
Could everybody see that we're dealing with base 3?
Yes, sir.
Okay,
Yes, sir.
the next thing I want to ask myself, is 3 a factor of 21?
Yes, sir.
Yes, sir.
Yes, sir.
If it is, can't I divide throughout by 3?
Yes, sir.
Yes, sir.
Okay, if I divide throughout by 3, I have base 3 here, and I'm dividing by 3. What's going on with the powers?
We subtract.
Exactly.
Subtracted.
And that would leave me with 3 to the power 2x. Great. Great, great, great. And on the other side, 21 divided by 3 is just
7.
7.
good. No, you end up with 3 to the 2x is equal to 7. Now you are trying to find for x. Now right now, x is our power, which poses a problem. If x is our power, you need to bring it to the side. So you'd apply logs on both sides to apply which rule?
The power rule.
The power
The
rule.
power rule. So apply logs on both sides, and I take the 2x and I bring it to the side. So it now becomes 2x log 3 is equal to log 7. Now I am trying to find for x. So I would need to divide by 2 log 3 such that the 2 would cancel off with the 2 and the log 3 would cancel off with the log 3. Obviously, if I do something on one side, I must do it on the
Other side as
Other
well.
side.
good. And well, 2 log 3 is just the same thing as what?
Log 3 to the power 2.
Exactly, which is log 9.
9. Or I
And
could do-
yeah, Nikolai?
No, I was going to say what you was going to say as well, which is the log 9, 7.
Okay, yeah. Now let me show you guys something, right? Let me show you guys something. If you see LG is understood to be what base? What log base?
Base
Base
10.
10.
So let me show you something, right? Log base 10, 7 all over log base 10, 9. I think everybody should get a 0.88, but here what, Here what? They don't want that. They want the answer in the
Exact form.
exact form, which is this. Somebody asked me, why did I divide by 3? I'll explain that just now. It's just a way to make your life easier. Yeah, we just do that to make our lives a bit easier, right? Now, let me show you guys something, right? Check this out. So what was the answer I just got? I got 0.88. So another way you could write log 7 over log 9 is log base 9, 7. But like that kind of advanced though. You would typically learn the change base formula properly in unit 1 pure maths. But log 7 over log 9 is just log base 9, 7. For those of you guys that know that. but this is fine. This is fine. This is fine.
Sir,
Yeah.
every casino calculator can do what it just did, because my calculator can't do that. And it's casino.
Cause that's why I said casino, you know. But which Casio calculator I have?
I don't know. I just know it's casino.
Check the top left. It is happy number. Limit.
Yeah, look at the top left.
It don't have any number.
You can point the camera and show me.
Okay.
All right, so I will explain back the question. A lot of people in the YouTube are kind of confused. I'll have to run it back. But let me show you guys something. Right? If my answer is correct, when I input it into the equation specifically on the left-hand side, I'm supposed to get what? If my answer is correct, I'm supposed to get what?
21.
Supposed to get 21. Let me see. So 3 to the power 2 times my answer, right? Plus 1. So when I press equal, what am I supposed to get? Tell me chat.
21.
21.
Boom! Badness. All right, give back 21. Talking about. Yeah. Well, let me explain back the question, right? So, guys, when you look at this question, when you sit down and look at this question, could I write 21 as 3 to some whole number?
No, sir.
No, which kind of tells us we should probably use logs. Now, when you look at the question, what base are you dealing with?
Base 3.
Could everybody see that we're dealing with base 3?
Yes, sir.
No, LOG is fine. That's fine. So here what, right? If we are dealing with base 3, what could save you? What can make your life a lot easier is potentially dividing throughout by 3. Granted, your number here is a fact is a multiple of 3. So we understand we're dealing with base 3. That's what we're dealing with, base 3. Could 21 be divided by 3?
Yes, sir.
Yes. So if I'm dealing with base 3 and 21 is divisible by 3, the next logical move is to divide throughout by 3, and that would simplify things for us. If I divide both sides by 3, 21 divided by 3 is going to be 7. Nice. Since we're dealing with the same base and I divided by 3, what's going to happen to the powers there?
Subtract.
Powers are going to subtract. So it's going to be 1 minus 1, and that's just going to leave us with 3 to the 2x is equal to 7. Good. Now we are trying to solve for x. Right now, x is a power, and that's a problem. So we apply logs on both sides so we could bring it to the side and solve. So we end up with 2x log 3 is equal to log 7. So let me run this step back again. So guys, if I use the power rule and I bring the 2x to the side, I end up with 2x log 3 is equal to log 7. Could anybody remind me what I'm solving for? Could anybody tell me what I'm solving for?
X.
If I am trying to solve for people on the YouTube, listen up. If I'm trying to solve for x, wouldn't I want to cancel off the 2 and the log 3 to leave us with x?
Yes, sir.
Yes,
So
sir.
what should I divide by?
2 log
2
3.
log 3.
Exactly. I should divide by 2 log 3. And if I'm doing that on the left hand side, I should probably do it on the...
Right hand side.
Right hand side.
No, if you want to simplify this as much as you can, this 2 log 3 doesn't that mean the same thing as log 3 to the power 2?
Yes, sir.
Yeah, so you end up with log 7 all over log 3 to the power 2. 3 to the power 2 is
9.
9.
9. Good. So that's my advice. Cool. Right? Let's do a log graph question because I feel I have a suspicion something like that might come this year. So log says on indices, all the log says on indices questions here. All right, here's the question. So this question, I used to bring this question a lot back in the golden days. So like in 2012, they ask you to linearize the exponential equation. In 2016, they ask you to make CD subject at the formula, which is essentially linearization as well. In 2017, they ask you that. 2018, they ask you that. They didn't ask it in a while though. They didn't ask it in a while. In 2024, they ask you to express the relationship v is equal to 7 by 5 to the power t in linear form. So see, I see they bring it in 2024. But let's do the graph anyways, in case it comes. Are you guys ready?
Yeah.
Yes, sir.
Let me handle this. I go in right down, till if I get the energy, till 4 o'clock in the morning. Once I lay here, I will try to help out as much as possible. But sleep is also very important. I find like the hard maths people are a lot more serious than the maths people. I've been noticing that. Yeah. Oh, they don't play games, boy.
Yes, sir. You can't joke. One is hard maths.
Alright, so in the question, they are saying the values of P and X in table 1 obtained from an experiment are thought to obey a law of the form P is equal to AX to the power negative K. Earlier, does this look like a linear? Does it look linear?
No.
No. What is the
No.
linear? What does the linear form look like again?
Y is equal to
Y
X.
equals mx plus c.
Yeah, this this don't look linear,
Oh.
guys. This don't look linear.
First of
Uh,
all, it's a power, and second of all, it's a negative power.
Exactly. If it have a power, it's not linear at all. So get on a page quickly. So after I do this question, I will do the one in 2024, and then we're gonna move on with the predicted test that AI so gracefully generated for us. Big up the AI. Big up Claude. Claude is the best.
So what if they're using Claude and it's the same questions they bring up? So I can be real happy, you know.
Hey, next thing people lock me up and think they say hey. All right. So here what? The first question. Use logarithms to reduce the equation to linear form. So we have P is equal to AX to the power negative K. Again, the linear form is literally Y is equal to MX plus C. And if you were to plot this graph, what would go on the Y-axis?
The
The Y, right? What would go on the X-axis?
X.
X, right? And M would represent the gradient, and C would represent the what?
Y-intercept.
Y-intercept.
Good. So here what? We want to put it in a linear form. First of all, we had to get rid of them powers for sure. For sure. What do you think I should do on both sides?
The
Both sides.
I should apply what on both sides?
Logs. Base 10.
Right? I should apply logs because if you recall, a property about logs is that if I have logs, I could take the power and bring it to the side. Now here's a mistake 80% of students would make. How much of you all in the next line are going to take the minus k and bring it to the side here? How much of you guys are going to do that?
Me.
Probably me.
But let me ask you that question. Let me bring back the rule, right?
1 over log ax.
Wait, eh?
Since it's the negative
Yeah.
the 1 over
Yes, sir. I see what you're talking about, sir.
Nah, that's not quite what I'm talking about. If you have log base AB to the power n, what does the log rule tell us?
Supposed to be multiplied by, well, carry across to the log.
So that would be equivalent to n log base AB. That's what it would be equivalent to, right?
Yes.
Now, over here, isn't B being raised to the power n?
Yes, sir.
Yes, sir.
Okay, when you look at it over here, what is the only thing that's being raised to the power minus k, chat? What's the
X.
only thing? X. So is the whole thing being raised to the power minus k?
No, sir.
No, sir.
No. Again, guys, what is the only thing here that is being raised to the power minus k?
X.
X, sir.
X. So, people, are you understand why we can't just do this madness, right? Are you understand why I can't just bring the minus k to the side?
Yes, sir.
Yes, sir.
Good. What I would need to do is I would need to apply the reverse of which rule? I see in log a by x to the power minus k. I see in right. Okay, somebody just remind me of the product rule. So like if I have log base a b plus log base a c, what does the product rule state?
It's equal to log
Log
A
log A
BC.
bracket BC.
So here what I told you, you can use these rules in reverse. So we have log base, well, you know it's base 10, right? We have log and you have a by x to the power minus k. So if I use it in reverse, what would it become?
Wouldn't it be log A?
Oh, listen, log a plus
KX?
nah. So Nikolai, watch. If I had log base ABC, that would be log base AB plus log base AC.
Uh-huh.
So I have log A, I have log A by x to the power minus k. So that'll be log A plus what?
X to the minus K.
I'm forgetting something. Plus what?
Log.
Log.
And you can see, if you wanted to apply the product rule here, and that would just be log A x to the power minus k.
Yes, sir.
So we're just working backwards. We're just working backwards as well. A little bit more now.
Yes, sir.
Yes, sir.
Again, somebody could just remind me why I didn't just take the minus k and bring it down.
Because it was minus k to the power x alone.
Right, x to the power minus k. X was the only thing being raised to the power minus k. Good. What to do in the next line?
Move the k.
Now you
Yeah.
bring France.
And well, they have a plus there. If you bring down the negative k, positive and negative is a what?
A negative.
Negative.
Are they with me so far now?
Yes, sir.
Don't worry, guys. We will do probability, but I'm gonna be to the end since you know it's the last section. We have a lot of time. It's 12 hours, 12 hours is a lot of time only. So here what? We want to put that in the form y is equal mx plus c. That's what we want to do. That's what we want to do. So here what? Let's identify our variables, right? So we have variables x and p. You'll see why I'm doing this. So what are my variables again?
X and P.
X and P. X and P. Good. Can we see that it's kind of looking like y is equal to mx plus c? Like it kind of looking like what? Kind of looking like that. Kind of.
Yeah.
Yeah.
So like what looking like y? What look like it? What looks as though it on the y-axis?
Log
Log
p.
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 Log p. If you're confused, watch. Now here what? Right? This term over here, it must have a variable in it. Is log a is that gonna be a variable? Log a?
No, sir.
No, sir.
So here what? I would need to switch around this order. So I would say log p is equal to what?
Y.
Now I had to switch around this order.
Minus
Log
K log X plus A.
Good. Minus k log x plus log e. So when you compare it now, could somebody tell me, like you should be able to see it now. What is y?
Log P.
Log P.
Right? What is m? What is m?
K.
Minus K.
Oh, minus K. Yeah.
Right? So you're seeing y over here. Can you guys see that m is the minus k?
Yes, sir.
And can you guys see that what representing x is the log x?
Yes, sir.
Yeah.
What would represent c, the y-intercept?
Log A.
Log A.
Log A.
Okay, let's show a little bit more now.
Yeah.
Yes, sir.
Yes, sir.
Okay, so again, why did I tell you guys to identify the variables? If you know the variables are x and p, right? If it don't have x and p in it, that automatically makes it a what? If it don't have x and p in it. If x and p are the variables, then every other term will be a constant. Yes, yes. Guys, x and p are the only variables. So then all my other terms have to be what?
Constants.
Constant.
Exactly. So when you look at this, right, this is a variable or a constant term?
Variable.
Constant. Oh,
No. Look, check it out. These are the variables, x and p. X and p are the variables. So log p is a variable or a constant term?
constant.
Variable.
Variable. Sorry.
Right, variable. Is log e a constant term or a variable term?
Constant.
Constant.
Right. Is minus k a variable or a constant?
Constant.
Right? How about log x? Log x is a what?
Variable.
Variable. Good. So if I want to put it in the form y is equal mx plus c, y is a variable. So log p is already where it should be. M is a constant. So, put the minus k there. X is a variable, log x is a variable, and c is a what?
Constant.
Right, so I put it there. So do you guys understand why I have to rearrange this in this format?
Yes, sir.
Yes.
So if I want to plot this graph to linearize it, I'll have to plot log p versus what?
Negative k log x.
Log x.
X.
Not negative k log x. Remember, m is negative k, m is negative p. What represents x?
Log x.
Yes.
Okay.
So if I want to plot a linear graph, I need to plot log p versus what?
Log x.
Yeah. All right, let me run through the process one more time because I've seen people on YouTube finna crash out. All right. Does this look like y is equal to mx plus c?
No, sir.
So,
No, you clearly seen a power, right? You seen x to some power. That is not linear. So you need to get rid of that power. And to do that, you'd have to use the power rule. So the first thing I did was I applied log on both sides. So I say log p is equal to log ax to the power minus k. Why did I not bring the minus k to the side? Someone fast.
Because only x is being raised to
Only
minus
x is
k.
being raised to the power of minus k.
Right, only x is being raised to the power minus k. So I won't do that. Instead, I wait to realize I have log a multiplied by x to the power minus k. So what rule could you use in reverse?
The product rule.
The product rule. And that's how I ended up with log a plus log x to the power minus k because I use the product rule in reverse. Over here now, you're seeing that x is being raised to the power minus k. So what rule could I now utilize?
The power rule.
Right. So minus k log x. No, this is not in the form y is equal mx plus c just yet. Y is equal mx plus c looks like this. You start off with a variable here. The gradient is a constant. You have a variable here, and you have a constant value here. So quickly, our variables are x and p. X and p are the variables, right? X and p are the variables. Is this a variable term?
Yes, sir.
Yes,
Yeah,
sir.
this is a variable term, right? And it represents y. That's what we're going to plot on the y-axis. Log a, is log a variable term?
No, sir. It's a constant.
It's a constant. Then should it be by the mx part?
No,
sir.
sir.
No, it should not. Minus k, what's that?
The gradient.
That's- Yeah, it's a gradient. It's a gradient. Yeah, but that's a constant, right? And log x, is that a variable or a constant?
A variable.
Good. So I hope you all could see why I rearrange it. I hope you could see why. M is a gradient, it's a constant. We plot in x instead of x, we plot in log x. And you should understand that x is a variable. And c is the y-intercept, and that's given by log e. The variables are x and p. If you have log e, that's a constant. So do you guys understand why I'm saying you have to plot log p on the y-axis and log x on the x-axis?
Yes, sir.
Yes, sir.
All right, cool. I'll let you know when people want to break and we just start. Exactly, Damel. We just start. I don't know why we want break and thing already. What is that? What is that about? All right, so that is how you linearize any exponential equation. Okay. Part 2. Using a suitable scale, plot the best fit line of the equation in C part 1. So, for us to get a linear graph, one needs to plot what against what? Remind me.
Log P versus log X.
Do you guys think I'm going to plot x against log p? I mean x against p.
No.
No, sir.
No, so I need to go and find log x and
Log P.
Log P.
cool. You understand what I'm saying, right? Because for us to get a linear graph is log p versus log x. So you need to find the values for log p and log x.
Yes, sir.
Right, so again, LG is understood to be log base 10. Okay? So in the calculator, where to put log base 10, 1.58, and tell me what you get.
So can I just put log, but not by base 10?
So that again?
Okay, like on the calculator, you could just press shift and log.
Yeah, you could just do that. You could just do that.
Oh, wow. I get 0.19, well, 0.20 to 3 significant places for the X.
Well, round it off to 2 decimal places. If I round it to 2 decimal places, what again, guys? 0.198. What would I get?
0.20.
Yeah. Okay, what is log 2.51? 2.51, what's that? What's that?
0.40.
Right? I only hear Nikolai, you know. I only hear my son. Yeah, boy. Nikolai.
Trust I hear.
People go think Nikolai, people go really start to believe he's actually my son. And people go actually start to think he's my son.
Yep.
Yeah. People on YouTube,
Sir.
with the people on YouTube, they think Nikolai is actually my son. I'm just curious. Yeah, but what again for log 3.98?
0.60.
I just say Nikolai.
0.6.
Okay, what is log 6.30? Wait, what do you think the answer will be? No, this is like a linear pattern, right? 0.2, 0.4, 0.6. I bet you the other one will be 0.8. And I bet you
Yeah,
the
0.8.
right. And then this gonna be 1.00. Cool. Because you know it's log base 10, 10, right? Log base 10, 10 is 1. It is 1. You know what I mean? Log base 10, 10 is 1. Because to get 10, you raise 10 to the power 1. Yeah. Cool. Let me do it for
Sir, isn't that another algorithm rule?
say that again.
I'm saying that isn't that an extra rule for our algorithm?
When you
When
say
the base
algorithm,
and the number is the same, it's equal to 1 automatically.
yeah, I guess you could say that. Yeah, I guess you could say that. Right? Let me do log P now. So that's
First
gonna
one, I
be
get 2.08.
2.08.
2.08. Okay. How about the next one?
2.04.
Are they getting that?
Yes, sir.
Yeah.
Um,
2.2 for the next
I
one.
skipped
That's
the gun.
2.02.
I skipped the gun. Mazak, yes, this is 2.02. Well,
The one before was 2.04.
when I run it off to 2 decimal place, I get 2.03 for 106.2.
Oh, wow. Yeah.
Yes, sir.
Then we have log base 1099.1.
I get 2.
Yeah, 2.00. Right? And then we have 93.8.
I get
You could say 2.1 or 2.
I see in 1.97 for 93.8.
Yes, sir, that's what I got.
Yeah, me too, sir.
Remember, it's log base 10. Alright? 1.97. So if we are plotting a graph of log p versus log x, then let me come up with my points quickly. So again, guys, this is the graph we're plotting. Log p versus log x, okay? Log p versus log x. What is my first point going to be?
0.20. 2.08.
If you're confused, right, when you're labeling your points, and just say the x value first and the y value.
Yes, sir.
Right, so the x value here comes like the log x, which is 0.20. The y value comes like log p, which is 2.08. What's my second point?
0.40. 2.04.
But it can really help you out and give you the scale. Yeah. I just hate to come up with scales.
Zero
Like that's
point
a waste of time.
See, they doesn't have to give us the scale.
Once in a blue moon. Once in a blue moon. I've seen it before.
That blue moon not happening today, sir.
Nicola, I remember when we did that question from 1972, and they did give us a scale.
Yes, sir.
Yeah. It's quite a blue moon. Quite a blue moon if you ask me. 1972. Are these all the points or not?
Yes, sir.
Yeah, are they okay with this, right? I'm only if are they okay with this.
Yes, sir.
Right.
Yes, sir.
Okay, bet. Let me go now. Let me tackle this. It's gonna be easy. Alright, so on the y-axis, I'm plotting log what?
P.
I hope to God this come tomorrow because something in my gut telling me it coming. I don't know what it is. If not a graph, just put it in linear form. That's what I feel. If not a graph, at least just linear form. And don't worry, we could do some on product too. I feel like that might come.
As with the alpha and beta you're talking about.
Yeah. Vieta's last theorem. That's the proper name for it. So we're plotting, what's saying log y, but and it was log p on the y-axis, chat.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, yeah. Trust this use. And it was log what on was log x.
Yes, sir.
Yes, sir.
Yes, sir.
Alright, let me come up with a scale for the x-axis now.
So why put X? Oh no, it is X. My bad. I thought I make this mistake now.
No. So on the x-axis, our smallest value is 0.2 and I go up to 1. Anybody can come up with a scale?
2 centimeters is 0.20.
Every what?
2 centimeters.
Yeah, I agree. So wait, every 2 centimeters is what? Say it again, and I'll tell you if it's correct.
0.20.
So effectively, you're just saying every 1 is 0.10.
Yeah. Yes, sir.
Let me see.
But not real small though.
Yeah, but this gotta work.
So would it deduct max if it does be too small?
Well, you could extrapolate a graph. Meaning you could like remember it's our best fit graph. So like if you have a bunch of points like this, and you're just gonna draw like you know what I mean, you can extrapolate the graph.
Yes, sir.
Extrapolate the graph. It'll be like in physics, they're a lot more stricter with the graphs, I would say. You can't play with physics. So like here what, right? Let me explain the scale. So these represent the values that are gonna go on my log x axis. So I had to go from 0.2 to 1. So the easiest scale to pick. Essentially what Nikolai picked is every 1 centimeter is 0.10. That's one. Which is equivalent to every 2 centimeters is 0.20. It works out anyways. Alright. Okay, this is the trickier one. Alright, so we need to make a really broad scale here. So like I thinking like 10 centimeters is 1. That's what I thinking. Let me see. 6, 7, 8, 9, 10. I'm corner back again. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 1.00. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Think it would work? Yeah, that should work. So if I say that, then every one will be what? If I say every 10 centimeters is one, then every one big block will be what?
1 or 0.01.
0.10, right?
Yeah.
Cool. You know what? I should just label it like this. So 0.20, 0.30, 0.40, 0.50. Cool. Can anybody tell me what this would be? 1 point what?
1.10.
Right. Like it, I will tell Romano to come and support you.
Alright. Yeah, we go bring him in.
Bring more that son. Yeah, and that scale would fit what we have. We had it's from 1.97 to 2.08. Yeah. I would not recommend cutting the x-axis because the y-axis because you want to find the intercept. Anytime you want to find the intercept, you should not cut your axes. All right. But like this scale gonna be problematic because like everything just gonna be like over here. The only way to do it is now you would have to cut it. You'd have to cut it. You'd have to cut it. Yeah, yeah. Because like watch like 1.97 to 2.08 are like real close over there. That's gonna be problematic. You gotta cut it then. You gotta cut it. Now keep in mind this scale this scale I come up with over here is just a random thing. I take a screenshot of it. I don't know what the actual graph would look like. But this this wouldn't work. I hope all you understand why it wouldn't work, because it's from 2.08 and 1.97. If I use this scale as it is right now, then my graph will be like it will be something like this.
Yeah, I have.
That don't make sense. So it's a good thing I'll see in my thinking through the process. I got how to cut the axes and how to cut the axes, even though I wouldn't advise it. If I cut the axes, what value I think I should start from though? Any suggestions? If I do cut the
1.80.
1.95?
Nah.
1.95. Okay. 1.95. 1.95. Like that could be fine. But just to be on the safe side though, I'll say 1.90. Just to be on the safe side. And what scale I should use here?
We're still gonna buy 0.10.
Yeah, we could still do that. Would that be advisable? Nah, that wouldn't be advisable. Because if I start at 1.90, then this would be, and I'm going up by 0.10, and this
You
would be
can go by 2
you say go up by 2?
for every 2 block. You go by 0.1.
Yeah, we
Okay.
start at 1 block.
Okay. That's a good scale. That's a good scale. Every 2 centimeters is 0.01. Yeah, that's a good scale. And so if we're using this scale, then what would this be? This would be 1 point what?
92.
Yeah. And what would this scale, what would this be?
93.
This would be 1.94. I just worrying about if it go fits. Let me just do that quickly. 5, 6, 7, 8. Now that wouldn't fit. That wouldn't fit. That would not fit. First out of 1.95 or 1 that would fit point. Let me see. Come on a second. 6, 7, 8. 6, 7, 8, 9, 2.2, 2.1, 2.2, 2.3, 2.4, 2.5. Nah, that wouldn't fit. That scale wouldn't fit.
I had scaled it to 1.95 and I used 1 centimeter to represent 0.0.
Okay. Yeah, because if I use 2 centimeters to represent 0.01, I'm not gonna work. I'm not gonna work. So if I do that, then this will be 1.96. What would this one be?
0.97.
All right, we're just going up. 1.98, 1.99, 2.00, 2.01, 2.02, 2.03, 2.04, 2.05, 2.06. Okay, cool. And when you drew the graph, right, was it able to cut the x-axis? I mean, the y-axis, the y-axis,
I think so.
Because here what, right? The problem with cutting the y-axis is that what if you cut the y-axis prematurely and your y-intercept is before that? That's typically the problem. So like imagine you draw a graph, right? Imagine you draw a graph and the points form and the line for and the y-intercept is below where you cut it. That's typically what we worry about. But this seems like it would work. So let me just explain everybody the scale, right? So the x-axis scale was really simple. It was 0.2 to 1. So we could have said every 2 centimeters is 0.20. That worked fine. That wasn't a problem. Let's look at the y-axis now. The y-axis is a really slim range, It's a really narrow range. 1.97 to 2.08. So you need to spread those values a lot. Now, seeing that we started at like 1.97 and we're going to 2.08, even though I don't want to, you have to cut the y-axis. So we cut the x-axis at like 1.95, and we said every one big block was 0.01. That's what we said. And that fits everything. So let me put on my first point. So my first point is going to be 0.20, 2.08. So 0.20 is here and 2.08 is right here. So my first point is going to be over here. Is there anybody confused as to how I got my first point?
No, sir.
All right. My next point is 0.4, 2.04. So 0.04, 2.04. That is going to be right here. My next point is 0.6, 2.0, 2.03. Right? My next point is 0.82. Then 1.97. 1. Okay. Right, let me follow okay with that.
Yes, sir.
Yes, sir.
Okay, now we could draw a best fit. So I'm gonna put on my ruler and I want you guys to tell me what would be a good best fit. Would this be a good best fit?
No, sir.
No. Would this be a decent best fit?
Yes, sir. That one.
Yes, sir. That's good.
Okay, that would.
Yes, sir.
Okay, so that will have to work. Cool. When you draw a line, what are the main things you need to know about the line, guys? For a line, what are the main things for a line? Remind me. The gradient and the what?
The line going down the grid will be negative.
Intercept.
Right. So here what? And we could read off the intercept one time.
Yes, sir.
You can see the intercept right here, right? Or no? You can see it.
Yes, sir.
I see it.
Okay, now our scale, we decided to say every one big block, so one big block, which is 5 small blocks, is equal to what? We said 5 small blocks was equal to what?
10. Well, basically. No, not 10.
0.
0.01.
So if 5 small blocks is 0.01, what would one small block be?
0.001.
It would be 0.01 divided by what?
Divided
5.
by
5.
0.002.
You got 0.002. Let me know if you guys getting that. 0.002.
Yes, sir.
So that would mean every small block is what? Every small block is what?
0.002.
So how much small blocks are going up by here?
2 small blocks.
Good. So this would effectively be 2.10 what?
4.
Are they okay with that or no?
Yes, sir.
So again, 5 small blocks is equal to 0.01. To find for one small block, you divide that by 5. And so one small block is going to be 0.002. We went up by 2 small blocks. So that's going to be 0.004. So you add that to 2.10 and you're going to get 2.104. For anybody that did this already, did you all get something close to this?
Yes, sir.
Right. 2.104. Right, 2.104. So that is my y-intercept. Let me know if you guys okay with that part.
Yes, sir.
Okay, cool. In the next question, they're saying hence estimates the constants a and k. So let me show you how we're going to handle this. From this, remind me, what did the gradient represent? What did the gradient represent?
Minus k.
Right, the gradient represented minus k. So I'm going to write that down. The gradient is minus k. And what did the y-intercept represent?
Log a.
Log a. So the y-intercept is log a. Are you guys, do you all understand that part? So the gradient
Yes,
will
sir.
give us minus k.
Yes, sir.
Oh, this is 2017. And the y-intercept would give you log a. Good. So here's what I'm going to do, guys. We already know that the y-intercept is what? What is the y-intercept?
2.104.
Right. So 2.104 is equal to log base. And instead of writing log, I'm gonna write the specific base, right? Log is understood to be log base what?
10.
Good. All you understand everything so far? So the y-intercept is 2.104, which is equivalent to log e. Do you all understand that so far?
Yes, sir.
Here what? To solve this, you could say 10 to the power 2.104 and 10 to the power log base 10a, and that would give you a. I'm not sure if you guys know this trick. Do you all know this trick or no? It's called anti-logs. Okay,
Yes.
if you don't know this trick, you could always just convert it back to index form. Do you guys know how to convert logarithm form to index form or not?
No.
Yes.
Okay, if you don't, let me show you an easy way to understand it. Check it out, right? 9 to what power would be 81?
2.
2.
9 to the power 2 would be 81. How would this look like in log form?
Log 2, 81. Wait, log 9.
Log
81
base
equal
9,
to 2.
81. Right, because the log function allows us to find the
Power.
power. Yes, that's what the log function allows us to do. So I want you guys to look at this as an example and apply the same concept here. So convert it to index form for me. So if I were to convert this to index form, what would that look like?
log 10 of 2.10.
Nah. You convert. Right now it is in log form, so convert it to index form.
Oh,
So check it out, right? Log base 981 is equal to 2. In index form, that is 9 to the power 2 equal to 81. So how would this look like in index form?
10 to the power of 2.104 is equal to A.
Correct. If you don't want to do it like this, that's fine. That's fine. I'll show you the hack. But this is how it would look like if you converted it to index form. So Nikolai, let's go over it one more time. Right, so Nikolai, we have 2.104 is equal to log base 10a. Let's look at this example here where we converted from index form to log form. So we have 9 to the power 2 is 81, which is log base 9, 81 is equal to 2. So Nikolai,
yes, sir.
I want you to apply the same concept here. So imagine for a second, you had log base 10a is equal to 2.104. What would the corresponding index form look like?
Mm, 10 to the power 2.104 is equal to A.
Correct. So if I wanted to find for a, then a would just be 10 to that power. And could anybody plug it in into their calculator and let me know what you're getting?
127.06.
127.06.
Yes, sir.
Yes, sir.
Now here what? If you wanted, there's another way you could have answered the question, right? And this is called anti-logs. So what base am I dealing with in this question?
Base 10.
Base 10.
So a really simple thing you could do, you could just say 10 to the power 2.104 and 10 to the power log base 10a. And that would give you an answer. So 10 to the power 2.104, that's 127.06. And 10 to the power log base 10a would just be what?
A.
That'll just be a. So whichever way you want to do. If you want, you could convert the log form to the index form, or you could just use anti-logs. If the base is 10, you say 10 to this and 10 to this. The 10 and the log base 10 will cancel off to just give you a. Which way do you all prefer? Converting it to index form or just anti-logs?
Index form.
Index.
Okay, no problem. Good. So we found for A. We found for A successfully. Although I feel like so much people are confused right now. Although understand how I find for A?
Yes, sir.
Yes, sir.
So you understand from when we wrote it in the linear form, you saw that C represented what? What did C represent?
The y-intercept.
Which was log A. So we know that C is equal to log A. When you read the graph, you're seeing that, C is 2.104. So 2.104 is equal to log base 10A. So if you want to find for A, you could just convert that to what form? I could just convert the log form to the what form?
Index.
The index form. Right. So 2.104 is equal to log base 10A would just be 10 to the power 2.104, which is equal to A. And so A would be 127.06. If you didn't like that index method, you could just use anti-logs. So if we're dealing with log base 10, then you could just say 10 to the power 2.104 and 10 to the power log base 10A. The 10 would cancel off for the log 10, and that would give you A. So A would just be 10 to the power 2.104. And you get your answer. Let me know if you're okay with that.
Yes, sir.
Yes, sir.
Right.
Yes.
So now they're telling us the gradient is equal to negative k. So if I want to find for k, I'd first need to find what? What do I need to find for, guys?
We're talking about for A.
We already found for A. A is 127.06.
Oh, we are find for K.
How would I do that?
Well, isn't it
Where
gradient
is it?
equals to K?
Say that again.
Is M considered the gradient here?
Yeah, M is the gradient. M is the gradient. M is the gradient.
Therefore,
M
we
is the
find
gradient.
M, which is the gradient, which is equals to minus K.
Cool. So we have to find ingredients, right? To find ingredients, we need 2 points on this graph. We already have 1 point over here. Can anybody read off this point for me?
0 and 2.104.
Okay. Let's look for another. Oh, this is an easy point. Could use this point here. Could anybody read off that point for me?
0.40 and 2.05.
0.40 and 2.05. So, which one do you want to label x1, y1, and which one do you want to label x2, y2? Doesn't matter.
X2, Y2 is underneath.
It don't matter. It really doesn't matter. It doesn't matter. And we'll get the same answer anyways. Yeah, we'll do kinematics. So here, we'll call this one x1, y1, and we call this one x2, y2. But again, it really doesn't matter. So how do I find ingredient? Remind me.
Y2 minus
Y2
Y1
minus
over
Y1.
X2 minus X1.
Cool. So what's y2?
2.05,
What's y1?
2.1.
2.1.
Right, 2.104. X2 is 0.40, and x1 is
0.
0. So plug that into your calculator and let me know what you guys are getting for gradient.
Minus 0.135.
Say that again.
Negative 0.135.
Is anybody else getting that? Is anybody else getting that?
That's it.
Okay, good. So that's the gradient. So the gradient is minus 0.135. So here what? The gradient is minus, I think it was minus 0.135. Yeah, minus 0.135. And that's equal to negative k. So guys, if that is equal to negative k, what is k?
0.135.
Yeah, k would just be 0.135. So guys, if the gradient is negative 0.135 and that's equal to negative k, then k would just be 0.135. If you wanted, you could have multiplied both sides by -1, but that's not necessary. No, anybody could join these Zoom meetings, anybody could join these Zoom meetings. Yeah, anybody could join these Zoom meetings. This is free. All this is free. I'm Santa Claus right now. Everything is free. Yeah. Do you guys understand how I got k to be 0.135?
Yes, sir.
So all I had to do was find ingredient because gradient was equal to negative k. So I found ingredient, and ingredient was minus 0.135. If minus 0.135 is equal to negative k, I hope you can see that k is just 0.135. So E is literally just 127.06, and k is equal to what?
0.135.
The only problem is, it's just me alone. I cannot short staff. I can't really reply to messages and thing when I'm teaching. All right. Yeah, they will have a range for these answers. I don't expect it to be 100% exact. They will have a range. Can't tell you the range specifically, but they do have a range. So if a question like this comes, remember this. Remember this session today, please.
Sure.
Let me just do one more similar question, and then we're gonna move on with the practice test. Let's do these log questions from 2024, and I call it a day when it comes to logs. Okay. Because real people was asking for logs, helping logs. Right. Let's tackle 2024 the log questions there. So write the expression 2 log base 3x plus 2 minus log base 3y as a single term. Would you all say this is a hard question or an easy question?
No, normal.
Normal? Okay. Before I explain this, right, they say they want the answer in a single term. For us to utilize the log rules, you must have the same what?
Same base.
You must have the exact same base. So watch. If I have log base AB plus log base AC, what would that be equal to?
Log
A plus
B.
BC.
Yeah,
I'll be
B.
log base ABC. And I can only do that because they have the same log base. If I had log base AB minus log base AC, what would that be equal to?
Log A
B
Log
plus
A.
B divided by C.
B was A.
And the only reason I could do this is because they have the same base. Which brings me to another point. Question, guys. If I had log base 3, what do you suppose that is? Log base 3.
1.
1.
1.
Because remember, the log function asks us what power would you have to raise the argument to get the argument. So like what I'm explaining. If I have log base 3 and I put in 3, what do I have to raise 3 to get 3?
1.
1.
Okay, let me give you another example. If I had log base 9, or what do I have to raise 3 to get 9?
2.
2.
Yeah, my one.
So this is how the log function operates, right? So let me show you something really cool about it. We know log base 9 is equal to 2. But if I had log base 9, and I could write 9 as 3 to the power 2.
Yes, sir.
Okay, and then I could take the 2 and bring it to the side.
Yes, sir.
Yes, sir.
Where's log base 3?
1.
1. So 2 by 1, which is 2.
2.
Good. I'll probably understand where I'm going with this, right? I hope you guys understand where I'm going with this.
Yes,
Let's just say I had a number like 9, right? Isn't 9 the same thing as 9 by 1?
Yes, sir.
If we want to use log base 3, how could I write 1 using log base 3?
Log 3 of 9.
No, I'd say log base 3.
Oh,
Nikolai, where's log base 3?
that'll be 1.
Right. So is there any difference between this and this?
Mm,
People in the class, are they real quiet? Is there any difference between this and this?
No, sir.
But is
No.
my answer correct?
No, sir.
Why I say log base 3 and 9?
Say that again?
Was my answer correct with log base 3 and 9?
Nah. So what I could do next, you see how we have the 9 to the side? What I could do with the 9 to the side?
Carry it across, so it'll be a comma power.
Exactly. And so that would be log base 3 to what power?
9.
Exactly. So you could represent any number in terms of a base if you want using the same technique. So let me give you another example, right? Say you wanted to write a number using log base 7. Stay with me, right? If I wanted to write a number using log base 7, remind me, what is log base 7?
1.
1. So if I wanted to write 8 in terms of log base 7, and I could say 8 log base 7, what? 8 log base 7.
7.
7.
And then I could take the 8 and bring it up to the top, and that'll be log base 7 to what power?
8.
Cool. So I explained that for a reason, I explained that for a reason. Because when you look at this question, you have 2 log base 3x plus 2. Is it 2 in terms of log base 3?
No, sir.
No, sir.
No. Could I represent it in terms of log base 3?
Yes, sir.
Yes, sir.
Yes, I could. This is already in terms of log base 3, so we're fine. So here's what I'm going to do. So we have 2 log base 3x, and you see this plus 2 over here? Isn't 2 the same thing as 2 by 1?
Yes, sir.
And instead of writing 1, what could we write?
Log base
Log
3
base 2.
of 3.
Exactly. Is anybody confused by this?
No, sir.
No, sir.
Because guys, remind me, log base 3 is what? What's log base 3?
1.
What's 2 by 1?
2.
It's 2. All the math haters like dogging on the add maths people. Add maths is amazing. Add maths is fun. If you hate maths already, well, I don't anticipate add maths being fun, but if you like maths, add maths is fun. Right? Minus log base 3y. Let me explain it back one more time. If we want to write this as a single term, then what do we need? Well, we need to have the same log base everywhere. I have log base 3 here. Do I have log base 3 here?
No.
No. But I could say 2 what? I could say 2 what?
Log base
2
3.
log base 3.
I could say 2 log base 3 because we know log base 3 is 1 and 2 by 1 is 2. Okay, cool. So now I could start to condense this. You see in 2 to the side here, what could do with that 2?
Put it to the power of x.
You see this 2 over here, what could do with that 2?
Put it to the power of 3.
Yeah. And what would that become? Anybody?
That would be log base 3 of x squared plus
Yeah.
base 3 of 3 squared
Right.
minus
Minus.
log base 3 of y.
Right, so far we're going good, team. We're going good. We're going good. We are going good. We could simplify this though. What is 3 squared?
9. Hey, look, the 9.
That way we're telling no.
Yeah.
Oh, Nikolai, I feel like it's telling me the right thing, but just not understanding what you're saying. So guys, do we have the same log base throughout here?
Yes.
If we have the same log base throughout, and we could start applying product and quotient rule and thing.
Yes, sir.
Yes, sir.
If I applied it, what rule would I apply there? Since I'm adding and I have the same log base, what rule would I apply there?
Product rule.
I'd apply the product, and so I would turn to log base 3 what?
X squared
9x
multiplied by 9.
Plus
X squared by 9 is correct. So, which is 9x squared. And then we have minus log base 3 y. So, what rule would I apply here?
Quotient.
Quotient rule.
And that would turn to log base 3 what over what?
9x squared divided by y.
Correct. And just like that, we have our answer here in a single term.
Yes, sir.
All right, let me know if you're okay with this.
Yes, sir.
So somebody in class, if I had something like plus 7, how would I write that in terms of log base 3?
7 log base 3.
And then I would do what with 7 to the side.
Move it and make it a power of 3.
Right. I feel like this is unfair now because Virginia, you in Form 4.
Oh, well, we did this already. I got this for Anderson before.
You gotta write this exam next year. Then gotta write it tomorrow.
Whoa.
But it sounds like you could write the exam tomorrow. It sounds like the exam. So it sounds like if you had to, you gotta get through.
I hope so.
So I think it'd be a private candidate and write in June for Add Math.
Yeah, you could be a private candidate and write in June. Anybody here doing paper 3 for Add Maths? Because I want to do some paper 3 sessions as well. For free, of course.
Yes, sir.
Okay, well, I will do some paper 3 sessions. Okay. We go with this or nah?
Yes, sir.
Okay, if I had something like minus 21 and I wanted to write that in terms of log base 8, how I would do that? Somebody other than Virginia.
21 minus 21 log base 8, or when it will be like log base 8 to the power negative 21.
So it would be log base 8, it would be minus 21 by log base 8, and then I would take the minus 21 and bring it up to up here. Be 8 to the power minus 21. Yeah. Cool. Cool.
So,
Yeah, somebody was saying something.
so if I explain the question you did over again, I don't really fully understand.
All right. Are you familiar with the product and the quotient rule?
Yeah.
All right. Wait, good notes being annoying. Right. What?
Good notes
What?
being bad
Good
notes.
notes. Fed up. Our good notes enough. Fed up.
Bad notes now.
And I close the whole thing and open it back again, and it still have the glitch. Gosh, man. All right. Abija. Is that what I'm saying him?
Yes.
Right. So for us to use the product and the quotient rule, I must have the same log base throughout. When you look at this question, we have log base 3 here. That's fine. We have log base 3 here, but is 2. That 2 there is a problem. That 2 there is a problem, Abija. That 2 is a problem. You understand? That 2 is a problem.
Yeah.
Because is the 2 in terms of log base 3?
No.
No. Abija, just to like assess it quickly. What would log base 3 be? Abija, do you know what log base 3 would be?
3.
Nah, that'll be 1. That'll be 1. Let me explain how the log function is work quickly. So if I had log base 981, Abija, do you know what the answer would be?
9 to the power 2.
The answer would be 2. The answer would be 2. Just 2.
2.
Because the log function tells you what power you'd have to raise a number 2 to get the desired result. So if I want to get 81, I have to raise 9 to the power 2. So log base 981 is 2, right? So what do you think log base 9 is?
1.
1, because I had to raise 9 to the power 1 to get 9. So generally speaking, Abija, log base A is equal to
1.
1. Cool. Cool. You see, understand that?
Yeah.
All right, so stay with me. So again, I said 2 was a problem because 2 is not in terms of log base 3. So here what? Ends I can write 2 as 2 by 1.
Yes, sir.
Okay. And we know that 1 is the same thing as log base 3 what?
3.
Right. So I wrote the 2 as 2 log base 3. And so now, Abija, do I have everything in terms of log base 3?
Yes, sir.
Yeah, so now I can start utilizing the rules. So the first rule I could apply is the power rule. So you see how I have 2 to the side, I could take that and bring it up by the base here. So that would turn to log base 3x squared. What do you think this would turn to?
Log base 3 squared.
Exactly. Cool. And well, this is just log base 3y. So I'll write back this. I didn't do anything with that. That's just x squared. 3 squared is what though? What is 3 squared?
9.
Cool. Say with me so far, right?
Yeah.
So anytime you're adding logs and they have the same log base, it could just do the product of what's inside each log. So I have x squared here and I have 9. So if I'm adding them and they have the same base, that would just be x squared by 9, which is
9x squared.
cool. All right, back to minus log base 3y. And over here now, you see that I have 2 logs and I have a difference. So which rule I should apply here? Product or quotient?
Quotient.
Good. Anytime you have a difference of 2 logs and you have the same base, quotient. So that'll be 9x squared over
y.
Good. Cool. So and in the question, they wanted me to write this expression as a single term. So I had to do as much simplifying as I could. But to do any simplifying, everything had to be in terms of the same log base, which was log base 3. So I had to write 2 as 2 log base 3, which then turned into log base 3, 9. And then I could, start applying the log rules. Yeah, let me know if you're okay with that.
Yes, sir. Thank you.
Okay, no problem. Okay. Let's tackle B now. Anybody want to help me with B?
So I don't mind.
All right. All right, guys. If all your hands, if all you're taking the opportunity, Nicola, go taking the opportunity, just like you just take people X's. Peak math vibes low. Peak math vibes low. Nobody, no outside people wouldn't get that. Outside people wouldn't get that. But yeah, guys, Nicolai's are jealous. anyways, I'm joking.
All right, sir.
All right, yeah. So part one, by using logarithms, express the relationship V. So we want to express V is equal to 7 by 5 to the power t in linear form. In linear form. First of all, guys, is this linear form?
No.
No.
Because you have a what? You have a what there? You have a what?
Exponent.
Power.
You have a power. So, Nikolai, what should I do next?
You should put everything to log first.
Right, so I could apply log. Oh, we're worm. The person has a worm. On TikTok, I live on YouTube right now. It's clear as day on YouTube. Math vibes. Go on YouTube channel. Go on my YouTube channel and you'll see live. So that will be log V is equal to what?
Log 7 multiplied by log 5.
Whoa. No.
It will be T log
Wait,
7.
no. Let's take all the time. Take all the time. Let me just run through the mistakes students will make there, right? I know for a fact some students will say log 7 multiplied by log 5. That's wrong. That is wrong.
Ah,
Nikolai, you're going to apply logs to both terms. So what is the term on the right hand side, Nikolai?
log 7 multiplied by 5t.
Right, 7 by 5 to the power t. So you're going to apply log to that whole thing.
So you change to add because it was the product of the when you multiply. No, when you add two logs.
Yes. Correct. Now before I move on though, guys, how much of you guys are thinking to take the t and bring it to the side? How much of you guys are thinking to take the t and bring it to the side?
Me.
That's wrong. What's the only thing that's being raised to the power t?
5.
5.
You guys, you see if it was 7 by 5 to the power t, but the whole thing was being raised to the power t? Yeah. But when you look at this, what's the only thing being raised to the power t?
5.
5.
So you cannot do that. What you could do though, like Nikolai suggested, you're seeing a product of two terms here. A product of two terms. So what you could do then, Nikolai, in the next line, what you could do?
It will be log 7 plus log
Mm,
t. Well, to the power t.
good. I'll understand what happened there, right? Because you have a product of terms on the inside.
Yes.
Yes.
Sai, DeAndre, I'll understand?
Yes, sir.
And Sai, you see how we have 5 to the power t now?
Yes, sir.
What could you do now?
Now you can put the T in front of the log.
Good. That does it. So it'll be log v is equal to log 7 plus, and I'll take that t and I'll bring it to the side.
Should be t log 5.
Excellent. Now, we want to put this in the linear form, express it in the linear form. What's the linear form?
Y is equal to mx plus c.
Y is equal to mx plus c. Is it quite in the linear form, or we have some work to do?
Have some
Some
switch
work.
We have some work to do, right? Remember, I told you this is a variable here, and x is a variable here. So, Nikolai, tell me how to switch around this.
You switch the t log 5 with this the log 7. So it'll be t log 5 plus log 7.
No, something is still not in the order it should be, because watch, y supposed to be a variable. Yeah, v is a variable. M not supposed to be a variable, guys. X not supposed to be a constant. Something
Ah, yeah, let's switch on the t. So it could
yeah.
be log 5t.
Yes. Yes. So log V would be equal to
Log
log 5.
t.
Yes. Yes. So if this is the case, guys, tell me what is the gradient?
Log 5.
Right? What is the y-intercept?
Log
Log 7.
Badness, badness, badness. Right? I hope all you understand what I mean. I'm telling you, y is a variable. Whatever I put there must be a variable as well. This, if I put here, it must be a variable as well. Right? Because y and x are the output. Y is the output of the function and x is the input. M is a constant and C is a constant. So if you're not seeing it, watch. Look at it carefully. I'm telling you that y is log v. You could see that. M is log 5. Remember, m is a constant. This is not keep. But if any of you guys do unit 1 pure math, it's really similar to this. It's really, really similar. And C is what? What is C?
Log 7.
Yeah, log 7.
Cool. Cool. Aliyah, that's excellent news. So this was the question. They said by using logarithms, express the relationship v is equal to 7 by 5 to the power t in linear form. So this is not in linear form. Why? Because you have a power. You have a power, guys. So you need to apply logs so you could eventually apply the power rule. So when I apply logs on both sides, guys, when I apply logs in this line, can I bring the t to the side?
No, sir.
No, sir.
Could someone, Sai, you tell me, Sai, why can't I take the t and bring it to the side?
Because you have the 7 and the 5 multiplying. Well, 5
Not,
multiplying.
not just that, was the only thing here being raised to the power t?
5.
5, so you can't do that. If everything was being raised to the power t, then you could do that. But you see how 5 is the only thing being raised to the power t? Can't do that. And if you look closely, what you see inside here? What do you see inside here?
7 by 5.
Which is that's a p. That's a p. Is that what?
Product.
A product. So what you have to do? Which rule you have to use?
Product rule.
Product rule. Right. So you see, log 7 plus log 5 to the power t. You understand?
Yes, sir.
Isn't this the product rule?
Yeah.
Yeah. I take the t now and I bring it to the side. T log 5. I want to put it in the form of a line, so I say log v is equal to t log 5 plus log 7. I want to put it in the form, right? So whatever comes here must be a variable, v. Whatever comes here must be a constant. So that's why I take the log 5 and I put it here instead. So you can see it's a constant here. T is a variable, so I put it in place of the x. And well, c is a constant, so I put log 7 here. Yeah. So, Sai, if I ask you to tell me the gradient, what you tell me?
The gradient will be log 5.
Right. If the gradient would not be t, right? That would not make sense. How the gradient gonna be t?
Because it's a no variable.
Yeah, t is a variable, so that can be the gradient. The gradient is supposed to be a constant.
Yeah.
Right? So the gradient is log 5. What's the y-intercept?
The y-intercept could be log 7.
Good. And if I wanted to get a straight line graph, I would have to plot what against what? So what going on the y-axis? What going on the y-axis?
So it will be t.
Wait,
log v.
Right? Yeah. Good job, Sai. Log v, because you can see that y would have to go on the y-axis. And what would go on the x-axis, Sai?
T.
T. Good. T. And that would give you a straight line graph where the y-intercept is what?
The y-intercept will be log 7.
Right? And the gradient would be what?
Log 5.
Badness. Drop a W in the chat farm. Sai one time, guys. Big up Sai one time. Right? Sai, there's what's Naruto one thing?
No.
Hey boy. If anybody did watch Naruto, they're gonna know the reference I'm making.
I know the reference.
Yeah, yeah. You know, Sai, the pale dude from Anu Black Ops. Yeah.
Yeah.
Yeah. Hence, state the value of the gradient of the line which represents the relationship. What's the gradient?
The gradient was log 5. Yeah, log 5.
All right. Cool. That's a day for logs. That's a day for logs. We should be a little better in logs now. A little better. A little better.
Yes, sir.
Right? Cool. All right. This is a tough question. Might make our head burst. Ooh. I don't think it's that bad, but I definitely think Claude did a good job making it sound scary.
As integration?
Nah, there's no integration.
APs and GPs.
Yeah, there's APs and GPs. All right,
I
so
hate this.
easier than you think. Here, before we even do anything, let me give a little crash course on APs and GPs. That's what I should probably do.
He's on thanks, sir.
So APs stand for arithmetic progression. If I spell anything wrong, I never say I was an English teacher. I'm a math teacher through and through. So what does an arithmetic progression mean? An arithmetic progression means that you have a common difference. Do you know what a common difference is?
Yes.
Like a difference
So, like,
of 2 throughout.
exactly like a common difference throughout. Let me give you an example. Consider 5, 10, 15, 20, 25. Guys, if you find the consecutive difference for any two terms, what would it be? For that one over there.
Plus 5.
5.
5. So that's how you know something is an AP if it has a common difference. Cool. What is the formula to find for the nth term of our AB? If you want to find the nth term, so like the nth term, I will start all off, right? So A plus
N
N minus 1.
N minus
N
1.
minus
multiplied by
D.
D, which is the difference.
right. People are doing regular maths until you know them questions where you had to like completely drawing on thing. All of those relationships are APs. Most of them, 90% of them are APs. I'm not sure if I realize that because most of those questions are in maths. And this is a common difference you have.
Yes, sir.
Yes, sir.
So
Yeah. Now, if you wanted to find the sum up to the nth term, what formula would that be? Start all off n over 2.
is equals to
2A
N minus 1
N minus 1.
by D.
E.
So let me explain the purpose of these formulas, right? Let me explain the purpose of these formulas. Earlier, how much terms I have here?
5.
5.
5.
5.
If I ask you for the 100th term, are you going to sit down in the exam and say 30, 35, 40, 45, all the way to the 100th term?
If I desperate, yeah.
Yes, sir.
No.
That is next level
Yeah,
desperation.
but
That is next level desperation, my guy. That's crazy. That's crazy. So, it would be good if we had a formula to generate any term in the. By the way, guys, we call this a series or a sequence.
So there's a
Sequence.
These are sequence. These are sequence.
Wait.
These are sequence, right? A sequence is just a list of terms. Just a list of terms. And a series is a sum of these terms. Anybody into maths and know about like the Taylor series or the Maclaurin series or anything? They doesn't know, but in all of those series is a sum. A series is a sum. A sequence is a list of terms. So anyways, wouldn't it be nice if I had a formula I could have just used to find the 100th term, the 120th term, the 200th term immediately?
Yeah.
Yes, sir.
Yeah. That's what this formula allows us to do. It allows you to find for any term in the sequence or the series. Cool. So when you look at this, right, let me just establish some things. A is the first term. D is the what?
Common difference.
Second.
Cool. And so here what? If I wanted to create the nth term formula for this sequence, here's how I would do it. Real simple, real simple. So a of n would just be equal to the first term. Remember, a is the first term. What's the first term? What's the first term for this?
5.
5.
Right? N minus 1. N is your input. So if you wanted to find the 100th term, you can replace n with 100. And d is your what?
Common
Five,
difference, 5.
What's the common difference for this?
5.
5.
So, then I would distribute and I would simplify. So that would be 5 by n is 5n, and then 5 by minus 1 is minus 5. And so a of n would just be what? 5 minus 5, guys.
0.
So 5n.
5n. So earlier, if I wanted to find the third term, I would just replace n with what?
3.
3.
What's 5 by 3?
15.
Isn't that the third term?
Yes, sir.
Yeah. If I wanted to find the 100th term, what would I do?
5 by 100.
5 by 100. 500. Cool. That's the purpose of the n term formula. It allows you to find for any term in your sequence by giving it to you in our formula. Are you understand?
Yes, sir.
Yes, sir.
Right?
Yes, sir.
Okay. On to the next formula, which is sum up to the n term. If I ask you to find the sum up to the 100th term, are you going to sit down there, generate the 100 terms, and then add each one individually?
No, sir, but somebody said I was real desperate, so.
So they might do that. They might do that. We don't know. Desperation is different. We will see.
Move on to
But
the next question.
so we'd use this formula over here, S of n. Let's see if it works, right? Let's see if it works quickly. Somebody, what would be the sum of the first three terms? Add it up manually and tell me what would be the sum of the first three terms?
30.
40.
30, right? 30.
30.
Let's use the S of n formula to see if that's true. So if I want to find the sum up to the first three terms, then I would replace n with what? What would I replace n with?
30.
3.
30. Oh, no, not. Oh, my bad.
What's my first term?
5.
5.
Right? I just showed them how to use it right now, Sammy. Alright?
Would that be the same 3?
That'll be 3, yeah? What's the common difference?
5.
5.
Right. You can put 3 over 2. 2 by 5 is 10. 3 minus 1 is 2. 2 by 5 is 10. You can end up with 3 over 2 by 20, which is
30.
30. Because 2 and 20 is 10. 10 by 3 is 30. Isn't that what we got when we added it up manually?
Yes, sir.
Yes.
Yeah. So I hope you guys understand the use cases. This formula over here allows you to find any term in your sequence or your series. This formula over here allows you to find the sum of any term in your series or your sequence. Hope all understand. And the formulas are in the formula sheet. So you don't have to place too much emphasis on remembering them, but at least you should understand how it works and why you would use them. So that's our AP. We'll focus on GPs just now. Alright? So I need a volunteer. Wanna tackle this question, man?
I would like to.
Okay, no problem. So Gabriel, give it a read.
The sequence an is defined recursively by a1 equals 2 and an plus 1 equals an plus 3 for n is more than or equal to 1. Prove that an is arithmetic sequence and find an expression for its nth term.
Okay, so Gabriel, if something is an arithmetic sequence, then
Right.
the difference between consecutive terms must be what?
The number.
Constant.
It must be a constant. It must be a constant. Yeah. So let me show you how we could handle this question. So if you want, Gabriel, you could have generated a bunch of terms and ensure that the common difference is the same. So here what? They're telling us that the first term is what? A1 is what?
A1 is 2.
And they're telling us if I want to get an plus 1, which is the next term, that's what n plus 1 means. It
Right.
is an plus 3. Wait, okay, cool. And so, Gabriel, let's just say, for instance, you wanted to find the second term. If you wanted to find the second term, what would that be?
An plus 1 minus an.
Not quite, but you're going on in a good route. What she just figured out is the fact that it would have a common difference at 3. I'm not sure if I realize that, but if you say an plus 1 minus an, the subject, you get 3. And that tells us the difference between the next term and the previous term is always 3.
Right,
And
I
this
think consecutive terms is constants.
Yeah, you could do this if you want. How much of you guys would do this to prove that is our AP? How much of you guys would do this? A lot of you guys may not have done this, right? Instead, you might opt to do Y13 and now. So here what, guys, you see this n plus 1? I want you to think of the n plus 1 like the next term. And I want you to think of n as the previous term. I'll explain something quickly. Guys, let's just say I had 7, 9, 11, 13, 15. My first term, n is equal to 1. My first term will be 7. My second term will be 9. My third term will be 11. My fourth term will be 13. So I have a question, guys. Stay with me, right, guys? Stay with me. What is the next term after n is equal to 1?
N is equal to 2.
N is equal to 2.
Isn't n equal to 2 just the previous one plus 1?
Yeah.
Understand what I mean, right? Okay, this is the previous term, but the next term will just be that previous one plus 1 to be the next term. Because where's 1 plus 1?
2.
Okay, let's look at it over here. If we dealing with n is equal to 2, what would the next term be classified as? What term?
N is equal to 3.
Isn't that just n plus 1?
Yeah.
What? 2 is 2 plus 1?
3.
3. So generally speaking, if I say n plus 1, I'm referring to the next term. If I say n, I'm referring to the
previous term.
Good. Are you guys seeing that or not?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So like the easiest way to prove this, right? If we're dealing with our AP, right? If we are dealing with our AP, then the difference between the consecutive terms must be a constant. And so if an plus 1 is the next term and n is the previous term, then any difference is supposed to be a fixed constant.
Yes, sir.
Yeah, so this is the first way you could do it. You could just say an plus 1 minus an, and you're seeing 3. So in other words, this is telling me that the difference between my consecutive terms will always be what?
3.
3. Because what does this mean? This means that the difference between my next and my previous is always what?
3.
Yeah, that is what it means. Next minus previous is always 3. If you're having a hard time seeing this one, let me show you a different way can I go about proving this. So stay with me, right? So guys, it's telling me the first term is what? What is telling me the first term is?
2.
2. And according to the recursive relationship, they're telling me that an plus 1 is equal to an plus 3. So if I wanted to find my second term, I would plug in n as what? 2. No, I plug in n as 1. Watch. It's n plus 1. So if I want to get 2, what would I have to put for n?
Oh, 1.
1.
So in other words, my second term would be equal to my first term plus 3. What was my first term?
2.
2.
So my second term will just be what?
3.
3.
Now I hope all they could see this. No, let's show is 3. Nah, wait,
Push it down, sir.
5.
5. So let me ask you that question, right? The previous term was 2. What was the next term?
5.
Yeah.
5.
What is the difference between the previous and the next term?
3.
3, which could be proved algebraically via this. It's just 3. Now, if you wanted, you could have generated some more terms to make a more conclusive argument. But the best way to prove it was literally just to do this. And again, I'm telling you, n plus 1 means the next term. N refers to the previous term. So if you could show that, generally speaking, the difference between the next and the previous term is a fixed constant, then is a AP. But if you wanted, you could have generate some more terms, right? So question, guys. If I wanted to generate the third term, I would say n is what? Remember, it's n plus 1, right? It's n plus 1. N
2.
plus 1.
M plus 2 plus 1. Right.
So that'll be the second term plus 3. So my third term would have been equal to, what's my second term?
5.
5.
5.
What's 5 plus 3?
8.
And again, guys, what is the difference between my third term and my second term?
3.
3. So I mean, if you wanted, you could have generated a bunch of terms in this manner and just find consecutive differences and prove that it has a common difference at 3. But this is the most elegant way you can answer the question. Because, hey, guys, they're literally telling you here that the next term is equal to your previous term plus what?
The next, what the difference?
Plus 3.
3.
They're telling you over, what they're telling you over here, Nikolai, they're literally telling us that, the next term. Okay, for me to get my next term, Nikolai, all I had to do is add 3 to my previous term. That's what they're telling me.
Okay.
Watch, Nikolai. The an plus 1 represents the what term?
The next term.
The next term. And an represents
Previous.
the previous term. Cool. And to get the next term, I have to add what?
3 to.
Exactly. And so if you make an plus 1 minus an the subject and you move it across, Nikolai, you realize the difference between the next and previous term will always be what?
3.
Which tells you that the common difference is
3.
Yeah. Are you understand that or not?
Yes, sir.
Yes, sir. Yes.
Yes, sir.
So again, you could have proved it like this, or you could have proved it by generating a bunch of terms and showing that the common difference is 3. I feel like the best thing to do is just do this, because this proves it for every single case. Okay, and then they're saying prove that. Okay, we already proved it's an arithmetic sequence. This was the proof. This was the proof over here. And find an expression for its nth term. They want us to find an expression for the nth term. What was the nth term formula again, guys?
A plus n minus 1 d.
A plus n minus 1 by d. Guys, we already proved that's an arithmetic sequence. Remind me, guys, if something is an arithmetic sequence, it will always have a what? It will have a what?
A common difference.
Difference. And the common difference is just the next term minus the previous term. Proved it over here. Common difference at 3. And if we want to find the expression for the nth term, which is a of n, all we had to do is identify the first term and the common difference. Guys, this is not rocket science. What was the first term?
2.
The first term was 2. They tell me that, right?
Yes, sir.
What is the common difference?
3. 3.
3. What to do next?
Substitute.
Nah. We're coming up with a general formula here. If you're coming up with a general formula, you're gonna do no substitution. You have to leave it in terms of n.
You have to state each one.
No, not transpose. You just had to expand. So what's 3 by n?
3n
What's 3 by negative 3?
minus 3.
Minus 3.
If we simplify that, what would that be?
3n minus 1.
1.
3n
3n
minus
minus 1. Because 2 minus 3 is minus 1. Right.
That's the answer, and just making sure.
Yep.
Nice.
Okay, cool. So that was it. That was it. That was it for this question. So CXC could bring a question like this and phrase it a bit funny, but it's simple. It's a simple question.
Easy 5 marks.
If it come tomorrow and I didn't do this session, I would have probably say it hard, but like it's a simple question, guys. Again, if something is an arithmetic series or sequence, it has a common what? What does it have?
difference.
It has a common difference. Yeah, I control Mikkel, don't worry. I control Mikkel. Yeah. Mikkel was spamming 6-7. Shame, shame, shame. Right? Spamming 6-7. Yeah. So, if you could prove that this sequence has a common difference, yeah, is a AP. And didn't we prove that? Because the next term minus the previous term is 3. So is a AP. Yeah. And in the question, they give us the first term to be 2, and we have the common difference at 3. So to find the n term, I just use the n term formula, plug in A and D, okay? People in the Zoom, all you understand?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, we not done, eh? What I'm gonna do, right? Every time we do a topic, I'm gonna like pause, take a little segue, and like just drill that topic. So we cover all topics, right?
Yes, sir.
Yeah, that's also funny what I've done too.
Yeah. So guys, give me a second. Give me a second. Why is it not okay, yeah, it can work in there. You guys can take a screenshot of this. I have a screenshot of that.
Yes, sir.
Okay, cool. That's fabulous. Cool. So let me tackle a bunch of arithmetic progression questions. Then we'll move on to GPs. Right. Do you have any requests specifically for series and sequences? Any particular year? Anybody?
2016.
2016. Okay. Starting off strong here, boy. Straight into the ocean. Okay, so I probably gotta explain summation notation. How much of you guys understand summation notation? Yeah,
Yes, sir.
This is sigma something.
yeah, this sigma thing over here.
Something to
So
do
this
with
was
the
already
To
stuff.
be honest, I don't remember that.
and this is something to do with the average.
Average, no, you're talking about standard deviation, which is sum of x minus x bar over n squared, square root. Wait, give me a second. I'm gonna give you all something to take a screenshot of as well. Y'all can take a screenshot of this. And I have a screenshot.
Yes, sir.
Yeah, do it at my still morning. Fun stuff. All right. So here what? You see this 3 to the power minus n over here, guys? Can you guys see that?
Yes, sir.
Whatever you have here is what you're going to use to generate your terms. You're going to use our formula to generate your terms. This is the lower limit of summation, and it's what you're going to plug in into that general expression to get your first term. So we have 3 to the power negative 1. And I'm starting off with 1, so what am I going to plug in for n to begin with?
1.
1.
Right, so that'll be 3 to the power negative 1, right? And again, the sigma symbol means summation. I'm going to sum. Right? Okay, so we start off at 1, and we're going, and this is the upper limit of summation, so we're going to go up to 25. So after 1, we're going to plug in what?
2.
2. Then I'm going to plug in what?
3. 3.
And I'm going to do this all the way till 3 to what power?
Minus
25.
Good. So this is the lower limit of summation, is the upper limit. And it tells you the values for n you're going to plug in into the general expression here to generate your terms. So we started off with 1. So I say 3 to the power negative 1, 3 to the power minus 2, yada, 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 all the way to 3 to the power minus 25. Are you going to sit down in the exam and add up all of this?
If
Are you going
necessary.
Yeah.
No, guys, we're not so desperate. We're better than that.
Really?
So here what, guys? 3 to the power negative 1 could be represented as what?
1 over 3. 1
Wait, Sammy, you want to lose this 3 marks or? You only get 1 mark if you plug this into your calculator. You gotta do the working. Yeah. So 3 to the power minus 1 is what?
1 over 3.
Right. 3 to the power minus 2 is 1 over what?
9.
1 over, yeah, which is 1 over 9. And 3 to the power minus 3 is 1 over what?
3 cubed or 26.
And we're gonna go all the way to 1 all over 3 to what power?
25.
25.
Cool. Question, guys. I should have probably take this. Because, like, okay, this is not AP, yeah? This is not an AP. You don't have a common difference here. You do not have a common difference. You actually have a common what?
Ratio.
Ratio.
Here, let me take this opportunity to just give all that crash course on GPs now. So this is a geometric progression, and each consecutive term can be found by a common ratio. So let me explain. When you look at 2, 4, 8, 16, it looks as though I'm multiplying each number by what to get the next number.
2.
Are you guys seeing that? Yes or no?
Yes, sir.
Yes, sir.
Wait, look this Mikel boy. Yeah, boy. Yeah. So for a geometric progression, you have a common ratio. Why are we saying ratio? Because, okay, if I wanted to get the 2 right, and I could say the next term divided by the previous term.
Yes.
Yes, sir.
For instance, what's 4 over 2?
2.
Right? What's 8 over 4?
2.
What's 16 over 8?
2.
Do you guys understand why we're saying common ratio?
Yes, sir.
Because the ratio between consecutive terms is constant. So for a common ratio, R is just the next term. Again, back with this notation. N plus 1 means next, N means previous. So if you want to find the common ratio, it's just the next term divided by the previous term. All you understand?
Yes, sir.
Yes, sir.
And if you want to figure out the nth term for a GP, you use this formula over here, where A of n, the nth term, is equal to AR to the power n minus 1. And of course, n is whatever term you want it to be. So question, if I wanted to find the 50th term, I'll replace n with?
50.
50.
50.
Right. And A represents the what again? What does A represent?
The beginning.
First
the
term.
first
Right. What does R represent?
The ratio.
Common ratio.
The common ratio. Nice. And for a GP, you have a bunch of different S of n formulas. You actually have 3. So you have A by 1 minus R to the power n over 1 minus R. And the way I like to remember this is you're using this when the magnitude of r is less than 1. Let me explain why. Let me just say I get r to be 0.25, right, guys? 0.25 is more than 1 or less than 1?
Less than
Less than 1.
So I'll wait. Well, how I just remember it, I just tell myself I don't want negative in the denominator. So n1 minus 0.25 will make more sense.
Yes, sir.
If it was 0.25 minus 1, we're going to end up putting the denominator.
Negative 0.75.
0.75.
I don't want negative in the denominator. So if the common ratio has a magnitude that's less than 1, you use 1 minus r, because r, of course, is going to be less than 1. Okay? If r is more than 1, though, again, I don't want a negative number, so I will place it first. Say for instance, I get r is 5. And if I say 5 minus 1, I'll get a whole number. I mean, a positive number.
Yes.
Yes.
Yeah. So that's how I just remember it. And for GPs, you have convergent series and you have divergent series. I don't know if you know about those. Or you know about convergent and divergent series?
Yes.
Yes.
Okay.
Yeah.
So anytime your ratio, your common ratio is less than 1, the magnitude of it is less than 1, the terms eventually will get smaller and smaller and smaller and smaller until it approximates to be 0. I mean, the term gets so small. And so anytime your common ratio is less than 1, you could find the sum to infinity, which is given by a all over 1 minus r. So you gotta remember these stuff, guys. You gotta remember these stuff.
Excuse me, before you continue, you really have a feeling that graph gonna come?
I feel so. If not the graph, they might at least ask you to put it in linear form. I don't know. I have a feeling. I don't know. I don't know. I could be wrong, you know. I didn't see the exam. I just think. I'm not sure. So if it don't come tomorrow, don't come and pitchfork something and
Oh, we
see.
coming for you one time.
Don't come and pitchfork something and see how it is, man. Hey, I just think it might come. That don't mean it will come. That don't mean it will. All right. So let me do a little test, right? Which one would I use if I had a common ratio of a half? 1 or 2?
1.
1. If I had a common ratio of 7 over 2, which one would I use?
2.
I thought that was trick color, you know. Pick up on yourself. Cool. And a convergent series is when the common ratio is less than 1, and a divergent series is when the common ratio is more than 1. Let me give you a quick example, right? Quick example. 2, 4, 8, 16, 32, yada, 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 so forth. So guys, it looks over here as though my common ratio is what?
2.
Yes, sir.
If I keep multiplying by 2, will my numbers ever get smaller, or will they just keep on growing?
Keep going.
Right, so they will diverge. They're gonna geo people, all they are geo, right? Until they know divergent means that the tectonic plates spreading apart, moving away.
And
Yeah.
So like, guys, if you have a common ratio and the common ratio is the magnitude of it is more than 1, over here is 2, then my number is just gonna get bigger and bigger and bigger and bigger and bigger. Okay, understand what I'm saying or no?
Yes.
So let me not bring Geo into hard maths.
The geo exam is,
please, the
hey,
first thing I thought about when you said converge and diverge.
that's good, that's good. Now, here what? Imagine you have this instead. 16, 8, 4, 2, 1, a half, a quarter, 1 over 8, 1 over 16. Okay, what does the common ratio look like in this instance?
Divide by 2.
Half.
A half. It looks like a half. It looks like a half. Are my consecutive term getting bigger or smaller?
Smaller.
Smaller.
Until we reach a point where the value is so small, it'd be negligible.
Yes,
Yeah.
sir.
Yeah.
Yeah, so that's why, okay, you see this one over here? Divergent series. This one though, the values look like it converging to a point because it will reach a point where the values get so small, it will just converge. I understand what I'm saying on that.
Yes, sir.
Yes, sir.
Yes, sir.
For something like this, I could actually find the sum to infinity. And the sum to infinity is given by what?
A over 1 minus.
1 minus r.
Good. And if I want to find the sum to the n term for this one, which formula would I use?
E a over n. No. Is it a over n or no?
Nah.
R minus 1.
R to the
In brackets,
Minus
1
1
over R minus 1.
over r minus 1.
Right. Nikolai, redeem yourself. Which formula would I use to find the sum up to the n term for this one?
That'll be a multiplied by r to the
Nah.
power.
Nah.
What? Wait. This would be the other way around.
Yeah, the other way
It would
around.
be the 1 minus the r to the power n.
Yeah, over.
1 minus r.
Right. Cool.
Okay.
Big up yourself. Big up yourself. Nice. So let me tackle the question now. So guys, when you look at this question, does it look like my terms are getting bigger or smaller?
Bigger.
Smaller.
Smaller.
Somebody say bigger, right? Somebody say bigger. Gabriel, you say bigger.
Yeah, I'm so sorry, guys.
That's okay. Let me show you why. Let me ask you that question, right? Come, I want you to compare a third to 1 over 3 to the power 25.
3 over
Okay.
1 is a whole number, so
Wait, say what? 1 over 3? 1 over 3, what's that? That is 0.33, right? That's 0.33.
yeah.
My calculator mightn't be able to calculate this. Look at that. Look at that. That's an insanely small number, you know. You see, what's power there? What is power there? Is power?
Negative 12.
Yeah. If I was cutting a pizza, would you want a third of the slice or multiply by 10 to the power minus 12 of a slice?
You lost me there. I will take the third, thank you.
Exactly. We take the third. Right? 10 to the power minus 12 is a very small number. So like my terms, somebody said we just take the whole pizza. You greedy boy.
I was not thinking the same thing.
So we will take the 3 over 1.
I don't have no 3 over 1.
We will take the 3
have no
pizzas.
tree.
We will make it into 3 pizzas and take 3 over 1.
Multiplication.
Yeah,
They're gonna
trust.
make my head my losing
This
boy.
is how we use
If you
multiplication and maths in
if
real
I
life.
make 3 slices, it gonna make it into a third. Hey.
Oh, but we will
But
flip it. Make 3 separate pizzas and take the 3 pizzas.
Just put the 3 pizzas over 1.
you gonna let me know how the Add Math just go tomorrow, right? Right, Gabriel?
Yeah.
You gonna let me know how. So
Just
we could we could identify that this is our what series? AP or GP?
GP.
GP.
Is a GP.
Yeah.
And the common ratio would be what? Or
A third.
what am I multiplying by?
That's it.
1/3.
Multiplying by 1/3, right? What's my first term?
1/3. 1/3.
Cool. And I want to find the sum up to the which term?
The 25th.
Find the sum up to the 25th term. So I had to use the S of n formula, but which S of n formula would I use?
The 1 minus r.
Yeah.
Yeah. So A is a third. And I want to go up to the 25th term, so I'm going to replace n with 25. So 1 minus a third to the power 25. If you somebody just making a bunch of different accounts just to type 6 7. That's dedication, boy. That's dedication.
So, you know, that,
What is that?
yeah, I gotta do like Coach Springer. Your mother take you 9 months to make, and you go type 6 7 with them fingers. See?
All right. And then in denominator is going to be 1 minus a third. right? Sammy, I gotta make you a moderator. Right? Sammy, I'll make you a moderator today. Right. So guys, if you have a sharp calculator in the big 2026, just go on, just cry. Just crawl up in a bowl and cry. Just do that. Do that. Right? Do that. Cause like, bro, good luck plugging this into a sharp calculator.
Serious? Are there any bad Casios?
Yeah. I have one Casio that is effectively a sharp. I don't know the model number though, but yeah.
So why put it on radians?
It don't matter. Hear what, right? It don't matter. Radians only plays a role. Okay, I'll say this now. Radians is only matter when you plug in something into a trig function. That's the only time it does matter.
Oh, okay.
It will not affect any other calculation. Radians will only affect trig functions. You guys should get 25. Wait, you guys getting 0.5?
Yes, sir. I also got 0.5, sir.
Yes, sir.
Right. Now, if I were to plug this into my calculator, I'm plug that in. So, sum 3 to the power minus x, so I press alpha, close bracket to get the x. My lower limit of summation is 1. Upper limit of summation is 25. Wow. See if I get any same answer. 0.5. Are you okay with the first question?
Yes, sir.
So does everybody understand that this is a GP we're dealing with? So, and not just any GP, it's a convergence series. So you have to use S of n is equal to a1 minus r to the power n over 1 minus r. And when you plug everything in, you get 0.5.
Yes.
Right. Okay, cool. Let's move on. Now, this is the question I suspect you guys interested in. This one. This is the one. Any volunteers? Any volunteers?
Going once, going twice. Lego,
I'll
sir.
go do it. Calm down. I will do it. Just.
Okay. Yeah, so Gabriel, get the question I read from him.
A man invested X amount of money in a company in January 2010, on which he earns quarterly dividends. At the end of the second, third, and fourth quarter in 2011, he earned $100, $115, and $130 respectively. Calculate the total dividends on his investments by the end of 2016.
Okay, who here, when they see a question like this, feel to cry? Raise your hand.
Zero, I feel to cry. I don't speak English.
Okay, let me show you how easy this question is now. So they're saying a man invested X dollars in our company in January 2010. Alright, so let me look at 2010. And they're saying he earns quarterly dividend. So every
1 quarter.
okay, exactly. Every 1/4 of a year, he gains some money on what he puts in, right? You understand?
Yeah.
So you have 1/4. So in every year, how much quarters you have?
4.
Four.
4.
Right, so in 2010, you have 4 quarters, right? Let's move on to 2011 now. In 2011, how much quarters you have?
4.
4.
So that'll be 5, 6, 7, 8. Are you understand so far?
Is the ratio number a quarter?
Whoa. Ratio. Nah, it's not a ratio. This, alright. So, wait, Gabriel, I want you to look at this. Look at the increase. Does this look like a AP or a GP?
AP.
Like AP. Because every single quarter, how much money does he get added on?
15.
15. Good. So here how easy this is, right? 2010, you have 4 quarters. In 2011, you have 4 quarters as well. And they're telling us at the end of the second, third, and fourth quarter in 2011, he earned 100, 150, and 130. So if we're talking about these numbers over here, which one am I going to put the 100 by? The 1, 2, 3, 4, 5, 6, 7, or the 8?
The 100 will go at 1.
Nah.
Oh, wait, no, it will go in 2011, which
No,
is
6.
5, 6,
Wait,
7.
let Gabriel figure it out now. Yeah, so
Why?
Gabriel,
Wouldn't it not be go on the 5? Because I
Let
heard
me
somebody
explain something.
There are
They said,
6.
all right, so Gabriel, read this for me. You're muted. You're muted.
At the end of the second, third, and fourth quarter,
Right, stop there. At the
yeah,
end of the, at the end of the, at the end of the
the second.
second.
Yeah.
So
Okay.
the first quarter here is 5. The second quarter is 6. So by 6, I'm gonna put 100. I'm gonna put
Right.
by 7.
115. And the third will be 130.
Let me explain something, eh?
Mhm.
Let me explain something, guys. Just with this alone, you could have backtrack and solve the entire question. Let me explain. What's the common difference?
15.
Common difference is 15, right? So
Yeah.
what do you think there would be then?
You take out from 15, so 85.
Okay, what do you think this would have be?
70. No,
This?
75. Wait. Yeah. 70. My bad.
What about this one?
55.
This one?
45. No, 40.
Gabriel, take your time. Because trust, you know, if I make any mistake, people go and say, Reggie made that mistake, you know. They're not going to say, how they made that mistake. I'll
I
be like,
take accountability.
right? And where's 40 minus 15?
35.
So earlier, just like that, if I wanted, then I could have figured out the total dividends on his investment by the end of 2016. If you don't understand, let me show you something, right? 2010, 2011, 2012, 2013, 2014, 2015. I'm putting on everything here to show you how easy this is.
Yeah, but and we had to use the
Please abstain from writing on the screen. Yeah, I will share the formulas just now.
I know the formula. I still
Oh.
want to.
The last one is 25, by the way.
It's not 35, it's 25.
Yeah.
You see, Gabriel, they will blame it on me. They go say, Mr. Rajiv said 35. Yeah, boy. Gabriel, take your time. You gotta take your time, right? You gotta take your time. Yeah, it's 25. Cool. So, how much quarters we have from 2010 to 2016? Well, 1 year.
28.
So, Gabriel, in every year, how much quarters we have?
4.
And how much years we have?
We have 7.
So, altogether, it will be?
7 times 4, which is
Right. So, it will be 28.
yeah.
So, we have 28 quarters. So, if we wanted to figure out the total dividends, which formula would we use?
The AP, the common difference. No.
When
They
I
are
find
the
the sum, when I find the sum,
AN equals A plus
nah,
N.
I wouldn't use the A of n formula. The A of n formula would allow me to find the nth term. I don't want to do that. I want to find the total dividends.
Sn equals n over 2, open bracket, 2a plus, open bracket, n minus 1, close bracket, d, close bracket.
Because this formula would allow me to find the sum up to the nth term. In this case, I want to find the sum up to which quarterly dividend?
The 8th one.
The 28th one. The 28th one.
The 28th one.
Right? So that'll be, I will show you guys a different way to work the question just now. But this is the most intuitive way I could think of showing you guys it. So that'll be 28 over 2. Is my first term?
100.
No, my first term is 25.
25.
Yeah. Remember, we backtrack.
Right.
We backtrack to find how much the amount of money he was when he put it in. He put in 25.
Right.
That'll be 28 minus 1, and the common difference is what?
15.
So again, why did we use this formula? Guys, they want us to find the total dividends. If it's total suggests that we are repeatedly adding, does it not? Total.
Yes,
Total dividend.
Yes, sir.
It makes a lot more sense to use the S of n formula, which allows us to find the sum up to our nth term. Right? And again, how do we know it's an AP? Well, we could just look at these consecutive numbers. Does this look like an AP or a GP, guys? What does this look like?
AP.
AP.
Right. Because where's 150 minus 100?
15.
Where's 130 minus 150?
15.
Right. 15. Cool. So, Gabriel, plug this into the calculator and let me know what you're getting. Well, I'll work it out here one time. So 2 by 25 is 50. 28 minus 1 is 27. 27 minus 15.
Tell her the answer or
Wait, I think I can figure it out. 4 5. 27 minus 27 by 15. 27 by 15, is it 4 or 5?
Yeah.
Yeah. And then it will be 4 5 plus 50, which is 455. And 455 by 28 is what? Okay, tell me.
6,370.
Right. Yeah, so Gabriel, 50 plus 4 or 5, you get that, right?
yeah.
Okay, nice. Yeah, so that's the answer. The answer is 6,370. Did you guys understand the intuitive approach to the question?
Yeah.
Yes, sir.
Do they
Right.
give this formula
Yes,
in the formula sheet or you have to memorize this?
Yeah, they give you this formula in the formula sheet.
Okay.
Right? Let me show you guys the more abstract way to work the question, right? It still relies on you knowing this too. So here what I was saying, right, guys? Okay, now what do you live, boy? Okay, I've seen like a green screen for a bit. So guys, in what year did he invest the money?
2010.
In January 2010, right? January 2010. So I'm gonna put on 2010. And they're saying he earns quarterly dividends. So that means every quarter in the year he gets some money being added on to the amount he invested. So in 2010, you'd have four quarters, right? Obviously. Tell me that makes sense.
Yes, sir.
Yes, sir.
Okay, cool. And then they're saying at the end of the second, third, and fourth quarter in 2011. So 2011, they be talking about the 6th, 7th, and the 8th term. Are you understand that or no?
Yes. Yes, sir.
Good. So let me show you guys the alternative routes you could do. So here what is the alternative route, which I think might be a bit harder for some people. So what is my 6th term? What is my 6th term?
100.
My 6th term is 100. Now, if I wanted, I could model an equation using the A of n formula. The A of n formula goes like A plus n minus 1 by d. Right? Cool. And so tell me, guys, if it's A of n is equal to A plus n minus 1d, and I want to create an equation, remind me, if the 6th term is 100, wouldn't A6 be 100?
Yes, sir.
Or would n be if I'm talking about the 6th term?
6.
Right? So I could formulate this equation, which is 100 is equal to A plus what?
5 multiplied by d.
Right. Is there any other equation I could come up with? And why I'm saying that? Well, if you look at this equation, how much unknowns you have?
2.
2. Anytime you have 2 unknowns, you need to solve what?
Simultaneous equations.
Simultaneous equations. And to solve a simultaneous equation, you need how much equations?
2.
2. Those.
So which term will I want to use to create the other equation?
Let me use that one. Oh, okay.
I like how the people avoid the 7th, you know? You know what I mean?
But let me do the 7th, sir.
So we just made a 6-7 joke in the chat.
No, the 8.
All right, so A8 would be what? If it's a 8 term, A8 would be what? A8. A8. A8 would be the 8 term. What would the 8 term be? Well, they tell them, all right? The 8 term is 130. Do I know what the first term is?
Yes, sir.
25.
No. I'm showing you a different approach to the question.
Alright, now.
If I deal with the 8 term, N would be what?
8.
8. Right? So this other equation would look like what is 8 minus 1?
7.
Right, so we have another equation. Could I then solve this using the elimination method easily?
Yes, sir.
Yes, sir.
Yeah, real easy. So, I could say so that'll be 130 equal. I just go and flip it around, right? So it'll be easier to understand. So A plus 7D is equal to
130.
cool, and A plus 5D is equal to
100.
kind of minus. What is A minus A?
0. Nothing.
Right. What is 7D minus 5D?
2D.
What is 130 minus 100?
30.
30.
Oh, which means that we'd have done something wrong over here. Oh no.
Oh, so
No.
the common difference is still 15.
Oh no, we still good. I get scared for a second there. I get scared. Right, so yeah. 2D is equal to 30. And so the common difference is just what?
15. 30 divided by 2.
Right, 30 divided by 2. Right, and it's 15. And if I want to find for A now, what how to do?
Stop. P is equal to 15 back into equation 1.
Any equation, right? Any equation would work. So if you pick in equation 1, that'll be 100 is equal to A plus 5 by 15. Right? What is 5 by 15? Should be 75.
5.
Wait.
And 100 minus 75 is what?
25.
25.
We get 25 the long way?
Yes.
Badness. So, I mean, if you wanted, you could do all of this, this is fine. But, I mean, how hard is this, guys? How hard is this?
So forget about that second one. The first one is the best.
Yeah. I'm trying to show you the easiest way to answer these questions. I mean, this is completely fine, But, like, I mean, you know what I mean? That's real easy. Right? And well, from here, you could just find so 28.
So how much you feel you ought to get like a 3? Because
Hey, Carlos, boy, just try to do the best you can do, boy. If you start worrying about them thing, just focus on what you can do now. I can't give all no advice on that. All I would tell you is just do your best, because the best is all you could do. You know what I mean?
True.
Right? So which one are you rather do? Are you rather do all of this or this?
I will.
All of that.
For sure.
Okay, well, if you wanna flex your math skills, I suppose you could do this, but if you want to just be quick and efficient, you could just do this.
Yeah, we have time for that.
Max. Yep.
Yeah, so cool. And well, of course, they want me to figure out the total dividends by the end of 2016. So that'll be how much years? How much years, guys?
6.
Let's show that 6.
Alright, okay. Because it's the end of the year.
7.
I had to be careful, because I know for a fact someone would have say 6 and I would multiply 6 by 4 and then I find S at 24, but that'd be wrong. That'd be wrong bad. Well, watch. 2010 had 4, 2011 had 4, 2012 had 4, 2013 had 4, 2014 had 4, 2015 had 4, and 2016 had 4. So how much years is that?
7.
That's 7. When you say 2016 minus 2010, you're finding for years in between them. But remember, you're starting at 2010. And it ended at 2016, so that'll be 7. Yeah.
I actually did this test on a mock before and I wrote 6 and didn't realize.
But now you understand, right?
Yes, sir.
Whenever you deal with years, you gotta be careful, you know. Gotta be real careful. So, are you okay with this question or not?
Yes, sir.
Yes, sir.
Yes, sir. Are you have any other requests when it comes to APs and GPs?
June 2023.
June 2023. This is not really a AP or GP question. It's more like regular formulas you learn in maths. But I will show you how to answer with APs and GPs. Right, so get the question I read from.
John's grandparents started a university fund firm at a bank with $4,000. The bank offered 2 options for interest. Option 1, $240 per annum, and option 2, 5% of the current balance. Determine the sum of money in the university fund at the beginning of the 9th year for both options.
Right. So the way to determine the sum of money in the university fund at the beginning of the 9th year for both options. So option 1 is 240 per annum. If it's 240 per annum, that's what interest? If it's 240 per annum, what's that?
$240 per year.
$240 per year. Right? Which is essentially simple interest. And option 2 is 5% of the current balance. If it's 5% of the current balance, what's that? Simple interest or compound interest?
Compound
interest.
Yeah. So this whole question was just a compound and simple interest.
So this question,
Say that again?
nah, this question not that hard, like compared to the other one.
No, this question actually very easy compared to the rest. So, you wanna help me with it?
Rather not.
But you just say it was easy.
I remember doing it, but I'm not doing it. I'm not doing it. I'm sorry, I'm not doing it.
Okay, no problem. All right, well, any volunteers? Cool. Any volunteers?
I could
Okay,
try. Yes,
I
sir.
didn't
Yes,
hear
I could
anything,
try.
right?
So you gotta find the simple interest for the first one, and then you're gonna have to do the.
So I could try.
You gotta be real careful. You gotta be real careful with this question. Since we already know simple interest and compound interest, I'm going to show you guys how to tackle it using AP and GP. So option 1 would have been an AP, right? Because you're adding a fixed amount every year. In option 1, how much you adding every year?
250.
Okay, do you think you're gonna receive that 240 at the start of the year or the end of the year?
And
at the end of the year.
Yeah. So when I show you the simple interest and the compound interest route, you see how we'll tackle that. But anyways, let's look at option 1. We realize that option 1 is just a what?
AP.
AP. Because in an AP, you're adding a fixed amount per consecutive terms. So the common difference here would be what?
240.
240, right? Because isn't that okay? The common difference is just the amount you're increasing by every single time. And if it's 240 per annum, that means every single year it's going to go up by what?
240.
Exactly. So that's the common difference there. And n will be equal to what?
9.
N will be equal to 9. So if I want to figure out the sum of money in the beginning of the 9th year, which formula would I use? The A of n formula or the S of n formula?
Yeah.
A of n.
A of n, not S of n. I know they're saying determine the sum, but are they asking you to find the sum of all the monies throughout the year? Or they were just waiting to figure out the amount of money in the 9th year?
9th year.
Exactly. So we're going to use the A of n formula here. So that'll be A plus n minus 1 by D. So that would be, what was the
4,000.
investment? 4,000, right?
4,000.
Right. That was the investment. That's the principal, 4,000. So that's the starting value. So that's going to be 4,000,
N minus 1. 9.
right? By 240. When you plug into the calculator, what do you get?
5920.
Everybody get that?
Yeah.
Yes,
Now,
sir.
here's
So
the
you
other.
can have an easier way to do that.
It's I thought it was 5290.
So, and to have another way to do that, like instead of using
If
Yeah,
I'm gonna do it a different way, I'm gonna get by the exact same answer.
yeah, there's a different way to do the question. You get the exact same answer.
but this
Nicola, yes, 5920.
so
Okay,
Yeah, Carlos.
but you could have this one and the other one, or it'd have to be like this, like just the same way you have it.
I feel like it would have to be like this, because this is what they want to see.
All right.
They want to see the AP. They want to see the AP, but let me show you guys an alternative route you could take to answer the question.
So for the exam, you'd have to work out both.
Yeah, you have to work out option 1 and option 2.
Okay.
And wait, are you talking about the other way to do the question as well?
Yeah.
No, only do it one way. You only do the work in one way, right?
Okay.
Let me show you an alternative way you could have worked the question out. So, guys, how much money you put in the bank at the start?
4,000.
4,000.
4,000. Wait, so I don't see what's so hard about this, guys. I don't see what's so hard about that one. It's more or less the same working. So he put in 4,000, and every single year, how much money is he getting? Tell me, guys, every single year, how much money is he getting?
240.
Right. If we're talking about the beginning of the ninth year, how much? Okay, how much 240s you think would have been added on? 9 240s or 8 240s?
8 240s.
8.
Yeah, because it's the beginning of the ninth year. If it's the beginning of the ninth year, do you think he received the 240 for the 9 years yet?
No, sir.
No. So when you work out, you get the exact same 5920, which is the exact same thing I did over here. It's the exact same thing. Yeah. I mean, if you want, you could do simple interest, but you got to take away 1 as well because it's the beginning of the ninth year. So some of you guys might have done simple interest, and well, the rate, give me a second. This calculator giving real trouble, boy. But everybody that said it did it differently. Did you do it like this?
Yes, so that's the same way I do it. That's why I didn't want to do it.
But this is the same thing. It's the same thing, is it not, Watch?
It is the same thing. It is the
Yeah,
same.
it's the exact same thing. You could also do it using simple interest. Watch, 240, let me show you, right? 240 over 4,000. Watch, I will share, right? Check this out. Simple interest. Check this out. Isn't simple interest principal by rate by time over 100? Isn't that simple interest, guys?
Yes, sir.
Yes, sir.
Right? What was the principal amount of money he put in?
4,000.
I just calculated the rate, right? The rate is 6. The rate would just be the amount he's getting divided by the total by 100. So it's a rate of 6%. And the time, am I going to put 9 for the time, or am I going to put 8 for the time?
8.
8, because it's the beginning of the ninth year. If it's the beginning, he's not going to receive the full amount for the ninth year. And I'm sure when I calculate this, I get the same answer. Let me see. Right, so 1920. And if I add 1920 to 4,000, what am I going to get? Somebody tell me.
The same.
5920.
The same 5920. The same 5920. So there were multiple different ways to work this question, a bunch of different ways. But I think CXC wanted to see you work it like this using the AP formula. But let me know if you guys understand the question. Well, option 1 at least.
Yes, sir.
Okay. Right. Option 2 now. Okay, so Liam, you there?
Yes, sir.
Okay, so if it's 5% of the current balance, then you'll have to add 5% to what percent?
Um,
So the current balance would be represented by what percent?
1.05.
100%. Wouldn't the current balance?
Yeah,
Okay.
105.
The
Maybe
current,
100.
the current would be 100%. And they're saying 5% of the current balance.
Yeah,
So you're gonna get 5% added on. So it's gonna be 105%.
yeah.
So if it's 105% that's being added on, what would that look like as a decimal?
1.05.
So in other words, my common ratio is what?
1.05.
Good. 1.05. And since R is more than 1, which formula would I use for S of n?
TN9.
Say that again?
AR n minus 1.
Oh, that's the S of n, boy. Yeah, AR to the power n minus 1. Yeah, so A of n is equal to AR to the power n minus 1. Cool. So that would be
4,000
equal to 4,000
by 1.05 to the
right?
power 9 minus 1.
Right, and let me know what you guys are getting.
5909.82.
5909.82. Cool. Now let me
Yeah.
explain something, and this last part might confuse a lot of people. Option 2 might confuse a lot of people. Let me explain something. Let me explain how this working. If the person put in 4,000 in the bank, right, and he's getting 5% of the current balance, let me show you what's happening there. So 4,000 would represent 100%. But in option 2, he's getting what added on to the 100%?
5%
of the current balance.
So I want somebody to find 5% of 4,000 and let me know what that is. Find 5% of 4,000 and let me know what that is.
200.
200?
Yes, sir.
All right. So at the start of year 1, that's how much money he'd have put in. And at the end of year 1, how much money would he have in the bank?
4,200.
4,200. So he would now have 105%. I'm not sure if all understand that. All understand what I'm saying or not?
Yes.
Yeah.
Yes, sir. Yes, sir.
Yes, sir.
Because they're saying in option 2, he's getting 5% of the current balance. So if he put in 4,000 at the start,
So
then at
every
the end of year
5%.
2, every year he's going to get 5% of the amount he had previously. So in the next year, it will be, you will find 5% of this, and you go add it to one at the end. So every single year, he's getting 105%. So, and fun fact, if I take 4,200 and divide it by 4,000, what would I get? I bet you're gonna get 1.05. I bet you're gonna get 1.05. Do that for me. 4,200 over 4,000.
Yeah.
Because every single year, isn't he just getting 1.05 times the amount before?
Yes, sir.
Yeah. And so in the next year, watch, let me show you something, right? Let's find 5% of 4,200. Let's find 5% of that. So 5 over 100.
210.
That'll be 210. So when you add it on, it'll be 4410. And here what? If you still don't believe me, I want you to put 4410 over 4,200. Where you go? Where you go?
1.05.
1.05.
So can you guys identify that this is a GP we're dealing with? Because every single year, the amount is increasing by what?
5%.
1.05.
1.05. Yeah, which is 5%. So I hope you guys understand this. So yeah, 5909.82. And again, this is what they wanted to see. Could I use the compound interest formula? But again, I don't really feel like that's what they wanted. I feel like they wanted you to recognize that the first one was our AP and the second one was our GP. Yeah. So which one is better? Option 1 or option 2?
Option 1.
Option 1.
Option 1, because option 1 is giving you what?
More money.
Exactly. All right, let me follow. Okay with this.
Yes, sir.
Yes, sir.
Yes, sir.
All right,
Yes,
I have any other requests for the series and sequences questions? Okay, here what? Let me pick some questions I feel like might be tricky if it does come
Yeah,
back.
but you don't feel like one of them might come for this here?
Say that again?
You don't feel like one of that question with the money might come this year?
I don't know. I feel uncertain about that.
And I feel no one of that coming. I just know one of that coming.
It
Well, we
might
see, right?
just have
We
POA and add math.
go make our bet. We go make our bet.
$1 million.
So here what? I gonna tackle this question. It was one of the hardest questions. And if something like it comes, you'll at least you know how to deal with it. But it's one of the harder questions. After this, we're gonna do the question in 2025. And if you guys have no more requests, I'll move on from APs and GPs. Right, so somebody get this a read for me.
Find the sum of infinity of the following series: 1/4 plus 2/4 to the power 2 plus 1/4 to the power 3 plus 2/4 to the power 4. This sequence can be written as sum of two geometric series. Oh, I remember this.
Okay, good. So let me ask a lot of question, guys. Here what? Let's try for a moment to see if it's a common ratio. So if something has a common ratio, then the ratio between consecutive terms would be what?
Constant.
The same.
It should be the same, right? So let's try it quickly. So 2/4 squared divided by 1/4, 1/4 cubed divided by 2/4 squared. So let's see if this series as it stands has a common ratio. Let's see. It's one of the harder questions, for sure. Does it have a common ratio, guys? Let's see. So 2/4 squared divided by 1/4, that is going to be a half. Okay, that's a half. 1/4 cubed divided by 2/4 squared. Does this look like it has a common ratio?
Nope.
No.
No, sir.
No. But they told us that we had to find sum to infinity. And I can only find sum to infinity if I'm dealing with a what type of progression? AP or GP?
Geometric.
So we had to figure, okay, how we gonna do this then, boy? Well, they gave us a hint. They said it could be rewritten as
Make two sequences.
The sum of two geometric series.
Instead of
yeah.
making two sequences.
Yep. Well, two series.
Yeah.
So what I could write, I could say 1/4 plus what?
2/4 to the power 2.
Now 1/4 to the power 3. And this could be added on to what?
over 4 to
2
the
over
power 2
4.
and 2 over 4 to the power 4.
Power 4.
When you look at 1 over 4 plus 1 over 4 cubed, and so you kind of visualize or immediately that it might have a common ratio of 1 over 4 squared.
Yes.
Yes, sir.
Right?
Okay. When you look at 2 over 4 squared plus 2 over 4 to the power 4, when you look at this, what does the common ratio just jump out to be? Like when you look at it, what does it look like?
1 over 4 squared.
Are you guys seeing that or not?
Yes.
Four.
Watch 1 over 4 squared, because 2 by 1 will give us back 2, and 4 squared by 4 squared is
Yes, sir. Division.
yeah. Let me know if you're okay with that.
Yes.
Yeah.
Yeah. How much of you guys would have taken the hint and actually figured this out? That's the question.
Yeah.
So,
No.
yeah, I remember because of the class that we did before, but if I was supposed to do this by myself, maybe not.
Well, if something like this come, at least you guys will be able to tackle it, right? This is a really tough question. Really tough question. For sure, really tough question.
Excuse sir.
So that is the answer there?
No, that's not the answer. We have to find the sum to infinity for each individual series and then add it up.
Yeah,
All
but
right.
excuse sir.
Yeah, Nikolai?
Not the Add Maths this year could be hard or easy.
I don't know. I think Add Maths in general is fun.
So, nah.
I think it will be fun. I think it'll be fun.
That will not hold up in court.
Exciting. All right. So guys, again, when we looked at this question and you checked to see if it had a common ratio, did it have a common ratio?
Yes.
No. No.
Oh,
If I,
I said I was watching the two blue things that I did before. Then I would have said yes. I said
nah, just by looking at the question, just as is. If I take this term and I divide it by a quarter, I got a half. When I took this term and divided it by this term, I got 1 over 8. So does it have a common ratio?
nah.
Nah.
No, it does not. But it told us, maybe we could rewrite this as a sum of two geometric series. Now, when you look at this, right, are you seeing any terms that have anything in common?
Yes.
1 over 4 and 1 over 4
First
cubed.
and third, and the second and fourth.
Yeah, they have something in common. So now they wanted us to find the sum to infinity. Let me ask you guys a question. Aren't both of these series convergent series?
Yes, sir.
Yeah.
Yes,
sir.
Because what would the common ratio for the first series be?
1 over 4 squared.
4 squared.
Right? What would the common ratio for the other series I came up with be?
2 over 4.
4 squared.
Cool. And this could be simplified to 1 over 16. And, oh no, 1 second. I'll charge my iPad. All right. Yeah. And the other one would be, if I simplify that, that'll be 1. Should be 1 over 8,
1
right?
over 8.
So here what? Since the common ratios are both less than 1, that again does not suggest that they are convergent.
Yes.
sir.
If you don't understand, think of it like this. If I keep multiplying a number by a fraction, will the number get smaller or bigger?
Smaller.
Smaller, sir.
Smaller. And eventually it will be so small it will be negligible. So I can find a sum to infinity then. Let's find the sum to infinity for the first series. So remind me, what is the sum to infinity formula?
A over 1 minus R.
Cool. And so the sum to infinity for the first series I came up with will be the first term, which is a quarter, all over what?
1 minus 1/16.
All right, so plug that into the calculator, guys, and let me know what you get.
Over 4/16.
What are you guys getting?
Yes, sir.
What are you guys getting?
4 over 50.
4 over 50.
No, 15, sorry.
1, 5.
Yeah.
Okay, let's find the sum to infinity for the other series we came up with. So my first term was my first term.
2 over 4 squared.
Which we know is 1 over 8, right? As 1 over 8.
Oh, yeah.
I just put it somewhere over here. So 2 over 4 squared is 1 over 8. So my first term is 1 over 8. Then it'll be 1 minus common ratio, which is also 1 over 8. So what are we getting that for that?
1 over 7.
2 over 7.
4 over 7.
1
1
over 7.
1 over 7.
Yes, sir.
Okay, so I have a question, right? If this series converges to 4 over 15, and this series converges to 1 over 7, what would the sum to infinity be?
Yeah, add up. Yeah, add up.
That's all. So this series over here, it just converges to 4 over 15. And this series converges to 1 over 7. So to answer the original question, sum to infinity, that would just be 4 over 15 plus what?
1/7.
And what would that be?
43 over 105.
Over 105.
Somebody said if he simplified it, yeah. So like, all masses are simplified. So to find the sum to infinity for the other series I made, 2 over 4 squared is the same thing as 1 over 8. So instead of writing 2 over 4 squared, I just write 1 over 8 instead, right? Yeah, what are you guys getting?
43 over 105.
All right, 43 over 105. My Apple Pencil just died.
Oh.
Yeah.
Is this a sign?
It's a sign. No, it's not a sign. It's not a sign. We're going to write down till we lie down.
So that means it's time for break.
I low-key feel so, you know, but let me just finish this question.
Yes, sir.
I want to finish this question. So what are you guys getting?
Put your finger now.
43 over 105.
43 over 105. Yeah, well again, 43 over 105. Yes or no?
Yes.
Yes, sir.
Yes, sir.
All right, Sammy, I will go over this. So when you look at this question, the way to find the sum to infinity, but you could only find the sum to infinity for a what kind of series?
GP.
A GP, right? You could only find the sum to infinity for a geometric series. And what do I mean by that? I mean that each consecutive terms will have a common ratio. Now, when you look at this, if you take the second term and you divide it by the first term, you're gonna get a half. If you take the third term and you divide it by the second term, you're gonna get 1 over 8. So immediately that tells us that as it is right now, it is not a what? It's not a what?
Geometric series.
Geometric.
Is not. So Sammy, I hope you understand that. As it is right now, this is not a GP. However, they said, note, this series can be rewritten as a sum of two geometric series. And so we're looking for terms that may have something in common. So when I look at 1 over 4 and 2 over 4 squared, you're looking like them have anything in common?
Sir.
Not really, right? Not really. But when you look at 1 over 4 and 1 over 4 cubed, what about that?
No.
Yeah.
Yes, sir. Yes. That one.
Yeah. Watch. 1 over 4 and 1 over 4 cubed. What is the ratio there? What are they linked together?
1/16.
Right, by multiplying by 1 over 4 squared. So I see 1 over 4 and 1 over 4 cubed have something in common, so I can make a series with that. Could I make a series with anything else?
The second and fourth too.
Good. 2 over 4 squared and 2 over 4 to the power 4 sort of looks like they have something in common. So I can make this series over here, 2 over 4 squared plus 2 over 4 to the power 4. Now we could see that both of these smaller series are convergent series. Why are saying that? If you find the common ratio, both of the common ratios are less than what?
1.
Right. If the common ratios are less than 1, you're dealing with convergent series, meaning that the consecutive terms are getting smaller and smaller and smaller and smaller, and they are convergent to a point.
Excuse
So we
sir.
can find sum to infinity formula. Yeah, Nikolai?
So would you say that the two geometric terms that we found here was convergent?
Yeah, both of these were convergent. Both of these were convergent. How do I know that, Nikolai? I know that because my common ratio, it was less than what? 1 over 16 is less than what?
Less than 1.
Right. 1 over 8 is?
Also less than 1.
Good. If you end up with a common ratio less than 1, you can use the sum to infinity formula, right? And so the sum to infinity for the first series would have been the first term. The first term was 1 over 4 divided by 1 minus the common ratio. The common ratio was 1 over 16. When you plug this into your calculator, I trusted my students, so 4 over 15, I think. Yeah. For the next one, it was the same. For the next one, it was the exact same process. The first term here is 1 over 8. If you're confused, 2 over 4 squared simplifies to 1 over 8. So 1 over 8 divided by 1 minus the common ratio. The common ratio was again 1 over 8. So I say 1 minus 1 over 8, and I trust my students, so 1 over 7. So here what? This series here, it converges to 4 over 15. This series converges to 1 over 7. And you're adding two series. So the final sum to infinity would just be 4 over 15 plus 1 over 7, which is 43 over 105. So you guys could take a screenshot. So I want to do the question from 2025, and that'll be it for APs and GPs.
Yes, sir.
The people that had come the lives I was doing leading up to this session were in a real good position because all they do differentiation, integration, kinematics already. That the whole section 3, I think.
Yes, sir.
And we effectively
Yes, sir.
finished in section 1 here. So I'm in a real good position. Yeah. Cool. So what percentage did it reach? 33%? Okay, we take that. All right. Who want to help me with the question from 2025?
Sir, I don't mind.
Well, you never mind, eh? Nikolai is never mind. Right, so Nikolai, part B, help me with that.
Determine whether the series 2 plus 6 plus 18 plus 54 plus 162 is arithmetic or geometric. Justify your response.
All right, so Nikolai, just by looking at it, what does it look like? An AP or a GP?
A GP.
Because it's looking like it have a common what? Common what?
Multiple, like multiplying.
It looks like I'm multiplying by what throughout to get the next term.
By 3?
3. So here what, right? Here what? Here what I would do. If you're seen as a GP, right? Then for a GP has a common ratio. And the common ratio is given by the next term divided by the
first term. Previous term.
So here what? Let's see if this is true. So I have my first term here, my second term, my third term, my fourth term, my fifth term. Nikolai, if we want to show it a GP, all we have to do is show that it has a what?
A common ratio.
A common ratio, yes. So let's try that. Let's just try to prove that quickly. So let's try the second term and the first term. So 6 over 2 is what?
3.
Right? Let's try some other ones. Which other terms do you want to try?
54. No, 162 and 54.
Yeah, we should like do it in order, right? So then I would say 18 over 6. Where's 18 over 6?
That will also be 3.
Let me do it for the other one. That'll be 54 by 18. 54 by 18 is
3.
And then lastly 162 over 54.
It's 3.
I'll verify that, right?
Yes, sir.
Since a common ratio exists, the series is what? The series is what? The series is
Geometric.
yeah. Everybody okay with why I said it was a geometric series?
Yes, sir.
Yes, sir. Yes, sir.
Because I had a common ratio, right? And I proved that for every single term that was available. Because here what I'm saying, guys. Imagine you do it with the fifth and the fourth term and you do get 3, you get 2. What I mean?
It's not a geometric.
It's not geometric.
Right. So do you all understand what the importance of doing it for every single pair of terms?
Yes,
Yes,
sir.
sir.
Okay, good.
Yes, sir.
All right, Nikolai, get us a read from her.
In a geometric progression, the third term is 25, and the first and second term is 500. Find the common ratio where r is more than 0.
So they're telling us immediately that R is
More than
Divergent.
0.
R is more than 0. So let me understand something. So we're dealing with a what type of progression?
Geometric.
And they're telling us the third term is 25, right?
Yes, sir.
If they're telling us the third term is 25, can we come up with an equation for that?
Yes,
Yeah.
sir.
Yeah, we could. So Nikolai, what would I use to come up with an equation for the third term?
T3 is equals to 25.
Wait, so here what? We know that the third term is 25, right?
Yes, sir.
And Nikolai, anytime I'm dealing with term, like nth term, where's the equation for that? For nth term?
Tn is equals to a, which is multiplied by n minus 1 by d.
Nah,
Oh,
Nikolai,
no, it is for arithmetic.
we're dealing with a geometric progression here, a geometric. So which A of n formula would I use?
Is that where it's a fraction, like a r is over a?
Nah, Nikolai, dig. Carlos, will tell him. Carlos, let Nikolai figure this out. So what's the n term formula for a GP? Actually, Sammy, I doing the whole syllabus. So like I created a test with the help of Claude AI, and every single time we do a question, I do any question there, and I'm branching off to do a bunch of questions related to the topic. Right? Yeah, Nikolai, what's the n term formula for our GP, boy? Nikolai, boy, I don't know this, boy. Hey. I'll help you out, But I can't help you out tomorrow, you know. It'll be AR to what power?
3?
No, AR to the power n minus 1.
Ah.
Nikolai, I way to write this in your book 5 times. AN is equal to AR to the power n minus 1.
Yes, sir. Yes, sir.
Sir, you have to excuse him, sir. It's only formula shit.
Yeah, so you feel I think he getting mixed up because the T and the A. I feel like he getting mixed up there.
Alright, so Nikolai, T of n and A of n mean the same thing, right? Mean the same thing. So when I write T of n is equal to AR to the power n minus 1 means the same thing. Means the same thing. Means the exact same thing. So Nikolai, I'm gonna erase the n term formula and tell me what's the n term formula?
an
For a
is,
G.
an is equals to ar n, well, the power n minus 1.
Okay, cool. So here's what. Nikolai, which term do I have? Which term do I have?
The third term.
We had the third term. If we had the third term, then n is equal to what? We know n is equal to what?
3.
Right. We know n is equal to 3. So A3 would be equal to AR to the power 3 minus 1. What's 3 minus 1?
2
And do we know what the third term is?
is 25.
Right. So we have 25 is equal to AR to what power?
2.
Good. Are they with me? This is an equation we have. How many of you guys with me?
Yes.
sir.
Nikolai, how much unknowns you see in there, boy?
Too many. Really? Too.
I like that one. I like that one. Too many. That was a good one. Anytime you see in two unknowns, it means you have to solve one.
Oh, one.
Nah, you had to, hey,
Wait,
two
no.
unknowns. Two unknowns. You had to solve one
Simultaneously.
simultaneously. So we need to come up with, so you have one equation there. We need to come up with
Another one.
another one. So they're telling us over here that the sum of the first and second term is 500. So if that's the case, Nikolai, remind me, Nikolai, how do I represent the first term again? First term is just what?
A.
First term is just A. Okay. And they're saying if I add the first term and the second term, I'm bound to get what?
500.
I'm bound to get 500. Could I come up with an expression for the second term?
Yes.
How would I come up with an expression for the second term?
AR?
AN. I'll use A.
N. Okay.
Remember, here was a Nikolai. Anytime I'm talking about the like a term, an nth term, you're using this formula. So A of n would be equal to. Remind me, what was the nth term formula?
AR, N, well, the power N minus 1.
Cool. Are we dealing with the second term here? So if we're dealing with the second term, what would n be? If we're dealing with the second term,
AR. Because
wait,
2 minus 1 is 1. So it's just
right?
be-
It just be AR. Yeah, it just be AR. What I was trying to say, right? If we're dealing with the second term, guys, wouldn't n be 2?
Yeah.
Yes, sir.
And Nikolai, you tell me the correct thing, right? 2 minus 1. And we know, well, we don't really know what the second term is. We don't really know what the second term is. But we know it will be equal to AR. We know the second term would be equal to AR. So in other words, A plus AR would have to be equal to what?
500.
We know that A plus AR had to be equal to 500. So now we just had to solve. Can I solve this by using elimination or substitution?
Elimination. Not substitution if you like.
Substitution for sure. Substitution. Yeah. Right? How to be substitution. So, Nikolai, which one you want to make your third equation from? So when you're doing substitution, you have to make a third equation. How are we going to make that third equation?
Could we do it from the 500? Seeing that.
Make R the subject.
Still making. You know what is AR, so
Get one letter and it's
Right.
translate.
So a lot of people saying
Can
different
we
things.
make A the subject?
Wait, what are they want to make the subject? A or R? Talk about that. A or R?
R.
Yeah.
R.
I honestly would suggest A, you know. I
well
would
yes,
suggest-
Yeah.
If you make
To
R the
find
subject,
the first term.
because like okay, check this right. If you make R the subject at the formula, okay, so that'll be watch. I run through the motions, so I'll move across the A, so that'll be 500. What's it? That'll be AR is equal to 500 minus A, and I would have to divide both sides by what?
R. I mean my bad.
And well, then you would have to plug that into this. And then you would have to square that. And then solve for E.
So that is too long. That don't make sense.
If you're like a really good math student, then that's fine. But like watch, check this out. If you notice, guys, and we could factor out A from this.
Yes, sir.
Yes, sir.
Well, I actually shouldn't do that. But if I want to make, actually, yeah, I would do that. I factor out A, and that'll be 1 plus R. A by 1 plus R is equal to 500. Okay, You see a A over here and you see a A over here, which meant that I could have do what? I have a A there and an A there, which means I could do what? I just do it.
Factorization.
Factorize.
I just factor out the A. So if I want to find for A now, what I could do?
Divide by 1 plus r.
And no matter how you do this, it's gonna be a bunch of working, regardless. So this is my third equation. So if A is 500 over 1 plus r, where could I sub that in? So I know A is equal to 500 over 1 plus r now, so where could I plug that in?
In the first equation.
Yeah, so Nikolai, instead of writing A in the first equation, what could I write instead?
500 over 1 plus r.
Good. So we could say 25 is equal to 500 all over 1 plus r by what?
R squared.
R squared.
Let me ask you that question. Are you like to work with fractions?
No.
Yeah.
Yeah.
Nah,
Like with fractions. Okay, what?
Yeah.
In this equation, you can see that we have 500 divided by 1 plus r. So if I wanted to get rid of that fraction, what could I do on both sides?
Multiply by 1 plus r.
Yeah, I could multiply both sides by 1 plus r. And if I do that, it's going to become 25 by 1 plus r, and that will be equal to 500 r squared. Yeah or no? If I see that.
That's it.
Yes,
Yeah.
Because the 1 plus r and the 1 plus r would cancel off on the right hand side of this. And from here, you could expand, so that'll be 25 plus 25r equals 500r squared. And this starting with a 25r. And this is starting to look like our what?
Quadratic expression.
Yeah, like quadratic equation, not expression, because it's equal, right? This is starting to look like a quadratic equation. Now, if I wanted to simplify this, what could I do throughout?
Divide by
25.
I could divide throughout by 25. And so I'm going to get 1 plus 1r. And what is 500 divided by 25?
20.
Now, here what? If you want to put it in the form of a quadratic, remember, a quadratic looks like ax squared plus bx plus c is equal to 0. So, what do you guys suggest?
Just carry
20r squared plus 1r
squared
plus
be
1.
negative 20r squared.
All right, so some people would want to move across it here, or some people would want to move across these two terms here. What do you guys want to do? Either way would work out.
Move the 1 plus 1r.
Move the 20, sir.
I feel like I would quicker move this across because working with a negative coefficient for the square term makes things a bit harder. If I move across the 1 plus 1r on the other side, wouldn't that give me 20r squared minus 1r minus 1?
Yes.
Yes, sir.
So like look at what I did, right? All I did, I just took the 1 plus 1r and I moved it across. And I put it in the form of a quadratic one time, which is ax squared plus bx plus c. Obviously, in this case, we have what inside of x? What we have inside of x?
R.
R. So all we need to do now is just solve this. Yeah. I think I seen the answers one time. It's looking like the maybe 5 and minus 4 or something. Or minus 5 and 4.
Minus
No,
5.
5 and
check this out, right, guys? You could use the AC method. So you have 20 here and you have minus 1 here. If you multiply 20 by minus 1, what will be?
Negative 20.
Right. What are two numbers that would multiply to give me minus 20?
5 and 4.
Minus 5 and 4. And if I add minus 5 and 4, do I get back the middle term, which is minus 1?
Yeah.
Yes, sir.
Yeah, so if there's, I need more space. Right. Cool. And so we could write that as 0 is equal to 20r squared minus 5r plus 4r minus 1. What next?
Factorize.
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 I'm gonna put down the Great Wall of China in the middle. Yeah, and I'm gonna factorize each side. So between 20r squared and minus 5r, I'm seeing I could pull out 5r. If I pull out 5r, what I write on the inside?
4r minus 1.
Right? And if I do this correctly, then immediately I know I will get 4r minus 1 here as well. So what would I have to multiply by 4r minus 1 to get back 4r minus 1?
Plus 1.
Plus 1. Plus 1. And so what could we pull out from both of these now?
5r plus 1.
Well, technically 4r minus 1. That's what I could pull out from both of them. Because both of them have 4r minus 1 in them. And so that would be 5r plus 1. So, but only one of these solutions are valid, eh? And you have to recall r is more than 0.
So it have to be the one with the positives.
Correct. So you move across the minus 1. And that's going to be 4r is equal to 1. And then you divide both sides by 4. And you're going to get 1 over 4. And Nikolai, for the other one, it's going to be 5r plus 1 is equal to 0. But Nikolai, if I solve this, what would I get?
5r is equals no. Yeah, 5r is equals to minus 1.
What next?
And then r is equals to 1 over 5. Or minus 1 over 5.
But in the question, guys, in the question, what did it tell us?
R is supposed to be more than 0.
More than 0.
So what is the only solution that's valid?
The first one.
First one.
R is equal to a quarter.
R is equal to a quarter. So this is the only valid solution we have. And if R is equal to a quarter, could I find for you?
Yes, sir.
Yes, sir. Substitute.
But I don't really need to do that, eh? Because all they really ask me to do is
the common ratio.
Right. So the common ratio is a quarter. Yeah. Tricky-ish question. I would say, like, if you're a strong algebra student.
Too much working.
Carlos, I feel like you're trolling, you know. I feel like Carlos go and mash up that exam tomorrow. What do you think? What do you think?
For sure.
Not me now.
I feel like Carlos trolling there, boy. Right. So let me explain the question back. So Nikolai, pay attention.
So yeah, now we're all good because I kind of confused here too.
No problem. So Sai and Nikolai, let's stay unmuted, right? I'll explain it back. So Sai, as a matter of fact, you read the question from Sai. Read the question from her.
In a geometric so you better read that. I heard I don't hear.
That's okay.
Nah.
If anybody tell you anything, I'll beat them up.
Nah, you read that.
We're not judging anybody here.
Nah, you read that.
I'll read it from. All
right, Carlos, read it from.
In a geometric progression, the third term is 25, and the sum of the first and second terms is 500. Find the common ratio where r is more than 0 or greater than 0.
Right. So, there's another way you can answer the question too, right? If you want, you could use the S of n formula, but yeah, but how to use, actually, I don't recommend that. Yeah, I don't recommend that. If you do that, problems. Yeah, do that. Yeah, so, Sai, you there?
Yeah.
Sai, here what I'm saying, right? First of all, it's telling you, in a what?
In the third term is 25.
No, but in a what? In a what?
The geometric progression.
A geometric progression. And they say in the third term is?
25.
Third term is 25. Here what, right, Sai? Anytime we're talking about terms, which formula should come to mind immediately?
The an equals ER n minus 1.
Correct. That's what you should be thinking about immediately. because we are dealing with the nth term, right? Nth term. And then you see they talk about the sum of the first and second term is 500. So, you see how they're telling us information here, like the third term is 25 and sum of the first and second term is 500. What we need to do, we need to convert this lingo to mathematical equations so we can work with it. Any piece of information they give you, you need to convert that to an equation. So if they tell me the third term is 25, then immediately I know that A3 is
25.
good. I know A3 is 25. And what is the n term formula? The n term formula is A of n is equal to AR to the power n minus 1. And if we're talking about the third term, then we know that n is equal to what?
3.
If n is equal to 3, doesn't it become A3 is equal to AR 3 minus 1?
Yeah.
Now let me explain something. Did they any question? Did they ever mention what the first term or the common ratio was?
No.
No, so you have to leave that blank then. You have to leave that blank. So when you end up with A3 is equal to AR to the power 3 minus 1, you have to remember, they told us what the third term was. What was the third term?
25.
Good. And so that would be 25 is equal to AR squared. Isn't that equation?
Yeah.
That's our equation. That's our equation. Cool. Now from this, you should already be seeing that we have how much unknowns? How much unknowns?
We have A unknown and R. 2.
So how much unknowns is that? A and R. How much unknowns is that?
2.
2. Anytime you're dealing with two unknowns, just know you'll have to solve our S. S.
The sum?
S. Nah. Anytime, guys, anytime when I have two unknowns, you have to solve
The
what?
sum of
Somebody.
infinity.
Nah. Somebody tell us. Anytime you have two unknowns.
Simultaneously.
Simultaneous equations.
Yeah, so anytime you see two unknowns, means you have to solve simultaneously. So it means, what does that mean in English? It means you have to come up with another equation. If you have two unknowns, you need to come up with two equations. Anybody here going to do pure math something?
Yes.
Yes, sir.
Yes. Yes, sir. Sir, I should do applied maths too.
Fortunately, sir.
That's fun. Everything maths is fun. Everything maths is fun. But here what I'm saying, right? When you do Unit 1 pure maths, you will look at solve. Okay, so you know how at this level you could solve for two unknowns using the matrix method.
No.
No. Oh, you're all learning that in regular maths. You know,
Yeah.
AX is equal to B, you multiply by A inverse, you get A inverse by A, AX is equal to A inverse by B, IX is equal to A inverse B. You know what I'm talking about now?
Yeah.
Yes, sir.
So
Yeah,
I just show me so I'll be able to know what you're talking about.
that is off topic, but anyways, in Unit 1 pure maths, you'll have to look at solving a system with three unknowns, and you'll need three equations. So you'll be looking at 3 by 3 matrices, as opposed to 2 by 2. Yeah. But generally speaking, if I have two unknowns, I'll need two equations. If I have three unknowns, how much equations do you think I would need to solve that?
3.
Yeah. But anyways, Sai, again, tell me, right, Sai, how much unknowns we have here?
2.
So if I have two unknowns, then I would need how much equations?
2.
And funnily enough, didn't they give us another piece of information here?
Yeah, the first and second terms is equal to 500.
Good. We need to write that. We need to write that now. If they tell me the first term, well, that really easy. The first term is represented by what? What is the first term represented by?
AN equals to AR minus N minus 1.
You're overthinking it. Now the first term is just A. The first term is just A. First term is just A. The second term though, if it's the second term, wouldn't the second term be
There's
if
2
it's the second term, N is 2, and so what would that mean?
Second term will be 2A.
No, it wouldn't be 2A. So remember, the nth term, wait, there's even a simpler way to think about this, you know. Here what, right? Here what, guys? Let me try to make it even simpler for you. Imagine you start off with that term, right? This is your first term. To get my next term, I would multiply this by what? Tell me, Sai. If it's our GP, I'd multiply it by what?
2.
Now I'd multiply by R. Remember, for a GP, to get the next term, you're multiplying by the common ratio. I didn't know that or no?
Yeah, my bad. That was
That's okay. That's okay. So the next term would be AR. That'd be my second term. And if I wanted to get my third term, sorry, what would I multiply that by?
On XR.
An XR, so that'll be AR what?
2.
AR squared, not 2. AR squared. And if we keep going like this, the fourth term will be given by what?
AR to the power of 4. 3, my
Yeah.
bad, my bad.
Are you seeing this logically or not?
Yes, sir. I mean,
So like, if you didn't want to do all of this, right? Like AR squared and saying, could I just do this? Could I just do this, guys? You know what I mean? Yeah, and you'd see that the third term is given by AR squared, and you could just say, you know, AR squared is equal to 25 and done. Sorry, what you rather do? You rather do this, or you rather use the AN formula?
Alright, I'll do this. I'll just confuse us with.
Okay. But for the people that prefer the other method, somebody just remind me, what is the n term formula again?
AR
eh,
to the power n minus 1.
And if we're dealing with the second term, what is n?
2.
2.
And so that would be A2 is equal to AR power 2 minus 1. And so the second term will just be AR. And of course, if you want, you could do it like this instead. This is the more intuitive way to look at it. If you start off with a term A, the second term will just be that multiplied by the common ratio R. So that'll be AR. The third term will just be this by R, that'll be AR squared, so on and so forth. So Psi, they tell us the sum of the first and the second term is 500. So in other words, Psi, that means A plus what is 500? Remind me, how are we representing the second term again?
AR.
AR. So A plus AR is equal to?
500.
A plus AR is equal to 500. Good. Good. You understand that, right?
Yes, sir.
And just like that, I came up with a
second equation.
Good, a second equation. So here, this is where the problem starts. You need to make a third equation, right? You need to make a third equation. So honestly, guys, I feel like the easiest thing to do, would I just probably be to make A the subject of the formula here. If you did do that, you'd end up with A is equal to 25 over R squared. And you'd plug that in over here. And that'd be real simple. Yeah. But it have a bunch of different routes you could take. So Sai, let me just explain it like how we did it. So
Yeah,
Sai,
no problem.
we decided to make A the subject of the formula here. So if I make A the subject of the formula, I had to pull it out from here and here. So that's why I say A by 1 plus R.
Yeah, I understand that.
Okay, so A will be equal to what?
A will be equal to 500 over 1 plus R.
So anywhere I see A, what could I write instead for A?
The 500 over the 1 plus R.
Good. So instead of we went over to the first equation now. And in the first equation, instead of writing A, what we write instead?
500 over 1 plus R in brackets.
Good. And do we like working with fractions, Sai?
Huh?
Do we like working with fractions?
Yeah, you're actually good in fractions.
You like fractions?
Yeah.
He's my ops then. I don't like fractions.
So I don't do it.
I like fractions. Who likes fractions? Let me read. Who like Olive? Put some L's in the chat for fractions. Who likes fractions? Yeah. But here what Sai? To get rid of the fraction, if we're dividing by 1 plus R, what could I do to get rid of the fraction?
Square R.
Say that again?
Multiply everything by the denominator?
Yeah, you can multiply everything by 1 plus R. And if I do that, Sai, wouldn't it cancel off?
Yeah.
Yeah, so I'm going to put 25 by 1 plus R is equal to 500 R squared because the 1 plus R would cancel off. So when you expand it, you're going to get 25 plus 25R is equal to 500 R squared. You understand? You with me so far?
Yeah, honestly, I gotcha.
From this point, you just have to solve the quadratic. So I had 1 plus 1r is equal to 20r squared. How did I get 20? Well, notice everything here has a common factor of 25.
Yeah.
So we divide short by that. I end up with 0 is equal to 20r squared minus 1r minus 1. If you're having trouble factorizing it, guys, just plug it into your calculator and done, right? But if you factorize it, you'll see that you get an r is equal to a quarter, and r is equal to minus 1 over 5. In the question side, what do they want us to find for?
Find a common ratio where r is more than 0.
Exactly. So which one would be correct?
The quarter.
You understand it?
Yeah, I got you now.
All right. Cool.
Excuse sir.
Yeah, Nikolai?
Send my pen answer.
So that again?
I send my pen answer via WhatsApp.
Oh, you do finance?
Yes, sir.
Oh, that's real funny, boy. That's funny. Now, there's one more question I was thinking to give you all from a paper 3. I don't know if they could bring this question, but I think it would be good to know. And it involves logs and APs. I don't know if Ollie can handle it. I think Ollie can handle it or not.
See, with the kind of AI questions we get into
Well, let me show you guys it at least now. So if something like this does come tomorrow, you'll know what you're dealing with.
So you're right, so you're right.
What are paper trees? Paper trees. Paper trees kind of tough, eh?
So you see that maths exam said, I do not have maths and I was doing have maths any maths exam say.
And maths exam wasn't bad.
That's the maths exam
It
was
was
bad.
terrible.
I wouldn't say it was that bad. I just say like the structure was weird. The structure was weird.
Sonny on that
Right. So like these are the types of questions that come in paper trees. So they will be like, so like in the first part, you have to figure this out. And then over here they're saying the points awarded for reaching each intersection increases according to your geometric progression, such that the points awarded for the third intersection are 100, and the sum of the points awarded for the fourth and fifth intersection is 600. So in other words, this question is almost identical to the question we just did. I don't know if I realize that, I don't know if I realize that. Like look at it. They're telling you the points awarded for the third intersection is 100. So A3 is 100. The third term is 100. And then it's saying the sum of the fourth and fifth is 600. And that's almost exactly like what we just did.
Yes, sir.
Yeah. Yeah. So sometimes it might take a little question from the paper tree. You know what I mean? So I should really give away this question then. Because like, what if it come? Here it is. Here it is. Who wanna help me with this question? Is logs and is logs is logs and APs and GPs. Well, AP.
So I don't mind.
All right.
Wait, and somebody said it was good.
Yeah, I think somebody had said it was good.
Yeah, I'll try it.
All right. So Priyanka, get the question I read for now.
The numbers log a to the power 3, b to the power 7, log a to the power 5 and b to the power 12, and log a 8 to the power 8 and b to the power 15 are the first 3 terms of an arithmetic series. The 12th term of the series is log b to the power n. Calculate the value of n.
All right. So, do you have any suggestions? Any suggestions? Just anybody that writes an add math paper 3, just know the word. Add math paper 3 tough. It's tough. Real tough.
So we go crazy.
So let me tackle this question first. So we have log base 10 a cube b to the power 7. I hear Priyanka. Why are you saying him? Because it's looking like it is not Priyanka.
It is Priyanka, I just spelled different.
Oh, okay.
So I was gonna say Sri Lanka, sir.
What did you? Sri Lanka is crazy. So this is my first term. This is my second term. This is my third term. And this is my 12th term. Calculate the value of n. So, Priyanka, I will tackle it now. So they told us it was our what? They tell us it was our what?
Arithmetic series, so AP.
If it's an arithmetic series, what it must have? What is supposed to have? Supposed to have a what?
Common difference.
Supposed to have a common difference, right, Priyanka? Supposed to have a common difference. Yeah?
Okay.
And you know that? Or nah?
Yeah, just
You know that, right? I'm not judging you or anything. I just want to make sure. I want to see where you're at. So, all right. So, if it's an arithmetic series, then you're going to have a common difference. And the common difference is going to be the next term minus the previous term. If you want to take it, use A instead of T, it's fine. This is a Add Math paper 3 question. But like, as you guys just saw, until you see that they bring a question that look real similar to Add Math paper 3 question, like, I'll just now see it for itself, right?
yes.
I'll just now see it for itself. So, I mean, anything is fair game. So, Priyanka, here what I'm saying. If this is an AP, right, then the common difference. Okay, pick two consecutive terms, man. Pick two consecutive terms.
Like random.
Well, you had to pick two consecutive terms that only have a limited amount of terms in.
Two.
So wait, so how would I find the common difference? How would I find the common difference for AP?
You'll take it away. Well, no, divide.
Nah. If it's an AP, you take away.
Oh, okay.
Remember, guys, an arithmetic progression has a common difference. So the common difference would be the second term minus the first term. So that would be log base a to the power 5, b to the power 12, minus what, Priyanka?
Log A 3 to the power, but B to the power 7.
Okay, cool. Notice we have the same log base and we're minusing. What do you guys think I should do?
Divide.
So you're gonna divide.
True.
So that'll be a to the power 5, b to the power 12 divided by what?
A to the power 3,
Power
B to the power 7.
Power 3.
Cool. And if I simplify that, what would I end up with?
A to the power 2.
2.
B to the power 6.
5.
I understand, all right?
Yeah.
And if you have trust issues, guys, the question just looking hard, you know. This question not hard, it's just looking hard. It's just looking hard, right? It's the same things you learn. It's like the exact same things you learn, right? It's just looking a little harder. It's an arithmetic series. Same rules apply. Has a common difference. If I wanted to verify that, I could just double check it over here. So that would be, I could say log base 10 a to the power 8, b to the power 15, minus what? Sama Priyanka.
Log A to the power 5 and B to the power 12.
Yeah. And we go use, since it have the same base and the minus.
You will divide. So A to the power 8 over B to the power 15 over A to the power 5 and B to the power 12.
And what would we get?
A to the power 3 and B to the power 3.
Ooh, so hear this, guys. Hear this. I'm a cook, right? I'm a cook. So, if it's an arithmetic series, what's supposed to be the same? What is supposed to be the same?
The difference.
The common difference.
So wait, let me cook. I love this question. Maths is the best. Oh my god, maths is the best. Big up maths, big up maths. I like maths. You know what I mean? Maths real cool, maths real cool. But anyways, Priyanka is a arithmetic series, which means that the common difference is supposed to be
Same.
Exactly. So in other words, this is supposed to be equal to what?
Log A
Yes.
to the power 3 and B to the power 3.
Yes. Yes. Watch. Right? A squared b to the power 5. And that's supposed to be equal to log a to the power 3 b to the power 3. Understand?
Yeah.
That's supposed to be equal. So from here, if you have the same log base, what you could do?
That's
You could
divide.
drop the you could drop the logs. You could drop the
What?
logs.
Yeah, that
You
is
could
all.
drop the logs. Because I have one log term here equal to one log term here. So I could drop the logs. If I drop the logs, I'll get a squared b to the power 5 equal to what?
A cubed to B cubed.
Right. So a squared b to the power 5 is equal to a cubed b to the power 3. Notice I want my answer as b to some power. That's what I want, b to some power. So here's what I'm thinking. Is it possible for me to make b the subject of the formula somehow? Or is it possible for me to make a the subject of the formula somehow? We should wait. If we want our answer in terms of b, then chances are we should find for a. So like, let me explain. So Priyanka, if I make a the subject of the formula, what do you think I should do?
If I carry the B to the power 5 over, you get A cube and B cube over B5.
Wait, I'm trying to make a the subject of the formula. So we think I should I should probably.
I carry the B5.
You want to carry across the b to the power 5?
Yeah, and it will be divided. So,
Okay, no
and then
problem.
you could square root that whole thing.
Square root? No.
Okay. Like that'll be easy.
So a squared is going to be equal to a to the power 3. And well, you have b cubed divided by b to the power 5. What would that be? You have the same base and you're dividing. What happened to the powers?
Put into 2.
So you have 3 minus 5. 3 minus
Yeah,
5 is.
2.
No, not positive 2. Not positive 2.
No, negative 2.
Negative 2. Notice we want to find for e, right? We want to find for e. But we still have an a on this side. So what do you think I should do?
Carry the
I want
A
to.
over.
Divide
Right.
by
So
1A.
I could divide both sides by.
A
How?
squared.
Now a cube.
A cube.
Right. So what is a to the power 2 divided by a to the power 3?
2. No, negative 2.
No. What is 2 minus 3?
Negative 1.
Negative 1. So a to the power negative 1 is equal to b to the power negative 2. Now this is not quite how I would work it. But from here you could see that, like, okay, let me explain. Like I would not work it like this. Watch. Okay, a to the power negative 1, that's 1 over a, right? And b to the power negative 2 is 1 over what?
B. Negative.
Nah. Okay. Seems like we gotta go through some like foundation with indices. Let me do that. So guys, if I had a to the power negative n over 1, right? And I take this indice, but I take its whole term and I send it to the denominator, it's gonna turn to 1 over what?
A over positive n.
A to the power positive n. So, let me get another example. If I had 2 to the power negative 1, what does that mean? Well, I can write 2 to the power negative 1 or 2 to the power negative 1 over 1. And what would that mean? What would that mean?
1/2.
2 to
1 over 2 to what power?
1.
Which is?
A half.
A half. So it's the exact same concept we're applying here. if I have a to the power negative 1, wouldn't that be 1 over a?
Yeah.
And if I have b to the power negative 2, that would be 1 over?
B squared.
1 over 1 over b squared. If I cross multiply, you'll see that b squared is equal to a by 1, and a by 1 is what?
A.
A. Cool. Now, I would not work it like that, right? You could, but I feel like that's all that's not working. What would I advise you guys to do if something like this does come? I'm sure what I would do.
That come, I just go and cry.
Nah, don't give up. Don't give up. It's just looking hard. Here what would I do? I would divide both sides by b to the power 3. If I do that, on the left hand side, I'll end up with a squared b to what power? Was if I have b to the power 5 divided by b to the power 3. Nah. Okay, b to the power 5 over b to the power 3. If you're using your laws for indices, that would be b to the power 5 minus 3, which is b to the power 2. Okay, do you guys know the... Okay, it seems like we're having some trouble with indices, guys. Do you guys know the rules for indices?
Yes, sir.
Some of them.
Yeah.
If you don't, that's fine. I could run through them. I hate to help all, you know.
So you could recall it again one more time.
Okay, no problem. If I have a to the power n divided by a to the power m, anytime you have the same base and you're dividing, what do you do with the powers?
Take away.
Take it.
Cool. So a to the power n divided by a to the power m is just a to the power n minus m. If I had a to the power n multiplied by a to the power m, what would I do with the powers?
Together.
Cool. Those are the main ones you need to know. So here what? When you look at this, you have b to the power 5 divided by b to the power 3. So what would that mean?
You're taking away 3 from 5.
Exactly. And so that would be b to what power?
That would be 2.
Cool. And that would be equal to a to the power 3. Now then, what I would advise is, I would then advise to divide by a squared. To avoid any negative powers now. If I divide both sides by a squared, I'll end up with b squared is equal to what? If I have a to the power 3 over a squared, what would that be?
A.
That would be a. Because what does this mean? This really means a to the power 3 minus 2, which is a. So in other words, a is equal to b squared. A is equal to b squared. I hope that'll bring someone like this, because you all someone this question someone like it's scaring on bad.
So look, all that's working for just 10 marks.
Well, I mean, it is 10 marks. It is 10 marks.
I sure that now even you like we know start that question.
No, we nearly finished actually. We nearly finished. So here what happening, right? Here what happening. Let me show you something really cool. So if we found that a, okay, from this, right? A is just actually what? A is just actually what? A is actually equal to what?
B squared.
B squared.
Right. If a is equal to b squared, then let's see what my common difference becomes. So I have a squared b to the power 5. Instead of writing a though, what am I gonna write?
B squared.
B squared.
Yeah. So and that'll be b squared squared. People are writing paper 3. This will come in. And paper 2 as well.
Badness.
So that'll be b to the power 4 by b to the power 5. What would that work out to be?
B to the power 9.
And let me show you something cool, right? I bet you if I do it for this, I'll get the same thing. Because remember, for AP, the common difference must be must be the same. So let me see quickly. So A is what? Where's A? Remind me, what's A? What is A?
B squared.
B squared.
B squared.
So that'll be b squared to the power 3 by b to the power 3. b to the power 2 to the power 3. Anytime you're raising a power to a power, you multiply. So that'll be b to the power 6 by b to the power 3. What is that?
Look at that.
Look at that. Is the same thing? Is the same thing? Same thing. Alright, so your common difference here, what? You're real close to the answer. Your common difference is log b to the power 9. Could I write my first term in terms of b alone?
Yes.
Yes, sir. Yes, sir.
You'll see where I'm going with this. You'll see where I'm going with this. If I write my first term, remember this is my first term, this is a. If I write my first term solely in terms of b, anywhere I see a, what am I replacing a with?
B squared.
Probably b squared to the power 3 by b to the power 7. So my first term is really just
B to the power 13.
yeah, because 2 to the power 3 is 6. 6 plus 7 is 6, 7. Oh, 13. And we wanted to figure out the which term we wanted to figure out.
The 12th.
12th. Wanted to find the 12th. So if we want to find the 12th, I'm going to recall the n term formula. So a of n is equal to a plus n minus 1 by d. Did we notice?
Yes,
the
sir.
n term formula.
Yes, sir.
And we want to find the 12th term. So that'll be, so in that case, n will be 12. Now I found my first term to be log b to the power 30. That's going to be 12 minus 1. And my common difference is what?
B squared.
9.
Oh.
Nah. What was my common difference?
B to the power 9. Log B to the power 9.
Guys, we're nearly there. So my 12th term, what's 12 minus 1?
11.
So I have a 11 to the side there. What can do that 11?
Put it as a power.
Bring it to the front.
And that'll be b to the power 9 raised to what power?
11.
11.
When anytime I have a power, it's a power. What else do?
Multiply.
Yeah, that's it.
Nah, multiply. Power to power means I'm multiplying.
Oh, my bad. Yeah.
So that would turn to log b to what power? Was 9 to the power 11.
99.
And so, guys, yeah, I have the same log based on your adding. So what you go do?
Multiply that.
So what your answer will be?
1287.
No. Anytime you have the same log base and you multiply, and what do you do with powers? What do you do with powers?
Add them.
Yeah, add them.
Add?
112.
Now you add them.
Okay, imagine you had b by itself 13 times, right? And then you had b by itself 99 times. Altogether, you have b multiplied by itself how much times? Wouldn't you add?
112 times. 112 times.
112.
Yeah. So your answer is just what? They asked us calculate the value of n for the 12th term, where the 12th term would be in the form log b to the power n. So our answer for n is just what?
Log to the power 112.
Again, wait, they told us our answer would have been in the form log b to the power n, and they said to calculate the value of n.
Which is
So what's
112.
112.
Yeah.
111.
112.
With n plus n.
So people are writing paper 3, prepare yourself for questions like this. Yeah. So the answer is 112.
Too much. You're doing all that.
Yeah, boy.
So I had attempted the question or you leaving it?
I ain't even watching. As soon as I
Which
see the
mark for
question, as soon as I see the question, I flip it.
That's gonna be my 13th reason why, I know.
Oh, yeah, it's not that bad. It just
not that bad.
Everybody flipping that page. Nobody doing that.
Dude, it's horrendous. I know it's like horrendous.
All put aside the negative mindset, it's not that bad. Like put aside the negative mindset, it's not that bad. Like,
So you bring up that question.
It is that bad.
Hey, so you just bring all the positivity in me. You see this? This is food. This is food.
that's why I'm saying it. This is food. This is
So we
food.
want to do like COVID. We staying positive. Positive. Do like COVID.
I like that one. So here what? Let's take a screenshot of this. Any off chance something, some BS like this come, you kind of know what to do, you know what I mean? Can screen.
Could go down a little lower.
Wait, take a screenshot of this first part. I have the screenshot.
Yeah.
I take it. Okay, cool.
So what time are we going up until though?
4 o'clock in the morning.
Sorry, what?
4 o'clock in the morning.
We now start by come now.
Hey,
lie down,
hey.
boy.
This is math vibes, you know. I remember like just the other day I do a 14-hour live. Now this is light work. This is light work, like, it's light work. Yeah, boy. Them men don't know me, you know. Them men don't know me.
Right now I did my third cup of coffee, you know.
Hey, boy. Yeah, so let's take a screenshot. I was feeling tired at the start of this, but when I start doing the math something, I get excited and I just start to get back energy.
I just see this, I see your energy, and I say, I like that energy, boy.
So definition of fun and my definition of fun is two different definitions, right?
So that again?
Your definition of fun and my definition of fun is two different definitions.
Oh yeah. If you want to become really, if you want to become really good at maths, you need to like change your perspective. Anytime you see a challenging question, you'll be like, aha, I get a chance to test my intellect. You know what I mean?
So
Excited.
last time I said that for the maths, I not believing it, sir.
Oh god.
I know the thing, me and Nicola the same.
Like add maths more than normal maths, huh?
So I do know add math papers that was easier than our maths exam, and so I even want like.
Hey boy, I real dog in a maths exam. But yeah, we done with
So that like ChatGPT, I feel like them teachers on just be a ChatGPT.
Damn. So here what? Wait, I hear what? Give a little break, come back, we're gonna look at section 2. So we're done with section 1. We're done with section 1. The only thing in section 1 I didn't really cover was sum and product of roots. Good thing that will come.
Sir, what about surds?
Surds is
food, real food. But yeah, man, right? You see in this pass practice test here.
Yeah.
If I do good in our practice test, you feel I will do good in the paper?
I think so.
Yeah, believe in yourself now.
We get you then, we get you.
Alright.
Yeah, not 3 for sure.
Yeah, what? When we finish with this, I will cover any topics we didn't look at. Because I here till 4 o'clock in the morning. Yeah. I hear.
I gotta also do because I revise geography right after this.
Yeah,
well, here what?
You are gonna be good.
Excuse sir.
Yeah.
Check what's on your sir.
It's on one message.
Yes, sir.
So, but where you finding this practice test? I don't know what to find.
Claude AI generated from a.
Serious? So I have my own.
Wait, when Nikolai, what did you? That's crazy. I need to see how much times Nikolai write AR to power n minus 1. Watch. Watch this. This is the first page, you know. This is the first page. Then he said, another page. That's crazy, boy.
That's a true mathematician, right there.
So how do I put that to my brain and sir?
It's in the formula sheet, I think, you know.
So you make me do all of that and it's in the formula sheet?
It is in the formula sheet, Nikolai.
It's
in
the formula sheet, and he was like, yeah.
Anyways, guys, I'll leave a little break and we come back with section 2.
Yes, sir.
Yes, sir.
Oh, you know the funny thing? Claude generated this question, and this is the question that come in the maths this year. Well, I'm sure that the points are cool in here.
They use AI. Confirm.
No, like I serious. I asked Claude to generate this paper, and it generated this question with the colon here thing with the points. I even joking.
What even was that question?
You just had to. Well, I gonna find like the vector, and I show that there's a scalar multiple and common point, but it's much easier than that, you know. All you had to do was show consecutive gradients were the same, or you could just find the equation of the line and make sure all of the points satisfying the equation of the line. Wasn't that bad.
See, but I find like There's some kind of hard math thing for a maths exam, you see.
Is
Like,
that cookie question? Is it a cookie question? That's the nicest question I see.
yeah,
That was
cookie
real
question.
fun, boy.
Excuse
I
sir.
see that quick question and I smile, boy.
Excuse sir. You realize that they're giving you the formula sheet and you're using nothing from it?
No, you're using equations for it, but you're using the AP and GP
I'm just
thing.
rich baiting, but I'm just giving it
Sir,
up.
basically that was just a display, sir. That was basically just a display.
Yep. So
I
yeah,
was
what,
waste of a piece of paper, boy.
wait, so they'll break and come back and grind section 2, or what they want to do?
You know, sir, I find you hyping me up too much and I want to do more.
That's good, that's good. That's the energy we want. Wanna hype, you know what I mean? That's what I hype. So finish with section 1, section 2. Something we didn't cover, or they go remind me, right? I just marking on the topics we didn't really do. We didn't really look at sum and product.
We didn't do vectors yet.
Well, not talking about for section 1. For sum we didn't do sum and product.
Alpha, beta.
We didn't do, well, alpha and beta is sum and product. We didn't look at rational inequalities.
We didn't do surds.
We didn't do surds. So when we're coming back in the morning, we can run through them thing. Right. So take I need some chicken. Coming back at 30 minutes break sound good?
Sir, is soya chicken or real chicken you're gonna eat?
Fried chicken, right?
Allah.
So eating the chicken, I eating the eggs.
I wonder what came first. You never know.
I remember
You never
Maths,
know.
like
you know what
soya
comes
too.
first? Sir,
What?
first, hear me, I don't go in mad. Sir, maths come first.
Maths is always first.
Right.
All roads leads to
Nah,
maths.
nah, physics came first.
No,
So
hey.
physics is what? What is physics?
You know that, hey, half of the thing in physics utilizes maths. More than half, more than half. Maths is
All
the
of the
language
things
of
in
physics.
physics utilize
Everything in physics is use maths. So you come on back at 9:40 p.m. Trinidad time.
Sir.
Yeah.
So there's 20 minutes, don't know.
You going on sleep?
Say that again.
So you going on sleep?
I not gonna sleep. No matter what. I not sleeping.
Right.
Me sleep. I'd be mad.
You know, it's Trinidad time, and you know it's Trinidad time.
What is sleep, guys? I don't know where you sleep, you know.
That's the weakness.
Sleep is a concept, guys. Why we
So I
forgetting?
really not got nowhere sleep because I had to pull 2 all-nighters for Add Math and Chem.
And Geo, guys, what? Us Geo students here.
Thank God I'm not
and
doing Geo.
Spanish paper 1.
Where's jail?
Well, guys,
Yeah,
I don't
wait.
speak. I don't
I
even
found
speak
it up.
English, guys. I'm going to kill myself for geography tomorrow.
What? Whoa, 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 whoa.
Whoa. No negative vibes.
whoa,
Chill
whoa.
out, chill out.
Whoa, there.
Salo, which country are you representing?
I'm from Venezuela, but I live in Trinidad.
Oh, so the English. But
Oh.
I see.
Yeah,
Interesting.
Me too.
You see the graph, right? There's the maximum velocity will occur as t
I
approaches
guess
it.
somebody. Yeah, boy.
Fue.
You gotta do it. You gotta do it.
No habla inglés, amigos. No inglés.
I hear one of the terrific tree. I hear one of them.
Yeah, boy. Terrific tree. You gotta do the personal. Yeah, boy. So
I
I'm coming
tell
back.
this, hey, my TV, it are you in my phone, TV have a next one, and it have to have a, we gotta pass.
You gotta pass. Yeah, boy. We're going right till 4 o'clock. So once I'm here, I'm here to help. Daddy mission. Yeah, boy. All right.
Enjoy your food, sir.
Yeah, guys, go and get something to eat. All right, guys, are you ready to start back?
Yes,
Hello,
sir.
guys. All right, cool.
That was one fast 30 minutes.
Yeah, boy. Whew. I'm gonna share the screen. I'm gonna roll back into the maths.
Oh my god, sir, I'm so ready to start back this Add Maths. Whoopee!
Yeah. Oh, then Mrs. Math vibes, right? Mrs. Math vibes, yeah. Love you too. Yeah, that's Miss Math vibes. Right, you gotta learn some Add Maths. You want to?
No,
No? Okay.
no.
I ready, sir. I ready for anything. Come, one time.
All right, no problem. I'm gonna start back to live. All right, let
That
me
is
jump straight in.
differentiation, sir.
So that again?
That's differentiation.
This question over here, this is coordinate geometry.
Oh.
Yeah. All right, so let's jump back straight into it. So they're telling us we have an equation of a circle here, and it is given by the form. I admit somebody there. Wait, people is trying to join the meeting. Let me see who I can make a co-host to like admit people in. Do I trust anybody here?
Sir.
Yeah.
All right, yeah, no, you could trust me.
I don't really know you. Celine, I can trust you.
Wait.
Trust.
You sure?
So we back to work?
Si, senor. Sure.
So trust the alpha. Trust is Celine.
Trust the alpha.
Celine just give me sauce vibes, you know. Man, Celine can
Are we back to work?
What did I ever do? I'm such an innocent person right now.
All right, so yeah, back to work. So we have an equation of a circle here. Immediately, is this the general form or standard form? What form is this?
Standard.
The general form.
Here, somebody says general, and somebody says standard. In a tiebreaker.
General.
Yeah, this is the general form. So in the general form of a circle, it's originally x squared plus y squared plus 2fx what? Somebody tell me.
2gy plus c.
All right, good. So here what? In the question, they want us to find the center and the radius of the circle. Not a problem. So for any circle, the center is given by, what's the center given by?
Negative f, negative g.
Cool. And if we want to find the radius, remind me, what's the formula for the radius if you're given the general form? R is equal to the square root of what?
X squared. No, f squared. Plus g squared minus c.
Hey, big up yourself, Amelia. Big up yourself. Hey, you know the thing. So,
Yes,
the center is minus f minus g. So we need to figure out what f and g is. Imagine this come for art maths and no circle come from maths. That'd be funny. See it. So, Amelia, can you identify what 2f is equal to?
Negative 8.
Okay, could somebody else tell me what 2g is equal to?
Negative 8.
2g. What is 2g equal to?
6.
Right, 2g is equal to 6. While we're at it, could somebody tell me what c is?
21.
21.
Good. If I wanted to find f, what would I do here?
Divide by 2.
Divide by 2 on both sides. So f would be what?
Negative 4.
Right? Divide both sides by 2 here. G would be what?
It will be 3.
So here what? If my center is given by minus f, comma, minus g, then what is my center going to be? So f is minus 4, you know. What would minus f be?
Positive 4 and negative
3.
Yeah, Carlos just trolling, you know. I feel like Carlos know he work proper. Carlos just trolling. So that'll be 4, comma, what?
Negative 3.
right? If anybody is confused, anytime they give you the general form, big up them. You can figure out a lot in the general form. The general form looks like this, and it's x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. From this, we could figure out what f is. So 2f would be minus 8. If I divide both sides by 2, I find f to be minus 4. 2g is just the coefficient of the y term, which is 6. So 2g is equal to 6. If I want to find for g, I could divide both sides by 2. So g is equal to 3. Recall that the center of a circle is given by minus f minus g. So if f is minus 4, then minus f would be positive 4. If g is 3, then negative g would just be negative 3. So the center of my circle is just 4, comma, minus 3. And if I want to find the radius, it's going to be the square root of f squared plus g squared minus c.
So you talk a little too fast, so you can go back over that, please.
Okay. Are you guys familiar with the general form or not?
Yes.
Not really, sir.
Nope.
Oh,
Yes, sir.
how some of you guys would have do it, some of you guys may use completing the square. And you may complete the square 2 times to get it in the standard form, which is x plus f squared plus y plus g squared is equal to r squared. And then from there, you would figure out what f and g is, and you would figure out what r is. I'm not sure if that's how some of you guys would do it. By finally completing the square. Yeah or no?
I don't think I ever do this.
Okay, that's a bit scary. I believe this formula comes in the I believe they give you this formula, I believe they give you this.
Yes, it's in the formula sheet.
Yeah, they give you this in the formula sheet, right? So guys, here was in, right? So Shivan, if you're comparing this and this, what is 2f? What do you think 2f is?
2f could be 8. So wait, sir. F represents the 8.
Later. So what is the coefficient of x here?
X. Oh,
Okay.
8. Sorry, 8. Negative 8.
Negative 8, right? What is the coefficient of x here?
F.
Nah, 2f.
2f. But sir, wait. It said 2f, right? So does not mean that I have to multiply the negative 8 by 2? Or
No. Nah. Right. I will take my time.
that just
Take my
did.
time. It's just there. So
Oh, okay.
what is the coefficient of x here?
Negative 8.
What is the coefficient of x here?
F. 2f.
2f. So in other words, 2f is going to be equal to
negative 8.
And if that's the case, then to find for f, I'd have to divide both sides by
2. Ah.
So f would be equal to negative 4, right? F would be negative 4.
Okay. Yeah. And then same thing for y.
Right. So what would 2g be equal to? What would 2g be equal to?
That would be 3.
Well, g would be 3. G would be 3, yes.
Yeah.
But 2g would be equal to 6. And to find the g, you would have to divide both sides by 2.
By 2, yeah.
So g is equal to 3. Now here what I saying. For any circle, the center is given by minus f, comma, minus g. So if f is minus 4, then just change the sign, that'll be 4. So negative f is 4.
Yeah, I understand that.
If g is 3, change the sign. So negative g is negative 3.
Mm-hmm.
So the center of my circle is given by minus f minus g. So that is 4 minus 3.
Okay, yeah. Understand.
Now the radius of the circle is given by f squared plus g squared minus c. So what's f? What was f, guys?
F was negative 4.
So that'll be negative 4 squared in brackets. Don't forget in brackets. What was g?
So you see negative 4 squared, right?
Mm-hmm.
Because but
To
why?
find-
How? Nah.
Okay, to find for r.
And it's okay. I know realize. All right, my bad. All right, so
No problem. So r is equal to the square root of f squared plus g squared minus c. If you use any formula, this is how you tackle it. And what's G? What was G?
So we say G was on positive 3, so 3
Right.
squared.
And what was C?
We said that was 21, so they could be raised as negative 21 since you're taking it away.
Good.
And
So
when you solve for that, you go and get some root 4, and root 4 is the same as saying for 2. So we
So
can
the
say the
radius
radius
is
is 2.
2
2
units.
units.
That's it? That's it?
Yeah, that's it, yes, sir.
Easy. I feel like these circle questions are easy, Max. So center is
So I
4
have a
minus 3.
question.
Talk to me.
If it is they don't give you the general form and they ask you to find the radius, would you not, but they give you the center and you don't have C.
All right, so if that's the case, then they would have to give you a point. They would have to give you the center point, and they would have to give you a point on the circumference. And you'd have to use the length of line formula. Do you recall what the length of line formula is?
No.
Okay. So what they could also do, they could give you the center point, and they can give you a point on the circumference, and you would need to use the length of line formula to find the radius. Does anybody know the length of line formula?
Or the square root of x squared plus y squared.
Not quite.
Y equals mx. Square root plus x1 all squared plus.
So I'll write it here. So the length of line formula now be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And for those of you eagle-eyed viewers, you'd see that that just comes from Pythagoras theorem, because if this is x1 and this is x2, the distance here would just be x2 minus x1, and the distance here would just be y2 minus y1. Since it's a right angle triangle, then the hypotenuse, which is the radius, would be given by the square root of this squared plus this squared. Is just Pythagoras theorem. I'm not sure how much of you guys knew that before, but you guys are Add Math students, so like I will explain a bit more than I would in regular maths, because I trust that you guys a little better in maths. So I might talk a little faster or explain a little more. If it's confusing, you guys tell me. Like the extra explanations confusing you guys.
No, I find it better. No, sir.
So the
No, sir.
formula for length of a line though, right? So we could have used that in the other equation. So we had to have like the tangents to understand. So use the other equation.
When you say other equation,
x2 minus x1 squared plus y2 minus y1 squared.
to use this formula, you
Yeah.
must have a point. Okay, you see this formula here just allows you to find length of a line, right? So if
Yeah.
they give you the center point and they give you a point on the circumference, what do you call this? What do you call that?
Well, there's a line, say, a tangent.
Radius.
That's not a
The
tangent, that's
normal?
a radius. That's a radius. That's a radius, guys. From the center to the circumference is the radius. And so if I want to find the length of the radius, I would just use the length of line formula here. Don't worry, we will do a question like this. We do a question like this.
Yeah, like do a question like that now. So feel like we might need some practice on that. Just
I
in
feel
case it's
like,
wrong.
okay, I understand why you guys call this the normal. It's fine. You could call it the normal as well. The normal is the line extended through this, right? Is the secant through it. But this over here is, in this particular context, it's the radius. And the radius could be found by finding the difference, well, the distance from the center to the point on the circumference, which is given by the length of line formula. And again, that comes from Pythagoras theorem, guys. But don't worry about that. We'll look at a question like that just now. We'll look at a question like this just now. Let me zoom in on this for the meantime. So, guys, if you have the general form is x squared plus y squared plus 2fx plus 2gy plus c is 0. From that, we could figure out what things. What could we figure out from that? Anybody from this? What could we figure out? I could figure out
Oh,
f on
that's
g. I could find f on g. I could find f on g. Is that hard or would you all say that was easy?
That would be easy.
easy.
That's
Easy.
easy.
Right. Because immediately we could see that 2f is equal to what?
Collective.
Negative 8, sir.
And 2g will be equal to?
6.
6.
So from here, you could immediately find for f and g. And why would we want to do that? Why? Well, the center of the circle is given by? What is the center of the circle given by,
Minus
guys?
f minus g.
Yeah, minus f minus g. So if I know what f is and I know what g is, I just have to negate the sign, and that will give me the center point. So watch. F was negative 4. So you know what negative f is? Negative f is just positive 4. If g is positive 3, then negative g is just negative 3. And so that gives me the center.
Excuse me.
Yeah.
So the next part you was doing was not necessary, right? So this is this is the answer here.
This is the work and this is the answer, this is everything.
Right. Because I see you do the length of a line on that side. I don't know.
You have to use this. Okay, let me explain something, right? Let me just say the only information they give you, right? The only information they gave you was the center and a point on the circumference. That was the only thing they gave you, right?
Right.
Well, from this, you'd have to use the length of line formula to find the length of the what?
The radius.
Exactly, the radius. Yeah. But if you're given the general form, you already have
right.
C. You already have
I
F.
understand what you're saying. Right. No problem.
So you understand, if you have the general form, you have F, you have G, what else you have?
C.
Exactly. So I could find your radius using this formula.
Right. Right.
But if
So
I,
that is in case they don't give you the general formula, that's what you're saying.
yeah. So we'll do some more questions like that shortly.
Sure.
But you guys could take a screenshot of this. You guys have a screenshot?
No, sir, just don't give in trouble. Right, I get you there now, sir.
Okay. Let me answer this other question first now. So they're saying they want us to find the equation of the tangent to the circle at the point 4, -1. What's our problem? So do you guys remember what a tangent is?
A line that touches one point of the circle.
That along the circumference.
Exactly. So let me just do a little sketch, right? Let me do a little sketch. So this part over here, this is the radius of the circle, correct?
Correct.
We typically also call it the normal as well. And this would be a tangent line. Wait, let me just fix it. This would be a tangent line. Yeah, are you okay with that?
Yes, sir.
And they want us to find the equation of the tangent to the circle at the point 4, -1. So chances are, this is a sketch, eh? Chances are the 4, -1 is right here. And well, this is the center. Didn't we find the center previously?
Yeah. So the point would be where the line touching the circle, right?
Correct. So the tangent only touches the circle at one point. Understand? So here's what I'm saying. The tangent and the normal are what to each other?
Perpendicular.
They are perpendicular. So if I were to find the gradient for this portion over here, for this line segment, which is the normal, let me just say the gradient, we get a quarter. What would the gradient for this be?
The negative reciprocal of the
Yeah,
gradient.
it would be the negative reciprocal. It would be the negative reciprocal, right? So change. I want somebody to change the sign for this and flip it. What would that be?
Negative 4.
Negative 4, right? Negative 4 is that simple. So if two lines are perpendicular to each other, then their gradients are just in negative reciprocal. So let me show you how we're going to tackle this question. So So as you can see, we have the normal here. Since I have 2 points for the normal, can't I find the gradient of the normal?
Yes, sir.
Yeah, because to find the gradient of a line, how much points I need?
2.
2. So let's find the gradient of the normal. So we could call this x1, y1. We could call this x2, y2. And we know that the gradient is y2 minus y1 all over
x2
minus
as x1.
right. So what is y2?
Minus 1.
What? Negative 1.
What's y1?
Negative 3.
I have to put that in brackets, right? What is x2?
4.
4 minus x1. What is x1?
4.
Cool. So the gradient of the normal, well, what is minus 1 minus minus 3?
Positive. So negative 1 minus. I mean, it will be.
Ooh.
My bad. It
Oh,
will be
wait. This is a nice question. I don't realize it's a nice question. If you work this question out, you'll see that the gradient is undefined. Gradient.
Yeah, now I seen here. Mine's saying maths error.
Yeah.
What's going on?
Now, anytime the gradient is undefined, that tells you that it is what? Say that again. Okay, let me explain. So if the gradient is undefined, it's a nice question, boy. Big up, Claude one time. So guys, you see this over here? If you go to find the gradient for this, it's gonna be undefined. It's gonna be undefined.
meaning.
Okay, here was right.
It have no.
It's going to approach infinity. So I say it's gonna approach infinity.
Oh, okay. I understand.
Try plugging this into your calculator. Watch -1 plus 3. That's going to be 2 over 0, right? Where's 2 over 0? The calculator is going to tell you undefined.
Yeah.
So what does that mean? Anytime you see you got gradient like that, it suggests that you have a vertical line. And so if it's a vertical line, then
it's going up forever.
exactly. And perpendicular to that, you'll have a what type of line? What type of line is this? So, okay.
A straight line, sir?
Horizontal.
Horizontal. So let me make a note about this now. Gradient is undefined. Anytime a gradient is undefined, it suggests that the line is what? Horizontal or vertical?
Horizontal. Yeah.
Horizontal.
No, vertical.
Vertical. Going up. My bad.
All right. And perpendicular to that, what is perpendicular to vertical?
Horizontal.
Yes. And if something is perfectly horizontal, then the gradient is what?
0.
Yeah, the gradient is 0. It's a nice question, boy. It's a nice question. Someone come like this, they get trick real people. I'm running back again, right, guys? So if you find the gradient of 2 points and you find the gradient to be undefined, that telling you the line is what? That telling you the line is what?
That means that the line is vertical and the perpendicular line is horizontal.
Exactly. So let me just fix this diagram, make it a bit more accurate. Make the sketch more accurate. Hey boy. Maybe they're really using AI to make them test papers on it. Who knows? Cool. So here we're saying, right? we know that the gradient here is undefined. So that would automatically make the perpendicular line, which is the tangent, have a gradient of what? So we found, wait, I'm going to explain the process again.
Gradient of 0.
Exactly. Guys, we found this gradient to be what? This gradient was what?
0?
No, it was what? When we found the gradient for this, we found that the gradient was what?
Undefined.
Undefined.
Meaning that it's a vertical line. It's a vertical line. And so therefore, the gradient of the tangent is going to be what? This is a perfectly horizontal line.
0, 0, 0.
0. So I'll make a note about it here again. If you get a undefined gradient, it means it's a perfectly vertical line. And therefore, 90 degrees to that, you would have a horizontal line with a gradient of what?
0.
Cool. So let me apply it to this question now. So remind me, what is the equation of a line?
Y is equal to mx plus c.
Cool. Y is equal to mx plus c. Now, do we have a point on the tangent?
Yes, sir. 4 and -1.
4 and -1. So x is 4 and y is -1. Cool. And I know that my gradient of the tangent is what?
0.
0. So here what? I'm going to plug in this information to hopefully find for c. So what's y? What's y?
-1.
What's m?
0.
M is 0.
Where's x?
4.
4.
Right? So 0 by 4 is 0 plus c. So c is going to be equal to what?
-1.
So then the equation of the line is going to be y is equal to 0x minus 1 over 0 by x.
0.
So the equation of my line is just
-1.
Yeah. It's a nice question, boy. If this had come tomorrow, well, if it does come tomorrow, how much of you guys are gonna get like, okay? I feel like this is one of those questions that if you didn't know about it before and you reach that point, you'll be stumped. You would be stumped.
So that's the same one with the collinear.
So if you didn't show you how to do it, I say I get like a 2 marks. But now the thing kind of simple.
Yeah.
If this
Well,
comes tomorrow, I will be the happiest person alive.
This is low-key easy marks. Let me just graph it quickly and see what happened. I'm gonna graph it quickly. So x squared. I'm gonna graph it. X squared plus y squared minus 8x plus 6y plus 21 is equal to 0, right? I find 4 minus 3. I just graphing it fast, right? 4 comma minus 3. Right, yeah, that's the center. Nice. And I had find y is equal to -1. Yeah, everything checks out. Let me show you. I'm blowing your mind, right? Check this out, chat. Check this out, chat. Oh, you know GeoGebra is my best friend. Right. So let me put in the equation of the circle now. So x squared plus y squared minus 8x plus 6y plus 21. Bam. Are you seeing the circle?
Yes, sir.
Right.
What?
Right. And we found the center to be what?
2.
No,
No, 4 minus 3.
I think you could see it. That's it. I think you could see the answer directly from the graph, right? Watch. Bam. As the center ends. Yeah.
Yes, sir.
Yeah.
All right. And we found the equation of the tangent to be y is equal to -1. Bam. I rest my case.
Whoa.
And when I tap the point, when I tap the point of intersection, where it should be?
0.
0, sir.
No.
Oh.
Oh, 4 minus 1.
My bad.
Bam.
Ah, okay.
That real
Yes.
cool. That real cool.
Right. So the maths was proven. It's correct. Let me explain the question again, right? Because if something like this comes tomorrow, I would hate for you guys to be stumped when you find the gradient is undefined. Guys, if you get an undefined gradient, it suggests that the line is what? The line is what?
Perpendicular.
No. Wait.
No, you heard it wrong. So,
If the gradient is undefined, it means that the line is what?
It means that the line is
Vertical.
equal to the constants.
Okay.
No.
In the simplest terms, guys, if your gradient is undefined, that means your line is vertical. That's what it means. In the simplest way, this is what it means. It's a vertical line you're dealing with. You're dealing with a vertical line, right?
Yeah.
So, say one more time. If your gradient is undefined, it means your line is
vertical
and perpendicular or be perpendicular to that.
The horizontal.
Horizontal. If this is vertical, 90 degrees to that is the horizontal line. And what's the gradient of the horizontal line?
0.
0. So we were able to figure out that the gradient of the tangent is
0.
0. And do we have a point on the tangent?
Yes.
Yes. 4, -1. If we have a point on the tangent and we have the gradient, we could find for C. So that's what I did. C is -1, so the full equation is y is equal to 0x minus 1. 0x is just 0, so y is equal to -1. And you guys saw everything working out here when we graphed it.
Perfecto.
So actually, I'll one more time. If I have a perfectly vertical line, what's the gradient of this?
0.
Nah.
Undefined.
Undefined. Okay.
It's undefined. And the line perpendicular to this will have a gradient of what?
That should be 0.
I want to be 0.
Equals 0.
Right. Good. Hope we understand it, guys. I hope we understand it.
Yay.
Yeah, boy. Big up.
So if that come tomorrow, you see how we doing it here, I go understand. But you see if I have to do it myself, that is problems.
Actually, sir.
Yeah,
If
Nikolai?
this come tomorrow, I will be really happy. I
hope
love
so.
it so much. This is so easy.
It is. Like, I feel like coordinate geometry in hard maths is light work. Yeah. Yeah, Nikolai?
Yeah, but yes, sir. And when the radius touches the tangent at that point, it is 90 degrees.
Yes.
Right. So wouldn't that be the same for all the other questions?
Yes. The radius of the tangent is 90 degrees.
So that means that undefined as well.
No. Nah. Right. So in this particular instance, the radius here was a perfectly vertical line. Okay, what I'm saying, guys, if it's a perfectly vertical line, meaning that it's a line like this, gradient is undefined. But if I imagine, wait,
yeah, my bad.
If I had this radius over here, Nikolai, does this look like a perfectly vertical line?
Nah. Okay.
Nah. So it would have a actual gradient. It have a gradient. But if it's perfectly vertical, then the gradient is undefined. Yeah, Carlos.
So like, let me say you could just say the denominator is 0. So you can divide by 0, basically.
Exactly.
Yeah.
Exactly. Cool. So let me tackle some more questions like this. Guys, I'll understand that if you're talking about an undefined gradient, it's a vertical line, right? Let me just take that away from today. If it's an undefined gradient, a vertical line. And 90 degrees to that is a perfectly horizontal line with a gradient of what? Perpendicular to the vertical line.
0.
Good. Let me do some circle theorem. Not circle theorem according to geometry practice. I still saw how did they bring no circle theorem in the exam. I still saw about that.
Well, you need to go up to CXC and get them a good talk.
Yeah, boy.
So I have a question, right?
Yeah.
For like the radius formula, we had to remember it, or it could come in the answer sheet.
Yeah, I remember that one. So again, guys, if you are given the general form, r is equal to the square root of what? If you have the general form, r is equal to what? Remind me, the general form. From the general form, what we could figure out, we could figure out.
X
Squared
2.
plus
Wait,
F
nah,
squared.
guys. Nah. All right, from the general form, you could figure out f, g, and c. So once you have the general form, the radius is just f squared plus g squared minus c. This is for the general form. The general form, from the general form, you could figure out f, g, and c. F, G, and C. And so the radius is just the square root of f squared plus g squared minus c. Remember this. General form. General form. But it'll be so easy all the time. So let's look at a situation where it's not as simple. So any volunteers for this question?
I don't mind.
All right. Give it a read.
The coordinates of the for the center of this circle is 2, 1, and the coordinates for a point on its circumference is 3, 3. Determine the equation of the circle in the form x squared plus y squared plus ax plus by plus c is equal to 0.
Cool. So guys, when we look at this, right? When we look at this, what are they giving us?
They're giving us the center and the point of the circumference.
Right. They're giving us the center and they're giving us our point on the
circumference.
Right. Point on the circumference. So there's multiple ways you could tackle this question.
The length of a line.
Right, so you'd have to use the length of line formula. We would use the length of line formula here to find fully length of what?
The
radius.
Radius. Guys, and the distance from here to here would tell me the radius because it's from the center to the circumference.
Yes, sir.
Yes.
Yeah. And while at it, I just wanna there's two ways you could attack this question. Two ways. If you guys recall, the general form is x squared plus y squared. Continue. X squared plus y squared plus
2hx. No,
2fx plus 2g.
Right.
Oh, my bad. So don't write it out already.
And from this guys, just from this already, and we could already figure out.
The x and y.
Nah.
Which would be f, 2f and g, 2g. Sorry.
The center, sir. The minus f g.
Yeah, Nikolai, you're on the right path. So I'll show you guys the first way, which is I think the easiest way to answer the question. For a circle, isn't the center minus f comma minus g?
Yes, sir.
If that is the case, could anybody tell me what f would be?
-2.
-2. And g would be what?
-1.
-1.
-1, right? If you're confused, right, watch. If negative f is 2, then to find for f, you gotta change the sign. So f would just be -2. If negative g is 1, and if you change the sign, you get for g is -1. So here what? Just from that, we could figure out this part over here, and we could figure out this part over here. Nice.
Yes.
The only thing we'd have to figure out is what?
C.
C is the only thing we'd have to figure out. But if you guys recall, the radius is equal to the square root of f squared plus g squared what?
Minus c.
And now here what I'm saying. And I can figure out what f and g is?
Yes, you already did.
And I can find the radius?
Yes.
What gotta do then?
You gotta exchange the -2 squared plus -1 squared minus c, and then you had a.
I gotta rearrange it. I gotta make
Yes.
C the subject of the formula. Nice.
Yes.
That's one way you could do it. The other way you could do it is you could find for it in the standard form. The standard form is x plus f squared plus y plus g squared is equal to r squared. But if you do it like this, hear what, eh? You gotta expand this. You gotta expand this. You gotta move across this. You gotta simplify all the like terms, then get answer.
Too much work, too much work.
That's a lot of work. That's a lot of work, guys. So here what? Let me start off by finding the radius. The radius, to find the radius, it's just the length of line I'm going to be using. So that'll be equal to, what's the length of line formula first?
And they have read this.
Would not be x2
X2
minus x1
x1
squared
squared plus
y2 minus y1 squared.
Right. Cool. So, which one do you want to call the x1, y1? Which one?
The center will be the x1.
It doesn't matter, you know, it doesn't matter.
Yeah, well, x1.
All right, cool. So to find the radius, it would be the square root of what? So what's x2?
3
minus
2.
minus 2.
Right, what's y2?
3.
What's y1?
1.
Cool, let me find for this quickly. So 3 minus 2, that's 1 squared.
1 squared.
3 minus 1 is 2, 2 squared. So a radius is going to be square root of 5. All right, that's a radius. Okay, everybody understand how I get the root 5?
Yes, sir.
Yes, sir.
All right, cool. Cool, so I have that, and I know what f and g is, right? Did you guys understand how I get f and g?
Yes, sir.
Right. Yeah. So here what I say now, and you know that r is equal to the square root of f squared plus g squared minus c.
Yes, sir.
What I just find r to be? Somebody tell me what I just find r to be?
Square root of
5 squared. I mean, root 5, my bad.
And I know that f is what? Where's f?
Negative 2.
And g is negative 1.
Yeah.
So that'll be negative 2 squared plus negative 1 squared minus c. So since I have square roots on both sides, what I could do if I wanted?
You could
to the power of a half.
Now I could square both sides.
Oh.
If I square both sides, what happens with the square root?
It could drop. Well, you could cancel it off basically.
Okay, yeah, cancel it.
And I go end up with 5. Negative 2 squared is 4. Negative 1 squared is 1 minus c. We're gonna end up with 5 is equal to 4 plus 1 is 5.
5.
Guys, when you move across the 5, 5 minus 5 is gonna be what?
0.
Mm-hmm.
So c, we're gonna end up with 0 is equal to negative c. So c is just what? What's c?
C is
0.
C is 0.
Right.
Because if 0 is equal to negative c, right? NC would have to be 0. What's negative 0?
It do exactly.
Just 0, right? And so now you could write the final thing if you want. You can write the final thing if you want. I'll go over the working when I'm done.
So I tell you, my whole people are going before drawings, you know, sir.
That's good, that's good. So guys, let's write the final thing. So x squared plus y squared plus 2 by f. What was f?
Negative 2.
Minus 2.
Right, plus 2 by g. What was g?
Negative 1.
What was c?
0.
Right. So when you work this out, it will be x squared plus y squared minus 4x minus 2y is equal to 0. That's it. That's it. Alternatively, we could add, right? You could say x minus 2 squared plus y minus 1 squared equals to root 5 squared. You could expand, move across everything, and you'll get the same answer. Yeah. You'll get the same answer. So that's another route you could take. So let me explain this route again. So in the question, they gave us a point on the what?
They give you a point in the circumference.
They give you a point on the circumference and a point at the
Descent.
right. Well, it's just a 1 point at the center, right? So they give you a point on the circumference and a point at the center. Cool. Earlier, center to the circumference is the what?
Radius.
Radius. And we can use the length line formula to find the radius.
Yes, you can.
Yes, sir.
So the radius is √5. Cool. We had the center. The center is minus f minus g. From that, where's f and g?
Substitute.
So F and G would be 2, 1.
No, -2, -1.
-2 and -1.
Right. Because minus f would be 2. So if minus f is 2, then positive f would be -2. You have to change the signs. And negative g would be equal to 1. So what would g be equal to?
-1.
Right. So f is -2 and g is -1. Cool. So I have f, I have g, and I have r. Yeah? I have f, I have g, and I have r. What's the only thing I'm really missing?
C.
C. So here what, right? Hence we know r is equal to the square root of f squared plus g squared minus c.
Yes.
Yeah. Hence we just find the radius.
Yes, it was 5. I mean, √5.
So √5 squared. Well, we squared afterwards, right? But anyways, so radius is √5. Bam. We found f is -2, so -2 squared. G is -1, so -1 squared minus c. Notice I have a square root here and a square root here. So to get rid of the square roots, what I could do, Nikolai? To get rid of the square roots.
Square it.
Could square both sides. So that's gonna eliminate the square roots, and that will leave me with 5 is equal to 4 plus 1 minus c. Now 4 plus 1 is 5. 5 minus 5 is 0. So c is equal to 0. Cool. C is equal to 0. And so here what? I know that f is -2. I know that g is -1. And I know that c is equal to 0. And I have everything to just plug into this.
Yes, sir.
Yes, sir.
That's all. And you get your answer. X squared plus y squared minus 4x minus 2y is equal to 0. Yeah.
This is a real nice thing.
So I could just take a screenshot when I'm done.
Yeah, take a screenshot.
Yeah.
I want to do one more coordinate geometry question like this with circles on. We'll move on.
No problem.
Hey, vectors is guaranteed mark in Add Math, eh? Saying that in big. Guaranteed marks. The vector questions in Add Math is ridiculous. Like, hey, them would tell you prove that two vectors are perpendicular for 5 marks. All they had to do just find dot product, and if it's 0, 90 degrees.
Isn't it? Yeah, I forget that.
They have
So they just give that in the formula sheet, by the way?
Yeah, just give that in formula sheet.
Yeah, that's the trade formula.
Now we're talking about 3 marks then.
The circle geometry does always come.
Yeah.
So what we really have to remember then?
This formula, yeah, I remember this one for sure. R is equal to the
Oh,
square
they
root
don't
of
give it any, they don't give it any
minus.
formula sheet.
Nah, yeah, I remember this one too. The length of our line is x2 minus x1 squared plus y2 minus y1 squared. You guys have the screenshots?
Oh yeah, and the trigs.
Yes, sir.
All right, cool. Let me tackle this one. The circle intersects the x and y axes at 3 points. Determine the coordinates of the 3 points of intersection. Fun. So here we're saying, right? If something intersects the x-axis, we call that the x what? If it cuts any x-axis, we call that. Right. We call that the x-intercept. At the x-intercept, what do we know?
Y equals 0.
Y is equal to 0.
Y is equal to 0. That's what we know. At the x-intercept, y is 0. So here what? What I could plug that into? Where could I plug that into?
Into the general form.
Into this, I can plug it into the equation of the circle. Because if I want to see where it intersects, if I want to see where the circle intersects the x-axis, and well, I know what the x-intercept y is 0.
You have to get rid of the y.
Well, I'm telling you y is 0, so I got where I plug in y. So yeah, in a sense, it would eliminate it because 0 squared is just 0. Anything by 0 is 0. So let's answer this quickly. So that's going to be x squared. At the x-intercept, y is 0. So that's going to be 0 squared minus 4 by x minus 2 by 0 is equal to 0. So what's going to happen here, guys?
Well, it could just be x squared minus 4x is equal to 0.
And how would I solve x?
Difference of two squares or no, factorize.
Factorize. And when I factorize, how would I write?
1. I mean, it
That
would be
x
minus 4.
Right.
And so x would be equal to 0. And then we would say x minus 4 is equal to what?
0.
0.
It move across the minus 4, and that would turn to plus 4. So x would be equal to
4.
4. Good. And so here what, guys? We know at the x-intercept, what is 0? What is 0 at the x-intercept?
That is
Y is equal to
y.
0. Y is equal to 0. We already established that from the start. So when I'm writing my points, I know that the y value is 0. X value is 0 here. And the other point would be 0, comma what? Well, wait. I make a little mistake, okay, guys? When you're writing your points, we had to put first the x value or y value?
X.
Right.
0.
So what would I put here?
4, 0.
4, 0. Let me run that back again. At the x-intercept, what do we know?
That is
Y is equal to
y
0.
0.
Hey, big up Cohen Springer. One time they say he sent them over for the late night grind. Right. So if we're talking about x-intercept, what we know about the x-intercept?
That is C.
Wait, we gotta take the time now. At the x-intercept, what is 0?
We know that
Wait, no.
y equals 0.
Right. At the x-intercept, y is equal to 0. And so if I know at the x-intercept y is 0, I can replace. I'm just gonna plug in y is 0. Right? That's all I'm gonna do as well. Because at the x-intercept, we know that y is 0. So I'm gonna substitute y is 0. So I say 0 squared, and then I said 2 by 0. And that's gonna give me x squared minus 4x, which is equal to 0. So how would I solve this? How did I solve that, guys?
X is equals to 0, and then x minus 4 is equals to 0.
Right. Now, when you're writing your coordinates, it's always x first, then y. So we found x to be 0, so I put that over here. And what we know y to be? What we know y to be?
0.
Right, because we're talking about the x-intercept. Over here, we found x to be what?
4.
4.
And we know that the y value is?
0.
Bam. All right, let's move on to the y-intercept now, because they wanted it. They told us that the circle intersects the x and the y-axis. So where it intersects the x-axis is the x-intercept, and where it intersects the y-axis is the what?
Y.
Y-intercept.
Now, guys, if y is equal to 0 for the x-intercept, what do you suppose x would be over here?
0.
Save 0.
X would be 0. So A is the same process, guys. Anywhere I see x, what can I replace it with?
0.
0.
Well, get with emotions, guys. We have it. So
on top, sir.
So that'll be 0 squared plus y squared minus 4 by 0 minus 2y is equal to 0. So guys, if you're confused, all I did, anywhere I saw x, what write instead? Anywhere I saw x, 0. So we're gonna put y squared minus 2y is equal to 0. What to do next to solve this?
Factorize.
So if I factorize out, what I write?
Negative 2.
Y minus 2
Y minus 2. And that'll be equal to 0.
equals 0.
So what would I write next?
Then
Y is equal to 0.
Y.
Right, so y would be 0. And what
So
else?
Y minus 2 is
Positive
equal
2.
to 0.
Right, y minus 2 is equal to 0. And like somebody said, that'll be positive 2. So, guys, again, we write the x value first and the y value. Now, if we're dealing with the y-intercept, what do we know?
that x is equal to
That
0.
x is 0.
So when x is 0, we get y is 0. And when x is 0, we get y to be what?
2.
2. Bam. So, I don't know if I realize this, but like 2 of the points is the same.
That is true.
So, when it boils down to it, how much intersections we really have?
2.
3.
3.
I have 1 here, 2 here, and well, these counts as 1 because it's the same thing, so 3. So, my 3 points of intersection will be 0, 0, 4, 0, and 0, 2. I don't know if you guys understand.
Yes,
Yes,
that's
sir.
it.
Yes,
And
sir.
Yes, sir.
that's with 3 points. So yeah.
So, guys, anytime you see x-intercept, what we know about the x-intercept, chat? What we know about the x-intercept?
I
X
equal
is
to 0.
Whoa. Again, now the x-intercept, y is 0.
Y.
Y equal to
Why?
0.
Yeah, that
Why?
was just it.
Okay, that's why I say x.
I hear x, but small thing.
Yeah, Nikolai, ready yourself. Y-intercept. At the y-intercept. What we know at the y-intercept?
X is equal to 0, but I say y was equal to 0.
I will listen back to the recording after. But that's it for this question. Okay. Oh, and this is what the graphs look like, by the way, in case you're curious. This is the graph. All right. Okay. I want to do one more question like this, and I'm gonna call it. That's it. That's it for this. Let me share one more case. I want the beast in you all to come out, you know. The beast. Need you guys to lock in. Need you guys to lock in. All right. So let me tackle this question fast, please, guys. Please. So, you have volunteer.
So, me.
Okay. So Gabriel, give it a read from them.
The points M, 3, 2, and N minus 1, 4 are the ends of the diameter of a circle C. Determine the equation of the circle.
Okay. So here what? Here what happened in here, right? Imagine you have a circle for a second, and it's
Right.
telling us that M and N are what?
Ends of a diameter.
Right. Ends of the diameter. Everybody with me, right?
Right.
Those? Good. Are we with me or not?
Yes, sir.
yes, sir.
Yes.
So here what? This could be M. These are sketch, right? M is 3, 2. And N is
The opposite side of M.
right.
Yeah.
And that would form the what?
The diameter
Diameter.
Again,
which
is a sketch. Let me fix it.
touches the center.
Well, it passes through the center. So here what I'm saying, Ole, here what I'm saying. What formula would I use to find the center?
Midpoint.
Hey, big up.
Midpoint.
Yeah, boy. We would use the midpoint formula. Gabriel, do you know the midpoint formula?
Yes, I do.
What's the midpoint formula?
It is the M is equals to huge brackets x1 plus x2 divided by 2,
Right.
comma, y1 plus y2 all over 2, close brackets.
Big up yourself.
Yay.
So we could call, again, it really don't matter which one is x. It really doesn't matter. We could call this x1, y1, and we could call this x2, y2. If that is the case, Gabriel, that'll be minus 1 plus what?
3 divided by 2, and then 4 plus 2 divided by 2.
So minus 1 plus 3 is?
Is 2 over
2 over,
2.
right? 2 over 2.
And then
4 plus 2 is?
6 over 2.
Right, that boil down to be what?
1 and then 3 over 1, which is 3. Yeah.
So the center is 1, 3.
Boom.
Now, here what, In this question, they never specified how they want the equation of the circle. So it's fine if you leave it in the standard form, which is the easiest thing to do here, as opposed, like it's just real simple, I'll show you what I mean. So Gabriel, we already find the center. That's great. We have the center. What else is a very important thing about the circle?
The F and the G.
Well, we have that for the center, right? We have that for the center, right? If you want, we can find it one time. So the center is given by minus F comma minus G. So if you
Right.
wanted, Gabriel, you could tell me F is what? F would be what?
F is -1 and
Yep. F is minus
G is
1
-3.
and G is minus 3. Big up yourself.
Boom.
Now, what is a very important thing we need to find for a circle earlier? For a circle.
Center. The other
The
center.
radius. The radius. The radius. So, Gabriel, how are we going to find the radius here?
Radius is equals to square roots. Open bracket x2 minus x1, close bracket square, plus y, open bracket y2 minus y1, close bracket square.
Now, let me ask you a question, right, Gabriel? Are we going to select these 2 points to find the radius?
No,
No.
you're gonna use the midpoint and one of it.
Big up, Gabriel, boy. Big up. W's in the chat for Gabriel. W's in the chat for Gabriel.
Thank you.
Yeah,
That's
so
my favorite topic in advance.
nice, man. So, here what? If you wanted to use N and M, you could have find the length for that and just divide it by what?
Oh, okay. That makes sense.
Could have just divided by 2. That's one way you could do it. Or you could pick NC or you could pick CM. Bunch of different ways you could work with it. But
Yeah.
Gabriel, what do you want to do?
Let me do the NC now. So
All right.
Nick, my question.
Wait, somebody said that's not, yeah, that is the line of that is the formula for length of a line. Yeah. Yeah.
To answer Nikolai question first then.
Nikolai, I see your hand raised for a long time. Hand probably hurting here.
Yes, sir. One question. The one that we had with the square root of r is equals to f squared plus g squared equals c. Wasn't that finding the radius as well?
Yeah, but to use that for, by the way, is square root of f squared plus g squared minus c, minus c. You use that formula when you have f, g, and c. And that's typically when you have the general form. Right?
Oh, okay, sir.
Sir,
Yeah?
someone is asking if we can substitute the center into and x and y into the standard form to find c.
I wouldn't recommend that. I would not recommend that. But you could do that if you wanted. But you would have to expand and then simplify and move everything across the left hand side, and then it will give you C. Yeah.
You said
But like in this question, guys, it never specified, and also if you leave your answer in the standard form, that's fine. Gotta take that. It never specified. Right? So let me do this question fast. So Gabriel, let's just say we want to find the length of N to C, right? N to C.
Yeah.
So we could keep this as x1, y1, and we could consider this to be x2, y2.
Right. So it will be 1 minus 1. Yeah.
Right?
But
1 minus 1 squared.
right. Plus 3 minus 4 squared.
Yeah.
That is 2 squared plus minus 1 squared.
Right, was minus, well, all right, okay, minus 1 squared, right? Bam.
Yeah.
So that would be 5.
Yeah, it'll just be 5. Because
All right,
minus
nice.
afterwards.
Boom. And here, what the easiest thing for this question earlier is just to write it in the standard form. If you guys forgot the standard form, Gabriel, tell me what's the standard form?
What?
What's the standard form?
Would it not just be R? I don't know what you mean.
Okay, this is the standard form, guys. X plus f squared
Right?
plus y plus g squared is equal to r squared. How much of you guys know this form?
I don't know that form, so.
I do.
Is that the standard? Oh yeah.
Standard form. I think it's a formula sheet, no? Is it not?
I hope.
It is.
Yes, it is.
Bro. Hey, this really helping Add Maths people, you know.
I swear.
Them real generous when it comes to Add Maths. Watch. Wait, where are they? Watch. Only watch. They're real generous, boy. Let's see in that. Gabriel, watch. Right here.
I know the formula above it, but
So here what? I'll understand why I say this is the easiest thing to do, right? Because you already have F, you already have G, and you have R. So, what was F? What is F? What is F?
-1.
Right.
yeah.
What is G?
-3.
And that'll be equal to the square root of 5 squared.
Right.
So that'll be x minus 1 squared plus y minus 3 squared. And the square root of 5 squared is what?
Yes, no.
5.
5.
5.
Yeah, so this is the easiest thing to do. This is the easiest thing to do. Obviously, if you wanted, you could expand that and put it in general form. But let them take this. Let them take this.
Let's see the difference between the R equals the bracket F squared plus G squared. What's the difference between that and this?
Okay. That formula you're talking about is to find the radius for. You use that to find the radius if you have F, G, and C, which is typically given to you in the general form.
Oh.
This is just another form of a circle. And like, for those of you people that really like maths, I don't know if you realize, right? But like, the form of a circle is literally just from Pythagoras theorem. I don't know if any of you ever realize that. Watch. Imagine I had a point AB. I had another point here. Call this x comma y. Then this would be x minus a. This would be y minus b. And the radius would always be given by x minus a squared plus y minus b squared is equal to r squared, which is the standard form of a circle. I don't know if any of you ever knew this before. Anybody knew this before?
Oh my
Or no?
God. No, but the way how you explain it now, I understand standard form so much better. So you're saving me. Holy.
Yeah,
I
this is
really-
standard form. This is standard form. This is literally standard form. That's where they get it from. But instead of saying minus a, we just say plus f, and instead of minus b is plus g. Yeah. But they're giving you this in the formula sheet, chat. They're giving it in the formula sheet. They're giving it to you in the formula sheet. All they had to do is plug in f, plug in g, and plug in r, and they're good to go. Let me know if you guys okay with this question.
So basically, that standard form is just the circumference of the circle, which is fine.
No,
Wait, what's the question asking?
No, the standard form tells you how you'd find the radius. Well, it's just the standard form is just Pythagoras theorem. It's just Pythagoras theorem. Literally just Pythagoras theorem.
Okay, yeah. No, I can ask you just this also.
Yeah, no problem.
Yes, sir. Thank you.
All right. So guys, if they give you 2 points and they are the diameter, they form a diameter, how are you gonna find the center?
Find the midpoint.
Just find the midpoint. Just find the midpoint, guys. Just find the midpoint. And from that midpoint, you'll be able to find for what two things?
The radius.
and the radius.
The center and the radius, right? But from that, you'll be able to figure out f and g. That's the main thing. From if you have the center and you can find for f and g.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
And if you have the center and a point on the circumference, and you can find for radius.
Yes, sir.
Yes, sir.
Yeah. And if they don't specify what form they want it in, the standard form is the easiest bet, right? Because with this, all you had to do is plug in f. What find f to be? -1. Put that in one time. What find g to be? -3. Bam. What was the radius? Radius was √5. Easy, easy, easy. All you could do it, man. All you could do it. Let me just answer this question here quickly. So Gabriel, read this question from her. After this, we done with circles. Read this from her.
The equation of the tangent to the circle C at the point P minus 1, 4.
Right, so we want to find the equation of the tangent. No problem.
Right.
So Gabriel, in the last question, we had found the center of the circle, and the center was 1.
3.
And now they want me to find the equation of the tangent to the circle at the point P minus 1, 4. Here what? This is just a sketch. That is all it is. It's just a sketch. So let's just say for a moment that this was point. Well, wait. If it's minus 1, 4, probably be like over here. It's like a sketch, right? It's a sketch. This is just a sketch so you could visualize what's happening. Alright, so Gabriel. This over here is the radius, or I could call it the what?
The radius.
The radius or the what? That's what N. N.
The normal.
Yeah, radius or the normal.
All right,
And,
because for the tangent, it'll be 1/9. Okay, I understand.
and Gabriel, you understand that the normal and the tangent are what to each other?
They make 190. They make 90 degrees.
So they are what? Yeah. Yeah, like somebody said, they are perpendicular.
Oh,
So Gabriel, is it possible for me to find the gradient of this line segment?
yes, sir.
How about find the gradient of the normal?
Y2 y2 minus y1 all over x2 minus x1.
Bam, we could call this x1, y1. We could call this x2, y2, and we fix up there. All right, so y2 is 4, y1 is 3, x2 minus 1. Where's x1?
1.
Right, where's 4 minus 3?
1.
Minus 1 minus 1?
2.
Minus 2.
Minus 2.
And 1 over minus 2 is just minus half, right?
Right.
Now, here what I'm saying, guys. If the gradient of the normal is negative a half, then all you had to do to find the gradient for the other one is flip it and change the sign. That's all.
Yeah.
Gabriel,
Which just
if I flip 1 over 2, what I will turn to?
that'll be minus 2, and then you have to interchange the sign, so it'll be 2.
Exactly. So this is just 2. Guys, all you understand what I'm saying, right? Like, okay, if I flip this, it goes into 2 over 1, and if I change the sign from negative to positive, that's just what?
2.
That's just 2. That's just 2. Negative reciprocal, guys. Negative reciprocal. Cool. So here what? We know that the gradient of the tangent is what?
The 2.
The 2. Good. Do I have any points on the tangent?
Yes, sir. The one
Yes.
minus 1 and 4.
The minus 1 on the 4. Brilliant. We have the minus 1 on the 4. So that's x, that's y. Remind me, Gabriel, what's the equation of a line?
Y is equals mx plus c.
Y is equal to mx plus c. Bam.
Sir, one question.
Yeah, Nikolai?
Sorry to interrupt midway, right? But could you have used y minus y1 is equal to m in brackets x minus x1?
Right. That's the slope point formula, and you could have used that if you wanted.
Oh, okay.
Yeah. I had a girl Juicy with Nikolai saying one question. Oh, I will make a Nikolai for your birthday. I'll buy a jacket or something and make a sticker.
So I want a jacket with Mac vibes, sir.
Uh,
You gotta find out.
Yeah, for you, sir, you need merch, sir. You need merch.
So when you do your
Merch, sir. You should make merch, sir.
when you do your meet and greet, we must have merch.
Wait, guys. Wait, chat, wait. Wait.
That jacket round full up, boy.
Yeah, boy. Math vibes, boy.
Yes, sir.
Yeah.
So I feel I'll just go and make one, you know. Like, let me just get a picture of the logo and I'll go and get one.
Yeah, we literally come in and meet and greet with just math vibes merch.
Right. I feel I might
will make one. I will make one with these sticker. One of your stickers.
bet. I feel like I go do a meet and greet in like C3 or South Park or something because I'm from South. Yeah. Right. So if you want Nikolai, you could have used the slope point formula. I just want to use the slope intercept formula. It's easier for me. So Gabriel, we know the gradient is 2. And we know that x and y is -1, 4 respectively. So what to do? What to do?
Find for C.
Right. So y is 4. The gradient is 2. What is x?
X is -1.
What is c? I don't know.
A constant, yeah.
Right. What is 2 by -1?
-2.
What would I do?
Put the 2 in the other side. So 4 plus 2, which is 6. C is equals to 6.
Bam. So where's the equation on the line?
Y is equals to wait, we just put in, we just plotting 2
Yeah.
2x plus 6.
Right. This is the moment of truth. This is the moment of truth. Let me see. This is the moment of truth. So check this, right? So x minus squared.
Circle.
Right there. I just want to check to see if everything is valid. So our circle here, right? We had found the center to be 1, 3. Boom, badness, right? And then we find the equation of the tangent to the y is equal to 2x plus 6. When I tap that point, what I supposed to get? When I tap that point, what I supposed to be?
2 or -1/2. Something like that.
No, Nikolai, read the question. Read the question from Nikolai.
Find the equation of the tangent to the circle C at the point -1, 4. Oh, wait, is -1, 4 we're looking for?
Bam. Mathematical badness. Mathematical badness, right there.
Yes, sir.
Maths is so cool. So we done there. We done with circles. That's the day for circles.
So I have a question. Did you put it in the equation of a line of a circle?
Yeah, this is the equation of a circle. This is the standard form.
Oh.
They never specified. So you could give them in whatever form. Like, okay, you know it's a different forms for a line. Like it had the slope intercept, it had the standard form, it had the slope point form.
Yes, sir.
All not correct. If they don't specify, you can leave it in the standard form. If you want, you could expand it and put it in the general form if you want. It's fine. Alright, cool. I can take a screenshot of this. I see real people want me to do that trig question in 2015, boy. 2015 trigs. Are you okay with this?
Yes, sir. I already opened it. Don't bring back anything from 2015 and then, yes, sir.
Alright, let me continue.
Really hoping they do that.
Alright, so now we're gonna Ollie should be able to answer this question, you know, because this is a question that come on the maths paper earlier. Yeah. So the points A, 1, 2, B, 5, 6, and C, 7 is are given. Show that A, B, and C are collinear. Now, to answer the question, you just have to show that gradients of gradients of AB and BC are the same. So if you want to show that, you know, points are collinear, then you need to show that the gradients are the same for like any two pair. So let me do that quickly. So which pair do I want to select first?
A and B.
AB. Because okay, if it has the same gradient, doesn't it slope in the same direction?
Yes, sir.
Yes, sir.
Right. So A is 1, 2, B is 5, 6. So I could call this x1, y1. I could call this x2, y2. Bam. Where's the gradient? Gradient of AB. Well, y2 minus y1 over x2 minus x1. Right. Wait, we are sticking in now. Where's y2? Where's y2? What is
6
y2?
minus
5.
6, yeah.
6 minus 2.
Oh my god, yeah.
Where's x2?
5 minus 1.
5 minus
The gradient is 1.
6 minus 2 is 4. 5 minus 1, 4. Gradient is
1.
Right. Now, if this is collinear, then the gradient of BC supposed to be the same as that.
Yes, sir.
So, if we're talking BC, then B is 5, 6 again, and C is 7, 8. So, call this x1, y1, call this x2, y2. I already know the formula, right? So, where's y2?
8.
Right? What is 6? x2, 7.
1 minus 5.
Where's 8 minus 6?
2.
2.
7 minus 5.
2.
2.
Right? So, the gradient of BC is
1. So,
right?
Cool linear.
Right. Since MAB is equal to MBC, and both of them have a common point. What's the common point between AB and BC?
5.
5, 6.
5.
6. Right. Since MAB is equal to MBC, and they have a common point, AB and C are collinear. They should bring back a real trauma, boy. Because it was that simple.
They did.
Yeah, guys.
So when it says collinear, it means that you find the gradient of both because they're gonna be equal.
Exactly. Now, Alyssa, what exactly does gradient mean? Gradient just tells us the slope of the line segment. So okay. So the gradient would tell me how the line is sloping, right? It would like specify how the line is sloping. So if two lines have the same gradient, then that automatically means they are what?
Parallel.
Parallel. They're parallel. Because slope is just a measure of okay. If you think of this as the x-axis, you can think of slope as the angle formed between the x-axis and the line. That's slope. So if two lines have the same gradient, then they are what? Guys, look, they what? They what?
Parallel.
Parallel. And Alicia, if both of them have a common point, then automatically, watch. Bam, bam, bam. They're what?
They become one line?
Right, and so therefore all the points would be on the same line. So it's collinear. Collinear just means on the same line. That's all collinear means. Collinear just means on the same line. So if you have two line segments and the two line segments have the same gradient, they're parallel. Cool. If they have a common point, then they're on the same line. That's it. That's it. Cool. This is a question from Maths, right? Find the equation and the perpendicular bisector of AB. So guys, if we're talking about perpendicular bisector, now bisect means to cut in what?
Half.
Half, sir.
Right, this is a maths question. I should tackle this fast. And perpendicular just means 90 degrees too. So consider for a moment that this was AB, right? This is just sketches I'm doing here. Just so you all could visualize it. So A is 1, 2, B is 5, 6. A is 1, 2, B is 5, 6. So therefore, the perpendicular bisector would cut this line in.
Half.
And it would be at what angle to this line?
90 degrees.
90.
Right, that'll kill the perpendicular bisector.
Yes, sir.
Right, this point it's cut in is going to be the what point?
The midpoint.
The midpoint. If we call this one x1, y1, and we call this x2, y2, how do I find the midpoint?
The x2 plus x1 divided by 2, and the y2 plus y1 divided by 2.
Cool. So that'll be 1 plus 5 over 2. And then if I add the y values, That's going to be 2 plus 6 over 2. So the midpoint is what? What's the midpoint, guys?
6 and 4.
So it'll be 6
3,
over 2.
4.
Yeah, 6 over 2, which is, oh no, 3.
3 and 2.
3 and 2, not 4 and 2.
The 2.
2 plus 6 is 8. Where's 8 over 2?
Oh, yeah, you're
4.
right.
Right? 5 plus 1 is 6. 6 over 2 is 3. So the midpoint is 3, 4. Now here what I'm saying, right? The perpendicular bisector will pass through this line. But here what? We now need to figure out the gradient of the perpendicular bisector. Now, if these two lines are 90 degrees, which gradient I could find for first?
AB.
I could find for AB. Let's find the gradient of AB fast. I already have it. I already have the gradient of AB. What's the gradient of AB?
1.
So if the gradient of AB is 1, then the gradient of this would be what?
Same thing.
Nah. 1 is the same thing as 1 over 1. So if you change that, the 1 over 1, and you change the sign, minus 1 over 1, which is just what?
Or
Minus.
-1.
it late. Sorry, sir.
That's all right. So if you want to find the equation on the perpendicular bisector, the gradient of it was -1, and a point on that line was m, the midpoint, 3, 4. So that's x, that's y. And we know that the equation of a line is y is equal mx plus c. So we know that y is 4, and we know that m is -1. We know x is 3. You're gonna end up with 4 is equal to -3 plus c. When you move that across, you find that c is
Wow.
So, well,
c
4
is
7.
7.
So the equation of the perpendicular bisector, which is the pink line, that's going to be y is equal to what? Guys, how many gradient? What's the gradient of the pink line?
-1.
-1.
What's the y-intercept?
7.
Wow. Right, let me tackle some more vector questions because I have a feeling they're gonna bring something real easy. By the way, I prepare a nice question for you, right? Nice question. I feel like this might come tomorrow. Low key. I have a strong suspicion. Low key.
Yeah, that look real difficult. I'm not
Nah,
gonna.
it is difficult. So how we gonna do it?
What?
Sir, can I get a quick screenshot of the question that you just worked out?
Sure, no problem. So if you stay the whole night, we're gonna do the whole syllabus, you know. It's like 2 years hard maths in one night. It's crazy stuff. Which question was that? This one?
Yes, sir.
Wait, let me
Yeah,
take
sir.
screenshot of this whole thing.
Sir, you know what's the annoying thing?
I got
Yeah,
it, sir.
Sir, you hear me?
I hear you.
Yeah, the annoying thing is we could go through the whole syllabus and then Add Math just feel like bringing in topics or questions that we really understand or anything like that.
No. The Add Math syllabus. The hardest thing about the Add Math paper tomorrow gonna be algebra. I feel. If you know how to tackle the algebra, it gonna be light work for sure. The
So
algebra
is the
you
way
have
they
to-
word the questions is that as catch man, huh?
Oh, that's
They're kind of funny.
Well, let we do these vector questions here. Quick crash course on vectors, right? What are the formulas you need to know for vectors?
Unit vector.
Unit vector. So if you want to find a unit vector, it's going to be your vector all over the magnitude of the vector. If you want to find the angle, right? If you want to find the dot product, that's real easy. Like, okay, if you want to find the product of AB, they're just going to be the horizontal components. You're going to multiply that and you're going to add the vertical components. So say we had a vector A and it was x1, y1. And say we had a vector B and vector B was x2, y2. Then the dot product at that would just be x1 by x2 plus what?
Y2 by y1.
plot y1 times y2.
Yeah.
I think the product. Cool. Remind me of the angle. I think it was, wait, I think it was cosine theta is equal to
E by
A dot
by length
B.
of A by length of B.
Over magnitude of A, magnitude of B.
Anyway, I don't know how I just remember these things, Collier. It's crazy.
No, sir, I actually remember that one.
Big up yourself. Big up yourself. So I feel like these are all the formulas you need to know.
So they don't bring this in the formula sheets, or they do they?
Just give you this one and just give you this one. Yeah.
So the magnitude. You didn't do anything about the magnitude.
The magnitude, okay, the magnitude of a vector is just the square root of the horizontal component squared plus the vertical component squared.
Alright.
So these are the main formulas you need to remember. Well, not really remember because most of it is in the formula sheets anyways.
So they have one more in the formula sheets where
Which is?
the first one, but they say that where v is equals to xi plus yj.
That's not a problem. So like you see that xi plus yj form? This is just the call this again. It's just the unit vector form. Because if you guys remember, I is a unit vector for the horizontal, for like the x-axis, and j is the unit vector for the y-axis. So I would be one block to the right, and j would be one block up. Right. So let me handle this. Hey, vectors in Add Maths so much easier than vectors in regular maths. I'm telling you. Trust. I promise. I promise, Ollie. I promise. It's so much easier than regular maths. So who wanna help me with the first question?
Sir, I want to do it.
All right. How do you say your name? I see your name, but I don't know how to pronounce your name.
Dave Annie.
Devani. Which country you repping for? Which country is this?
Jamaica.
I'll big up Jamaica one time. Right? Yeah, so give me a question I read from her.
The position vectors of A and B relative to an origin O are such that OA equals 3i minus j and OB equals 5i minus 7j. Determine the unit vector AB and the acute angle AOB in degrees to 1 decimal place.
Right, so Devani.
Yes, sir.
All right, so anytime you see position vectors, that means that the vector starting from the what?
The vector starting from the origin.
Yep. Right, so let we answer part one. So they want me to find the unit vector of AB. So without anything, like what we had to find for, like to begin with, what we had to find for.
We have to find the vector for A and the vector for B.
But we had to find the vector for AB.
AB.
So let me show you an easy way to understand this, right? So we know that these vectors, all these vectors here starting from the origin. So O to A and O to B. O to A, O to B. So Devani, I want you to think of the origin kind of like a middleman. So if I want to go from A to B, then I would leave A, I would go to O, and then from O I could go to where?
From O you could go to B.
Good. Now anytime you go in the opposite direction in vectors, what are you gonna do?
Make it negative.
Exactly. So you see that, watch, we're going from A to O, but any question they give us,
3i plus j is OA, so we'd have to.
so that will turn to what? What would that turn to?
It's going to turn to negative 3i plus j because we're multiplying by the negative. The entire
Good.
thing by
And OB was what?
B was 5i minus 7j.
Are there any like terms over there?
Yes. So So minus 3i plus 5i is going to be 2i minus 6j.
And what is G minus 7G?
Minus 6j.
Cool, so that's vector A to B. People in the Zoom, you guys understand that? Okay, they said all the vectors starting from the origin, so we could think of the origin kind of like a middleman. I don't know what else to describe it. So if you want to go from A to B, you could go from A to O, and then from O you could go to
B.
right. We were going in the opposite direction. Notice they gave us O to A. However, we want to go from A to O. So all we're going to do is we're just going to change the signs. So that'll be minus 3i plus 3. We're going in the same direction here, O to B, so that remains the same. So 5i minus 7g. Only with more now.
Yeah, I know, understand.
Yeah. Yes, sir.
That's the
They made it negative.
Light work stuff, light work stuff. So now we need to find a unit vector AB. So if I want to find a unit vector for AB, then how would I work out, Devani?
You'd have to put the position vector over the magnitude of A and the magnitude of B.
Not quite. Not quite. If I want to find a unit vector for AB, that would just be the vector AB. That would just be the whole vector AB.
So AB
All
over the magnitude of AB.
correct. So vector AB is 2i minus 6g. Yeah?
Yes, sir.
And if I wanted to find the magnitude for that,
It's going to be 2 squared plus negative 6 squared.
for those of you guys that are having trouble with this, right? You're going to see the unit vector form a lot. You're gonna see vectors being represented in the form xi plus yg. What is important is you understand that the coefficient of I, which is x, is the x value, and the coefficient for g is the y value. And remember, if you want to find the magnitude of a vector, it's just the square root of what?
X squared plus y squared.
Good, x squared plus y squared. That's all, guys. That is all. So here what? If we have 2i minus 6j, then x is 2 and y is minus 6. So that is why I'm saying 2 squared plus minus 6 squared. So we have 2i minus 6j. And when I work out the inside the square root, what again, Devani?
The root square root of 40.
Square root of
40.
1 4
40. 40.
40. I'm sure we could have then a simpler form. The square root of 40, that looking like 2 root 10.
Times 5.
That looking like 2 root 10.
Yes, sir. 2 root 10. Wait. 2 root 5. Because it's 4 times 5, so 2 root 5.
Oh, yeah. So here I was saying, guys, the square root of 40. Where's the square root of 40, boy? I can give a little crash course on surds. So the square root of 40 is just, isn't that 4 by 10?
Oh, yes, sir. 4 by 10.
So that will be the square root of 4 by the square root of 10. What's the square root of 4?
2.
Guys, I do connected rate of change question real plenty in my videos on my YouTube channel. Where I did integration, where I did differentiation. I did that in detail. It's on my YouTube channel. Guys, it's on my YouTube channel. All you had to do is just go on my YouTube channel, guys. Like, watch.
So there Plants vs Zombies, I see in this.
Probably. Yeah, like Plants vs Zombies, but Plants vs Zombies is peak.
Yeah, I know, so I grew up with that game. So.
Right, so differentiation, watch. If you go somewhere to the end, I looked at rates of change in real detail. Real detail. Real detail. Rates of change here. Check out our first video. The one with 1.7K views. Streamed 4 days ago. Alright. Alright. But I will do those questions today as well. But anyways, that's gonna be 2i minus 6g all over 2 root 10. If I break it up into the parts, that's gonna be 2i all over 2 root 10. And then that's gonna be minus 6g all over 2 root 10. So you're gonna end up with 1 over root 10i. What? Tell me that, Johnny.
1 over root 10i and 3j over root 10, or 3 over root 10j.
And let me ask you a question, right? The unit vector has a magnitude of what? What does the unit vector have a magnitude of?
The unit vector,
When you hear unit, what do you think of? What length? A unit.
1.
1. So if I were to find the magnitude of this, what do you think it should be?
1.
Let me see. Let me see now. So that'll be the square root of 1 over root 10 squared. Cool. Plus what?
3 over root 10 squared.
Well, technically negative, but it wouldn't matter because I'm squaring. And when I press equal, since it's a unit vector I found, what is it supposed to be equal to?
1.
Magic.
Magic.
Yeah, boy. Magic. So that's how you find a unit vector, guys. It looks complicated, but it's not that hard. Let me run back the process again. Let me run through the process again. They wanted me to find a unit vector AB. So the first thing I had to find for is what?
Product of AB?
No, I needed to find A to B. I needed to find A to B. I needed to find the vector A to B. Right? So A to B would be A to O plus O to B. That's what it would be. Now, Nikolai, they gave us O to A, but we want to go A to O in the opposite direction. So, Nikolai, what would this turn to? Anytime we go in the opposite direction, what do you do the signs?
You change the signs.
So, positive 3i would turn to what?
Negative 3i.
That negative j would turn to what?
Positive.
Good. O to B. That 5i would, well, we're going in the same direction, so 9 would change, right?
Yes, sir.
Then is 2y minus 6j. Bam, that's A to B. Right, so we have A to B. If you want to find the unit vector for that, it's going to be the whole vector all over the magnitude of vector AB. So that's going to be the whole vector, which is 2i minus 6j, divided by the magnitude, which is just 2 squared plus minus 6 squared. Now, I gotta be real with you. Guys, you see how I gonna do this? No. If you have a Casio will give you the answers like one time. Let me show you what I mean. Right? Okay, stay with me, right? If you plug root 40 into your Casio will give you 2 root 10. One time. Until again, then only Casio, 2 root 10.
Yes, sir.
Yes, sir.
Yeah, and well, the next line will just be the 2 over 2 root 10. If you have a sharp boy, I'm feeling bad for you. Real bad boy.
So people use something in your life, sir?
Yeah, if you're an engineer, it is use these kind of things all the time.
No, I'm not talking about the sharp, so people use sharp in your life.
Yeah, apparently.
So I saw someone with a sharp going into the maths exam. I said, good luck with you, yes?
Yeah, boy. Making your life hard, yes?
So you don't think
But if
sharp
they
good
get
first
correct, that
treated?
means they're bad. What?
So you don't think sharp good first treated and paper one, so that is it?
No, hey. You could do 99% of the whole hard maths paper with your Casio. You can't really do that with
Oh,
your sharp.
no, I talk about maths, no, sir. We had our paper one in school, and we find out a way that like, he could have like save numbers in your save history now. So like 1 mean A, 2 mean B, and we just do that in that order for the all 60 questions because we know which year we was getting. And
That's
everybody
crazy.
and everybody in
That's
the form that get like up to between 50 and 60.
That's crazy, boy.
Yeah, but you can't use
You
calculator for
can't use
paper one.
calculators in paper one and maths.
Well, not for CXC, but I talking about like for midterm.
Yeah, well, hey, who cares about midterm? The big exams what we care about, you know. The big exams what we care about, and you can't use calculator and paper one, so it don't make sense. All right. So anybody that is confused, let me explain this back again to you. Quick. In the first part, they want me to find the unit vector AB. The first thing we have to find for is vector AB to begin with. So how would I find A to B? Well, A to B, that would be A to O and O to B. Imagine it's a triangle. How would I go from A to B? Well, I had to go from A to O and then O to B. You're probably saying, so where you get the O from? Well, I know I'm dealing with position vectors, and position vectors start from the origin O. So we can look at that as a middleman. So A to B is A to O plus O to B. I see they give me O to A. However, I'm going in the opposite direction, so I change the sign. 3i, bam, that goes into minus 3i. Minus g, that goes into plus g. So minus 3i plus g plus 5i minus 7g. I see in minus 3 plus 5, 2. I see in 1 minus 7 minus 6, bam. I want to find a unit vector. That'll be the whole vector all over the magnitude of the vector. So the magnitude is just going to be the square root of the x value squared plus the y value squared. That's why I say 2 squared plus minus 6 squared. And square root of that. And yeah, you simplify and you get your answer. That is it. Bam. Well, you okay?
Yes, sir.
All right,
Yes,
cool.
sir.
Yes, sir.
In part 2 now. Add page after. People, before they head out, right? I hear all they wanted me to do the trick question in 2015.
So we're
People
talking
in,
about kind of notes, sir.
I see it on the YouTube. People on YouTube go and head out.
Uh-huh.
Yeah.
So this is Zoom here, sir.
Right, in part 2. Yeah, I've seen real people asking for 2015 trick question there, boy. Real people. Real people. Right, part 2. They want me to find the acute angle. Devani. I didn't forget you know. We answer part 2. Right, so Devani, you there? Can I hear her?
No, we
All
don't
right.
hear you.
Right, so remind me, guys, if you want to find the angle, it's cos theta is equal to what?
E by B over length.
A dot B all over.
Magnitude A by magnitude by B.
So here what I gotta do, right? Here how this is actually work. Here how it is actually work. That's how it is work. And so let me explain. When you look at this question here, right? They want me to find AOB. And in the question, didn't they give us vector OA and OB? No,
Yeah.
before I say anything, right, guys, do we really care about the direction of the vectors?
Yes,
No.
sir.
No, we
No.
don't. No, we don't. Let me ask a question, right? If the vector was going in this direction and this vector was going in this direction, does that change the angle between them?
No,
Oh,
sir.
no, sir.
No, it doesn't. So we don't care. We don't care about that. Right. So here we're gonna do. We have vector O to A. Vector O to A. We know that is 3i minus g. That's 3i minus g. Vector O to B. That is 5i minus 7g. So if I want to find the angle here, you know what, maybe if I do like a sketch, I'll be able to visualize it better. Because I feel like I'm gonna get that. Check this fast. So O to A, you see in O to A is 3i minus g. What does that mean? That means 3 to the right and then what? 3 to the right and then 1 down. That's what it means. Because watch. Okay, you see the 3 over here, it tells us x. If it's positive, it's to the right. And then over here, you're not seeing it, but it's -1. And that'll be y. So if it's -1, that means you're going up or down?
Down.
Right. So 3i minus j really means 3 to the right and then 1 down. So guys, this over here is vector. This is point A over here. So that's O to A. And then O to B now. Somebody tell me, how would I go from O to B? How would I go from O to B?
5 to the right.
5 to the right, then what?
7 on.
And now it correlates at what point?
B.
B.
And we're trying to find the angle, what? Watch. AOB. 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 Isn't that the angle right here?
Yes, sir.
That's what we want to find, because remember, this is O. That is O. Watch. AOB. This angle over here. So all we had to do is just find the dot product on top. And in the bottom, you have to find the product of the magnitudes. So let's do that quickly. So cosine theta is going to be dot product. So here what, guys? If I am finding dot product, I'm going to look at the horizontal part. So like you see 3 and 5, guys, we're going to multiply that. And then what?
Multiply 1 by 7 by -7.
Minus 1 by?
-7.
I'm going to add those, I'm going to minus those. Product.
Yeah.
Somebody tell me dot product. What are we going to do?
Add?
Add. Are they understand or no? Dot product. People, dot product.
Yeah.
I only hear Nikolai.
Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
I using all it I using all the energy to keep up, If I give him a false energy and say, I wouldn't be able to keep up.
So I don't mind. I drink 2 cup of coffee there and I good.
Okay.
Sir, I
Nice.
don't really understand it.
Oh, I gotta explain it, but that's okay. I'm gonna finish the question.
No, I don't understand why I add by it not like 8 dot. Was it dot or
The dot, okay. When we say dot product, what does dot product mean? It means that it's a product of the horizontal components plus the product of the vertical components. That's what it means. So Gabriel, you see what we did on top here?
yeah.
This is the dot product. So OA dot OB is literally, all right, so Gabriel, what is the horizontal component for these two?
3i and 5i.
Right, so we're gonna say 3 by 5, and then we're gonna add that to, what is the vertical components?
1 and -7.
Not so fast.
No,
Minus 1.
-1 and -7.
Right. So you're gonna say -1 or -7.
Mhm.
That's the dot product. That's the dot product.
Okay.
Right? And now we're gonna give you the dot product. So that's what I did on top there. And let's find the magnitude of vector OA. How would I find the magnitude of vector OA?
3 squared plus 1 plus -1 squared.
Right? What would the magnitude of BV? BB.
So 5 squared plus -7 squared.
Cool. So cosine theta, when you work out the top, that's gonna be 15 plus 7, which is 22, I believe.
Yes,
And
sir.
and in the denominator, that's gonna be
9 plus
square
1.
root at 10 and 25 plus 49, 70, no, 84. I think, verify that for me. 25 plus 49. 25 plus 49.
70 4.
Right, 25 plus 49.
Yes, sir, 74.
So my bad. Yeah, 74. Cool. And so if you want to find your angle is going to be what?
Theta equal cos inverse of everything that's right there.
Good. Devani, you have a sharp or a Casio?
Sarah Casio, I can't deal with that sharp.
Yeah, earlier, imagine you having to do all of this on a sharp. That's mad work, bro. That's mad work. It's
Sure, I
crazy.
had to do it before. I bought the Casio before, like last week for maths.
Yeah. So
But
let
it's
me
not
know.
once you know how to use it, it's not as difficult, but it's still like tedious.
Well, I will tell you this. I had a sharp calculator from Form 1 all the way to Unit 2 Pure Maths.
So how you manage?
Well, I get distinction. I get distinction and everything. So in maths. I feel like the sharp awaken the beast on man. For a Casio or be I do most of the work for me, is what I'm trying to say.
You have to lock in with the sharp.
I don't lucky with the sharp. But let me know what answer you guys getting. I ain't anybody, but again,
36 degrees.
they said to the to one decimal place.
0.0.
All right, 36.
Point
All right, 36.0 degrees.
0.6.
Nah, that'll be 36.0 degrees because they wanted the answer to one decimal place. One decimal place. So in the calculator, you should get 36.027. And so the first
Oh, I think
decimal
because
place
my
is.
calculator is in radians. Hold on.
Oh, in degrees, eh? Ole, read that. In degrees. In degrees. Gabriel, you see that? In degrees.
And didn't we put this in degrees though?
Well, the calculator had to be in degrees if you want the answer in degrees.
I put I in degrees. Trust. Ain't no radians yet.
All right, that's so rad, bro. That's so rad.
So when it is multiply your calculator in radians.
Anytime you're plugging in like pi or like pi over 3, yeah, what? Anytime you're doing any trig part, any trig section of Add Maths, 90% chance your calculator should be in radians mode. When we do trigonometry, you can see what I mean, but once you're dealing with the trigonometry section in Add Maths, chances are your calculator should be in radians. I never used a Texas Instrument calculator before, never. Right, I got 36, right?
Yes, sir.
Okay.
Excuse sir.
Yeah, Nikolai, talk to me.
You want to go till 6 in the morning?
Whoa, 6 in the morning.
Yeah.
We need to sleep enough.
Slow down, slow down.
Sir, I locked in, you know, sir.
Let me go straight on to the
Yeah, I
exam.
mean, we
Start
already
now.
did the maths enough.
Nikolai, we sleep. We like to
No,
sleep.
hear Nikolai
You need
out,
sleep,
right?
Nikolai.
No,
Let me
no.
function
Hear
until like
Nikolai
the
out.
exam start now, sir.
If we finish 4 and we go to sleep for 4, who getting up?
I getting up. You talking about?
Well, I
I
have to
wake up
get
at 4 to go to school, bro.
Well, while asleep, while asleep, I've been.
Let me go straight until 1 p.m. sir. The maths fresh in we had 1 p.m.
Hey, Ollie, I've been doing Add Maths live, so like every day, like 9 hours every single day,
We need sleep
This is not the
now.
first Add Maths live I
Not
was doing.
human.
So that we stick to the 4 o'clock.
Today's the final countdown, sir.
All right, so guys, let me run through the whole question. I think Ollie okay with this though. I low-key feel like Ollie okay with this. Like low-key.
Yeah, vectors in your that big a problem, I know, sir. Okay.
In Add Maths is not a problem. In maths is kind of a problem. When you had to show that the collinear or like, ooh, Add Maths is be a problem. In regular maths is be a problem. So,
Sir, for me, vectors anywhere is a problem.
all right, so Alicia, let me run through this question now. So in the first part, they want me to find the unit vector AB. So first of all, what vector I have to find? Or what vector do I have to find?
A, O, and OB.
Nah. I had to find vector. Well, you're not wrong. They want me to find the unit vector of AB. To find the unit vector AB, I need to find A to B. So A to B is just A to O plus O to B. A to O is in the opposite direction of O to A, so I change the sign for everything there. Negative 3i plus j. I go in the same direction here, so I write back the same vector. You with me?
Yeah.
Then I simplify it, and I got 2i minus 6j. So, Alyssa, this is the vector A to B. However, they want me to find the what?
The unit vector.
How do I do that? Explain it to me. How do I do that?
I just know the formula. I don't know the name of the formula.
That's okay. So, if you want to find the unit vector, it is the whole vector divided by the what of the vector?
Is that called the magnitude?
Yes, the magnitude. So my whole vector is 2i minus 6j, and the magnitude would just be the 2 squared plus the minus 6 squared. Bam. When you plug this into your Casio calculator, you're going to get 2 root 10. From here, you just split it up. So, Alyssa, and I could just split it up. So, like 2i over 2 root 10 I, and then minus 6 over 2 root 10j. What could simplify there?
2 and 2 and 6 and 2.
Good. And you're going to end up with 1 over root 10i minus 3 over root 10g. Here what? Now they want me to figure out the acute angle AOB. So in other words, they want us to find the angle between vector OA and vector OB. So to do that, it's just going to be the dot product of these vectors. So dot product of OA and OB all over the magnitude of OA by the magnitude of OB. And that'll be equal to cosine theta. You know that or nah?
No, but I will remember.
Well, it's in the formula sheet. It's in the formula sheet, so it's there. So, Alyssa, how do I find the dot product of these two vectors?
My phone giving problem. Hold on. You're gonna times the 3 and the 5, and you're gonna add that to the -1, which is in front of the j, and the -7.
Bam. And you get 22. Cool. Cool. Easy. Light work. So that'll be 22 on top. In the bottom, you have to find the magnitude of vector OA and the magnitude of vector OB. Right. So how are we doing that? Well, that'll just be the square root of what?
The square root of x squared plus y squared
So 3 squared plus
plus -1 squared.
bam. And the square root and the magnitude of OB will be what?
5 squared plus -7 squared.
You have it, man. You have it. You have it. Watch. 22 over square root of 10, square root of 74. Bam. From here earlier, you just had to find cos inverse. Cos inverse of all of this, and you get your answer. 36.0 degrees.
So it acts with the angle. So yeah. Okay.
Light work stuff, bro. Light work stuff.
Excuse me, sir.
Yeah.
How would you work it on a sharp calculator, though?
Are you seeing my face right now?
First thing you have to do is cry. Second thing, get a
Hear what, eh? Hear what? You can work this on a sharp. Let me show you. I need to cater for my sharp brethrens.
Now, but you could get through. It just says have more brackets, answer.
Real brackets. Real brackets. So here we're going to do the sharp, right? You're going to get cos inverse first, right? You have cos inverse.
Uh-huh.
So we're going to plug this in into the sharp. So cos inverse 22 divided. You don't have to put too much brackets actually, you know. Press square root of 10. Then you're going to press the arrow to the right. Then you're going to because you want to come out of the square root. So you should have 22 divided by root 10. Then you're gonna come out the square root, then you're gonna press the square root again. Press 74, and you're gonna close the brackets, and you should get the my calculator in radians, my bad. Give me a second. Yeah, you should get the answer there. Cos inverse 22 divided by root 10, root 74. I feel like in again now.
Big W. Go and just try this exam.
You got through?
Mm-hmm.
Okay, good. Tell me if I could
Part by parts.
say that again.
And you could just do it in part by parts.
Yeah, you can do them part by part. That's completely valid as well. Yeah. So let me answer this question. Any volunteers for this question?
I don't mind.
Alright, so Nikolai, let's read it now. Any question I read?
Given that the coordinates of the points A and B are 7, -3, and 2, 1 respectively, say the position vectors according to the points A and B in form xi plus yj. First, determine AB.
Let me tackle this question fast. Alright. Yeah, so Nikolai. So one question, right, Nikolai?
Yes, sir.
If they give you coordinates, then the coordinates would be the same thing as what vector? Remember, coordinates start from where? Where the coordinates start from?
From the origin.
Yeah, the origin. So this vector would be O to A. And how would I write O to A? In this form, xi plus yg.
It could be 7i plus minus, no, 7i minus 3j.
Bam. W's in the chat for Nikolai. W's in the chat for Nikolai. Right? Then what would the other vector be? The other vector.
It could be 2i plus j.
Right. So that'll be vector O to B. O to B. That would be 2i plus 1j. Alright. Guys, we're cooking. We understand these questions?
Yes, sir.
Yes,
We're
sir.
cooking.
Sunshine
Right.
and university exams, looking good.
Looking good, looking good. Then we had to determine A to B. Nikolai, how we going from A to B?
A to O, no, O to A plus O to B.
Nah, it
No.
was going good this time.
Yeah, A to O and then O to B.
Now, Nikolai, if O to A is 7i minus 3j, then A to O would be what?
Minus 7i plus 3j.
Right? That'll be minus 7i plus
3j.
And O to B is 2i
plus
plus
1j.
Right, so minus 7i plus 2i is what?
Minus 5i.
And
Plus
3j plus 1j is what?
4j.
Real easy.
Yes,
Yo,
sir.
guys, this is real easy. Real easy. And Nikolai, let me figure out the scalar product OA dot OB. Nikolai, how are you doing that?
Multiply the 7i minus 3j by 2i plus 1j.
Wait, take your time. No, take your time. So are you gonna multiply
Yeah, well, you gotta multiply all the I terms and all the j terms, but I just say multiply the first by the second. I thought you was going to write out the 7i plus minus 3j now.
Oh no, we're gonna jump straight into it. So that'll be 7 by
7 multiplied by 2 minus 3 times 1. That'll be 14 plus 1 minus 3.
which would be?
That will be 11.
So guys. Guys, it. I don't think you get this 5 marks.
Yeah, speed run. Speed through that
I
question.
need to ask.
So you don't have to get them marks if it come in the exam.
I hope it comes in the exam. I hope this comes. This is so easy. It's so easy.
Me too. I hope it
With the way
comes.
CSEC moving, I really
So
hope.
you
I
don't find
really
Nikolai,
hope.
that's not too much dad jokes.
Hey. that jokes, Nikolai. Nikolai will come for you, and you go take your X. Nikolai, the X stealer. Let me explain something, right? Okay, this is what a vector question in Add Maths look like, and this is what a vector question in regular Maths look like. E, E. You don't know these, you don't. Yeah, boy. What would you rather? A vector question in Add Maths or a vector question in Maths?
Add Maths,
Add
definitely.
Maths any day, so add Maths
Add
any
Maths,
day.
definitely.
For sure. Right, so let me I want to do one of them questions where they ask you to prove it's perpendicular. If vectors are perpendicular, then the dot product is what?
0.
0.
Yeah.
0.
I low-key guessed.
Is it 0 or negative 1? Say?
0.
Oh, okay.
Guys, anytime they ask you for the unit vector, the way to find the oh yeah. And they literally tell you, they said determine the unit vector in the direction of PQ. So anytime they ask you for the direction vector, there's just a way to find the unit vector. Just saying that. Okay, well, I'll just do these two questions one time. These vector questions are going to take long, and I want to take these marks. These are guaranteed marks in the exam, Ollie. These are guaranteed marks. So who else for the next vector question?
I don't mind.
Me.
I'll let you help me with it, because Nikolai. Yeah. Right, so Amelia. But Amelia, you're real smart too.
Somewhat.
Right, so they want me to calculate P dot Q. How are you doing that?
The dot product.
So how are you doing that?
8 times 1 plus 2 times negative 4.
So if you're confused, watch, right? So we're going to multiply the horizontal components, which is 8 by 1. And then you're going to add that to the product of the vertical components, which is a 2 and a negative 4. So 8 by 1 is?
8.
Right. 2 by minus 4 is?
Negative 8.
8 minus 8 is?
0.
So when they ask us to state the angle between the two vectors, P and Q in the second part, what that will be?
90.
90 degrees. Yeah. Guys, anytime the dot product is 0, what does that say?
That they're perpendicular.
Right. Okay, well, let me share a quick proof, right? Because some of you guys in disbelief. Amelia, if we want to find the angle, isn't it cosine theta? In this case, it'll be P dot Q all over the magnitude of P by the magnitude of Q, right?
Yes, sir.
Now we find that the dot product was what?
0.
0 divided by anything is what?
0.
So cos theta is what anyways?
0.
0.
Where's cos inverse of 0, guys?
90.
Yeah, that's why. That's why if the dot product is 0, the vectors are perpendicular. More you know. I understand that. Watch. I'm asking that question. How is 0 over 5?
0.
0.
What is 0 over 1,000?
0.
0.
What's 0 over magnitude of P, magnitude of Q?
0.
And what is cos inverse of 0?
90.
90 degrees.
90.
If they ask you to prove that two vectors are parallel, you're just gonna show that they are scalar multiples of each other. That's all. That's all, guys. Guys, you do that plenty times in regular maths. If they ask you to prove two vectors are parallel, all they're gonna do is just prove that these two vectors are scalar multiples of each other. Well, you understand what I'm saying, right? Scalar multiples of each other.
Yes, sir.
Are they sure?
Yes, sir.
Trust me, yeah. Okay. Let me answer part C. So Amelia, they say in the position vector A is 4i minus 7j. Find the unit vector in the direction of A. How are you in that?
The vector over the magnitude of the vector.
Right. So that'll be vector A all over the magnitude of A. So the vector A is 4i minus 7j, and the magnitude is going to be the square root of what?
4 squared plus minus 7 squared.
Plug that into your Casio and never know where you get.
65. 6 square root of 65.
I can simplify. Look at it. Why does this thing keep closing for? Oh my days! Oh my days! Come now, bro. Alright. I keep playing up. Right. Oh, that can really simplify. That leaves us square. That's 65 then. So if you break up your answer into parts, but that will be Amelia.
4i over 65 minus 7 over 65 j.
And if I find the magnitude of this, what it will be?
1.
Yep. Because, watch, 4 squared is 16. 7 squared is 49. Where's 16 plus 49?
65.
Where's the square root of 65 squared?
65?
Yeah, where's 65 was
65.
65?
One.
One. Magic. Yeah, that's out there. Let me tackle this question first. Any volunteers to 2021?
I'll go do it.
So Gabriel, they're
Yeah.
saying that we have the position vectors P and Q relative to the origin. Telling us that O to P is 2 minus 3 and O to Q is minus 4, 1. They want us to determine the unit vector in the direction of PQ. So what to do, Gabriel? What's the first thing I gotta do there?
Yeah, well, you know that is P, no, yeah. O, yeah, you had to find for PQ
I gotta find for PQ. Yes, that's the correct answer. How would I go from P to Q?
from P to O and then O to P
Nah, P to O and then O to?
to Q, my bad.
That's okay. Alright, if it's P to O, right? If it is P to O,
Is
then
minus 2 plus 3.
right. And O to Q is minus 4, 1.
Yeah,
So that's gonna be what?
minus 6, 4,
Yeah, that's gonna be minus 6, 4. Bam.
boom.
Now, we want to find the unit vector for this. So that'll be what, Gabriel?
And that's the A dot B.
Nah,
No,
that is so to find the unit vector, Gabriel, it's just gonna be the whole
that
vector divided by the magnitude of it.
that the weight of the number over the 2 lines thing.
Nah, you're talking about the angle. So Gabriel, here we're gonna be, right? If I want to find the unit vector for PQ, it's gonna be the whole vector PQ divided by the magnitude of the vector PQ.
Oh, with the square roots, open bracket. Okay.
Yep. So here what? Maybe if we write this in the other form, it might be easier to work with.
di and dj.
Right. So how would I write that in the I and the j form?
Oh, minus 6 plus 1
Minus
minus
6i
I plus 4j.
all over the square root of
6 minus 6 1.
and minus 6 squared.
Oh,
So okay,
and
Gabriel, if you want to find the magnitude of any vector, wait, what's in there? If you want to find the magnitude of any vector, it is just the square root of the x value squared plus the y value squared. The x value is the first one and the y value is the second one. So x is minus 6, so I say minus 6 squared, so then plus what?
plus the 4 squared.
Right. So plug that into your calculator. So we have 36 plus 16. Run out of space here, buddy. So this is the last vector question for ninth. So guys, what are you getting for the denominator?
15.
13.
Again, 2 root 13.
Gabriel, let me know if you're getting 2 root 13.
Oh, no, I just plug everything on my
Wait, you can't put in the numerator, no, you cannot put in
Oh,
the
yeah,
numerator.
because it's
Can't.
an ing. Yeah, I get 213.
So when you break it up into its individual parts, it's going to be minus 6 all over 2 root 13 I plus 4 all over 2 root 13 what? All right, so Gabriel, all I do, I just split it up. So
Right,
I
yeah,
said minus
see
6,
that. I saw that.
but then the last one will be what?
J. Yeah,
J,
that would
yes.
be J.
Could I simplify this? I have minus 6 on top and then 2 in the bottom.
Yeah, that is 1 minus 3 on top.
Right, so I'll be minus
3 over 13, and then the next one will be 2 over 13, well, root 13.
guys, how you feeling about vectors, right?
Yeah.
Okay, get 3 marks from this, sir.
Confidence.
3 marks there, boy. 3 marks. Cool. So we're done with vectors. Nice. Let's move on to trigs. This is the moment we've been waiting for. Are you ready? Are you excited?
Somewhat.
No, sir. Okay.
Sir, could you
A
go back to
little
the
bit.
previous question real quick?
Well, we know we
Okay.
can have a lot of sine and plus cos a lot of tan is there when we
Sir, let me ask you one question, sir.
You
Yeah,
don't have
Nicole.
to change anything to sine and cosine?
Wait, guys. Nicola, you asked my question.
Yes, sir. Would the tan A plus B would be like the same thing like cosine and sine, cosine and sine rule, but it's basically fractions we're dealing with.
Yeah, you're onto something. So remember, guys, tan theta. What was tan theta equal to?
Sine over cos.
That was sine theta over cosine theta, was it not?
Yes, sir.
So let me ask you that question now. Waiting tan A plus B is?
Sine A over cos A.
Nah, sine
sine A plus B over cos A plus B.
right.
Ah,
Write
okay.
that down.
Okay. Sir, write that as peninsula, sir.
Guys, hear what, right? So tan is just sine over cosine, right? Hear what? If I ask you to tell me what tan 2A would be, what do you think that would be?
Sine 2A over cos 2A.
Guys, well. So here what? I'm gonna give a little real trigonometric questions. I give it like 3 minutes. Try a thing. Try that thing. People like to figure that out.
So now I figure it out, sir.
Hmm?
I say, sir, now I figure it out.
You figure it out?
Yeah.
Like the whole thing?
No, I didn't write it down yet, but I just picture it in my head.
What? What? Bro, what?
No, the sine AB, that is the compound angle, and the equation for the sine A plus B and the cosine A plus B is also a compound angle. So you just use that, you just break those two down, and then you solve to try to get tan A plus tan B.
Cool,
Well,
cool.
basically on the next side.
Try to do it fast.
So watch out when Nikolai going and see if you can start dreaming at math. So
For sure, for sure.
I was the same thing for maths, I'm not gonna lie.
Just come tomorrow. That's crazy. That's crazy. Let's come tomorrow. But it's one of the tougher profs. For sure. This is one of the tougher profs.
So it is already tomorrow, so.
So that again?
It is already tomorrow.
Yes. It's already tomorrow.
Well, for y'all, I'm 1 hour behind.
So that again?
I said for y'all, I'm 1 hour behind, so it's 11:06.
Oh yes, yes, in Jamaica. Have anybody okay, other than Jamaica, have anybody else from other countries here? People on YouTube, drop all your flags, drop all your flags.
I remember Christopher was in Guyana.
Right? Big up the Guyanese, big up the Jamaicans.
I know it have some people in Dominica.
People in YouTube. Where are you guys from? People. Just some Jamaicans and Guyanese. People here. Big up yourselves.
I only figured out the numerator, but not the denominator.
Certainly a tough question.
Sir, if we know that tan of A plus B is already equal to the right hand side, what are we trying to prove?
The pass rate for all maths is like 60%. It's be higher than regular maths. Yeah.
We're
Keyword,
trying to
right?
prove how it's equal to it. So
We are trying to prove this.
Okay, how the sine A plus B over cos A plus B is equal to the tan?
Yep.
Okay.
All right. I myself the only proof for this. I cannot forget it, so we will see. We will see how I handle it too. There we go. So tan A plus B is just sine A plus B over cosine A plus B. That's the main thing you have to see. Right? Hey, Nushi, big up yourself. Happy to hear I was able to help you get one. Right? So sine A plus B is what, chat? What is sine A plus B? What's that?
Sine A cos A plus sine B cos B, which is really 2 sine A cos A.
No. No. Nikolai, what are you talking about there? As if I had the same angle. That's what
Oh,
you're talking about.
so I put cos A. It's supposed to be cos. Wait.
plus
Nah, I lost myself there.
cos A sine B.
Yeah, take your time, Nikolai. Nikolai, I'm worried about you, you know. As my son, I'm worried about you.
No. So I can pass it, sir.
I hope so.
So, and this is in the formula sheet as well?
Yeah.
Yeah, I don't get through already, sir.
And well, cosine A plus B is what?
Cosine A cosine B minus sine A sine B.
Oh no, this is real easy. Yeah, it's real easy. So chat, here what happening? This is a big hint. The term here turned to what?
1
Okay, so what would I have to divide that by to turn into 1?
by itself.
Yeah. And if I divide this by cosine A, cosine B, what happen?
It'll turn to tan A, tan B.
Whoa, let's go. And if I divide this by cosine A, cosine B, what happen?
It'll just be tan B.
Nah, we figure it out, Figure it
Right?
out, guys. Wasn't that bad.
So
Yeah.
originally I was gonna change the two tans on top to sine over cosine, but then I was like, where do I go after that?
You see it now, right? You see it now?
Yes, sir.
So like all I had to do was just divide the top and bottom by cosine A, cosine B. Watch. So I'm gonna divide anything I do in the bottom, I have to do it on the top as well, right? So divide by cosine A, cosine B. So I'm gonna divide every single thing by cosine A, cosine B by. So that's gonna be sine A, cosine B. And I'm dividing that by.
Cosine A, cosine B.
And I'm gonna divide this by.
Cosine A, cosine B.
And the denominator now. What am I doing in the denominator?
Cosine A, cosine B.
Right. What's that gonna work out to be, guys? So
First
when
one will be
I look at this,
tan A, because the
That's
cosine
tan
B
A.
is cancelled.
Yeah, tan A, my bad.
right? What would happen over here?
Tan B because the cosine A cancel.
Right? What's over here?
That could be 1.
Yeah, that'll just be 1. That'll just be 1. Because everything cancel. Just be 1.
So
Over here?
that could be tan. No. Would that be tan A and tan B?
Correct. So sine A over cosine A is what?
Tan A.
And then sine B over cosine B is what?
Tan B.
And well, cosine A, cosine B over cosine A, cosine B is what?
1.
That's 1. And then we have sine A, sine B over cosine A, cosine B. What would that be, guys?
Tan AB.
That'll be tan A, tan B. If you're confused, watch this. What is sine A over cosine A?
Tan A.
What is sine B over cosine B?
Tan B.
Let me explain something. Somebody asked me, how could I just divide? Let me explain something, right? Guys, consider we had 8 over 16, right? Consider you had 8 over 16. Now, we know for a fact that would boil down to what? 8 over 16 is just what?
A half.
That would boil down to a half. And I could divide throughout by 4. And wouldn't that still boil down to a half? Watch. 8 divided by 4 is what?
2.
16 divided by 4 is?
4.
So, Nessa, if I divide the top and bottom by the same number or the same term, I'm not going to throw off the meaning of the expression. So consider you have something like 8 over 16, right? If I divide the top by 4 and the bottom by 4, notice I get 2 over 4, which still reduces to a half. So it's still equal. So this was a legal move I made. I divided everything on top by cosine A, cosine B, and I divided everything in the bottom by cosine A, cosine B. That was a legal move. It's just necessary whatever you do on one on top, you have to do on the bottom as well. And you need to do it to every single term. Alright, Nessa? Hope you understand that. So this is completely legal. And break any laws here. but I low-key feel like this might come today. Yeah, let me know if I have this done.
Do me one favor, right? I
Mhm.
looked the formula in the formula sheet because you said that on this in the formula sheet, but it looks confusing on the formula sheet.
No problem. You're probably talking about the plus or minus.
Yeah, with the how like a plus b in the brackets and stuff, because it's like usually just b in theta.
No problem, I'll explain it.
Thank you.
So, Nessa, let's see what I did. So, Nessa, I divided here what, Nessa? Sine A plus B? That's sine A cosine B plus cosine A cos B. I mean, cosine A sine B. And cosine A plus B, that's cos A cos B minus sine A sine B, right? So, Nessa, look at this. In what we want to obtain, my eyes are drawn to this part over here. So, Nessa, you see this part over here? This part over here turns to what? People on in the Zoom, that cosine A cosine B part turns to what?
1. No.
One.
It turns to 1. It turns to 1.
Yeah.
So what do I have to
Because
do
you
with
divide
cosine A? What would I have to do with cosine A cosine B to make it turn to 1?
divided by
Divided
itself.
by itself.
Exactly. And if I divide in this term by cosine A cosine B, and I gotta divide the whole thing here by cosine A cosine B, and the whole thing here by cosine A cosine B?
Because whatever you do to the bottom, you have to do to the top.
Correct. Correct.
Excuse sir, do you mind if I just take a screenshot?
Wait, so Nazia, you're asking me how did I get the first part? How did I get the first part? So if you guys forgot, just a reminder, tan theta is sine theta over cosine theta. It doesn't matter what the angles are. The point is tan theta is equal to sine theta over cosine theta. So what do you suppose tan A plus B would be? Well, that would just be the sine A plus B all over cosine A plus B. If instead of A plus B it was Z here, then it'll be sine Z over cosine Z. So I hope you understand. It's just sine over cosine, whatever the angle is. Now, sine A plus B, this is the compound angle formula for sine. And this is something I have to remember. Sine A plus B is just sine A cosine B plus cosine A sine B, something I have to remember. But it is in the formula sheet, and I'll explain it now in the formula sheet. So yeah, Nikolai, you can take a screenshot. Yeah, it's Joshi. After tomorrow is physics.
Yes, sir, thank you.
All right, so let me explain how it comes in the formula sheet quickly. So in the formula sheet, you are going to see the plus or minus. You can see the plus or minus, right? So Gabriel, you see how both of them are plus or minus?
Yes, sir.
What does that mean? That means, okay, that means if it's positive here, it will be positive here. So if it's sine A plus B, that would just be sine A cosine B plus cos A sine B. But if it was negative, instead, what is it going to turn to?
Negative sine A cos B negative.
Right. But over here now, you're seeing plus or minus, but over here you're seeing minus plus. So Gabriel, if it's positive over here, where do you think it will be over here?
Minus.
And if it's minus over here, where do you think it will be over here?
Plus.
Yeah. You understand?
Yes, sir.
If it's upside down, it just means when one is positive, the other one is negative, and vice versa.
Okay.
If both are the same orientation, it means when one is positive, like over here. This means if this is positive, over here is positive as well. Good.
So basically they combined it into like
Yeah, they
one
combine it.
equation.
They combine it into one. So Nazia, look at it right here, Nazia. Nazia, look at it right here. The compound angle formula for sine. So let me finish the trigonometry question here, and then we'll answer that question from 2015 I was giving people trouble, as well as a bunch of other trig questions. So they want us to solve the equation 2 sine squared x plus 3 cosine x is equal to 0. Now we spoke about this yesterday, guys. People that was there yesterday, You guys should know. Wait, remind me. Remind me, guys. What is the main identity you need to know? What is the main identity?
Sine squared plus cos squared. Well, sine squared theta plus cos squared theta is equal to 1.
Sine squared x plus cos squared x is equal to 1. Right. So let me ask you a question, guys. What would sine squared x be?
1 minus
1 minus cos squared x.
And what would cos squared x be?
1 minus
1 minus sine squared x.
1 minus sine squared x. Question. In these trigonometric equations, can I convert cosine theta to sine theta and say that legal?
No.
No, that is not legal. You cannot do that. You cannot do that. The only ones you could convert in terms of cosine or sine is the squared terms. Only the squared terms. Only the squared terms. And when you're working with trigonometric equations, we want the same, guys, we want the same trig function throughout. So same trig function. We want the same trig function. So when you look at this trigonometric equation, right, guys? When you look at it, you're seeing sine squared and you're seeing cosine. Is that what we want? Is that what we want?
No, sir.
No.
No, that is not what we want. We want everything in terms of one trig function. Could I convert the cosine?
No.
No. Could I convert the sine squared though?
Yes.
Yes,
sir.
Yeah. What could convert the sine squared to?
1 minus cos squared.
Somebody tell me.
1 minus cos squared x.
What is sine squared, guys? What could I convert sine squared to? I'm waiting, guys. Talk to me. Talk to me. Are we
1
1 minus cos squared x.
right? Plus 3 cosine x. And that'll be equal to 0. Let me go. And then we're going to distribute that 2 across all the terms here. What is 2 by 1?
2.
2.
Now, let me be real. That cosine thing making things look a little complicated. So if you wanted, you could have say, let y or something be equal to cos x. So question, if I am saying that y is cosine x, then I could rewrite this as 2 minus 2 what?
Y
squared.
Plus 3
Y.
3y.
equals to?
0.
This happens to look like a what?
Quadratic.
If I put it in the form of a quadratic, that'll be minus 2y squared plus 3y plus 2 is equal to 0. Are you seeing that on that?
Yes, sir.
Yes, sir.
I can't say this in big. If you're having a hard time factorizing this, it's not worth the pressure. Just plug it into your calculator and put down the answers, right? Right? If you did want to factorize it, you use the AC method. You want to factorize this with my fast. The volunteers want to factorize this with my fast. All right. Well, Nikolai. All right. I know you're already willing, right? A by C. A is minus 2, C is 2. Where's minus 2 by 2?
Minus 4.
Right. Here we're asking you, right? What two numbers would multiply to give minus 4, but add to give a what? You think you know?
Minus 1 by 4.
Wait, that's correct. That's correct. Minus 1 and 4. Because I want to get what when I add, I want to get what number? When I add, I want to get what number? 3. Right? The middle term. Cool. So I'm going to rewrite this as minus 2y squared. What? Some of us.
Minus 1y. Plus 4y.
What's
Plus
in,
2
boy?
is equal to 0.
Right. Can't put on the Great Wall of China in the middle.
Mm-hmm.
Great divide. Then we want to factorize each side. What's the greatest common factor here?
Y.
Y. We're gonna pull out the Y. I'll pull out the Y. What right on the inside?
Minus 2y minus 1.
Right. And if I do it correctly, I'm supposed to get that over here as well. So
Yes,
tell
sir.
me, Nikolai, what would I multiply here to get back positive for Y?
2. Well, minus 2.
Minus 2. Good, good, good. I see in minus 2y minus 1 here. I see in minus 2y minus 1 here. I can pull that out. So what would I write inside the brackets?
Y minus 2. Or
Big up
minus
yourself.
2y.
Now Y minus 2. I don't see doubt in yourself. Check Gabriel now. Oh, Gabriel look like she gonna fall asleep any minute, eh, boy. I like to put on the camera and thing and be part of the blanket squad, you know. Yeah, boy. For the ones who like you got the blanket and thing, boy. Sleep over, boy. Is that sleep over,
Yes, sir.
boy?
Yes, no, come on, come on.
Yeah, boy. Anybody else have the camera on? Look, Kyle, how you camera on, boy. Kyle, big up yourself, big up yourself. Look, Celine, punch camera. Celine had the blanket turning 2 out. Nice, nice, nice. Ah, boy. Oh, let's see the video with the
Target my team.
Kyle, you look like you're not gonna make it, boy. You look like you're not gonna make it.
So today, man went through like 2 different sets of lessons. Then after that, well, a high exam and a little bit. So
Yeah. I understand why you're gonna be tired. Right. So, minus 2y minus 1 is equal to 0. So we had to solve for y there. If I solve for y, I'll be minus 2y is equal to 1. So y would be equal to what?
Minus a half.
Minus a half, yes. And over here we have y minus 2 is equal to 0. So y would be equal to what?
2.
Positive 2.
Let me ask you that question, right? Let's recall what y was. Remember, earlier we said that y was cosine x. Somebody tell me, what's the only valid solution here, boy?
Right, but the first minute.
What's the only valid one? Somebody tell me.
This is y, well, cos x is equal to 2.
Negative a half.
Negative a half.
Negative a half. It won't give you any solution.
Let me ask you that question, right? Try to remember what the cosine graph does look like. It goes up to what?
1.
And it goes down to what?
Negative 1.
Negative 1.
Negative 1.
Will any angle ever give us 2?
Yeah. No.
No, this is highly illegal. Highly illegal. As Stefan would say, illegal.
So it's undefined.
Yeah. The proper thing you would say is undefined.
Here they ask us to draw the graph sometime, right?
Yeah, they ask you to draw. I will show you guys how to draw the trig graphs. I feel like I might come low key. They might ask like to sketch that. All right. So here how we gonna do this. Does anybody here know about the reference angle and thing on that?
Yes, sir.
Yeah,
Yes, sir.
I learned.
Okay, thank God.
Yeah, I
Thank God.
feel like
I learned
maybe we
it
could
from
like
you,
have
So we
the
didn't do
sir.
that last time.
feel like maybe we could probably like wait. You're talking about some all stripper teachers case?
Yes.
But like, I mean, how the other one I do ever forget so bad. Me feel like I could see that one here.
Yeah, you probably shouldn't say that over here. So guys, let me show you what we're gonna do, right? So it has something called the reference angle, and we use the reference angle to locate all the other solutions. In the question, they specified they want the answer. So people I was asking, how you know which one to use? If you look at the range here, they want the solutions between 0 and 2 pi. You think that's in degrees or radians?
Radians.
Right, radians. Good. Want to know. So over here would be 0 rad. Over here would be what? Wait, for those of you guys that don't know, Remember, pi radians is equal to how much degrees?
180.
180.
180.
Cool. So this will be 0. What would this be?
Pi over 2.
Apple pencil that I gave, boy. Oh, God. Let me see if the fake Apple pencil go carry me through.
Just get a Samsung tablet.
I feel I might just low-key had to get a Samsung tablet and done, yes? I want to get like the tablet 10 Ultra or something. Look, hey, big up the fake Apple pencil one time. Big up the fake Apple pencil. Alright? Double use any chats for the fake Apple pencil.
Holy clutch.
Right. What would this angle here be?
Pi over 2.
I'll be pi over 2, right? What would this angle here be?
2 pi.
Nah. 2 pi is 360.
Pi.
Pi.
Right? What would this be?
3 pi over 2.
Right. 3 pi over 2. And lastly, over here would be what?
2 pi.
Hey, yo, Ray. Whoa. If I listen to Ray type in the YouTube chat, oh my God. Oh my days. Ray, boy. You get me banned now, boy. Hey.
Wait, so he said the one you don't forget it.
I feel like that had to be it, you know. I feel like that had to be it. Because I forget that.
Well, thing take cash.
Yeah. I said that's easy.
What?
All the teachers said all that in school.
Yeah. No, well,
What?
the art teacher was one of these students who was like, if you don't want to forget, just remember that. And like up to this day I don't ever forget. So
So what are you doing, sir? What is Ray doing?
Ah, boy. Nah, man, garbage, boy. All right, so yeah. Here what? The reference angle, right? If you forget this, right? Here was remember it. All school teachers, girls. So in this quadrant, everything is positive. In this quadrant, where's the only thing positive?
Sine.
Sine.
Where's the only thing positive here?
Tangent.
And the only thing positive here is
Cosine.
cool. And again, the reference angle is in the which quadrant?
First quadrant.
First quadrant.
And it's an acute angle. Now here what? If we know that the reference angle exists in the first quadrant, what you could do is you could actually mirror this in the other quadrants to locate the other answers. But here what? I'm mirroring the reference angle, you know, but here the reference angle actually is in the first quadrant. So here we're saying, guys, the reference angle is in the which quadrant?
The first quadrant.
Right, alpha. This is the reference angle. And this is in the first quadrant, implying that it is always what?
Positive.
Always positive. So, let me cook, right? We have cosine x is equal to negative a half. Now, we're not going to find cos inverse of negative a half, you know. We're going to find the reference angle, and the reference angle is going to be what?
Cos inverse of a half.
Right, cos inverse of a half. But is that my answer? Is the reference angle my answer? Yes or no?
No, sir.
No, it is not my answer, but it will allow me to locate my solutions. What's cos inverse of a half? In radians, eh? In radians. We need to know in radians, eh?
Pi over 3.
Well, again, pi over 3.
Yes, sir.
Cool. So my reference angle is pi over 3. So let me explain something. We want to figure out where cosine is what?
Negative.
Negative a half.
Negative a half. So could anybody tell me where cosine is negative?
In the second and third quadrant.
So let me show you how we're going to do this. We're going to start from 0 and we're going to go in an anti-clockwise direction until we touch the line touch the line there, corresponding to the reference angle in that quadrant. So let me explain something, right? It looked as though this angle stopped how much? Here what? For the purpose of explanation, I will use degrees to explain this, right? Here, how much degrees is this? How much degrees is this?
180.
Down 186.
And the reference angle is pi on 3, which is really 60 degrees. So it looked like we stopped how much degrees before 180?
120.
Well, 120 is the answer, right? Because you stopped 60 degrees before 180. I'll understand. Do you guys understand why my solution is going to be, well, I could say 180 minus 60?
Yes, sir.
Right. So that's my solution there. So that's one of my answers. So one of my answers is going to be theta is equal to pi minus what?
160.
6 pi over 3.
No, pi over 3. Pi on 3. Then what the answer in radians, you know? I just do that over there for it to understand the explanation sake. So this part over here, you know this is pi over 3. And you know that the pi is the full thing. So really, that's just pi minus pi on 3. So I hope you understand that. And my next answer is going to be how would I figure that out, guys? So here what? This over here is how much radians? How much radians is that?
Pi.
That's pi radians. That's pi radians. And then we went pi on 3 radians. So this whole thing is pi, and then we went to extra pi on 3. So what that will be?
Pi plus pi and 3.
Yes. Pi plus pi on 3. So let's calculate the two answers quickly. So pi minus pi on 3 is what?
2 pi over 3.
Pi over 3.
2 pi over 3, right?
Yes, sir.
All right. And my other solution is what?
4
4
pi
over 3.
Now question. When I plug that back into this, what's supposed to get?
Let's get
What's supposed to get, guys?
Negative a half.
Yeah, I'm supposed to get negative a half. If I don't believe me, let me show you, know? Alright, let me show you. Quick. Right, watch. I want to cosine 2 pi over 3. When I press equal, what's supposed to get?
Minus half.
Bam. Again, the negative a half. Seeing that again, the negative a half, right? Okay. The other answer was 4 pi on 3. What's supposed to get?
Negative half.
Bam. I get back the negative half. That's what we're talking about. Let's go. Whew. So my answers are 2 pi on 3 and 4 pi on 3. Yeah, you guys understand this or not?
Yes, sir.
Yes, sir.
So guys, if you get a negative answer, okay, if you work it out and you get a negative answer, are you just gonna find cos inverse of the negative answer and done?
No.
No, we gotta do. You gotta find your what?
Reference.
You have to find your reference angle, and your reference angle is always
It's always
Pi over 3.
it's not always pi over 3, but it's always positive. So you see how we have negative a half? the reference angle will always be the positive counterpart. So cos inverse of positive a half. Okay, if you had got a negative a quarter, where I find for the reference angle? Tell me. Tell me, guys.
Cos inverse a quarter.
Exactly. Cos inverse of positive a quarter. Hope you understand. Now, we want to figure out where cosine is actually negative. Negative. So, that's going to be in the second and the third quadrant. To find the answer in the second quadrant, that's just going to be pi minus pi on 3. And to find the answer in the third quadrant, that's going to be the pi plus the pi on 3. Okay. I gotta move on there. Let me follow. Okay with this.
So wait, you could go back to the original question. So I can see it.
Sir, somebody said they don't understand, and I don't either.
Okay, no problem. Maybe a little tough. Like, all right. So, Alyssa, when you work in these trigonometric equation questions, right? You need everything to be in terms of the same what?
You say function?
The same trig function. Over here you're seeing sine and over here you're seeing cosine. We can't have that. We cannot have that. We need everything to be in the same trig function. So, Alyssa, I could convert sine squared to what?
To okay, but anyway, 1 minus cosine
Right.
squared.
Good. I can convert that to 1 minus cos squared x. Now, when you expand this, you realize that we end up with an equation only in terms of what?
Only in terms of cosine.
Good. Only in terms of cosine. Now, the cosine can be a bit complicated, so we could say let y be equal to cos x. If I tell you that y is cosine x, then this is going to turn to y squared, and this is going to turn to y. So we end up with 2 minus
Sorry.
2y squared.
Why is it 2 minus 2 cos squared x?
Right. So we replace sine squared x with what? What did we replace sine squared x with?
With 1 minus cosine squared x.
Right. What is 2 by 1?
2 to 1 is 2.
And 2 by minus cos squared x is?
Oh, 2 cosine squared x.
Right. So I said let y be equal to cosine x. So this will be y squared, and this will be y. So 2 minus 2y squared plus 3y. Yeah? Then we need to solve this quadratic. So I put it in the form of a quadratic and I solve it. So I would have factorized and I found, and when I factorize, I got minus 2y minus 1 is equal to 0, and I got y minus 2 is equal to 0. So what did I end up with y? What did I find y to be?
Equal to 2.
We found y to be 2 and we found y to be what?
Negative a half.
Which one out of these solutions is invalid?
The 2.
2, because if you look at the cosine graph, what's the highest value the cosine graph will give you?
1.
Could it go down and it goes down to what? What's the lowest value it can give you?
1.
Exactly. Does it give you 2?
No, we can't go there.
Nah, so that's illegal. Next part. This is the part that was confused real students. You notice that the angle here, well, cosine x is going to give us a negative answer. But that does not mean we're going to find cos inverse of negative a half, Alyssa. We are going to find cos inverse of the positive. Probably saying why, sir?
Why?
We're doing this because we need to find for something called the reference angle. The reference angle exists in the first quadrant, and we could use it to find where all the other angles are.
Okay.
So we found the reference angle to be pi on 3. So this over here is going to be pi on 3. This over here is going to be pi on 3. This over here is going to be pi on 3, right? And this over here is going to be pi on 3. And we want to figure out where cosine is what? Positive or negative?
Negative.
Negative, negative, negative. So it'll be negative in the second quadrant and in the third quadrant, second and third quadrant. Because Alyssa, what is the only thing positive in this quadrant?
Sine.
And the only thing positive in this quadrant is?
Tangent.
Here what we're going to do. To find our angle, we are going to go in an anti-clockwise direction until we touch this line over here.
Mhm.
Now, did we make the full 180 degrees?
No.
No, we actually stopped. We actually stopped pi. Well, here what? We're not working in terms of degrees here. We're actually working in terms of radians. So did we make the full pi radians? Remember, pi is 180. Did we make the full pi?
No.
No, we actually stopped pi on 3 before pi. So my answer would just be pi minus pi on 3. Because this is pi on 3, and the full thing would be pi. So I say pi minus pi on 3. You actually understand that or no?
Yeah.
And then the other solution will be in this quadrant. So watch. This over here is pi, and then we proceeded to go pi on 3. So what would I say the answer is?
You're gonna add pi on 3?
Yes, I'll have to add pi and pi on 3, and I will get 4 pi on 3.
Okay.
Yep. And when I plug it into my calculator, I am supposed to get back negative a half. Watch. When I put cos 4 pi on 3, what do I get?
Cos inverse or cosine?
Cosine, watch. Cos x supposed to give me negative a half.
Mm-hmm. What am I doing? Hold on.
The calculator needs to be in radians, eh? Radians.
Yeah, I realize.
This time passed by so fast, like, it's already 4. It's like almost 4 o'clock.
It's almost 1, just 3 more hours. And so if you think about it, 4 more hours in Germany. Just.
I find like you will say, like check Gabriel. Trust. Gabriel is cracking me up, yes?
Good.
Yeah. So you're supposed to get a negative a half. Supposed to get a negative a half. Alright. So we had to move on there. But Alyssa, if you plug cosine 4 pi on 3 and you calculate in radians, you're supposed to get the minus a half. Alright. Now we let's do the question in 2025 now. So I can show you guys how to sketch graphs.
So one question. From the
Yeah.
from the question, right, it says 0 is less than or equal to x. Does that not mean x not negative?
Okay, wait. Let me explain something. This is telling us the range for our angle. Remember. Oh, I make a mistake here. This one should be theta. This should be x. Good point. This is all that is supposed to be x. I saw a custom with theta. All that is supposed to be x. Yeah, boys, I good thing you tell me that. So here what, right? Marva. You see this over here? This is telling me that my angle needs to be between 0 and 2 pi. That's what it tells me. My angle needs to be between 0 and 2 pi. So my angle I get needs to be between 0 and 2 pi. So these were my answers. These are in between 0 and 2 pi.
Okay, thank you.
No problem. Let's do the question that was in 2025 now. My students should be able to mash up this question by now. We do this before. All right. So, guys, they want us to draw the graphs of sine 2x and cosine 2x. Now, you see how we have 2x over here? Well, let's see that, yes or no?
Yes, sir.
Yes.
What does that mean, boy? That means that any angle I put into this is going to be multiplied by
2.
Exactly. Somebody tell me. How much Okay, for the regular sine graph, right? When does a full revolution happen? Between what and what?
0 and 180.
Between 0 and 360 degrees.
Oh.
Remember, a full revolution is between a successive is like a is the distance between a successive crest and trough. Are you not talking
Yeah.
about physics people or not?
Yeah.
All right, so for sine x, you have one full revolution from 0 to 360. Now for sine 2x, if any angle I'm putting in there is going to be multiplied by 2, one full revolution is going to take place from 0 to what? Anybody can tell me?
Double
180.
720.
180.
No.
Because if I plug 180 into this trig function is going to experience it like what? Since it's 2x, it's going to experience as 2 times 180. Where's 2 times 180?
360.
Right. You know what? I'm going to make it even simpler for you, right? You see this over here? See this number over here? This number tells us the amount of revolutions. Tells us the amount of revolutions. So in other words, from 0 to 360 degrees, how much revolutions you go off for sine 2x?
2.
2.
2. For cosine 2x, how much revolutions you go have from 0 to 360?
2.
2.
2.
Yeah. So let me show you how we plot on this in like the most simplest way possible. Everybody have a Casio, right? I hope.
Yes, sir.
Okay. Here we're going to do, right? Let me start off with sine 2x. And if you look at the graph, they already gave us some key points. I'm not sure if all seen that. Are you seeing that or not?
Yes, sir.
Yes, sir.
And well, obviously we'd start at 0. We should probably start at 0. So here we're going to do, right? Here we're going to do. Starting off with a 0. What is sine 2, 0? What is sine 2 by 0? What would that be, guys?
That would be
0.
That would be 0,
0.
right? That would just be 0. So my first point is 0, 0 over here. Then the next thing I'm going to plug into my function is pi on 4. So I'm going to say sine 2 pi over 4. Plug into your calculator and confirm that you're getting 1.
Yes, sir.
When you guys plug in pi on 4, this should work it as sharp as well. Just make sure you calculate in radians mode though. Anytime you see pi, your calculator has to be in radians mode. That's like the giveaway. When you guys put sine 2 by pi on 4, remember your trig function is sine 2x, you know. So whatever you put in, you need to multiply by 2. So what are you getting for sine 2 pi on 4?
1.
1.
1. Okay, according to the graph, what's the next angle we should consider? Pi on 2. We should consider pi on 2. So I'm going to put sine 2 pi over 2. Let me know what you guys are getting.
0.
Anybody else getting 0?
Sir.
Yes, I get 0 too.
So I'm going to put that point over here. Are you understand what happening so far or no? Yeah or no? I see
Yes.
Gabrielle is hitting
Yes,
some
sir.
bad. Check Gabrielle. Gabrielle actually listens some training badly.
Somewhat.
No,
Somewhat.
actually, I was listening to 3 Days Grace, but I had to wake up myself somehow.
Okay, that's true. Where's my next angle I should consider, chat?
The 3 pi over 4.
Right, so I'm gonna plug that in over here. You know what song I have in my head right now? Wake me up and save me from
Yeah,
myself.
innocence. I
Wake
was
me
gonna play
up.
that after, you know. You're so right. I'm gonna play that now. Actually, you're right.
Me up. My voice a bit. Oh, woo. Long time I sing. Good.
So
Wake
after
me
we
up.
done
Take
that,
me up
we'll
inside.
sing a song
Just
too.
say. Say that again.
After we done doing work, so we'll sing a song.
Right, we will sing a song. Don't know. What again for 2 by 3 pi on 4?
-1, sir.
Right. I will put that right here. Bam. And then what's the last point I should consider?
Yeah.
So that pi. Pi.
Yeah.
Just 0? Oh no,
That just
2
zero. That just
2
zero.
pi.
That just be 0, right?
Still 0.
So guys, I don't know if all is seen it, but let's see in the sine graph. Or let's see in sine 2x.
Yeah.
Yes, sir.
Well, yeah, I don't see it. I gotta try to do a sketch here. Let me see if I can get this done.
You got
Wait,
this.
but
So remember the last time you did a sketch?
oh my days, yeah. We gotta take that. We gotta take that. We gotta take that. How to take that. Right? That was nerve wracking. So that's sine 2x done. Let me know if you're okay with that. Now, how much revolutions is that, guys? How much revolutions is that? We have one up and one down.
2.
No, that is not 2. That is
One.
2. That
One.
is not 2. That's 1. Probably saying
One.
so. Probably saying so, but and it just tell me this tells us the amount of revolutions on this 2. Well, let me explain. In this graph, did we go from 0 to 360?
No, sir.
Yeah.
No,
I
sir.
went from 0 to pi. Pi is how much degrees?
180.
Right. And since you're multiplying the angle by 2, the sine function is going to experience this as one full revolution, and it's going to feel like it went from 0 to 360. Let me ask you that question, right? If I put 180 by 2, what is sine function going to experience at us? What's sine 2 by 180? What's 2 by 180?
360.
I know, but 360, 360. Question, if this graph had go on to 2 pi, then how much revolutions I would have then?
2.
2. I would have 2. I would have 2. Right, let me plot cosine 2x now. Cosine 2x. It's the same process, you know, it's the same procedure, guys. Same procedure. You're gonna follow the points they tell you to follow. So we can start off with 0. So you want to plot cosine 2x now. Cosine 2x. Cosine 2x. So the first thing I start off with is 0, right? So cosine 2 by 0. What again for that?
1.
1. So at 0, I'm gonna put 1 here. I'm gonna follow confused by that. Are you understand or nah?
Yes, sir.
Yes,
All
sir.
right. What's the next point I should consider from a graph?
Pi over 4.
I feel like all they dying on me, you know. I feel like all they dying on me. I feel like all they dying on me.
Wait,
So
what's happening? Where did the
that'll be 0.
cosine come from?
They wanted us to draw the graphs of sine 2x and cosine 2x.
Oh.
So the other point I'm going to consider is pi over 2. That's the next point I'm going to consider. So that'll be cosine. Are they getting -1?
Yes, sir.
Yes, sir.
Yes, sir.
A -1 will be right here. Right. What's the next point I should consider? Somebody tell me. What's the other point, guys?
3 pi upon 4.
And you'll get 0, sir.
Right. Okay, cool. And then the last one is just pi.
1.
1. Wish my luck, guys. Wish my luck. I had to draw this. Bro. Bro. Oh my days.
You've got this.
So we believe in
So
it. It
that
has,
I give
we
me
have
be
to see that.
careful.
Where did that points went?
Supposed to be at 1.
Where did that points went? Entry pi over 4 was 0?
Yes, sir. And then and the last point supposed to be 1.
Yeah. Where it went? It just vanished. I was going so good too.
Yeah, so we take that.
nah.
No. You didn't pass it 3 pi over 4.
Does it have to be perfect though, Chad?
Yeah.
It's gonna be perfect in order to get.
Like, if you want to get the answer to the next question, you had to try like relatively perfect.
So don't worry, we believe you could do this.
Okay, we could take that. We'll take that.
First try.
Actually, wait.
Never mind.
Okay.
That's it, that last part there, sir.
Why you whole thing erase? I'm trying to draw it perfect because of the next part all there.
So you don't have to copy and paste the one that you did before?
You could
Nah.
copy and flip it.
Now we don't be moving like that, Nikolai. I didn't want to see my range. Quit.
I'm not going to say that crash out.
We're not gonna pass.
Okay. I will take it out. I'm not going to do anything.
Crash out,
I'm not going to do anything else. Okay.
As we
Yeah.
say, it's a
So
crash
that's the
course.
first try this.
Oh my gosh.
I will go into a shooting mode.
So that's your first try this, sir.
That was
Congrats.
first try. Right. Thank you. So, I trust that you guys will draw this a bit better in the exam. I trust.
Nah, they're gonna have to take it out again.
So let me explain something. And this is insane. If you realize this, you're real good. In the next question, they're saying hence or otherwise solve the equation sine 2x is cosine 2x for 0. The angle is essentially between pi. Okay, no problem. Let me show you guys something. Stay with me, right? Anytime you set two functions equal to each other, you're trying to solve them what?
What?
I explained this to my class. Anytime you set two functions equal to each other, you're trying to solve them what?
Simultaneously.
Exactly. You're solving them simultaneously. And graphically, the solution for this, you're looking out for the points are what?
Intersection.
Interception.
Yeah, intersection.
Graphically, we are looking right. So let me explain. Solve them simultaneously. Anytime you set one function equal to another function, graphically, you are looking for the points of intersection between the two graphs. And between what two graphs?
The sine 2x and the cosine 2x.
Right. Are you seeing points of intersection anywhere?
Yes, sir.
Yes, sir.
Yeah. And so if Alia saw that in the exam, you can get the easiest 4 marks in your life. Right? So the first point of intersection is right here. Now if I were to draw it perfectly, it's really supposed to be over here now. If I drew it perfectly. And if I drew it perfectly, it's really supposed to be over here. So, could anybody help me find for this angle over here? It's in the middle of 0 and pi on 4. What I could do?
That pi over 8. Just take the first one, and the
Yeah,
second one, divided by 2,
divide
and
it
you
by
get pi over 8.
2.
And I will get what?
Pi
Pi
over
over
8.
8.
Let's get pi over 8. Bam. That's my first answer. So, x would be equal to pi on 8. And let's find the other solution. So, my other solution is in between what two things?
2 pi and 3 pi over 4.
Mean pi on 2 and 3 pi on 4.
Yeah.
Okay, that's why I say 2 pi.
Nah, I think I said 2 pi.
So, you're going to add this.
And
When you add
divide
that,
by 2.
where you getting, guys? IGCSE owned. That's correct. You could do tan
5
2x is equal to 1.
pi over 8.
Well, again,
5 pi over 8.
Now, the 5 pi over 8 is when you divide it by 2. Am I right or am I wrong?
yeah, that's when you divide it by 2.
Right.
Oh, yeah.
And then when you divide this by 2, what would you get?
Then you get the 5 pi over 8.
5 pi over 8.
Bam. And just like that, yeah, your answers, you know.
Yes, sir.
4 marks, easiest 4 marks in your life. Yeah, like we're going till 4 o'clock in the morning.
That's it.
So did you divide it by 2 because you originally multiplied by 2?
No. We want to find the angle in the middle here, in the middle. If I want to find the angle in the middle, wouldn't I? Wait, earlier? I don't think this was hard. Let me just check something. I don't know if I tweaked in there, but come on a second.
So I feel like I tweaking, sir.
No, we're good. So like here, what? If I want to find the angle in the middle, I'll add up these two, and I'll just divide it by 2, and I'll find the angle in the middle. I don't know if you understand that.
Yes,
Okay,
sir.
that makes sense.
That's all. Like if I want to find the angle in the middle, I just add pi on 2 and 3 pi on 4, and divide it by 2, 5 pi on 8.
So I swear, if I don't get a distinction in Add Math, I crash in it.
I will cry. Hey, Nikolai, I'm crying for you. I'll cry for you.
What?
No. How could you see if that's correct? Let me show you. If that is correct, the left-hand side is supposed to be equal to the
right-hand side.
All right, let me just test it quickly now. So like let me just pi on 8. And that's supposed to be equal to cosine 2 pi on 8. What are we getting for that? I get root 2 on 2.
Yes, sir.
I'm gonna plug that in for the other one. So cosine 2 pi over 8. If I'm correct, when I press equal, what am I supposed to get?
Root 2 over 2.
Bam, badness. Boop. Let's go. Math is the best. Math is the best. All right. Now, I don't think a lot of people would have see it like this though. I don't think a lot of people would have realized it's just looking for the points at intersection. How much of you guys would have realized it's just the points at intersection? I mean, they did use the word hence. They did use the word hence. How much of you guys would have figured this out?
Me.
Not me.
All right. Well, here's the other way you could have worked this question out, right? Let me explain, which is what I think some other students would have do. So you have sine 2x is equal to cosine 2x. So stay with me, right? What you could do, remind me, guys, we know that tan theta is, well, okay, I'm going to use x. We know that tan x is equal to what? What is tan x?
Sine over cos.
Sine over cos.
All right, so stay with me. So here what? If I divide both sides by cosine 2x, I would end up with sine 2x over cosine 2x equals to cosine 2x over cosine 2x. With sine 2x over cosine 2x, chat? What that'll be? What
Tan
that'll be?
2x.
Tan squared x.
Tan 2x.
And what is cosine 2x over cosine 2x?
1.
1.
So let me show you how easy this is right from here. It's real easy from here, guys. Real easy. Here we're gonna do. We're gonna find your reference angle. Alpha would just be tan inverse of 1. What is tan inverse of 1, guys?
Are we dealing it in radians or
Radians.
1 over 4 pi or pi over 4?
Pi over 4, are you getting that pi over 4?
Pi over 4.
Alright, cool. Here we're gonna do. We're gonna draw with quadrants. Bam, bam, bam. We're gonna draw with quadrants. Easy thing. We're gonna draw with quadrants. Remember, guys. I'll decide. You have some crazy Henry echo feedback or something. Yeah. So this will be 0 radians. What would this be? What would this be, guys?
90?
Or we're working with radians. So I'll write it in radians.
Nice pi over 2.
Pi over 2.
What would this be, chat?
Pi.
Pi.
What would this be?
3 pi over
3 pi over 2.
And this would be what?
2 pi.
So I found my reference angle to be pi on 4. So I'm gonna put my reference angle in each quadrant. Now, according to the question, I'm trying to figure out what my answer is, positive or negative.
Positive.
I don't know if I realize it, but look at the question. The way to figure out where tan two times the angle is what?
Positive.
So if we want the angle to be positive, which quadrants am I looking at?
The first and the third. Well, yeah, the third.
The first quadrant for sure, and the third quadrant for sure. So what was my reference angle, guys?
Pi over 2 minus pi over 4.
Nah.
Pi over 4.
Or alpha.
This is the reference angle.
Oh, no, so I was done calculating this stuff already. My bad.
Wait, boy, Nikolai, boy, jumping the gun. So here how this gonna work out, right? The answer in the first quadrant, remember, we're starting from 0 and we're going in an anti-clockwise direction. What's my first answer, guys?
Pi over 2 minus pi over 4.
Wait, Nah, even simpler than that. Nikolai, it's even simpler. Watch.
Pi over 4.
Yeah, Nikolai.
Pi over 4.
Yeah, just be pi over 4. Just be pi over 4. So my first A, and remember what we're solving for? We're solving for 2x. We are solving for 2x. I can't stress that enough. Solving for 2x. So 2x will be equal to pi on 4. That's one of my solutions. And my other solution will be let's pick up a pencil, we get trouble sometimes. Tell me, Nikolai, what would I do to find out angle?
180 minus pi over, pi minus pi over 4.
It's a minus. Minus is wrong.
Oh,
Nikolai, I'll try to understand why. So, Nikolai, we go in the pi. So, this is pi, right?
Yes, sir.
So, that's the 180 degrees, quote unquote. And then they go in pi on 4 again on top of that.
You could be adding. When I minus it, what I'm looking at?
All right, when you're minusing, all right, so look, if you're minusing, it will be something like this. So, Nikolai, if you're minusing, it will be something like, watch.
Oh, okay.
Because in this case, you're stopping pi on 4 before pi. So, you say pi minus pi on 4. But over here, what? You go in the pi radians, and then you go in what? Where you going extra?
No, next pi over 4.
Right. So that'll be what? So my next answer would be Nikolai?
5 pi over 4. Is
5
it
pi
5
over
pi
4,
over
right?
4?
Yep.
Yeah.
So that'll be pi. Hope I can understand this, Let me explain something. So over here, you see that we go in pi, right? And then we go in how much more again?
Pi over 4.
So we had to add pi to
Pi over
Pi
4.
over 4.
right. So what is pi plus pi on 4? That'll be 5 pi on 4, right? You can plug that into your
Yes, sir.
Casio.
Pi over 4.
Now here what I guys, that is 2x. We want to find the x. So I gotta divide both answers by what?
2.
By 2. So pi over 4 divided by 2 is what? What is pi over 4 divided by 2?
Like 5 pi over 8.
Now, well, this one will be pi over 8.
Oh, so
Pi
I'm doing
over,
that.
right? In the next one, when we divide by 2 to find for x would be equal to 5 pi over what?
8.
Right.
Correct. Yeah.
So at this point, I just find easier x's to look for here. So these x's kind of difficult. So I gotta find for 2. Let me just find for 1 now. So
The x is causing some trouble.
exactly.
Ooh, this is the alternative solution. Well, I can take a screenshot. Ryan, I never thought about why it was anti-clockwise. Yeah. I never really thought about why it was anti-clockwise. So that's something I have to research.
Yes, sir, I get through there.
I suppose the reason why we're going anti-clockwise is because the angle's increasing in an anti-clockwise manner. I'm not sure if you see that. Angle's getting bigger in an anti-clockwise manner. So, Ryan, I presume that's why we're going anti-clockwise, because the angle's increasing in that order. Right, so I hear real people telling me they wanted me to do 2015 trigonometry question. So let me look at that. We're going to do the whole question one time. Any volunteers? Can do the whole question.
Can I try?
Who's that? Amelia, that's it?
Yeah.
I feel like all they will make till 4 o'clock, guys. I see you all there, all they moving and thing. Hey.
No, hey, sir. I can roll
Nah,
through.
we have it, sir.
No, that is the
We.
Well, they sure they have it.
we having it, sir.
Sir, the
Trust
whole team
me.
Yes,
have
sir.
it.
I'm fueled on coffee, ready for
I
you.
don't know when I start speaking French, bro, chat you.
This
Yeah, I
is
might go
the
and look for a
math
cup of tea, sir.
sleepover vibes. So the math
Sleepover?
vibes.
Hey, if I need to sleep, all they had to go sleep, I don't want all the parents to be saying, well, math vibes is the reason them fail the exam and thing.
Sir, we gotta do the burnout method, sir. We
Do
gotta
we
study to be
really need
about a
to
We
burnout,
gotta do what we gotta
and
do.
then so we gotta study almost at the point we go and burnout, then burnout after the test.
I suppose so.
Hey, so I don't want to burn out and all my hair fall off,
Otherwise, you wouldn't be able to take the X's. Otherwise, you wouldn't be able to take the
Exactly.
X's.
I keep myself looking sharp, comb up my hair, look nice, all kind of thing.
Wait. Let me show them the picture.
Whoa. That's private information.
Alright, let me get some now.
Whoa, Sigma. Sigma.
Okay, guys, that's what taking all the X's, by the way, guys. That is what the X taker, by the way.
Yeah, boy.
That's the X snatcher right there.
All right, so let me look at the 2015 question. Amelia, you ready? Where did it go?
Yeah.
I'm excited for the physics, boy. I'm excited for the physics lives. There gonna be a lot more vibes on this, for sure. I love hard maths, but I don't feel like a lot of people like hard maths the way I like hard maths.
And it would have more people in the physics drive, as more people does do physics than add maths.
Yeah, boy. And then I got a lot of people,
So
a
you have
lot of,
29 people in TikTok, not 31.
and I have 133 people on YouTube.
Dang.
So hold up. I love your hat, Kyle. So big up Kyle hat right now. Look at his hats.
Let me
Yeah,
check
for
that.
real.
Hey, Kyle. Hey,
Really?
hey, you had too much on your head, boy.
Yeah, for real.
So
See, I
that
have burdens in my head. See, I have burdens in my head. See,
Hey, don't carry that into the exam tomorrow, you know.
see, it's plenty something on my mind. See, it's plenty something on my mind right now. See,
Hello, check Kyle now. People on the
Hey,
TikTok.
just flush it now, Kyle. Just flush it now, way.
Wait, I'm showing you people on TikTok. Man have a poop hat, yes?
Where you get that from? Like, where you get that from?
Why that look like the Sorting Hat from Harry Potter, boy? Loki? It Loki look like the Sorting Hat from Harry Potter.
see, like
Alright.
that. See, I have plenty of that on my mind right now. See,
Alright. I see somebody jam, big up yourself. It was bound to happen. Math vibes is the future, you know what I mean? Math vibes, you know, the young generation had a rise. You know what I mean? Young generation coming up. Yeah. You guys are the future, you know. You all are the future. You're shaping the world. Alright? So, thank you, Jam. I don't know your name, but big up yourself. 2015. The following diagram shows a circle of radius 4 centimeters. I have a question. Amelia, if O to B is 4, what do you think O to A is?
4.
That's 4. This is 4, right?
Yes.
And they're saying with center O, and they're saying the sector AOB, which subtends an angle, theta is equal to pi on 6. We can see that. The angle, like AB subtends the angle pi on 6, radians are the center. If the area of the triangle AOB is a half r squared sine theta, then calculate the area of the shaded region. Okay, not bad. Before we do anything, guys, Amelia, walk me through this process. How would I find for the shaded area over here?
Find the area of the triangle and the area of sector, then subtract.
W's in the chat for Amelia one time. Big up Amelia one time. So Amelia, what you want to find for first? The area of the triangle or the area of the sector?
The triangle, since they gave it to us.
Right. Big up. You know, I started this class thinking I would not make it to 4, but now I feel like I can make it to 6.
Hey, let me go, sir.
that's what we like to hear.
Sir.
Go to school at 4.
You
Daddy already know all that, you know.
I
See,
can tag it out, you will tag it out.
So you see 4,
see,
sir, my body ready for 4, sir.
see. I mentally prepare myself for 4, you know. So I can't make that 6 o'clock thing, you know. So
Well, who can make? They can't make. I was say who can make? All right, let me tackle this fast. Amelia, where's the radius?
4 squared.
And the angle is what?
Pi over 6.
Your calculator have to be in what mode right now? Have to be in what mode?
Radians.
Have to be in radians. If it's not radians, what are you doing? So where's half of 16?
Radians.
8. Half of 16 is 8. Okay, I think, hey, if you're feeling sleepy to the point where you're having trouble with basic arithmetic, I think all you should sleep there. You gotta know yourself and you gotta gauge yourself. You gotta know what you could do.
To push through. We got to push through.
I want to help all you, but I also don't want to be the reason why you crash in the exam. Consider enough. Alright, come on, calculator. Come on, man. What is 8 sine pi on 6, guys?
4.
4.
Are we
Yeah,
getting
4, sir.
right? You guys getting 4 now?
Yes, sir.
Yes, sir.
And
Yeah.
and that's area just fine enough, so I'll say 4 units squared. 4 units squared, cool. So I found the area of the triangle. So I just found the area of this triangle over here. What do I need to find for next?
The sector.
The sector. So the area of the sector will be equal to a half what?
R squared theta.
Right. You want to blow your mind, Amelia?
Sure.
What's the area of a circle?
2 pi r.
Nah, that's circumference.
Pi r.
Pi r squared, pi r squared, pi r
Wait.
squared, pi r squared.
Oh,
And for a circle, how much radians have in a circle?
2 pi.
2 pi, 2 pi radians. So watch this, bam, half, bam. That's the area of a full circle, pi r squared. If I ever wonder where it come from, pi r squared, bam. Because for a full circle, the angle is 2 pi. So a half r squared by 2 pi is just pi r squared, which is the area of a full circle. Because a full circle has 2 pi radians. Cool. But anyways, area of sector is a half r squared theta. Guys, for this formula to work, it must be in what?
Radian.
Radians.
Don't go in the exam and convert anything to degrees and say I did never say that. It must be in radians. Must be in radians. Otherwise, this formula will not work. So our radius was 4. So that'll be a half 4 squared. And our angle is what?
pi over 6.
Amelia, you sound like you're on cap out the way. So that's gonna be, I'm plugging into my calculator, a half
4 pi
by
over 3, sir.
wait there.
Here we go.
Yeah, again 4 pi over 3. Unit squared. And so if I want to find the area of the shaded region, how do I do that?
Subtract.
Which one bigger?
The sector.
Yeah, the sector bigger. So I'm gonna say the 4 pi over 3 minus the what?
4.
So again, I'm the answer to 2 decimal places. Yeah, that one again. Anybody else getting that? Or nah?
Okay.
Yeah.
Yes, sir.
Answer.
The 2 decimal places will be 0.19 units squared.
Sorry,
Oh, wait, it says centimeters. Oh, there. Hey,
the
oh
centimeter.
my days. Bruh. New mistakes, yes, rookie mistake. This is rookie mistakes. Better than this. Better than this. Cool. Badness. That was hard or that was easy?
Normal, so normal.
Easy.
Nah, that was easy.
That was real easy. Like they give you the formula for
Yeah.
area. You had a radius.
I
You had
hope I get this on the exam.
You have nothing to think about. Just minus it. That's all. Bam. Easy marks. Easy marks there, chat. Easy marks. Let's do the next question. We tackle a question like this just now. Right? We know how to deal with this question. We know how to deal with it. This is not hard. Which one are going to convert immediately?
Sine
Sine
two.
squared.
But sine squared.
I can't change sine squared to what? To what?
1
1
minus cos squared
minus
theta.
cos squared theta.
Bam. And that'll be equal to 5 minus 10 cosine theta. When I expand our brackets, what going to happen there?
8 minus
8 8 cosine squared theta.
Right. Let me make it in the form of a quadratic one time. And I'm going to stick. I'm going to do it one time. So minus 8 cos squared theta. I'll move across the minus 10 cosine theta. So that will be plus 10 cosine theta. I'm gonna put the plus 8 over here, and if I bring across the 5, it will turn to what? Minus 5, right? And that'll be equal to 0.
Negative.
So what did I do? Well, I took the 5 minus 10 cosine theta, and I brought it across. And I put everything in the suitable position one time. So minus 8 cos squared theta plus 10 cosine theta. Where's 8 minus 5?
3.
And if you want to make this a bit simpler, you could say let y be equal to what?
Cosine squared. No.
Cos theta.
Cos theta, cosine theta. So that will become minus 8 what?
X squared.
Y.
Y squared.
You know what? I fed up factorize. And the question is with what? Formats. I don't know, but if I just use a calculator and done, you go and press here. Let me run through the process one more time. If you want to solve a quadratic in the calculator, you're gonna press, well, for me, menu. Then I'm gonna press A for equation. I'm dealing with a polynomial, so I'm gonna press 2 for polynomial of degree 2. My coefficient for the squared term is minus 8. Coefficient for the x term is 10. Coefficient for, well, the constant term is just 3. So I get in my first solution for y to be what?
3/2.
Right? And the other solution is what?
Negative 1/4.
What is the only valid solution there, guys?
The 3/2.
The 3/2.
Guys.
N minus 1/4 because
Wait.
half does go
It's the
to
negative.
negative 1 and
Oh, yeah.
Because a
Hey,
3/2
guys.
is not on
I
the
remember something,
graph.
Pick up
guys.
yourself, Gabriel. W in the chat for Gabriel.
And usually I don't remember anything. Holy.
God, Olia. Why is equal to 3/2? What is 3/2, boy? That
More
is
than
1.5. That is 1.5. Oh, look what TikTok making me complete. Look what TikTok making me complete. I think I'm a robot. Hey, boy. Alright. I'm not a robot. Who would have thought? Where is the Apple Pencil? Where did they go? It's here just a minute ago. I'll find it. Yeah, 3/2 is 1.5. 1.5 is more than what?
1.
Exactly. This is invalid. Invalid. Because we are dealing with cosine theta. And the cosine graph goes up to what?
1.
What? This is what the cosine graph does look like. It goes up to 1 and it goes down to? Tell me. It goes down to what?
Negative
Come on.
1.
Negative 1. Negative 1. Does it go up to 1.5?
No.
Nope.
No, it does not. That's invalid. That's invalid. It's the only valid solution. So from here, I would say cosine theta is equal to negative 1/4. Let me see if I remember these steps, right? Let me see if I remember. What will be the next step?
Yeah. Find the inverse of positive 1/4.
Right. And we call that the what angle?
The reference.
Pick up yourself, W in the chat formula one time. You gotta find your reference angle, which is cos inverse of always positive. What is cos inverse of 1/4? Should be some weird angle. Hey guys, we're working in radians or degrees?
Degrees.
Degrees.
Oh, degrees, because there's 360.
You gotta look at the range. Please look at the range, guys. Yeah. So what's
75. 75.
Let me switch.
Decimal.
Let me just switch my calculator to degrees. Right. So cos inverse of 0.25. You're again 75.5? 75.52?
Yeah.
Yes.
And what kind of angle is that? Is it acute? Is it reflex? Is it obtuse?
Is less than 90.
Right. It's acute angle like Mrs. Math vibes.
So
This is working.
she take them pieces of recordings, sir.
Eh?
Should he take them pieces of recordings every time you raise she up?
She on time with me, boy. She on time with me.
Next
We...
compilation of maths vibes using
Sir. You should
Ah.
do a pose, sir. But don't take the X's.
Wait.
Yeah.
I'll take a screenshot, chat.
Wait, I'll fix my hand thing. Wait.
Do I beg somebody make us stick out this?
Yes, sir.
Sir.
Sir,
Beg
when
you
you do
put this
that,
as a thumbnail, sir. I beg you put this as a thumbnail, sir.
Wait.
so when you do that dot,
I feel like I'm rusty, boy. I feel like I'm real rusty, boy. Nah. I didn't get a haircut and thing, boy. Hey. But it is for the kicks. It's for the kicks.
Sir, I beg you put as a thumbnail for this.
Wait. Somebody take a screenshot. Are they getting screenshots?
I did. I was
Alright, good. I'll put out.
Sir, I beg you put as a thumbnail for this.
I will do that.
I'll send it in GC then.
I'm a man of my word. Always. Right. So, since we're working in degrees, this could be 0 degrees. What is B?
90.
90.
Right. What is B?
180.
180.
What was this gonna be?
360.
270.
Oh, it's 270? Wait, because 0 would be 260.
And let's go be 360 degrees.
180.
Yeah.
Remember, everything positive here. What positive here?
270.
Sine.
What positive in the third quadrant?
Sine.
Tan.
Sine.
Tan. Positive here.
Cosine.
Cosine. Good. I think his name was Jamal. Jamal, no problem. Best of luck, Jamal. So our reference angle is 75.52. I gotta put it in every single quadrant. So we want to figure out where cosine is what?
Negative.
Yeah, where is cosine negative?
Sine and tan.
The second and third quadrant.
Second, right? Right, to find my answer in the, I should be able to see better what the degrees, right? So it looking like we stop in 75.52 degrees before what? For what?
at S, at sine. How
you gonna find? How are we gonna find this angle, guys?
Is it 180
180 minus
75.52?
75.52.
Yes, so that's all. It'll be 180 degrees minus 75.52 degrees. Sky, when you do any types of questions, you have to find the reference angle first, and the reference angle is always positive. The reference angle exists in the first quadrant, and you mirror it in the other quadrants, and that allows you to find where the other solutions are. Right? So, Sky, that's why you're not seeing the negative here. When you're working these types of questions, you find your reference angle first, and your reference angle is always positive. And that's the green angles you're seeing here, the 75.52s. So my first solution is going to be 180 minus 75.52. What are you guys getting for that?
I get 104.48.
And question, when I plug that into this, what's supposed to get?
Minus a portion.
Negative a quarter.
Negative a quarter.
Let me see now. Are they believing in maths?
Yes, sir.
Let me see.
Take my
Ooh,
life
bad,
on that math. So
badness. Absolute cinema. You know what I mean?
So I'm gonna screenshot that I'm making.
absolute cinema.
Alright, cool.
We so bad. We are so
Yeah,
bad.
yeah.
We're like the baddest.
Right. The reason why I go into so is because like the whole time I was doing all the other sessions I do. We finish section 3 now. Like if you was there for the other sessions, we finish the whole of section 3. We finish the whole of section 3. We do all that. We do all our differentiation, integration, kinematics. We do all of that, in the last couple of sessions, we do all of that, and then in extreme detail. So okay, the next answer would be watch. Look at this other answer. This other answer looking like what? This is 180 then.
180 plus 75.52.
Right, 180 degrees plus 75.52. What are we?
255.52.
Cool. That's the answer. And if I plug that in over here, what I should get?
Negative a quarter.
Bam, negative 0.25. Cool. Right, so that's it for these types of questions. After this question, I feel I'll call it a day for when it comes to trigonometry. Who wanna help me with this question? The trig
Oh,
I wanna do it.
Who's that?
Devon.
Who?
Devon.
Oh,
Yeah.
all right. The background on the hoodie looking like that one meme, like where the alien following the other alien. You know what I'm talking about?
No.
It's like, wait, it's like,
Oh, it is we do this. Yeah. I know it.
yeah.
So we interlock. I think
All
that's
of
the
us
meme.
twins. That's how we are. We're locked like that with add
Yeah.
maths. Us with
I'm
add
a
maths. Dab me up. Dab me up right now.
Gabriel. Is that
Yeah.
a wig?
Yeah.
Gabriel, is that a wig you have on?
I just stand my hair like that. So I had a
Oh,
fun to keep myself entertained.
right.
Yeah.
Okay, so who wanna help me on this
Agreed.
question? Devon.
Yes.
All right. So here what, right? Here's my advice. If you see, this is my main advice. Here what? If you see tan theta, immediately convert that to what?
Sine theta over cos theta.
Immediately, don't stick. If you see sine 2 theta, immediately convert that to what?
Sine 2 theta. Oh,
That is 2 sine theta what?
2 sine theta. I don't remember the formula.
Oh no. I had to remember this, This is going to come most definitely tomorrow, Sine 2 theta is 2 sine theta cosine theta. And what is cos 2 theta?
Cos 2 cos theta. Wait, I don't remember.
Is it 1 minus? No, never mind.
It's cos squared theta minus sine squared theta. Okay, where did I get these things from? You're probably wondering where you get them things from. You pull it out from a magic hat.
Derived it from the normal one.
Right. So they've I don't want to say your name wrong. When you look at the compound angle formula, what is that? What's the compound angle formula?
It would be sine A cos B plus cos A sine B.
So you know this. You know this. Well, instead of A and B, just say theta plus theta. So I'll write instead.
Oh, you write sine theta cos theta plus cos theta sine theta.
Sine theta cos theta plus cos theta sine theta. You'd probably realize that, this and this is the same thing. So that'll just be equal to what?
Sine theta. 2 sine theta cos theta.
Yep, that's where I get it from. All right, look at the next one. Where did I get this from? Well, let's look at cosine A plus B. What's cosine A plus B?
Cosine A plus B is cos A cos B minus sine A sine B.
Cool. So if I replace the A and B for theta plus theta, what are we?
Cos theta minus sine theta sine theta
What would our work out to be?
is equal to be cos squared theta minus sine squared theta.
Good. And from here, you can manipulate it however you want to. But these are the main things you need to know. Right? Cool. If you forget, notice. So here what? Immediately when I look at this question, by the way, here's a mistake students would make. Some of you go and look at this and only go and write sine 3 theta. Just no. Please no. No. Can write back sine theta and we're gonna replace sine 2 theta with
For sine 2 theta, you're gonna write 2 sine theta cos theta.
that's gonna be 1 plus cosine theta. And cos 2 theta, we're gonna replace that with
Cos 2 theta is gonna be cos squared theta plus sine, no, minus sine squared theta.
this particular question might be a bit tricky. Might.
It's
Well,
sine theta over cos theta.
well, we know tan theta is sine theta over cos theta, right?
Yes, sir.
So here what I see in my head, I see in that, maybe on top, it looks like I could pull out what?
Hey, repeat, sir.
So I know I know that eventually I'm going to get sine theta over cosine theta. Now when I look at the top, well, what scene I could potentially pull out?
So wouldn't you be able to factor out sine theta?
Yeah, we need to factor out sine theta. I'm gonna go right. Tell my Amelia. Now Amelia, Devani.
Okay, so sine theta bracket 1 plus cos theta.
2 cos theta, right?
Cos theta.
Okay. So in the denominator, here what I thinking, Devani. Tan theta is sine theta over cosine theta. So I thinking in my head, maybe this could work if I could somehow make that happen. How I could make that happen, boy? Wait, let me see. Is there any way I could write sine squared theta into like cosine squared theta?
Yes, sir.
How I could do that?
Minus bracket 1. Wait. 1 minus cos squared theta in brackets.
Anybody here that's watched The Boys? You know about that? Like with Homeland, aren't it?
Yes,
Yes, sir.
Hey, this season, I was expecting so much more from this season, eh?
And so, you know what, too, I love Supernatural. Like, I'm a die fan. So when I saw them, like, in it, the one episode, yeah. I don't know if you might know it.
Nah, I don't know. I know about Supernatural. With Ken Clark.
Oh, that's Smallville.
Oh, a small little
Yeah, okay.
supernatural.
And it had a crossover episode where this dude and they killed him off. It was in a recent episode that came out like not so long ago. Where they
Oh,
like
wait. Yes. When they went to ambush Homelander and
yeah,
like they went because yeah, I know what you're talking about.
right. So
You're
like
talking.
that was a big thing because them two actors plus
Yeah. I see the edits. I see the edits. I know what you're talking about.
so
Sir, sir,
yeah.
Yeah.
So look at my
the
two
trigonometry.
ones.
You
Boom.
finish.
Wait, so Devani, what is minus by 1? What will be?
You're gonna be 0. Wait,
Minus 1. What is minus cos square theta?
-1 plus cos squared theta.
Plus cos square theta. Oh, there, the light is at the end of the tunnel. The light is near. The light is there. I can see the light. Can you see the
The
light?
light can see me, but I can't see the light.
All right, here's my intuition, right? When I look at this question, I know how to get tan theta. Here how I thinking. At some point, tan theta is going to be sine theta over cosine theta. That's how I thinking. Well, you already see that on top. I factored out sine theta, and I got 1 plus 2 cosine theta. So in my head, I thinking, okay, you see that denominator? That denominator go how to be cosine theta 1 plus 2 cosine theta. So it will cancel off eventually. That's what I think. And so I look at the denominator and I see now sine squared here. Nah. We can't have that. Can't have that. So I convert it to cos squared theta. So I say sine squared theta is 1 minus cos squared theta. Now we need to simplify it. You'll see what you see the light. You see the light just now. If I simplify this, what will happen?
The one that is cancel.
Yeah, the ones that are gonna cancel.
And you see in how much cos squared theta terms?
Cos squared plus 2 cosine squared theta.
Oh, okay. Somebody say let him cook. What we could do next?
Factor out cosine theta.
Okay, let's go. And if I factor out cosine theta, what would I get?
You get cos theta, open
Now
bracket.
I'll get 1 plus.
Oh, yeah, open bracket 1 plus cos theta.
2 cos theta. Can you guys see the light at the end of the tunnel now? I was talking about. I had to see it, please.
Yes, sir.
What cancel off there?
The ones in the brackets.
The brackets.
The bracket born.
It like
I want to sine theta over cos theta.
Tan theta!
Let's go.
We win this!
Wait, sir. But you were saying something about people would look at sine theta plus sine 2 theta and be like, oh, it's sine 3 theta.
That's wrong.
And then
Yeah.
it cut out and I didn't hear anything else.
Just know that's extremely illegal, and if you do that, I'll jump off a cliff. I might.
that's how we get stuff right.
Sir, I need you for physics.
Gabriel, what? I was so confused for a second here. Gabriel, take off that. I'm looking so weird. Gabriel, take off that.
Absolute cinema.
Yeah,
So,
sir, don't
Yeah?
jump off a cliff. I need you for physics. Stop thinking about
Yeah.
them things.
if all you go in the exam and say sine theta plus sine 2 theta is sine 3 theta, I would cry, I would cry. Don't do that.
But
Don't
sir,
know.
you're gonna never know. Sir, you're gonna never know.
Do not do that, sir. Do not do that, Ollie. Just don't do it. Don't do it. We know that sine 2 theta is actually what? What is sine 2 theta?
Sine 2 sine theta
2
cos
sine
theta.
theta cos theta.
Right. And you know that cosine 2 theta is actually what?
Cos squared theta minus sine
Minus
squared
sine squared
theta.
theta.
Good. And when I look at this question, I know in my head, tan theta is sine theta over cos theta, right? I see that already. Could I pull out what's here? What could I pull out here?
Sine theta.
So here how I thinking. If I get sine theta by this on top, then at some point I should get cos theta by 1 plus 2 cosine theta. So you will cancel off to give me tan. That's how I see it, the foresight. That's like the Mangekyu Sharingan kind of thing. You know what I mean? For maths. For maths.
Yeah, you're right. Come on.
And I mean you saw what I saw, like I see it at the start, but you see that's what we end up with that's what we end up with at the end. Right? Come on guys. You have to develop your Mangekyu Sharingan. Come on.
Develop that medulla oblongata or
Yeah.
done. Bio's done. That's it.
Gabriel, I have this one character in Naruto that's always be around Konohamaru. Like she always has her hair like, I don't know if you know who I'm talking about.
No,
This
you're talking about. I just can't remember Shino, but I know you're talking about.
Muwegi or something. Muwegi or what's she name? I forget your name. It's looking like that. Yeah, the hairstyle. But that's it for this question. What other questions I think could come by for Triggs? Are you ready to move on from Triggs?
Yes.
So I thought we already did
Let us
that.
Oh,
escape.
sir, can I get a screenshot of that question that you just did? Okay, you can skip now.
I want a screenshot of the tan theta that you like over at the side.
Take a screenshot.
Yes.
My concern is we can't do these screenshots, boy. The exam is like just now. We can't do these screenshots.
You're gonna look it over before we go in.
We're gonna do it back.
Bro. Well, the exam is at 1 o'clock, to be fair.
We have time.
Woo!
I can see that.
I
Hey,
can't
what?
believe I'm doing Add Math tomorrow.
We are doing Add Maths tomorrow. We are doing Add Maths today.
Oh yeah, we're doing chemistry tomorrow.
All right, because it's not
Don't
like
remind me about chemistry. Don't talk to me about
My bad.
chemistry.
Oh, my bad.
Let's not talk
Don't shoot.
about chemistry
And,
right
and,
now.
wait, chemistry is day after tomorrow.
she like nah.
Chemistry is tomorrow.
What if
Wait.
I just
Mañana.
I did say I was going to a chem live, you know. Did say I was
Really?
going to.
You
Yeah.
should. You should.
I've never seen chemistry vibes before.
Like the
I've
max
never seen chemistry vibes.
To be fair, my mother-in-law is a chem teacher, you know. So I mean, I should know some chemistry. My mother-in-law is a chem teacher. So
Call her up. Let's get taught some chemistry because I need that drastically. What's a nitrate?
We need that.
We nosotros.
I give an this side. I look, we doing maths and we going into chemistry, and I wanted to see
all right,
what.
hear what. Let me tackle this question fast, earlier. I just want to do this question in 2024 in case something weird like this come.
Yeah.
Right. Use the letters P, Q, and R, write an expression for each of the following trigonometric ratios. Earlier, if theta is over here, that would make this the hypotenuse. That would make this the what?
Adjacent.
And this is what?
Oh, opposite.
Right. They want me to write sine theta. We know sine theta is opposite over hypotenuse here.
Yes, sir.
Which in this case is really, it'll be what over what?
P over Q.
P over Q. Yeah? Are they okay with that?
Yep.
You know that cosine theta is what over what?
Adjacent over
Adjacent over hypotenuse.
Adjacent over hypotenuse.
SOHCAHTOA.
Which will be R all over
Q.
Q.
R over Q. Let's go.
So at this point, I gonna be an energy vampire from now on.
I had like teeth energy from people, boy. Like that's what I do. Like you see, last couple sessions for Admas, how I had like no people and it was like real dead. I could not make it. But like you see how we have energy tonight, I couldn't make it.
Hi, pop.
All right, so it's almost like we're on some hypotenuse. Got him.
I'm leaving right now.
Adrenaline.
I'm leaving this meeting right now.
Adrenaline.
They would test change our base. They wouldn't test a change our base alone. I don't think so.
Dad jokes.
Right? Using your answers in C part 1, determine the value of sine squared theta plus cos squared theta. That easy thing, guy. Easy. So here what? Sine squared theta plus cos squared theta. We just found that sine squared theta was what?
P over Q.
So if I'm finding sine squared theta, then that'll be p squared q squared, p squared over q squared, right?
Yes, sir.
And cos squared theta will be what?
R over Q.
That'll be r squared over q squared.
Mm-hmm.
So we had the same denominator, so what we could do?
P squared plus R squared over Q squared.
Probably saying, so, we're going with this. I will show you. From our good friend Pythagoras, we know that q squared is actually somehow what?
P squared plus R squared.
Whoa.
So that'll be 1. No, that'll be Q.
Yeah, yes, Nikolai. Yes, Nikolai. 1. Why keep doubting yourself for?
My brain right now at this point.
Bam. Because all the ends we know sine squared, we know sine squared plus cos squared theta is
1.
1. Watch it again, right? P squared plus r squared. According to Pythagoras' theorem, the hypotenuse squared will be equal to p squared plus r squared. So p squared plus r squared is literally just q squared. Sorry, replace p squared plus r squared with q squared. And q squared over q squared is
1.
1. Bam, cool.
Absolute sense.
I'm gonna accept one more trick proof question. Who wants to do it with me? Celine. Celine should help me with this question. Celine, I volunteer Celine for tribute.
Yeah.
I volunteer math 5.
It don't work like that. It don't work like that. It don't work like that.
I
It
don't
don't work
do
like that.
trig
It
identity.
don't work like that, Celine. Don't work like that, Celine. Celine, you had the exam
Oh my
tomorrow.
goodness.
Right. So Celine, any way you see tan, you gonna write what instead. Any way you see tan, you gonna write what instead.
Sine theta over cos theta.
Well, in this case, you're gonna write theta.
No, well, you will write sine A over cos A.
And then we have 1 over.
1 over sine A over cos A. Wow.
As a fellow ADHD person, Celine, you have ADHD too, eh? Or not?
Well, let me get diagnosed first, and then we'll talk, right?
I feel like if you get diagnosed, there's like a certain chance you have ADHD. You see moving like me. You be moving like me, kind of crazy.
Yeah.
Right? So like, here what? Now gonna be sine A over cosine A, and where's 1 over sine A cosine A?
What? Say that again?
What is 1 over sine A cosine
I don't know.
Now you
One
know which.
divided by sine A
No,
over
wait.
cosine A.
What is 1 divided by sine A over cosine A turn to?
1 times cosine A over sine A.
Oh.
Right. Anytime you have 1 over something, it's just your reciprocal. So Celine, that 1 over sine A cosine A going to turn into what?
It's going to turn into 1 times cosine A over sine A,
Right, which is just what?
which is just cosine A over sine A.
Right.
Okay, peek.
What to do next?
We have to find the LCM.
Right, where's the LCM?
Cos A times sine A.
What next?
Oh my god, I'm losing my voice. Help. Okay. Then we put sine A over times sine A, and then it'll be cos A times cos A.
Right, where's sine A by sine A?
Sine A squared, sine squared A,
And then we get plus what?
plus cos squared A.
Right, where's sine squared A plus cos squared A?
Uno.
Right? And I can write cosine A sine A as sine A cosine A.
Or
And that's it. You get the answer one time. That was really easy.
absolute cinema. Yippee!
That was
Guys,
easy, guys.
That's Alpha Celine for you all guys.
QED question easily done, guys. Didn't break a sweat, didn't lose sleep.
So, guys, anytime you see 1 over a fraction, what will happen to the fraction?
You just
Be the reciprocal.
divide it and say you're gonna do the reciprocal.
Multiply by the reciprocal.
Just be the reciprocal, guys. Just be the reciprocal. Cool. So we're done with trigonometry. Kablamo, we done. We're done with trigonometry. Tango.
Somebody
Section
play a celebratory noise.
Section 3, we're going on track with time. Moving on to introductory calculus. Let's go. So, I have a question here. So,
Yippee!
Celine is going to help us again.
Wow.
Yippee!
Wow.
Hey,
Yippee,
everybody,
yippee,
unmute,
yippee.
unmute and be like, yippee!
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 Right.
Thank you so much for this opportunity.
W's in the chat for W's in the chat for
This
Celine.
opportunity, yes.
Right. Opportunity. I don't even know that song.
No.
Standing right in front of me.
Right, so we want to differentiate the function y with respect to x.
Okay.
How am I doing that, Celine?
You take, see, I know how to do it, but what?
Tell me the answer then.
Okay. The answer would be 5x4. 5x to the power 4 minus 21x to the power
21.
2
I'm sorry.
plus 2. That's it.
Right, that's it, yeah.
You're 20?
When you're differentiating, you're gonna multiply by the power and then take away 1 from the power. So you notice 5 by x, 5x, and then you minus 1 from the power. So 5x to the power 4. That's it, that easy. Then minus 7 by 3 minus 21, then a minus 1 from the power. Turns to 2. If I differentiate 2x, I'll just be 2, and if you differentiate that constant will just be what?
0.
0. Good. Right, so let's look at the rules again. If I differentiate something that's in the form ax to the power n, I'm going to multiply the whole thing by what?
N.
Right, so I will say an, and then I'll do what with the power?
Minus 1 from it. So n minus
Good.
1.
Cool. If I have to differentiate something in the form ax, what will be?
A.
A. If I differentiate a constant?
0.
0. Cool. I'll let me go into the connected rates. I changed question just now, don't worry. But everybody okay with basics of differentiation, right?
Sí. Sí se puede.
Alright, cool. I need a volunteer. Guess we're gonna break there.
Can I try?
Sure, give me question I read from her.
The function y equals x to the power 4 minus 2x to the power 2 plus 5 has stationary points at x equals 0 and x is equal to plus or minus 1. Determine the nature of each stationary point.
Alright, that's a nice question. So, Alyssa, first things first, right? They want us to determine the nature of each stationary point. What tells me the nature of the stationary points? The what derivative?
dy by dx?
Nah, the second derivative.
Oh, you mean, yeah, it's coming back.
So here, what if I wanted to find the second derivative for this function? What would I have to do?
Find the first derivative,
right?
And then you find the second derivative.
So the first derivative would be what?
4x to the power of 3 minus 4x, and that's all.
That's all. And let's find the second derivative now. The second derivative would be what?
Second derivative would be 12x squared minus 4.
Good. And they are giving us a bunch of stationary points. They're telling us that x is equal to 0, and then they're saying x is equal to plus or minus 1. So plus or minus 1 means x is equal to 1, and x is equal to what? Plus or minus. Well, plus or minus 1.
Oh, -1?
Right, -1. I have a question, guys. If I ask you guys to find the stationary points, right? Right now, these are just the x values for the stationary points. How would I find the first stationary point? Does anybody know?
You plug the X into the function.
Yeah, you plug it into the function. So if x is equal to 0, then the y value will be what?
5.
0? Oh.
0 to the power 4 minus 2 by 0 to the power 2 plus 5. So the y value will be what?
5.
So my stationary point is really 0, comma what?
5.
Right. How about the other one? How about this one? What am I gonna plug it into the function? Guys, x is equal to what?
1.
1. So I will say 1 to the power 4 minus 2 by 1 to what power?
4 power.
By 2.
2. Second power. Plus 5.
So when you work that out, that'll be 1 minus 2 minus 1 should be 4. 0. We want to say in 0. 1 comma 4. Let me just verify that though and do that quickly in my head. Then the other one will be y is equal to negative 1 to the power 4 minus 2y negative 1 squared plus 5.
So you
Somebody said it matters which one we plug it into. Yes, it does. It does. Yes, it does. Guys, if you are trying to find a point, remember a point is made up of an x and a y value. So you'd have to take the x value and plug it into the original function because the original function tells us what is. And I ain't nobody tell me no, but the original function tells me what y is. It literally says y.
My bad, my bad.
Right, y. So let me just verify this. 1 to the power 4 is 1. 1 minus 2 is minus 1. Minus 1 plus 5 is 4. Cool. What about this?
We also gain 4 on the next side, sir.
You still gain 4 here too.
Yes, sir.
I'll again 4 as well, right?
Yes, sir.
Yeah.
So my next point, my next stationary point would be what?
Minus 1.
1 comma.
Cool. So these are my stationary points. Nice. I do in physics after tomorrow. Every single day, 10 hours, more or less every single day, real vibes. Stay tuned for that.
So you take time tomorrow, well, today and sleep, eh?
Yeah.
Use your vitamins and sleep.
Right. So here what? I want to find the nature of each stationary point. What was the first x value for the first stationary point?
0.
Right. So I was x is equal to 0. This is how it is, right? It's like if you want to plug in a value into like a derivative, like I typically put a vertical line, I say what plugging in and I plug it in. So I will say 12 by 0 squared minus 4. What will be?
Minus
What will
4.
be? So okay, if the second derivative is negative, remind me guys, if the second derivative is negative, if d2y dx squared is less than 0, is a maximum or minimum?
Maximum.
Right, the maximum. If d2y dx squared is equal to 0, is a point or what?
Symmetry?
A point of inflection.
Right, it's a point of inflection.
Oh.
If all it was there in them lines, when it was doing this in extreme detail, you would know. Shame. And if d2y dx, looking at Selena, especially looking at Selena. And if d2y dx squared is more than 0, is a maximum or minimum?
Minimum.
Right, exactly. Probably saying so, where's a maximum or minimum, boy? Right, look at this cubic graph over here quickly. This looking like a what?
Maximum.
Minimum.
This looking like a what?
Minimum.
Minimum.
And this over here is 40 points or what?
Inflection. But sir, what is the point of inflection?
All right, so you see how, okay, see over here we have a maximum, and you see over here we have a minimum.
Mm-hmm.
The point of inflection is neither maximum nor minimum.
It's just in the middle?
Yeah.
Okay.
So then I'm gonna say, so my first point, 0, 5 is a what? So I'd say 0, 5 is a what?
Is a maximum.
Maximum.
Right, it's a maximum. Let me do the other one. So d2y dx squared. What I'm plugging into it now?
Uno.
Yeah, I'm plugging 1. And so that'll be equal to 12 by 1 squared minus 4, which will give me what?
12 minus 4, which is
That'll
8.
give me 8. Now, if that is the case, right, that would mean 1, 4 is our what?
Minimum.
Minimum. Nikolai, remember, if d2y dx squared is positive, is our minimum. And over here, I can plug in what? Nikolai, I can plug in for the last one.
Minus 1.
Yeah, I can plug in minus 1. So I will say 12 by minus 1 squared minus 4. And I'm going to get 12 minus 4, which is...
Minus 16.
Nah, minus 1 squared. Minus 1 squared is...
Oh no, they positive 1 by 12. No.
And 12 minus 4 is?
8.
Right, so that would make minus 1, 4 what?
Minimum as well, or?
Yep. Let me graph the function and I'll go see. All you guys know what cubics look like, but you don't really know what quartics look like. For sure. Kind of weird, right?
Yes, sir.
Woo.
Yeah, it's like a W. W in the chat. W in the chat, guys. W in the chat. It looks like a W, right? Does it not? Does it not? Like, does it? Isn't it seen it looking like a W?
West, as in W with a S.
Yeah, yeah. So when I tap the first minimum point, what I should be? Well, I will show you, right?
1, 4.
Negative 1, 4. Bam. Right?
Ew.
When I tap the other minimum, what should be seeing?
1, 4.
1, 4.
1, 4. Bam, you seeing that?
Woo.
And when I tap the maximum, what? 0, 5.
5.
Okay. Everything
Absolute
checks out.
minimum.
Everything checks out. So again, guys, just a recap, right? Just a recap. If I want to find, remind me, let me run through the whole process. If I wanted to find the stationary points for a function, what we know are the stationary points? Nikolai, what we know are the stationary points?
Is equal to 0.
What is equal to 0?
Dy dx. Am I saying that right? Dy over dx, right?
Yeah, dy dx is equal to
0.
good. If I want to find the nature of the stationary points,
The second derivative, which is d squared y over dx squared, is equal, yeah.
so if it is less than 0, is a maximum or minimum?
That is a maximum.
Yes, it's a maximum. Because if it's negative, remember, if it's negative, right? If you're negative, yes, add.
Yes, sir.
If d2y dx squared is more than 0, more than 0 means what?
Minimum.
Right, because you're positive.
Yes, sir.
And it's gonna be you guys after the Add Math exam tomorrow. Hopefully. I can't say I dread quiz.
Definitely.
And maximum is very sad. And minimum is very happy.
All right. When I finish with this section, I will go through some more questions. Don't worry. Okay, I need a helper for this. Want to help me with this?
I don't mind.
All right, Nikolai, take that fast food. Right, so this is an easy question. So we're just gonna integrate. So Nikolai, how are we doing this?
Add 1 to the power and divide.
So let's go into 7x to what power?
To the power 4 divided by 4 minus 2x to the power 3 divided by 3 plus 5x to the power 2 divided by 2.
Olha, how I get this marks in the exam, boy. If this come, Olha cannot lose his marks. And that will be minus what?
8x plus c.
Guys, you cannot afford to lose his marks in the exam. This is so easy. This is so easy. You
So
cannot
after my SP with integration, nah, this how to get full marks in this section. So.
Exactly. By the way, let's look at some weird cases, guys. Let's look at some weird cases quickly. If I had to integrate something in the form ax plus b to the power n, what would be?
Ax plus b n minus 1 over n plus
N plus 1.
1
N plus 1.
times a.
Right.
Yeah. Over, yeah.
Right. Remind me, guys, if I integrate sine x, what would be?
Minus cos x.
Minus cos.
Nikolai, remember, boy. Nikolai, remember. W in chat for Nikolai, boy. Nikolai, remember. There's one thing, Nikolai, I'm gonna fumble about tomorrow, I hope. But today. Right? If I have sine ax dx, what would be?
1 over a. No, minus 1 over a cos x.
Cos what? Not cos x, cos.
Oh, cos ax.
Cos
Yeah.
ax.
Right. What's the integral of cosine x dx?
Sin x.
Nikolai, we're nonchalant. You hear him? Sine x. I found my son. Big up my son one time. Plus c. What would the integral of cosine ax be?
Would that be 1 over a sin x? No, sin x. Yeah. Plus c.
I was using the chat for Nikolai, boy. Big up Nikolai one time. These are all of the weird cases you need to remember.
Yes, sir.
Right. Let me tackle this question here. So Nikolai, let me run it fast. Give it a read it.
Particle moving along a straight line such that its velocity is given by v is equal to 4 t cubed minus 3 t squared plus 2. Find its displacement function given that s is equal to 5 and t is equal to 1.
Okay. They want me to find what?
Displacement is the integration.
Whee! Big up Nikolai one time, boy. Man have it on lock. Alright, let me explain why, guys. Let me explain why. As some of you guys may know, velocity is just a change in displacement with respect to what?
Time.
Time. And so that's the 4t cubed minus the 3t squared plus 2. So if I wanted to get rid of the derivative and just find for s, what would I have to do?
Differentiate. I mean, integrate.
Integrate. I would integrate because integration would undo the differentiation.
Yes, sir.
So I'm going to integrate.
So in school we learn an easy way to remember it because like how it had we have where we put D, V, and A. So all the arrows on the left hand side going down, you had to differentiate, and then from A to D you draw arrows going up. So you know you had to integrate.
I swear I should have that way.
Yeah, you did, sir. You did.
Arrows, yeah.
Yeah, so it will be
Watch. Like S. Okay, if you want to go from S to V, differentiate. If I want to go from V to acceleration, differentiate. If I want to go from acceleration to velocity, integrate. If I want to go from velocity to displacement, integrate. Let's remember that SVA backwards integrate.
Yes, sir.
And I'm gonna integrate this 4t
4t to the power 4. Huh? Oh, brilliant. Oh, that's right. I know the full thing first. My bad, my bad.
On the left hand side, they go turn to what?
Why?
No, remember, you're integrating ds dt. Where you go turn to, Nikolai?
D. Displacement.
You go turn, remember, displacement is s. Displacement is s.
Yes, sir.
Somebody had raised their hand. Sarah, Kim. Sarah.
Excuse sir, you could explain it over, please. From the beginning.
Right, so they give a velocity, right? They give a velocity. Velocity, you know what velocity means? Velocity.
Yeah, I know what it means.
Alright, so velocity actually means the change in displacement with respect to time. So if I have ds dt and I want to get s, what would I have to do with ds dt?
Yeah, differentiate it.
Nah, ds dt literally means the derivative. Like, okay, if it like, okay, v means ds dt and ds dt means the derivative of displacement with respect to time. So if you want to undo the differentiation, you gotta integrate.
Oh, okay.
So okay, v is ds dt, right? So this what I mean. Originally, you had some function for displacement with respect to time, and you differentiated it. So if I want to work backwards, I had to integrate to get back s. You could try to remember this. S to v differentiate, v to a differentiate, a to v integrate, v to s integrate. But like the reason why is because v actually is ds dt. So I want to undo the differentiation to get back s. So I would integrate. Yeah, so Nikolai, integrate that for me.
With 4t to the power 4 divided by 4 plus 3t to the power 3 divided by 3 plus 2x plus c.
Them sessions where we do this in detail, come on, good boy.
Yeah.
Right, so plus c, right? Don't forget the plus c. Don't forget the plus c.
Yes, sir. Which
Well, we
that
had
would be 4, well, t to the power 4 minus t to the power 3 plus 2t is equals plus c.
no, we need to find for c. So to find for c, you're looking for what?
You're looking for s is equals to 5 and t is equal to 1.
Big up Nikolai one time, boy. S is equal to 5, t is equal to 1. S is equal to 5, t is equal to 1. I'm plug that in. So S is 5.
So
So I
we
got
have in brackets 1 to the power 4 minus 1 to the power 3 plus 2 to the power 1. No, 2 in brackets 1 plus c.
right. 1 to the power 4 is just 1.
1.
1. That would just be 1.
The answer is 3.
Now, where's 1 minus 1? Oh, your final answer is 3. Yeah, that's correct.
Yeah.
Nikolai moving fast, boy. Big up Nikolai.
There's 3 marks basically.
This is
So
3 marks.
charge on your thing. We can't have you disappearing on us before 4 o'clock.
Oh. Yeah, the Apple. I mean the iPad. So I get to him somehow about that. Yeah, 37 people on TikTok. That's wow. Alright.
Surprised. We still have a large amount of people.
I have 100 people on YouTube. Yeah. Alright. So then S would be equal to t to the power 4.
Minus c to the power 3 plus 2t plus 3.
Wait. Cool.
I
Nice.
swear, if I don't pass, I'm not gonna cry. And crash out.
I will as well. But don't worry, I'll make sure they get full marks on all the paper. Don't worry.
Kinematics should be the only thing on that test paper.
Hey, I'll tell you all, differentiation, integration, and kinematics is, hey, you see section 3? Section 3 is cake, buddy. Section 3 is cake, buddy. It's cake.
Yes, sir.
We just section 4 and we done. Alright, so
Do we
yeah.
do any definite integrals?
No, we're gonna do that. We're gonna do that. We're gonna do that. So, let's do some questions like that. Calculus. Okay.
Yippee!
Let me do this whole question from 2016.
I feel like I need to wake up a brain.
Perhaps. Good luck, Aditya. Pick up yourself. I seen that. Come on, what?
Yeah.
What?
Bad notes playing up again.
What are you on about, bro? Okay, but that will work. I who wanna help me with 2016 question 5.
If nobody willing, I go.
Me.
Who is me?
That's me, sir.
No, somebody that volunteer themselves.
Yeah, I know, I
said she
know.
wanted to
So I
do
know.
it. Said
I was just saying it was me.
me. Me.
Oh, to draw these diagrams
Me.
was supposed to pain, like I draw all these diagrams.
Amelia volunteers as tribute.
Me.
All right, Amelia. Let me.
It was
All right, so
me.
Amelia, the first question. What to do there?
Why that look like that?
Oh no, the Apple Pencil tip. Where's the Apple
Why it
Pencil
look
tip?
like that?
This question is easy. Amelia, were you there for the past sessions where we did integration and differentiation in detail?
So
Wait, boy,
yeah,
what
I
it
was
was,
there.
boy? Where were you guys when we was doing anything in detail, boy?
I was there.
Oh, you was
I
there.
was there.
Well, it's light working. So here, what?
What is this?
Like, I'm gonna write the square root as what?
Oh, we're differentiating. A half.
I fake Apple Pencil giving trouble. Anytime I charge my iPod, it's give real trouble. Here, what? Again, I'm gonna give Olive 5 minutes, and I'll let you try this question for yourself, and let me know if you get through. Try these questions here. Give my Apple Pencil some time to charge. But person with the dot, you are correct. That's correct. Kinematics is the best part of calculus. It's really fun because it's the direct application of it. You guys, if all you're watching, don't forget to subscribe to Math Vibes. A lot of free content coming up. A lot more free content coming up. Yeah. All right. We had 4.49. We can make it to 5K before the exam season is finished. For sure. Celine, are you cooking? Are you cooking, Celine? I hope so. Amelia, is that like a light? What's that like? Yeah, I've headphones on and there's a light. It's my mic.
Yeah.
Oh, okay. I gotta sleep, guys. Good night.
Good night.
I'm gonna give Ola some time. Yeah, 3 minutes. Try to do as much of these questions as I could while my Apple Pencil charges. Cramming maths is never a good idea, to be honest. Yeah. You need some motivation. I'm gonna make a video after the live motivating you guys. You know, the first exam I write in Add Maths, I get 42 in Form 4. Yeah, boy. I thought I was ready and I was going to do excellent. This exam, I get 42.
Sir, well, you do better than me. First exam I write, I get 22.
Wow. But you improve, right?
Yes, sir, we improve by a lot. I getting at least 60 to 80 something now, so we
That is
getting there.
that is what we're talking. Marie CDK, that happened to me, like I was helping everybody, and when I look and see I see I get 42, I was like so stunned. Yeah. Oh. I like what you say once you have a Casio. That's correct. Add maths is really simple when you have a Casio. Are they ready to start back?
No.
Right. No, gotta start back. All right. So the first question is what? Starts with C. Why is the Apple Pencil not working? Okay, it's working. Time go. Yeah, the first question is just what? Does anybody know?
You're gonna change the square root into half?
Yeah.
Okay.
Nikolai, we do questions like listen on Nikolai. This is just what? What's this? Nikolai? Is Nikolai here with us? He doesn't know, but guys, this is an example of the chain rule. Now, since it's a standalone question by itself, and it is worth 4 marks, you actually have to do the full working. So let me show you how we're gonna do this. When you look at this, what causing the real trouble? What causing real trouble?
The half?
So the half not causing trouble. The half is not trouble. Watch. If I had something like y is equal to x to the power half, would that be trouble to differentiate?
No.
Nor.
That wouldn't be hard to differentiate. That'll just be a half. X to the power minus a half. That's real easy.
Mhm.
So what's causing any trouble here then?
The square inside.
Bracket.
The 5x squared minus 4. This is what causing any trouble. So we're going to say let u be equal to 5x squared minus 4. And if I tell you that u is 5x squared plus 4, what does the equation now become?
U to the power of a half.
Yep.
Could
So now,
can
so
I
now,
use functions to identify stuff? Because that's how I work it out.
yeah, you can think about it like that. So over here we have u. So when we differentiate this, we'll differentiate the function u with respect to what variable? So we're going to differentiate u with respect to what? Respect to x. I feel like we hit a wall here, right? But you're going to differentiate the function u with respect to the variable x. The variable is x over there. And so that's going to be 10x. Over here, I'm going to differentiate what with respect to what? Hello?
So why?
With respect to x.
No.
I respect to you.
When you look at this, right, you have the function y, and what's the variable here?
You.
U is the variable, so we dy over
U.
The u, yes.
D.
To differentiate this,
Du.
multiply by the power. So the power is a half. So we're going to say a half, and then we're going to take away 1 from the power. What's a half minus 1?
Minus a half.
Negative a half.
Minus a half. Cool. So here what? At the start though, we actually wanted to find the dy what? I wanted to differentiate the
over
function
dx.
by
UI dx.
dy dx. If you notice, we wanted to find the change in y with respect to the change in x. So here's what we're going to do now. We have to use chain rule. So how would I get back dy dx is the question. How am I going to get back dy dx? Well, to get back dy dx, I could say dy du multiplied by what?
Du dx.
Du dx.
Yeah. Because watch, the du and the du would cancel off to effectively give us what?
dy dx.
Dy dx.
UI dx.
Right, right. So dy du, that was a half u to the power minus a half. And du dx, that was 10x. So tell me guys, what is a half of 10?
5.
Inco.
So we're going to put 5x by u to the power negative a half. Now we're not going to leave our answer in terms of u, because when you look at it, it's dy dx. So we got to recall what u was. What was u?
5x squared
5x
minus
squared
4.
minus 4.
So I'll say 5x by 5x squared minus 4 to what power?
Half.
Negative a half.
You know, if you wanted, here what? At this level, how our brains are melting, this is fine. But if you saw that you can go further, that's all fine and well. Notice I have 5x squared minus 4 to the power negative a half. That really means 5x all over the square roots of 5x squared minus 4. But why am I saying that? If it's a negative power, that means it'll go to the denominator and you'll end up with to the power of half. And summing to the power of half is what?
The square root.
Square root.
Square root, yes. Cool. That's the answer. Now, what would the shortcut for this look like? Now, you had to do the full work and take a full marks, but what would the shortcut look like?
So like a times n bracket 5x squared minus 4 to the half minus 1.
Yeah, that's correct. So, if you're doing this the shortcut way, you're going to multiply by the power of half. So that's going to be a half. Then we're going to differentiate the inside, differentiate the inner function. If you differentiate 5x squared minus 4, what would that be?
10x.
That'll be 10x apart, 10x on the outside. Now I'm going to write back the original thing. But I'm going to do what with the power?
Minus 1.
Yeah. What's a half by 10x?
5x.
Yeah, and you'll get the original. You'll get the same thing. But this is a shortcut. Yeah, they want to see the full working. If it's a chain rule question involved in a product rule question, you do the shortcut. But if it's a standalone chain rule question like this, you have to show the full working.
So I have a question, sir.
Yeah.
We could leave it just as the 5x, or we have to simplify it even more, like how it did below.
Like this?
Yeah.
And this is fine. That's fine.
Okay, thanks, sir.
But like if you could do this, is good. It's good. All right. Let me get our next one like this just to make sure we have it locked in. So say we had a function y is equal to 9x cubed plus 7 to the power 8. How do I differentiate this using a shortcut?
You put down the 8.
I put on the 8, right. What then? What next?
Then you
So then we multiply by 9.
inside the brackets.
The inside.
I gotta differentiate the inside. If I differentiate the inside, what right?
27x2 to the 27x squared.
Right, then
Then the original. So it'll be
9x
9x cubed plus
cubed
7
plus 7
all over
to the power of 7.
right? What is it by 27? Chat, what is it by 27?
216.
216. 216x squared. 9x cubed plus 7. And I feel like all you understand is shortcut version of the chain rule for sure.
Yeah.
Yes, sir.
You just gotta multiply by the power, differentiate the inside, multiply by that 2, write back the original thing, and take away 1 from the power. Easy stuff. Alright. Now, for those of you guys that don't know, dy dx means the same thing as what? When you differentiate, you just find the what function?
Gradient function.
Yeah, you find an gradient function. Anybody that watch my video go understand that, because dy dx, it really means change in y over. So it means change, so like change in y over change in x. And this actually tells us the gradient of the tangent. So if I find dy dx and I plug in a value for x, I'm really finding the gradient of the tangent at that point. So let's read this question. Any volunteers to help me with this one?
I want to.
All right, read the question.
The point P1A lies on the curve with equation y equals 2x bracket x plus 1 all squared. Determine the equation of the normal to the curve at the point P.
So they gave us the equation here. Y is equal to 2x by x plus 1 squared. What is it? What is the first thought?
To
differentiate.
Right? Now, here what? We're only going to differentiate it. Are you going to differentiate it looking like this?
No, sir.
What we can do with that?
So we could use the. Can we use it? Oh, we have to use the product rule.
Are they making our life harder now? Yeah, let's do all of that.
We could put 2x inside the brackets and then just use chain rule.
No, all they making our life way too hard. Anytime something is to the power 2, you could expand it and simplify.
Oh.
So watch. Instead of doing all that madness, right? And I could just say 2x by x plus 1 by x plus 1. I could simplify this. So x by x is x squared. X by 1 is x. 1 by x is x again. And 1 by 1 is 1. So what would the inside be?
X squared plus 2x plus 1.
Yes, I did that too.
I would do, I'm going to do any product rule or chain rule or anything on the madness. Right? When I expand, all I get.
So 2x cubed.
2x cubed plus 4x plus 2x.
Plus 2x.
Right. Isn't this super easy to differentiate now?
Yes, sir.
It's really easy to differentiate, so we gotta find dy dx.
dy dx would be equal to 6x squared plus 8x plus 2.
Plus 2.
Good. Now here what? This is a gradient function, but it will allow us to find the gradient of the what?
We want to.
No, this will allow us to find the gradient of the what? Yes. We would use this to find gradient of the tangent. We want to find the equation of the what?
The tangent.
Equation of the normal.
Of the normal.
So we'll have to find the gradient of the normal. We'll have to find the gradient of the normal. So let me remind you guys about something. The normal and the tangent are always what to each other?
Perpendicular.
Correct. So imagine that you have a curve here, right? Imagine you have a curve and you have a point here. When you find the first derivative, you're really finding the gradient of this tangent over here. So this is a tangent over here. And this purple line over here would be the what?
Be the normal.
The normal.
Normal.
So we could find the gradient of the tangent, and then we could use that to find the what?
To find
The
the
gradient of the normal.
Yeah, that's exactly it. So we could find the gradient of the tangent at the point what?
P.
1/8.
1/8. So we're going to plug into dy dx.
1/8.
No, not 1/8. The gradient function is a function that accepts our input x. So if you're looking at point 1/8,
Oh, my bad. Just one.
just 1, right? X is equal to what here?
Uno.
1. So I'm going to plug that into dy dx. So I'll be able to find the gradient of the tangent at x is equal to 1. And so that will be equal to 6 by 1 squared plus 8 by 1 plus 2. What would I get?
Plus 8 by 1 plus 2. So you get
16.
16.
And that'll be the gradient of the tangent or the gradient of the normal.
The gradient of the tangent.
Right. So the gradient of the tangent is actually 16. What the gradient of the normal be?
We just
The
put that change the sign.
negative reciprocal of it.
Right, which would be minus 1.
1/16.
Correct, minus 1/16. Because 16 is the same thing as 16/1. If I flip that, be 1/16, and I change the sign, minus 1/16. Oh yeah. So the gradient of the normal is when I realize I type of this. Oof. Yeah, the gradient of the normal is what?
The gradient of
Negative 1/16.
negative 1/16.
Do I have any points that lie on the normal?
Yes.
Which point? Which point line on the normal?
P.
P. Yeah, P. Because it said P lies on the curve, determine the equation of the normal to the curve at point P. So remind me, what is the equation of a line?
Y equals
mx plus c.
So we're using the point 1, 8, and we're using the gradient of the normal, which is the negative reciprocal, which is minus 1/16. And we're going to use these facts to find for c. So x is 1 and y is 8. So I'm going to say 8. The gradient is minus 1/16.
Times 1 plus c.
So c would just be equal to 8. And if I move across the minus 1/16, we plus 1/16. So that'll work out to be what is an improper fraction. Nikolai, are you alive?
Right here now.
Oh, you was quiet for a bit.
No.
Would that be nice? 1/16? Am I tweaking? No, I think I'm tweaking. Never mind.
So we want it as an improper fraction.
Yeah.
129/16.
What again?
129/16.
Yeah, 129/16. So the equation of the normal would just be y is equal to summer, guys. Y is equal to what?
Y is
negative 1/16.
Negative 1/16x plus
plus 129.
129/16.
You know me, I'm a trusted you, so I'm gonna just verify if this is correct. One moment. So I'm gonna put in have the function y is equal to 2x by x plus 1 squared. Cool. That's a cubic over here. Cool. And this is the equation I come up with. Funny, had this tool in the exam, eh?
All right, so
For 429?
129, so
Right, so when I tap here, what point should that be?
1/8.
1/8.
Boo! But
We win these, guys. We win these.
Guys, you see, we did that. We did that ourselves.
doesn't it look 90 degrees to the line?
You're
Yeah.
So we're definitely getting all ones. Like
For sure,
I
for
can
sure.
see the vision.
ones. It's ones.
So remind me, guys, when anytime I find a gradient function and I plug in a value for x, I really find any gradient at the what? Tangent or the normal?
Tangent.
The tangent. If I wanted to find a gradient at the normal, what would I do?
Yeah, the
Find the
flip it
negative
and
reciprocal of the gradient of tangent.
Right, I would have to find the negative reciprocal. Cool. Cool. And then you would use the point you have on the normal and you use the gradient on the normal to find for c. Then you fix it. That's it. Cool.
5 marks.
Right. Let me see if we can tackle this question now. So Salim's gonna help me with this question.
Okay.
Can you get the question I'll
Yippee!
read?
Obtain the equation for each of the two tangents drawn to the curve y equals x squared at the points where y equals 16. Right. So did you hear me?
Yeah.
Okay, peek.
I didn't run through probability yet. Wait, I ran a Sokini question. So they're saying
Me too.
obtain the equation for each of the two tangents drawn to the curve y is equal to x squared. Okay, no problem. So if it's y is equal to x squared, is that maximum or minimum? Is that quadratic for sure? Is that maximum or minimum?
A minimum?
Yeah, it's a minimum because the
Oh,
curve is
minimum?
x1.
Okay, bad. Okay, right.
It's a minimum.
Whew.
And they're telling us at the points where y is 16. So Celine, if y is 16, then how would I find the x values?
Oh. I
So
don't know.
they're telling me that y is equal to x squared. How would I find the x values?
Y is equal to x squared.
And they're
How would
telling
you
us that
find
y is what?
that y is 16
So I would say 16 is equal to.
x squared.
So how would I find for x?
You would
You
just
have it.
square roots both
Yes.
sides.
And anytime you find the square root, how much solution to this really get?
2,
2.
a negative and a positive.
Right. So x would be equal to plus or minus 4.
Plus or minus 4.
So what are
Okay.
what are my 2 points then?
X is x minus 4 equals 0 and x plus 4 equals 0.
Nah, minus 4, 16.
Oh, points. Minus 4, 16 and 4, 16.
Right. And they want us to obtain the equation of the two tangents. So here what? If we're talking about tangents, then you really have to find the gradient of the tangents at these points. So how do I find the gradients of the tangents?
By finding the derivative of the equation of the curve.
Correcto. So we gotta find dy dx. Remember, this is a gradient function, and it allows us to find the gradient of the tangents.
Right.
So dy dx is what?
2x.
And so if I want to find the gradient at so we have two x values, right? Positive 4 and negative 4. So let's find the gradient at Let's find the gradient. Which one you find? Which one you want to find for first?
-4.
-4, okay. So I would say 2 by -4. So the
Which is
gradient there,
-8.
-8. So the gradient of this tangent is -8. And for the other one, we're gonna plug in 1.
4.
So the gradient for the other one will be
+8. Well, 2 times 4, which is 8. Okay, weak.
so let me do the equations, right? So we know that
Okay.
for the easy 5-mark question, but so Celine, the first point is -416, and use the gradient for that point.
-8.
Right. Use the equation of our line.
Y = mx + c.
Tell me what to do next.
Okay, then we
So where
input
did the 16
the
just
points.
become negative?
Yeah, where did it become negative, boy? That's a really good question. No.
So we substitute in the points and the gradient. So it'll be 16 equals -8 times -4 plus c.
That would
So
be
we're gonna work
32.
that out.
So 32, that'll be 16 minus 32, which is
16. So c
nah,
equals
minus
6.
16.
Okay. Oh, so my bad then.
Because Celine, wait, minus even -4 is positive 32. And positive 32 when you move it across will be 16 minus 32.
Right.
So
Okay.
this equation here would be y is equal to
Y is equal to -8x plus -16.
right. Let's find the other equation quickly.
Okay.
Have this one. When I saw this question, I had to like think about what it meant for a bit first. Then I was like, oh yeah. If they want me to find the equation of the tangent, I had to find the first derivative. Because the first derivative tells me the gradient of the tangent.
Yeah. Trust.
All right. And then the other point is, what's the other point, buddy?
416.
460.
And the gradient is 8. Substitute that in.
Is it 8?
Yeah.
Yeah, it was 8.
16 equals 4 times 8 plus c. Whoa. Yeah.
Same thing.
Same thing. Yeah.
So C is what?
C is equal to -16.
So then this other equation will be what?
This will be y equals 8x minus 16.
Now, Celine, like we have trust issues. So that we actually verify it on the graph. So y is equal to x squared. I always starting off with. All right, cool. We have the parabola here. And then the two lines I came up with, y is equal to negative 8x minus 16. Right, so here what? This should be a tangent at what point?
-416.
Bam. Let's go. Let's go.
Oh
Right,
my
and
goodness. We all won. We win these. One in Add Math, guys.
For sure. Y is equal to 8x minus 16.
Right, 416, give it to us.
Bam. Let's go.
Man.
And both of them cut in the y-axis at what, Celine?
What do you mean? 0, -16?
Minus 16, watch. And look at the y-intercepts.
4.
Yeah, so we're 100%.
Oh, we're so back.
We're 100% correct, guys. So, if they ask it, I never expect Nikolai to say that. You hear Nikolai just now. Nikolai was like, yippee.
Yeah, of course.
Right, so anytime they ask you to find equation or tangent, you just have to find the first derivative, plug in the values for x, and that'll give you the equation and the tangent, and you look for a point
Some of
on the
them
tangent.
just asleep.
Right, let we tackle the integration part now, guys. Let's go. And after this, we go start some work on probability and statistics, and that'll be it for the crash course.
And then we done, and then we go and we get a 1 in maths, add maths. I mean,
My concern is like all your brain fried. That's my concern.
So I go to sleep real good tonight. I mean, in the morning.
You
Wake up
see, your brain
in the
already
morning.
fried.
You mean today?
Your brain already fried. I'm very concerned.
So think about it like this: if we go to bed 4 o'clock and we get up at least 11 o'clock, there's 7 hours of sleep before we exam. We'll be fine.
That's true.
Nah.
No, well, I
I
had a
have to wake
different
up early
Wake up
and
7
go
hours
anyway.
for that exam.
So, guys, let me continue. So, who else know this question?
I don't mind.
All right, so Nikolai, you usually specialist for these kind of questions. I have hiccups.
What you say, sir?
I say I have hiccups. I have hiccups. So, 3 cosine theta. I'm starting to sound like Celine, man.
Oh my god, that's so real. That's so real.
I think Celine faking the accent. Like that's actually what she's doing.
Whoa. This is a real authentic accent you are hearing right now.
What do you guys think? People in the Zoom meeting, are they think Celine being real or not?
So I know people who gone in America for 2 days and done talking American already, sir.
I'm sorry.
The accent of the school she goes, trust.
Trust.
Convent.
I've never been to America and I never will go to America.
That is just the accent of our school.
That's the accent of the convent.
What school is go to?
I go to
That is
Ashton.
not.
It's like
And I
anyways.
guessed her school on first try. Ooh.
She did. Ate that down, clocked me up.
My Mrs. Math Vibes went to Astra Girls Hindu College and she does not. I should say Hindu College. I'm still Shiva boys, but like yeah, she went to Astra Girls College and I mean she does not talk like that.
Oh well, that's just me then.
No, because this is Sando Astra. That is
She went Sando Astra. She went
That's
Mrs. Math Vibes.
Such a great
Went
school, by the way.
Sando
Best
Astra.
school in the world.
Right. So Nikolai, let me figure out this question. So Nikolai, tell me what to write.
First it could be minus 3 sine theta.
You sure about that?
It's okay.
If you integrate cosine, where is it?
Minus sine. I mean sine. Sine.
Eh, Nikolai. So you'll get
Minus probably fried.
3 sine theta, and then here what? Forget about the minus 5. Just focus on the sine theta. If we integrate sine theta, we'll get
Minus cos.
right. And I'll put the plus c here. So you're gonna end up with 3 sine theta minus by minus of that plus.
Plus
So plus.
5 cos theta plus c.
So Nikolai, let me do some penance. If you integrate
Some what?
cosine theta,
Do some what?
penance. If you integrate cosine theta, what do you get?
Sine theta.
And if
Plus
I integrate sine theta, what do I get?
minus cos theta plus c.
Guys, y'all understand that, right?
Yes, sir.
Yes, sir.
I feel like I'm seeing things. Oh,
Lack of sleep, hallucinations.
you know what I'm seeing all of you guys getting ones.
Ah, that's what we like to
No,
hear.
that's
too.
true. That could never be a hallucination.
Can never.
That's the prophecy.
Is that you know Drewski?
Yes. Yeah.
Yeah.
Yeah, you know Drewski will be like, yeah.
Nah.
All right, so that's the day. Nikolai, you didn't make me proud, and I need to give you another question to make me proud. So
Yeah.
Nikolai, let me just say we have minus 9 sine theta plus 5 cosine theta d theta. Celine, get into more. Why am I sound like a white person?
when neurodivergent people personality match?
I'm very neurodivergent.
That's what's happening. That's what we're matching right now.
All right. So Nikolai, here what a Nikolai, you forget about a negative 9. Just write back to negative 9
Yeah,
and
that was
ask yourself, Nikolai, if I integrate sine theta, what am I gonna get?
minus cos theta.
Okay, what to do for the other one?
That'll be plus 5 sine theta.
What is minus 9 minus cosine theta?
9 plus cos theta plus 5 sine theta plus c.
All right, that will be in chat for Nikolai. Good.
Yeah, redemption, sir. My brain tweaking.
Yeah, you're low key it is. Let me give you a spontaneous question. Let's just say we had a definite integral from 1 to 2, and it was minus 3 later, and it was 7 minus 3x to the power of 4 dx. How am I going to work this out?
So wouldn't it be in this way? Can I bracket the box then?
Yeah,
Yeah. So it'll be 7 plus 3x to the power of 5.
it means 7 minus 3x to the power of 5, yeah?
Minus, my bad.
All over.
By 5 multiply by, is it 7 minus 3x? Or how did you differentiate that?
Yeah, differentiated.
So it'll just be 3.
Yeah, minus 3. Remember how the rulers go? The rulers go like this. If you integrate ax plus b to the power n, it's going to be ax plus b to the power n plus 1 all over the coefficient of x, which is a, by n plus 1 plus c. So Nikolai, you add 1 to the power into 5, you write back the 5, and where's the coefficient of x?
3. Oh, minus 3.
Minus 3. Down put the 2 here, down put the 1 here. You real work today, you know? A lot of work. Yeah, what next?
It could be 7 minus 3 in brackets 2 to the power of 5 divided by 5 in brackets minus 3.
Wait,
What's that?
we could simplify before you do anything.
Oh, well, okay.
What that will be now?
Alright, that could be 7 minus 3 in brackets 2 close brackets to the power of 5 divided by 15. And we already considered the next side to be 0. No, the next side is not 0. Is 7 minus 3 to the power, well, in brackets 1 to the power of 5 divided by minus 15.
Right. So it's a good thing I'm give out that question like that, boy. Right. So somebody plug that into a calculator and let me know what you're getting. I'm trusting you guys, man. I'm trusting you guys. Actually, I'm gonna do it on my calculator regardless. I must. 7 3.
I get minus 1 over 15 for the first one.
I will tell you what I get for my final answer.
Good night, sir. I'm
All
going
right.
to bed.
Bye-bye. Best of luck in the exam. For the final, I'm getting 0.2. For the final thing again, 0.2. You guys will let me know if you're getting that for the final answer. Anybody get 0.2?
Yeah. Yes, I'm
Gabriel, you're supposed to plug in this in the calculator, but Gabriel, boy. Gabriel, I know ease up here, Gabriel. I wonder if I get 0.2.
So, and for the first one, you get minus 1/15. Like for the first side.
I don't know. I don't know. I just plugged the whole thing into my calculator and I got 0.2.
I don't know what I did, but I got 68.2.
Yeah, that way again.
Let me plug this back into my calculator to make sure I'm not tweaking, bro.
Is your calculator gaslighting you?
Is my brain gaslighting me? It's a question.
Oh, that just might be it too. No, because remember you prophesied that we get one, so obviously it's
So,
okay.
here what? I can unplug, like, okay. Let me just get I can't get the answer immediately, right, chat? Immediately.
Yeah, I get 68.2. I know I get 0.2.
Oh, right. We could just, oh, right. Oh, I did the entire thing out. Unfortunatamente.
Okay, I did something wrong then. Sorry about that. Sign of defeat. Heartbreaking. Yeah, you guys got 68.2, right?
Sure.
Why are you wrong then, boy?
So, Nero, say that you're not trusted me.
And that I should not trust myself. That's what. Oh, the whole thing was being raised to the power of 5. Oh, I see what I do wrong. It's crazy mistake. Crazy mistake to make.
So you have to close the bracket on the other side. On the first side, on the first side. Or you don't have to.
I don't have to. That's fine.
Are you
So,
sure?
probably we'll see. Oh, I see what you're talking about. Shouldn't matter though. Wait, eh? Yeah, it doesn't matter.
Oh, okay.
Point. Sorry about that, guys.
No, no scene. And you hear 12 hours now?
Yeah. Cool. That's a day. Move on. Right, so we have to evaluate this definite integral here. Any volunteers? Any
If
volunteers?
nobody willing, you don't know what you're saying.
Alright, well, let me tackle this fast. So, Nikolai, guide me through the process.
R1 to the power and divide it, but as seen here, you have 2 divided by x squared.
What to do with that?
Change it.
Change it to what?
The minus, well, it could be 2x to the power negative 2.
Good, you handle that good. I didn't tell you. You handle that for yourself. I'm proud. They
Then
were the
you
groups
add
in
1,
class.
and then you divide it again.
Everybody will do that, right? You'll take the x to the power 2 and bring it up to the top. Take x to the power minus 2 on that.
Yes, sir.
I hope you guys will do that. So then what, Nikolai?
R1 to the power, so is 2x minus 1 divided by minus 1 minus 3x plus 2x to the power 4 divided by 4, close that bracket, then 3 and 1. So we put 2x 2 to the in brackets 3 minus 1 over minus 1 minus 3 in brackets 3 close brackets plus 2 in brackets 3 to the power 4 divided by 4. And then we do the same thing basically on the other side, but instead of 3, we put in 1.
Bro, let's just skill out using a calculator at this point.
Yes, sir.
I don't know how these sharp people survive on this rounds, boy. I have no idea, boy. I have none. All you know what I gonna do? Let me show you what I gonna do, right? Let me show you what I gonna do. Here what? Here what I gonna do, right, Ole? I'm going to press the integral sign. That's what I'm gonna do. I'm gonna put 2 over. I'll put 2 over x power 2 minus 3 plus 2 x cubed 1 3 put this in brackets. And I'm gonna get my answer one time.
Excuse me, sir.
Yeah?
For in the first step, when you went from 2, like the 2 over x squared to the 2 to the x to negative 2, wouldn't it be 2 to the x minus 2 minus 1? So it would be minus 3?
Yeah, adding 1 to the power.
Or you're adding 1? Okay.
Because you're integrating. If you add 1 to negative 2, we go to 2.
Or minus 1. Okay then.
Right. So, and here what's it? Anytime you do a definite integral, you're really finding the area. So you really should say unit squared. Anytime you find for a definite integral, you really find area under the graph between the two bounds. So you should put unit squared. Anytime you're doing definite integration, right? So guys, I don't know if I want to plug that whole thing into a calculator, but it's 35.33. Lani, I see you raise your hand. Talk to Malani.
I want to know how to plug that into my Casio, sir.
Hey, my advice is just plug this into your Casio and write the answer. Yeah. I think I'll plug that whole thing in. You know how to plug this into your Casio?
I don't, because I don't have the one you have, sir.
Does your calculator have the integral button anyway though?
It doesn't. I was now looking at it.
Oh no. Oh no.
Indeed.
Yeah, I think I might be cooked, sir.
Does your calculator allow you to put fractions though?
Yeah.
Well, yeah, I mean, just putting it, just putting it, you just plug anything the same way you see it. So, 2 by 3 to the power 1. I'm gonna plug it in with you, right? Power negative 1 over negative 1 minus 3 by 3 plus 2 by 3 to the power 4 over 4 close our bracket minus open bracket fraction button 2 by 1 to the power negative 1 over negative 1 minus 3 plus fraction button 2 by 1 to the power 4 over 4. Yeah, look, I get through.
Yeah, I got you, sir.
Alright, just take a little while, but I get through. Cool. Let me do this question now. After this is it for integration. What else more with this question? Easy question, in my opinion.
Like I say, if nobody going, there we go.
Well, there we go, right? So Nikolai. Indefinite. Okay, if I want to find area, what to do? What to do?
Integration, area
Right.
arithmetic.
So I'm gonna integrate what?
Y is equals to x minus 2 squared plus 5. Which really and truly, y is the integral. Well, change it. Yeah, you change it.
So I could If I expand that, what that will be?
X squared minus 2x positive 4.
What would that be?
Simplify, that would be x squared, and that be 4x plus 4 plus 5. I mean, yeah, well, and then gonna be 9.
Right? So I'm gonna integrate this function from what to what?
Upper boundary is 2, lower boundary is 1.
That is all easy thing. Come on fast.
Oh, well, it could be x to the power cube divided by 3 plus x to the power 2 divided by 2, then plus 9x, close brackets, 2 and 1. Then lower down, you'll put 2, well, in brackets, 2 to the power 3 divided by 3 minus 4 in brackets, 2 to the power 2 divided by 2 plus 9 in brackets, 2, close brackets. Then you do the same side, but with 1. So it'll be 1 cubed divided by 3 plus, minus 4 in brackets, 1 to the power 2 divided by 2 plus 9 in brackets, 1, close brackets.
Scramble into my calculator one time. So integral
I got minus 38 over 3. That's not supposed to happen.
a negative area just means
Oh,
the area of the
no,
graph.
no. So I put a minus when it's supposed to be plus 9.
Again, 16 over 3.
Yes, sir. I got the same thing. 16 over 3.
Yeah, got the
It's
same thing.
5.33.
And now we units what?
Squared because it's area we're dealing with, not volume.
Right. Cool. Let me do this question quickly. The point 1, 2 lies on a curve which has a gradient function given by dy dx is equal to 3x squared minus 6x. Find the equation of the curve. How would I find the equation of the curve?
Well,
By
we have,
integrating,
Yeah. Nikolai,
yes,
what would I
sir.
have to, if I want to get back y, why to do the gradient function?
Integrate
Right, so I will integrate dy dx with respect to,
x. With respect to y.
no.
Oh,
No,
well, yeah, well,
respect
okay.
x.
Yeah, my bad.
You keep saying the correct thing and then switching.
Sorry.
So 3x squared minus 6x. Watch. I
Wouldn't that be the
integrate
bound?
this.
Sorry, you forget the point 2 and 1.
Don't worry about that. No. That's not an upper and lower limit, Nikolai. That's not an upper and lower limit.
Oh,
Remember,
okay.
Nikolai, I would end up integrating and I would have plus c. Remember how it is go? I would have plus c. And then
Yes.
how do I find for c?
Yeah.
Yeah, so no. That's not what it means. No. Right?
So
When I integrate dy dx, I'm gonna get y. So what I will work out to be, Nikolai,
3x to the power 3 divided by 3 minus 6x squared divided by 2. But you cancel that and lower down it'll just be x cubed minus 3x squared plus c.
how finding for c now?
By using the points 1 and 2, which one is the x, what y is the 2. So you replace y with 2 and x with 1. So it'll be 1 cubed minus 3 1 squared plus c. Yeah, substitute to find c.
So c will be equal to what?
0. No, to 4.
4. So what's the equation for y?
Y is equal to x cubed minus 3x squared plus 4.
Badness. Big up one time. Easy marks. The only thing we
So
have to look at is finding volume, right? That's the only thing we had to look at. Do you guys remember how to find volume generated by revolving the area around the curve?
Yes, sir.
Trinidad?
A little, yeah.
I hope so.
All right. If you want to find volume, it's given by AB y squared pi, forget the pi, dx. Of course, where b is more than a. So let's do a question quickly on that from the 2025 paper. Why not? Okay, so guys, figure 2 shows the shaded region enclosed between the x-axis, the y-axis, and the curve y is equal to 4 minus x squared. So first we need to figure out our lower and our upper boundary. What is the lower boundary?
0.
X is equal to
0.
0.
what is the upper boundary?
4.
Somebody said 4.
Why would it be 2?
It'd be 2, yeah. Aren't you guys seeing like what this is like? What it closing off it over here and closing it off over here?
yes, sir.
Yes.
So x is 0 and x is 2. And if I want to find volume, remember volume is v is equal to pi integral lower upper y squared dx. So here what would I have to find first to begin with? Guys,
Uh,
fine.
so it is integrated to find volume, is it? This is volume.
No, but guys, the volume formula calls for you had to find for y squared.
Yes, so y squared is the equation, which is 4 minus x
So
squared.
just
So here
put
what?
equation.
Yeah, watch y is equal to 4 minus x squared.
Yeah, and you just, well, isn't that y? So y squared will be 4 minus x squared that.
Yeah, which is 4 minus x squared by.
4 minus x squared.
So guys, when you're finding volume, you always have to square the function. You always have to, which just means you multiply it by itself. So 4 by 4, 4 minus x squared, minus x squared by 4, minus x squared by minus x squared. So what would that be?
Well, 4 times 4 is 16, x squared by x squared. I mean, minus x squared by minus x squared is positive x.
Oh, wait, that'll be minus 4x squared.
Oh, yeah, my bad.
Then
Minus 4x squared. Positive x to the power 4.
good. To simplify this now, that would be 16 minus 4 is what?
8 minus 8.
Right?
X plus
So that's
x is 4.
good. So now we can actually plug it in here. So that'll be the integral of, and what's the lower limit?
0.
Upper limit is?
2.
Right, so I got to 0, 2, and what was y squared?
16 minus 8x squared plus 4x to the power 4.
Right, let me tackle this quickly.
So if I remember this correct, was it 256 divided by 15?
I don't know. I said I'm not good at memorizing. I just good at figuring things out. Not
Oh yeah,
memorizing.
it's 256 pi over 15. Units cubed.
I hope you are you okay with this? How I integrate it? Nah.
Yeah.
So if I integrate 16 goes into what?
16.
16x.
16x.
15x. Minus 8x squared. Add 1 to the power into 3 and divide by 3. X to the power 4. That's into x to the power 5 divided by 5. Nice. So V now is going to be equal to pi. And on the inside, that's going to be 16 by 2 minus 8 by 2 cubed all over 3 plus 2 to the power 5 all over 5. Now, the max for that question, right? If the lower limit is 0, we're going to make this whole thing.
Everything 0.
0.
So
Alright,
we
well,
just
let me know
have
if I'm wrong here. If
this
I
multiplier.
memorize it correctly.
So plug that in and let me know what you guys get in.
Let me know if I get wrong, eh?
Plug it into my calculator. So after this, we're done with differentiation and integration and kinematics.
So you want it in decimal or fraction?
Fraction would be good, yes, sir.
256 over 15.
Don't forget the
Think about
pi.
it. That's what you said. That's what you had said.
Yes, sir, but you forget the pi.
Oh, yeah. Don't forget the pi.
So it'll be 256 pi over 15 units cubed.
They wanted the answer in terms of pi.
No, but I
We had
just put it as pi.
we
Yeah,
had to multiply by pi.
that's typically how they want it to know, like the exact form.
So I remember the answer, but during the test, I could not have figured out how to work it to get that answer, you know, sir. And that
Well, no,
was
you don't. So if you round this answer to 2 decimal places, no. That is 53.61.
0.62, isn't it? Or
Yeah, 0.62.
Yeah, that's what I got.
units cubed.
Cool, man. So when you're finding volume, you have to find what of the function. We had to do the function. Tell my guys, we had to do the function.
Expand it.
You had to square it, you had to multiply it by
Square it.
itself. You had to multiply it by itself. And then you could plug it in and integrate. Don't forget that, chat. Don't forget that. All right.
Sir, what else should we know to do like that, like volume? Or is it just volume?
Just volume. So here what? We just have the last section to do now. And that is it. We're Gucci.
Oh, they're making out so far.
Sir, are you still going to do the third crash course after? And the rational inequalities and stuff?
I don't think that's gonna come though, but I could do like 1 or 2 example.
Yeah, but sir, how are you making out so far?
Crashing out.
Internally. Crashing out very internally.
I feel like my eyes red, but I'm not seeing it. I can't prove it.
All right, let me not waste any time and move straight on to probability and statistics. Right, the scores of 12 students on a test are 10, 15, 18, 22, 24, whatever. Determine the mean and standard deviation. How do I find the mean?
Add up all those things and divide it by the n numbers.
Right, so x bar would just be 10. I don't know, I'm getting more than that. I just plug it into my calculator. Wait. So 10 plus 15 plus 18 plus 22 plus 24, plus 25, plus 29, plus 33, plus 35, plus 38, plus 41, plus 45. You guys will confirm if you get in 335.
27.92.
But you get in 335 for the sum?
Yes, sir.
Anybody else get in 335 for the sum or no?
That's like
Sir.
Are they getting something different or no?
no,
I
I
got
get
the same
that.
thing.
That's 335.
Right, so the mean would just be that 335 divided by the what?
12.
So that'll be what?
27.92.
27.92.
Don't
So,
look at the last two numbers.
say that again.
Don't look at the last two numbers.
Do not look at the last two numbers. Oh,
Yes, sir.
yeah, 6, 7, 6, 7. All right, so do you guys remember how to find the standard deviation?
Yes, sir. Isn't that the sum of x minus x bar squared divided by the x minus x bar?
Well, the sum of x minus x bar, yeah, x minus x bar squared over,
X minus n.
and it's the square root of this whole thing.
Yes, sir.
How much of you guys remember that? I
Partially me.
feel like standard deviation gonna come tomorrow or today, you know. I feel so.
And that in the formula sheet as well, in case you forget.
Don't look at the formula sheet, you'll cry.
Yes.
Yeah, this is the formula that's give you any formula sheet.
Yeah, it's literally so confusing.
Oh my god, what is that?
All I need to know is it divided by n, you know. I already know the top part already.
Like, why? Why would it do this? How does that help any student? But don't
They're
worry.
trying to confuse you. Don't let them get in your head.
Wait, eh? 1 second. Yeah. Why did I? Oh, this is variance grouped. Yeah, so it's just standard deviation is just the square root of s squared. So s squared is the sum of x minus x bar squared over n. And so if you want to find for s, you just find the square root of this. So yeah, all you guys need to know literally is yeah. Where is it? We're nearly done, guys. We're nearly done. Thank God. Yeah, its standard deviation is the sum of x minus x bar squared over n. So let me do that quickly. So you see these scores over here? These are your x values. Understand? Here, what? To make all it life a little easier, I can make it. I can cut this theta in half. Well, a little more than half, right? Just to make all the life a little simpler. Let me do that. So instead of 12 students, how much students we have there?
Yeah, what?
I cut it
5.
just to make our life simpler. So where's 10 plus 15 plus 18 plus 22 plus 24?
What we adding? The 10 plus, oh,
Yeah, I try to make it simpler.
again, 89.
89.
So the average would just be 89 over 5, which is
17.8.
we're getting 17.8. Yeah. And the standard deviation was square root of the sum of x minus x bar squared all over n. So here how I go in again from the left at 4. So here what? You see these values over here? These are your x values, guys. And so I need to find x minus x bar and square it. So let me show you how we can do that. So you're going to start off with 10. So it's going to be 10 minus 17.8. And then square that. What are we getting for that? I trust in you guys to work fast. What's 10 minus 17.8 squared?
10.
Right. I'm moving with pace, so I'll go and do this quickly.
60.84.
Yes, 60.84.
Right. That's not the only one we need to do. We need to find 15 minus 17.8 squared. I'm gonna work that fast. That's 7.84. Now we need to do 18 minus 17.8 squared.
I got 0.04.
Yeah, 0.04. So I don't know if you guys realize what's happening here, but we are trying to find how each score varies with reference to the what? We're trying to see reference to the what?
Mean.
It's literally x minus x bar. So the greater the numbers is from the mean, it's going to produce a greater difference, right? And then we have 22 minus 17.8 squared, which is 17.64. And that's going to be 24 minus 17.8 squared, which I'm getting 38.44. I mean, if you guys get that as well.
Yes, sir.
Guys, imagine doing that for 12. That's crazy. And now we have to find the sum of x minus x bar squared. So what that will be, guys?
Oh, there's some of all that.
Yep.
Sir, so in the exam, we have to sit down and work it out for
Yep.
all.
Do all of that. You have to do all of that. Yep. It's crazy. I know. It's crazy.
I got 124.8.
Right. So my standard deviation is just going to be the square root of this 124.8 divided by what? What was the number I told you? How much? 5. So what am I going to get here?
24.96.
From our square roots and that. So if you guys work this out correctly, you should get approximately 5.00. I mean, if you guys get that.
4.99.
And if you're on out of the 2 decimal places, we will get.
Yes, sir, 5.00.
Right. So my mean is 17.8 and my standard deviation is 5. Right. All right. So what does standard deviation actually tell us? Standard deviation tells us how spread out our data is with reference to the mean. That's what it does. Right? Again, when you look at these scores here, do these scores look like they vary that significantly?
Repeat, sir.
No,
Do
sir.
these scores look like it varying that significantly?
No, sir.
No, not
Not
really.
really. If I had like a little 50, a little 70, a little 100 and thing, would the scores vary significantly then?
Yes, sir.
Yes, sir.
Yeah, it would. So what do you think would happen to my standard deviation then? Would it increase or decrease?
Increase?
Increase, because standard deviation tells us how spread out our data is with reference to the mean. Yes. So in part 2, if a new student joins the class and scores 50, analyze the impact on the mean and standard deviation. So we have to recalculate it. So remember, I had cut down the sample size. I had cut it down, right? So if a new student joins and scores 50, then we'd have to increase our sample space. We'd have to add on what?
Add 50.
Right, 50. So how would that affect our mean? Wait, do you think that would increase our mean or decrease our mean?
Increase.
It increase our mean. Let's see. So our new x bar would be the 89 plus the 50, which is?
139.
And it'll be 139 over what now? Instead of 5, it'll be what now?
6.
Right, where's 139 over 6?
It's
23.17.
23.17, right? So it increased my average. Alright, it increased my average. Are you seeing that or no?
Yes, sir.
Wait, well, you gotta recalculate this whole thing. Wait. Long story short, I don't think they wanted it to calculate the whole thing back. But if you add a new person, just know that it would cause the average to increase, and it would cause the standard deviation to become higher as well. Because think about it, guys. If somebody scores 50 and you compare it to the other sets of data, is 50 close to the data points there or like kind of far?
Kind of far.
Kind of far. So would it increase my standard deviation or drop it?
Increase.
It would increase it. Because standard deviation tells us how spread out my data is with reference to the mean.
Yes,
So I'm gonna calculate that like real fast, like light speed out there. Light speed. Let me run this thing fast. So instead of 17.8, I just gone right 23.17. But I already know what the results would be. I know that it would increase. I know that. So somebody, well, actually, I'll just do it quickly.
No, I gotta what's up, yo? What you gonna say?
Wait, I go work it out fast. Sorry. So the first one, it'd be 173.45. The other one will be that'll be 66.75. Oh, immediately. And it looking bigger.
Yeah, it does look bigger. Wait, we just changed the x prime just now?
You mean we just changed the average.
Oh,
Remember, if we add a new person in, right? Wouldn't that change the average?
yeah.
Yeah, it would.
Okay. I'll just add up all those things in the meantime.
Wow, what? 719.85. So add up all that, let me know what you guys getting.
I got 988.84.
You add up the 719 too?
Yes, sir.
Bigger?
So, oh wait. 988.84.
Yeah, so my standard deviation is now 12.84. Did it go up or did it go down?
Went up.
Before it was 5, now it is what? Now I don't suspect they wanted all of this calculation, right? What would I say? You would just say it would cause the mean to increase as well as the standard deviation. Conversely now, imagine I tell you it had a new student and they got a score of 1. What would they do to the mean? Somebody tell. The person get a score of 1, a score of 1 out of 100. Will they drop the average score or like increase the average score?
Drop.
Drop it.
Drop it.
Drop the average score. And would it increase the standard deviation or decrease the standard deviation?
It will decrease.
No, it would increase. It would
Increase.
increase. Because okay, everybody get like 10, 15, 18, 20, 20. But like this random person get 1. Doesn't that mean the data is a lot more spread out now?
Yeah.
That makes more sense. Okay.
Yeah.
So what
Yeah.
that one person was doing, man, like he never, like he slipped throughout the exams.
Probably.
He's me. He's me. I am that person.
Don't say that. So who wanna help me with this question? The typical question with the red, blue, green marbles, who wanna help me with this?
Sure, I will do that.
Alright, give it a read.
A bag contains three red, 5 blue, and 7 green marbles. 2 marbles are drawn at random without replacement. Find the probability that both marbles are red.
Okay. So, Gabrielle,
Mm-hmm.
the bag contains how much red?
3 red.
Wait, here what? I can draw the probability tree, right? I can draw the probability tree. And so you know how probability trees work?
Not
Yes,
really.
sir.
Okay, good. So Gabrielle,
Yeah.
they're saying without replacement. If it's without replacement, then am I putting back if I take one?
No.
No. So here what? Let's just say we're using this for red, right? This one over here is red. To get
Yeah.
red at the start, it'll be 3 over what?
Over the total amount, which is 15.
50. Right? To get a blue, that would be what?
5 over 15.
And to get a green,
7 over 15.
I'll you understand how I come up with the first branch, the first branches for the probability tree?
Yes.
Yes, sir.
Okay, so let me just say you got a red in the first round, and let's see what we could get again. All right, so Gabrielle, if you did pick a red, right?
It will
You did
be
pick a
4 of 15.
Apple Pencil that again, boy. Oh my days. Everything dying, everything dying. Oh, let's see if I can complete this one. See if I can complete this. But Apple Pencil charges. Guys, what should the sum of all the branches be? What should the sum of all the branches be if you're correct?
15.
1.
1. Because the
Oh,
maximum
1.
probability is what? What's the maximum probability?
1.
1.
15 over 15.
Right, 1.
So I probably said the correct thing, but did not say 1 here. Because
15 over
it's
15 is what?
15.
15 over
Yeah.
15. But that would
So
be,
you wouldn't get like a fraction,
what's that?
but because like without doing it with the tree, right? And you had a like without replacement would be like 2 out of 14, because and you had like to take it out, right? And it would be 3
No,
over
no, but
14.
like you had to draw probability tree. You had to draw probability tree for this. Like,
Okay, but like
I
hear
recommend one.
out on what I'm
All
doing,
right.
right? It would be like 3 over 15 times 2 over 14. And then you would get
Oh well, you don't need to do a probability tree, because they're saying both marbles are red. Both marbles are red. They're telling you both marbles are red. It only have like one occurrence where both are red.
so my teacher never really teach the tree properly, so that's why I don't really know it.
Okay, that's no problem. I'm going to dedicate most of the session to probability as opposed to statistics. Right?
Okay.
Probability is a lot more. I feel like it more marks for that. Plus, I don't like statistics. Ew.
Well, me nada.
Right? So here what? I'm gonna teach you. I'm gonna show you guys how to do with all the probability tree, right? If both marbles are red, then that we want to find the probability of picking a red and a red. In the first round, what was the probability of picking a red?
1,
No, 3 over
what?
50.
50? Yeah.
And then if you pick, okay, so you pick a red already. So the sample space for red will drop because you have a red already. You have a red already. So how much red you have to pick in the next round?
2
So out of
and it
14.
would be 14.
Right. And when you multiply that, you'll get an answer. It should be, come away again.
2 over, it would be 2 over 10 and it would reduce to 1 over 35. That's how I would do it.
Wait, 3 over 15 by 2 over 14. I get in 1 over 35 here.
Yeah, 135.
How many fall I get 1 over 35?
Yes, sir.
Yeah.
If I were to complete the tree diagram though, because I feel like them asking for a tree diagram, then to get a red again, that would be 4 over 14. To get a blue, since you didn't pick a blue yet, it's still 5 over, it'll be 5 over 14. A green, since you didn't pick a green, it'll still be the full amount, so 7 over 14. Are you understand what I'm saying or nah?
Yeah, I think I get the gist.
Yes, sir.
And then it will be red, blue, green. So Gabriel, let's just say, okay, so in this probability, you pick up blue, right? So if you pick up blue, how much blue is remaining?
It will be 4 over 13. Well,
No.
14.
And before about 14 for this, did you, in this instance, did you ever pick a red?
No.
No. So how much red you still have?
7.
Nah, it never had 7 reds to begin with.
I mean, 1?
Nah, I have 3 reds at the start.
Oh.
Watch.
Sir, how did you get 4 over 14?
Yeah, I was confused how I get that.
Okay.
Go back there to any tree, the red, yeah, 4 over 14. Would it not
Right.
be 2?
So guys, we start off with 3 red, 5 blue, and 7 green. In this branch, you never pick, you only thing you pick here was a blue. So in this branch, you pick up blue.
We're talking about any red branch, on top. You write 4 over 14.
What? How I get 4 or 14? What? I just confuse myself sometimes. That should be what? What should it be?
2 over 14?
2 over 14.
And I'll put the correct thing here. No? Oh, yes. Yeah, and if you're correct, it's supposed to add up to the 14 over 14, which is 1. Watch, 2 plus 5 is 7, 7 plus 1, 14. 14 over 14 is 1. Right, sorry about that. Yeah, and I trust all you would understand as well if all you call them out on a mistake. So, if I pick a blue, that means I didn't pick a red or a green yet. So I still have the total amount of reds, which was 3. I didn't pick any red yet. But the sample space dropped to 14 because I pick a blue. The blue sample space will drop by 1. So from 5 it went down to 4. 4 or 14. And the last one will be what?
7 over 14.
Because did I pick a green yet?
No.
No.
No. You know, tree diagrams are really easy, you know. Tree diagrams is really, really easy.
So the green will be the 6 over 14.
Right? It'd be 6 over 14.
And then since you never pick red or blue, it would stay as 3 over 14 and then 5 over 14.
Correct.
I get in there.
Oh, yeah, tree diagrams easy, right?
Yes.
So I'm not too sure about that. Remember, I had
But I
struggled
want to
with
know how we
this.
get the 1 over
Something a bit missing, right? Something missing. Right? Yeah, something missing over here. Actually, is it?
Be 5 over 14, not 2.
You go add up to 14. 6 plus 5 is 11, and 11 plus 3 is what? You getting back to 1.
Be 15.
Yeah, you can back the
Yeah.
ones. So.
Hold
You're
on.
working, you're working. All right,
Yeah.
so Gabriel, I think you made a mistake earlier. Because, did you? No, you never make a mistake. I was just tweaking. There was no mistake. Yeah, that's correct. Because watch. I want to get... Okay, let me just say I pick a green, right? If I pick a green, what sample space would increase? I mean, would decrease. Which one would decrease?
Green.
The green, right? So the green would drop from 7 to 6. So 6 over 14. Yeah, if I pick a green, and that means I never picked a blue before. So the blue will remain at 5. 5 over 14. The red will remain 3, so 3 over 14. Simple. I wonder if you guys understand the tree diagram.
Yes, sir.
Yes.
Right.
Wait,
So
so
question. If I ask you guys, what is the probability of getting 2 different colors? How would I tackle that using the tree diagram? Can you guys identify the branches where I got 2 different colors?
Yeah,
Yes,
no.
sir.
Isn't it the branches at the end mostly?
Well, watch. Red and a blue here. Red and a green here. So like watch. I could have gotten a red and a blue, or I could have gotten a red and